Did he say it was pseudoscience or a pseudo-force?
Well, the force would be a pseudoscience in regardless. If it's a pseudo-force or not.
So
where
you're not
do all these
listening.
people-
All you're here for is to flap your gums and
No,
try
no.
to pretend you're intelligent. Yes, yes, yes. That's what you're here for. Flap your gums. Look at me. I'm educated. I'm doing some bullshit at university that no one really gives a fuck about. And try to pretend to be clever. How about you start listening to some of these other guys? They've been through university. They know the shit that you're getting taught. You might learn something.
Okay. Alright. Then do this. Tell me of these scientists that are talking about pseudo-force. Give me 3. And give me one of their papers.
Why should I bow down to your bullshit requests?
Well, you're the one that brought it up, and you wanted me to listen.
You're the one who believes it. How about you go and get these so-called scientists? Go and look up Newton's works.
No, you're the one that said it.
Of
That's
gravity. Go and look
up
Einstein's stuff, and you will realise that they are just mathematical frameworks to make you easier to do stuff. That's all. There's no actual evidence. If you're doing science, show us the scientific experiment that was done to verify the existence of gravity.
So what I'm saying is you, or maybe
show us the experiment. You're telling us all about it. Go and present the experiment for us.
I'm saying for you, since you or
no. Go and present the experiment. Here you are preaching gravity. Present the experiment, and we'll go from there.
Which experiment would you like? Because there's multiple.
Whatever one makes you feel warm and fuzzy.
There's multiple, and you're going to deny them all. Which is why
Poisoning the well.
Which is why I'm saying you or AG, since AG
poisoning the well. Just present your data. At the moment, you've just got a cool story. You're just like the last guy. Cool story. I'm not going to present anything. You've got nothing to present.
I've already answered this question anyway. I posted in the side chat. There's 3 scientists. There's the answer to your question. Check the side chat. I'm not giving you shit else until you look at that side chat.
Which paper?
I'm not giving you anything until you look at the side chat, and I don't owe you anything either.
I'm saying which paper has Brian Reese, for example.
Now, I want you to provide me a paper that has these mainstream names that say the opposite, that claim that they don't say that, because you're the one claiming that they never said that. That's your claim.
You're saying...
So go ahead. Prove that they didn't. Prove that they never claimed that it's a pseudo-force. Go ahead. Prove it. I'll wait. Good luck.
Provide me their paper.
What you're saying is you've got absolutely nothing, so you want to shift the burden of proof onto somebody else because you've got shit. Yeah, yep. You ain't got shit.
What I'm saying is, okay,
cool. Never heard of the theory of relativity? Have you ever even read any of Einstein's work? Like, honestly, have you read any of it?
No, you're the one that's doing it. You see?
No, have you read any of it? I'm just asking. It's a yes or no question. Have you read any of it at all? Yes or no? What I'm saying is, if you haven't read any of it at all, then what are you even talking about, dude? You're trying to ask for shit that you don't even have.
What I'm saying is, if you're able to provide me any one of their papers that speak specifically about this, then I'll read it.
Oh, you're the student. You're the one in school for this, right? So you should know this already. I shouldn't have to feed you this like baby milk.
I've Googled it. They've provided me the names, and nothing's on there. No paper they have is anything related to what you said about.
So what I said is the mainstream claim to this says this. I don't have to give you anything else because I've already proven what I said to be true.
Which paper speaks about it? Because otherwise, I'm just going to say.
I never agreed to give you a fucking paper. I just gave you 3 names.
But then gravity's real.
It's up to you, student, to do your research. I answered your question.
Real.
Axie, your claim was you wanted
gravity
3
works
people
fine.
provided.
Well, you go then. That's what I'm saying. Hey, what the fuck was that?
No, gravity works fine on a flat Earth. In fact, it requires 2 horizontal baselines. You can't have gravity without a flat Earth. Good luck with that.
But you just told me gravity isn't real.
Yeah,
at the beginning of the conversation,
it's a pseudo-force. It's a mathematical framework. Yes, mathematical frameworks exist. Are you daft? Are you like some kind of clown? You don't think a mathematical framework can exist within reality? That doesn't make the math reality. I can give you an equation for how hard Superman has to slap a raw chicken in order for it to be fully cooked. That doesn't mean that there's a Superman. The math still exists, but I don't need a Superman for that math to exist.
Blood, you conceded without realizing. And maybe you did realize.
I didn't concede anything. There's no gotcha here, buddy. If anything, we might have clarified things in a way where you now further understand them. But keep on listening.
You asked for 3 names. He gave you the 3 names. That's it.
Yeah, you're not going to move the goalpost and ask.
That's broken, dude.
Yeah.
Like, seriously.
Yeah, he's trying, because I gave him what he wanted. Now he wants to move the goalpost. I got to give him something else. Then he's going to move the goalpost. I got to give him. I ain't playing that game. That's stupid. You're the one with the burden of proof.
I already got my answer. I read one of their things in the biography, so I already.
So they
no, I mean
describe
like
gravity as a pseudo force or not?
Requirements. No,
So
it
they
means that,
describe it as a pseudo force or not?
No, it's not that it's a pseudo force regardless.
Do they describe it as a pseudo force or not?
No.
But you clearly haven't read any of their work. You're a liar.
You're full of shit then.
Yeah, he's a liar.
Let me read another one of his works. 1 second.
If he's read any of it, he would have found that. So he's clearly lying.
Well, he's a physicist, so I doubt it would be would be able to find one for him specifically.
No, dude, you can literally read their work. You don't have to read something somebody else wrote about their work, because you can read their work.
Let's see if he's referenced anywhere else then.
Not to mention, Einstein said that math doesn't refer to reality in the first place.
Have you heard any of Brian Greene's works on string theory? Do you at least know that?
String theory, pseudo force. No, they don't even sound the same. Try harder.
He's literally a physicist who's one of his biggest works is on.
I don't give a shit if he's literally a garbage collector. The words you're looking for is pseudo force.
Yeah, it's non sequitur. We'd prefer not to keep jumping around. We could stick to one point at a time.
You haven't read his works.
It's non sequitur to anything because we're focused on one specific data.
But he's a string theorist, and you said that you read his works.
Cool. Yeah, and I'm saying that what we're focused on now is gravity being a pseudo force. Then we can move on to string theory if you'd like.
How does that relate to anything?
Because
that's what you've been arguing about for the last 25 minutes.
No, how does gravity itself being a pseudo force relate to anything? What I've been arguing is that gravity exists.
Well, if it's not a fucking force, then you can't sit here and claim that it is, can you?
It exists.
That's correct. It exists as a force. It is recognized as a pseudo force. Can you say that?
What does that mean to you? Because it's still a force.
A fake force, fictitious, not real.
Pseudo doesn't mean fake.
Oh, it does. It's imaginary.
Pseudo doesn't mean imaginary either. You don't even know what pseudo means. What the heck am I arguing with you guys?
Yeah, I'm quoting professors and physicists and shit, so you can laugh all you want to.
You didn't even know was a
You can laugh all you want to. If you want, you can laugh. That's fine.
I just gave you the thing, yeah. It's just most commonly used to mean not genuine, false, pretend, etc., and it's derived from the Greek word pseudonym. To lie is the original etymology of pseudonym in Greek means to lie. Yeah. So the description they gave you, hang on. So the description that they just gave you, or the definition, sorry, was correct. Yeah. So your knee-jerk answer to say, "Oh fuck, you cunts are so dumb. I don't even know why I'm bothering to speak to you anymore," was completely incorrect. Yeah.
Okay. Pseudo, if you're saying pseudo forces in gravity is fake, would mean that you don't believe in gravity. You just admitted that gravity is real.
Okay.
So now what do you believe? Do you believe gravity's real or not?
Let me explain this for you really simply.
How did he get that out of what you said, AJ?
You are the one that disagreed with me.
I got no idea, dude. All right. Axie, let me make this very clear for you, my friend. Yeah? When you use gravity for whatever you're doing on the globe, yeah, you're using calculations based off the effect, nothing to do with the causation. It's always the 9.8 meters per second squared down. Yes? Correct?
What? No.
Whenever you're doing something that requires calculations for gravity, your rockets, your orbits, all of these other things, yeah? It's based off of the 9.8 meters per second, the calculation of what we witness, things going down. It's not based off of the causation.
Neither.
Oh. So
you're talking about
not,
rocket science, right?
Whenever we use gravity for something in reality, when you want to calculate for gravity, yeah, the calculation is based off of the effect, not what the cause is.
No, you just calculate the gravitational potential of that force and its mass.
The assumed effect.
That object, sorry.
Translated for dumb fucks.
No, gravitational potential.
Yes. What you are calculating for, Axie, is the effect. Shit going down at 9.8 meters per second squared, not the causational mechanism. You seem to believe it's the causational mechanism. This is a falsity. Science to date does... Shut up. Science to date does not know what the causational mechanism is. I told you this earlier.
But you're talking about... I'm pretty sure Flying Kai was talking about the object itself, and that's related to gravitational potential. It's different.
And how do you calculate it? Using what number?
You calculate the gravitational potential.
Using what number?
A specific number. You calculate the mass of the object.
And that mass of the object times what? 9.8 meters per second squared. There you go.
You talk. Wait, but what do you talk about in itself? Because you're talking about just the object itself. That would just be gravitational potential. You just calculate that.
The outward force is fictitious because in our Earth frame of reference, it doesn't exist.
So all you're doing is clinging on to hopes and dreams. Very easy.
Right.
You were sold a story. You believe it. They gave you numbers and you believed it more. That's all.
Really.
They haven't given you science. Your definition of science is also broken in order for you to believe this bullshit model that they've given you. Here's an idea. I'm just throwing it out there. As a really cool student of science, why don't you go and test some of the bullshit that they feed you as opposed to just blindly accepting it? That would be an awesome idea.
Well, nuclear physicists, not astrologists, but okay.
Okay, so again, let me try.
You're going to need to rephrase it.
Near the Earth's surface, what's the equation that's used? It's U equals mgh, yeah?
For gravitational potential energy?
Near the Earth's surface, everyday objects near the Earth's surface, as you would call the gravitational force, yeah? The energy is calculated using the formula, the mass of the object, the acceleration due to the claimed gravity, 9.8 meters per second squared on Earth, and the height above in meters.
Slightly incorrect. If you're talking about the gravitational potential energy for an object, it would be the mass of the object, the gravitational field strength, and then the height from its reference.
That's exactly what I just fucking said.
No.
Mass of the object in kilos, G, acceleration due to the gravity, and height
you're saying
above the reference point.
Just the field strength. No.
U equals mgh is what I fucking said.
But it wouldn't be acceleration. It would just be the field strength itself, not the acceleration.
Mass of the object, acceleration due to gravity, the approximate 9.8 meters per second squared, and the height of the reference point in meters, if we were working in kilos and meters.
What I'm saying is that middle part is just the
answer the
gravitational
question.
field strength.
For everyday objects near the Earth, the gravitational force, we would
Potential
use
energy.
U equals mgh, mass of the object in kilos, the acceleration due to gravity, the approximate 9.8 meters per squared on Earth, and the height above the reference point in meters. Is that correct?
That 9.8 meters squared is talking about the field strength. It's not talking about acceleration. As in how strong.
Am
So,
I
for
correct
example, if
that
you're on
it's mass, the
no,
9.8
so
meters per second, and the height.
What I'm saying is that 9.8 millimeters squared, that's talking about the field strength. If you're, for example, on the sun, it would be like a billion.
Okay, I'm not talking about the sun.
Squared.
I'm talking about everyday objects on the Earth.
I get it.
Not the
what I'm
fucking
saying
sun.
What I'm saying is that
Axie, listen, Kev. Axie,
I do get what he's saying.
Stop talking. Yep. Bzz. Check this out. Easy Google search. How to calculate gravity field strength. The very first thing that pops up. The equation for gravitational field strength was discovered by Sir Isaac Newton and contains a gravitational constant. Right. Not to be offensive, but Newtonian gravity was superseded, about 112 years ago? Something like that?
Yeah, he's just dancing around this, But at the end of the day, if they make their calculations, it's based on the mass of the object in kilos or pounds, the acceleration due to gravity, or the downward of 9.8 meters per second on Earth, and the height above the reference point. Where in this equation are you accounting for the causation?
So, number one, you're talking about gravitational potential energy. You're not calculating the gravitational acceleration. You're not calculating that when you're talking about potential energy.
We are calculating that when we're talking about
the
potential energy.
I bet you can't go 1 minute without
gravitational. No, because you're lying, because gravitation potential energy is the energy of an object the object possesses due to its position in the gravitational field, which would be typically defined by its height above the ground. And then we're using the mass of the object, the acceleration, and the height. Now, can you please explain to me, out of the equation U equals mgh, where is the causation?
Should I just provide you these?
Where is the causation? Your argument was that you account for the causation.
I was already right. I knew you couldn't go.
Axie, pro tip, talking through people, not cool. If you're wondering why the little red flag, the mute button comes on, it's so we can hear the end of AJ's question. Because I know if you're talking, you fucking well didn't hear it. Because I can't hear through you yapping. You've made claims, and now you're getting asked to back them up. That's all that's happening. You seem to want to dance around this for some reason. That would suggest to us that you've got no idea, and you're just being a weasel. If you did know what you were talking about, and you could back it up, you would have just answered. You would have sat there and went, "Oh yes, that is just. Here's your answer." But you seem to not do that.
If that's true, then you wouldn't be muting me right now. But I bet you're going to mute me in the next minute, even though I'm going to be the only one speaking. When you're talking about gravitational potential energy, that's different from acceleration. You're talking about the gravitational field strength, which is and mass of the object and the height from its reference point.
I read it out for you.
Not talking about the acceleration itself. I
read it out for you.
Mute me and you're going to interrupt me as well. Watch.
I don't have to mute you.
If you're talking
I read
about
it out for you.
Itself, then what you're going to say is, or you should be saying, is that you're calculating the reference of the object. All right, that's what we're talking about here. So that would be saying you're referring to the gravity itself, not the acceleration.
In the U equals
what I'm
mgh, what does the G stand for?
That if you're going to go to another planet, for example, and you're going to calculate the mass of that
planet... You're not going to other planets, that's a fucking red herring. And I didn't mute you.
No, I did this time, because all I want to know of him is, in the equation U equals mgh, what does the G stand for? And what does it represent? Simple question. That's all I need to know.
Told you. I understand. You need to serve mute me when I'm speaking.
It's because you're talking shit.
Equals mgh. What does the G stand for?
When calculating what? Gravitational potential energy. The G would stand for the gravitational field strength.
What have we been talking about?
When you're talking about gravitational potential energy, the G stands for gravitational field strength. Hence, it would be
which is
J, well, in kilojoules or joules, equals mgh. Because you measure the gravitational potential energy in joules or kilojoules.
Yes.
Yes. So I was right, and you were wrong, and you kept interrupting and muting me, which is fine.
Which is
gravitational potential energy. But I'm going to get server muted again, so I might as well not.
Oh my god, you just talk in circles, dude. Where in any of this?
Why don't you server mute me again?
Where in any of this does it account for the causation?
Gravitational potential energy is potential.
What's the
causation? So potentially not there.
Of the gravity on the mass of the object, then you're just saying the gravity itself is causation.
So it's fictitious force, as we claimed earlier.
No, it wouldn't be fictitious.
Pseudo force.
It wouldn't be a pseudo force either, because it's
potential.
An actual force that's pulling on the object.
Really cool thing about potentiality, it could potentially be zero. And your mathematical equations don't mean a fucking thing. Interesting, isn't it?
It's in space. Because there isn't any.
You haven't been to space to verify this.
I don't need to go to space to
verify. So potentially another broken answer.
Has no gravitational. And I don't need to go to space to verify that a vacuum that has no gravity.
This is more claims. How are you validating your claims? At the moment, you keep spooling off cool stories, bro.
Gravity.
How do you know it's a vacuum? You've not been there.
Because it doesn't have gravity.
So it doesn't have gravity. So let me get this straight. How are all your bullshit planet stories holding themselves in orbits if there's no gravity?
Because they have an orbit.
So no gravity then?
An orbit is gravity. Space is a vacuum. It doesn't have gravity. An orbit is only dependent, contingent.
So no gravity. So if space has no gravity, the next clown that comes in here and says the moon causes tides, are you going to put your hand up and say, this is incorrect?
Space isn't the moon, lad. Space itself does not have gravity.
If space has got no gravity, it would be holding the moon. Because it wouldn't reach us. Because space would be blocking it.
Lad.
Remember, potential zero.
Yes, the vacuum of space doesn't have gravity.
So potentially you've got nothing.
Because we're talking about the vacuum of space, yes. We're not talking about planets.
So you're talking about shit. Do you know why you continue to talk about space? It's because you've got no proof of Earth curvature. We know this. We've met plenty of clowns like yourself.
The space is a vacuum. A planet would orbit around.
Don't give a shit. All crap that you... It's a cool story, bro. All shit that you can't verify.
It's called the vacuum of space. It's verified.
All things that you can't verify.
So a vacuum...
You can call it whatever you like. You can call it pink elephant's rooting. I don't care. You still can't verify it.
Well, we could just make an artificial space here, which is done.
Yep, that's great. You can make up names, but you still can't verify it.
But it's literally vacuum. Like it's an artificial thing.
And yet again, you still can't verify it. It's a claim. It's a story. Now back it up.
Do you want me to show you like someone floating in space? I mean, I can do that if you want.
And how are you going? How do you know that's real? Without going there yourself, how do you know what they are demonstrating to you is true? And why the fuck do you talk to people? You rude little cunt. How do you know? How do you? Yeah, I'm just gonna rail you. Shut the fuck up.
Go on then.
I'll ask this question. How do you know that those men floating in space are actually true and correct if you've never been there to confirm such a position?
Empiricism, simple.
Empiricism. So your answer to something floating in space is a singular word, empiricism.
Yeah, it's the same thing you use.
Yeah, there's a difference. We're using tape measures. So the only thing you can argue is the color of the tape measure. You're using cool stories. Cool stories are not empiricism.
Empiricism is simply the observation. You use observation as well. Everyone uses observation.
So when have you observed, for real, somebody floating in space?
You can observe it telegraphically.
So you've seen Spaceman telegraphically.
And everyone has a television. Everyone has broadcasts. Yes, unless you're going to say
so. So your definition of for real is via a television.
It's real, yes. It's portraying something real on a real thing, yes.
There's actors on television, son. Surely you would have learnt that by now.
But I can't observe Artemis going in through a telescope. I can't observe Artemis 2 in a telescope. But when it comes to...
So there's a difference between telescope and telegraphic. So which are you talking about? Your television? Which are you talking about? Your television or your telescope? You seem to want to jump between them.
I can use both, but you deny both. That's what I'm saying. You deny everything.
The problem with the television, number one, listen carefully. These are the problems you've got with... How about you just go, shut up, so you don't talk through me again. Number one, your claims of what you see through the telescope are anecdotal. It's just your words. You've got nothing to back that up. Number two, your claims of what you witness on the television, how can you verify that it is true and correct? There has been many a TV show. Like shit, that movie, what was it called? Sandra Bullock movie, Gravity. That looked more real than some of the space shit that they show us. So how are you going to claim that the television shows real stuff when movies showing fake stuff look more real than the real? Like seriously, dude. So both of your claims have falsities. Number one, it's anecdotal. Number two, you can't verify it. So see what else you can throw at us.
So I can't use anecdotal empirical evidence, but you reject other pieces of empirical evidence.
Your anecdotal is not empirical. It's just anecdotal.
Me looking at Artemis 2 through a telescope.
It is just anecdotal. It is your words.
And it's empirical as well.
How do you validate its empiricism?
So you just don't believe me.
You're a liar. You've spent most of the last hour lying through your teeth.
100% he has. In the side chat, right there, in the side chat from Science Facts, again, exactly what I just explained of the gravitational potential, where you keep on insisting that it has something to do with the causation and not just the effect. Please describe how the potential... Please tell me how the potential requires the effect.
What is the potential? What effect of what?
Sorry, the potential requires the causation, not just the effect.
Causation of what? What are you talking about?
The causation of gravity.
Causation of go on. Like, what is this?
You're not being...
Are you telling me
serious
to
here,
find the causation of gravity,
serious,
or are you telling me what? Like, what are you telling me?
The discussion that we were having, I said earlier that when we calculate for gravity, we're calculating based off an effect, not off the causation. You insisted it was from the causation. I gave you the equation. Yeah. I asked you where in this equation was the causation, and you said, well, that's the effect. That's the potential. The potential is the causation. The potential is not the causation.
1 second, let me read your article that you sent. Because I can't give you the benefit of the doubt.
Gravitational potential does not rely on the causation, is my statement that you keep trying to rebut, but we can't get through. Doesn't rely on causation, it relies on the position of the masses within the gravitational field, like I stated. Causation is still disputed today, like Matrix stated.
I'm talking about the object itself, not Earth. That's where you're getting the difference. I'm talking about the object itself. You're talking about Earth. Okay.
No, you weren't. You made that explicit earlier. You were talking about not the object.
That's where you're getting it from. My apologies then.
You're a lying cunt. And I mean that in the nicest possible way.
Earth's gravitational
because AJ brought up the object earlier, and you jumped straight down his throat. You weren't talking about the object.
In fact, he referenced it in his sentences as well. You're denying me, you're denying him.
Is this guy that much of a numpty, AJ? That much of a I'm superior that I have to fundy mute people, that he even talks through his own mute? That is amazing. No, you just did a reset. You're back.
All I'm asking him to do is back up his claim that whenever we use gravity in any type of equation, that they're accounting for the causation, not just an effect. And we've just gone around in circles with bullshit for half an hour.
Causation of, if you're saying like the reference object in relation to gravity, that would just be them calculating gravity.
Causational mechanism of said gravity.
There we go. Look how you interrupt me when I'm speaking. Then
You're a fuckwit. Why wouldn't I? Causational mechanism of said gravity.
Go on. You finished or?
You were asked for the causational mechanism of said gravity.
So you are asking me what gravity is caused by the whole time.
That's what AJ asked you probably 45 minutes ago.
What
I asked for was because you're claiming that the causation is accounted for. So I'm asking you in any of these equations I've given, because we're talking about potential, yeah, where is the causation in any of these? Yeah, we're talking about the effects. We're not talking about the causation. Your argument was that we account for the causation. My argument is that we don't.
Okay, so the answer would just be the mass of the Earth, which would also be enhanced by the atmospheric pressure, which allows it to keep its density. That's it. It's the same thing with a black hole, same thing with the sun. Same thing with every other planet and celestial object.
Okay, so then now you're talking about...
Sorry?
I understand what the claim is, yeah, but when you calculate, when we use this in reality, yeah, we're not accounting for the causation, we're accounting for the effect that we see. The causation of gravity is still in contention. Today it's believed it's the bending and warping of a fourth dimension, space-time. Which is what you're describing to me, which is just a mathematical construct as well. But when we have to account for gravity in reality, that does not come into the equation.
It's already proven that gravity is caused by the mass of the planet. And the density is maintained by the atmospheric pressure.
This is where you're mistaken.
And the chemical compounds within
They don't know what the causational mechanism is.
I just told you.
But he's still skirting around the question. He's still skirting around what I'm trying to ask here, Matrix. But anyway.
So let me get this straight, AJ, then. Let me get this straight. Are you disagreeing with the answer I provided for you?
What I was trying to claim earlier, or what I was trying to explain to you earlier with all this gravitational argument where you keep stating that flat earthers deny gravity, that is not the case, yeah? Because gravity itself, no one denies the cause. No one denies the effect that we see, yeah?
Right.
No flat earth is going to deny that in reality because that is what we see. When we account for this, we account for it with the 9.8 meters per second squared.
So I was wondering if you and AG were the same. Sorry about that. That's why I was confused, because I thought you and AG, as far as I'm concerned, everyone in this VC agrees with the same thing. So when AG denied that, when I spoke to him, now you're affirming it. Now I'm confused. So
I don't think that AG does not deny either the effect that we see, yeah? What I'm trying to say to you is the causation is what is the contention, yeah? Now, you may believe that the causation is the bending and warping of space-time. As far as I know, this is not settled, that there's many other proposals out there. This is their best explanation at the moment, and it's a mathematical framework. So we don't deny, if you want to call gravity the effect, yeah, well, we don't deny gravity because no one's going to deny the effect that we see in reality. However, I would question what the causation of that
another
is.
point is that why is every other planetary object round?
Say that. What? Was he speaking to me or you?
Well, no, I don't. I think he was speaking to me. He wanted to know why every other planetary object is round. Well, first of all, round is not spherical, yeah? And you're correct. When we look at them through a telescope, we don't have a 3D view of these objects, and they just do look like a round object in the sky. Secondly, sorry?
No, I said okay.
Yeah, okay. Secondly, we see these objects in the sky. Why does the Earth have to be the same as these objects? What do you see on these other so-called planets, yeah, that would give you any indication that they are the same as the Earth? Do you see plants, water, life, any of these things on these planets?
Well, I would say that there are people who are. I'm sorry, I'm walking to my apartment. But,
You're right. Do you know what the definition of a planet is?
A planetary object.
That?
So okay.
A planetary
Would you
object.
say that
That is not the. I'm only asking this for clarification. Hang on. I'm asking you this. I'm asking you this for clarification because I don't believe you actually know what the definition is to begin with. And this is why I'm trying to step you through this logically. And one, yeah, the first question I said, the first statement I made was that, yes, we just do see a circle. That doesn't mean it's a sphere. Two, yeah, if it is a sphere, why does the Earth have to be the same? What do we see on the Earth that's the same as what we see on these planets? Do we see trees, people, waterfalls, rainforests,
why is our moon,
any of these things?
Why is our moon objectively?
And thirdly, hang on.
Why is our
We're
moon
not talking.
objectively
Hang on.
a spherical?
How is it objectively spherical? How have you shown that?
So would you say that every other planetary object in our solar system is
lights in the sky
in a plane, flat?
Lights in the
sky. Did I say that? Is that what I said? Was that my claim? You look up through your telescope. I agree with you. We see something that's round. We see a light in the sky. So, what do we now see on these planets that would make you have any thought process to believe that the Earth is the same as those planets?
And well, would you believe that the Earth is flat?
Hold on.
In your words.
We're not gonna jump around here.
In your words. In your words.
We're gonna stick to the same subject. We're talking about the planets and the Earth being like the planets. So what would give you the idea that the Earth is anything like those planets? What do you see with those planets that you would see on the Earth where you could go, wow, we're one of those?
Well, because there is a amateur program in astronomics between people who have no bearings on any belief system, and so why would anybody believe that the world is flat? Because
that
you
did
believe
not
it,
answer my question. I'm sorry.
And so why would you believe that there is a global conspiracy that the world is flat?
We will get there. We're going to cover your first statements, questions, whatever you'd like to call them, first before we get to that point, yeah? You said, why are all the other planets round? So by stating that, yeah, you're claiming that the Earth is also like these other planets. I agreed with you. They look round, yeah? Not spherical,
Well,
but
they
round.
don't look
But what
round.
do
They
you
are
see?
round based off of amateur astronomical.
Round is not spherical. Yeah, round can just be a two-dimensional
Okay,
object. Yeah, a
so
circle.
based on your words, why would the Earth be flat?
No, my question was, why would you believe that the Earth is the same as the things we see in the sky? And what do you
Okay,
see?
and
What do you hang
okay,
on?
and
What do you
then
see on these
my
planets?
counter argument would be that why would the rest of the world not agree with you, and why would, for example, Russia, Europe,
Well, right now,
India,
you're not
Japan?
answering my. Right now, you're avoiding my question. Yeah,
I'm
and
not
you're
avoiding
just
your
got.
question. I'm
And all
answering your
you've got,
question. If anything, I'm answering your
no, you're not.
question.
All you have is an appeal to ad populum, a logical fallacy. So my question is, what do you see
So every
on
single
these?
country in the
What do
world,
you see? What do you
is involved in
see?
this conspiracy that
What do
the
you
world is flat.
see, dude? What do you see on these other planets that would make you believe that the Earth is the same? Do you see waters, lakes, oceans, rainforests, trees?
I own a 580 telescopic, and then I see them as myself.
So
Axie,
you look up into the
And so
sky.
hang
You
on.
see
my
lights in the
question would
sky.
be my
We've got
question would be
someone.
You see
is
lights.
Hang on.
Why does this? He's
why would
another
it
one of
be?
these.
Hang on a
Wow,
second.
dude,
Axie,
shut up.
Axie, you are you're independent here, and we just had quite a heated discussion. Am I being unreasonable here, or is he just skirting around my question with the topic that he brought up, please?
Well, it depends, because if no one's come to a concrete answer, then I'd say no one has gone further with this discussion.
No, but he's trying to jump away now from his original point.
I've absolutely answered it.
Did either one of you
You
provide
did
a
not.
concrete answer?
You did not
Absolutely.
answer it because
There's
my
thousands of
question to
pictures
you
of
was. My question to you was. Yes, I agreed. We look up, we see circular things in the sky. Now, my question was, what do you see on these planets, these so-called planets, yeah, up in the sky, that would make you believe that the Earth is exactly the same? Do you see trees? Do you see water? Do you see things that we see on Earth? What are you seeing when you look through your
That's a
telescope?
fallacy.
What are you seeing when you look through your telescope other than a circular light in the sky that would make you believe the Earth is the same as those things in the sky?
I've
That's my
answered it.
question.
Amateur
And what was
astronomers I've already like pictured them, have made sure that we have witnessed Pluto, we have witnessed Saturn, we have witnessed Jupiter,
your answer is
Uranus.
non sequitur to my question. My question
I
was,
am
what do
answering your
you
question,
witness?
and
What do you see?
you're trying to divert. But
What do you see
what I'm trying to ask
on
you is,
those
Hey,
planets
why is our
that would
moon?
make you believe
Why is
the
our
Earth is exactly the same? Fuck, is this really
hold
that
up,
hard?
AJ. AJ, our friend here's got this idea in his head that he can answer anything to the question, thus the question is answered in his mindset. I don't know why they do this. Excerpts. You are asked a question. Perhaps you should answer the question you are asked, not some pseudo question that's off in the ether that you have attracted telepathically. And then you will find you won't be talking past each other. You may actually get somewhere. And also, talking through him isn't very productive. So, I'm going to let you off mute, answer the question as to what is in the sky that is of similarity to the Earth in order for you to believe we are the same thing or similar things.
is the moon flat?
That doesn't answer the question.
Is Jupiter flat?
That doesn't answer the
Is
question.
Uranus flat?
That doesn't answer the question.
I'm answering the question because I'm telling you that
no, you're
we
not.
have amateur astronomers.
You are asked, using your amateur astronomers, they look up into the sky, they see the pretty coloured balls. What do those pretty coloured balls have in common with the ground in order for you to conclude that we are the same as them?
Then you are going against what I'm saying.
I am not going. I'm not going against anything. I am asking you the same question that AJ tried to ask you, which for some reason you don't want to answer. What in the sky, on these pretty little lights in the sky, is similar to what's on the ground in order for you to say we're the same as them?
Jupiter, Saturn, Uranus, the moon.
What about them?
Amateur astronomers have made thousands of depictions. Amateur astronomers.
I've got no problem with that. So let's get to the second part. Dudes looking at things in the sky. We've established that bit. You've said it 4 times now. I've got no problem with that as a statement. There's even flat earthers that have got telescopes and look into the sky. Yay for us. Now, what is in the sky on these Jupiters, Saturns, Mars, Uranus, moons? What do they have that's similar to Earth in order for you to conclude that we're the same thing?
You see a orbit between the moon. That's why we have a difference.
When do you ever see the Earth orbit? Because when I'm standing on the Earth, I see the sun, stars, and moon pass over my head. I don't witness.
That's a fallacy because I answered you when I said the Uranus.
How's it a fallacy?
Jupiter.
Please explain the fallacy I've just committed.
I answered Uranus, Jupiter.
So what fallacy did I just commit?
We see moons orbiting those planets, and so what is it that you have to offer?
That is not the definition of a planet. The definition of a planet.
What is the definition of a planet to you then?
That the planet, not to me. What is the definition of an actual planet? That is the definition. It's not my definition.
I answered it, but you don't like my answer.
No, it's not that I don't like your answer.
What is the definition of a planet to you?
Oh my God. A planet is a large celestial body that orbits a star. That is the definition of a planet.
Orbits.
Correct.
You said it yourself. Orbits.
Yeah. The planet orbits the star, not the star orbits the planet.
Orbits.
So when do you witness?
No.
When do you witness?
Now you have to tell me. You have to tell me why the Earth
do you witness the Earth orbiting the stars?
You have to answer me now. Why would the Earth be flat?
Dude, you still haven't fucking answered anything in this conversation.
I've answered you, but you don't like my answer.
No, you've answered questions. You haven't answered the question asked. There's a difference, guy. If I say to you, what colour is your car, and you turn around and say chickens are yummy,
that's a
yes, you've answered a question.
That is a fallacy.
Yes, you have answered a question, not the question. I don't know if you're really, really stupid or you are deliberately skirting around for some reason. Either way, same result. Why can't you just
giving
answer
him
the
the
question?
Cybermute treatment as well.
I'm going to talk about arguments. You guys have a fallacy that you don't want to answer me.
So what's the fallacy that he put forward?
You tell me.
You just claimed, listen carefully. Exit, listen carefully. You've just made a straight out statement that AJ has projected a fallacy. I'm asking you quite cleanly and clearly, which fallacy has he put forward so we can address it?
Go ahead and look at your goddamn GPS. Do you think a flat world would have
stop.
a GPS?
Go backwards. Go back. Listen,
really
you're not listening. You're not. It's not about, kid. It's not about belief. It's about listening to what people are saying. AJ asked a question. What fallacy? We'll go from there. You tell us what fallacy he committed, and we can address that. That's what we want to address at the moment. One thing at a time.
Apparently the fallacy is if you take a look at your GPS fallacy.
Saturn, and then you can see the moon.
Okay, Exotus, are you even listening? Do you know you were muted? Yes or no?
That's a no. It doesn't matter. It doesn't matter.
Excellent. So, now that you're listening, you said AJ committed a fallacy. The question on the table was, which one? It's that simple, dude.
He means?
He doesn't listen at all. This random kid just sits there talking under randomness. What fallacy did AJ put upon you that you're offended by?
I think you're uneducated. All of you are uneducated on the fact that we do rotate around.
You said fallacy. You said that AJ had committed a fallacy.
What fallacy means then?
We're trying to get out of you which fallacy he did.
I told you.
What you said
was flat.
We're just going to go. You're an idiot. It's not worth wasting brain cells on such stupidity. Unless you want to play with AJ like fair dinkum. That's dumb.
No, that's a waste of time, that one.
Like, seriously. He's had a complaint about a fallacy being brought forward. Why not just address that first up? And then go on. And here's this other one still in side chat. Gravity is still a force. Wow.
He didn't answer any of the questions. He didn't answer any questions. He answered his own questions in his own mind and ignored mine, and then just claimed a fallacy and then tried to state that the fallacy was take a look at your GPS fallacy. I'm not quite sure what that is.
Yeah, I got nothing there, man. That's some funny shit. But, like, yeah, if you're going to call someone out on a fallacy, that's not a problem. I got no issues with that at all. Shit, we don't get it at least 10 times a day. Something's gone wrong.
And then the definition of a planet was somehow a gotcha moment for him because a planet's something that orbits a star. Somehow the word orbit for him in his mind is some sort of gotcha when he was trying to tell me that a planet was something that a star orbits. He had it completely backwards.
And look at our mate has referred back to the vacuum of space. This kid is so indoctrinated. You're going to be broken when you get to finally get through all your schooling and education and shit. You're not muted. You can talk in the side chat. Probably the best place for you. Right, so I wonder if this guy's going to actually be sensible. Right.
Yeah, I was muted. Yeah, thank you for unmuting me.
Do you know why you were muted?
I don't care.
Well, you should, because if you know why you were muted, you can stop doing that and you won't get muted. How's that? Wouldn't that be a cool idea?
Me again. You guys are wrong.
You haven't shown how we are wrong.
You're wrong for.
You haven't even.
I've explained to you guys, but you guys.
You haven't explained anything.
You two are the most.
This is what you keep doing. You keep talking whilst you're muted. You keep talking whilst other people talking. We can't hear you whilst you're yapping through other people. That's what you got muted for. Every time AJ has spoke, you've decided to finish his sentence off with whatever random shit you decide to talk about next. That's why you got muted. That's why no one understands you. Because you get 10 words out and you just make a dog's breakfast. So how about listen to what AJ's saying first. He will ask a question, you can answer it. The question, that is, not something else random.
Okay, just to further this along, we'll just leave off where we were. The audience can make their own decision on who was right, who was wrong. I don't believe anyone was, because we really didn't get anywhere, but the audience can make that decision. So what would you like to go on to?
What's great is that you have muted everybody.
I haven't muted anybody. I haven't muted anybody in this channel. I'm asking you,
Your friend has.
what would you like to go? What would you like to go on with?
No, your friend has. Your friend has.
So you'd like just to talk about being muted? You don't want to talk about the topic?
It doesn't matter because you won't listen.
Well, I was the one that was actually having the discussion with you, and I don't feel like we got anywhere at all. So if you'd like to move on to something else, and like I said, let the audience make their own decision, I'm happy with that.
Audience, when everybody else is muted.
There is an audience, not just here, but also on YouTube. This is being streamed live to YouTube.
It should be. It should be, because you're wrong.
That's okay. So how am I wrong?
How many people do you have on YouTube?
In what context is he wrong?
Please explain how I'm wrong.
About? We can't have broken him after one question. You just made a statement that we are wrong. Okay, we accept your statement, and now the question follows. What are we wrong about?
You did not accept my statement.
And
you did not accept my statement.
You just said we are wrong. You just said we are wrong. Now the question that follows, what are we wrong about?
You muted me twice. You muted me.
And make that 3 times. This is why you're getting muted. You said we are wrong. Okay, I understand what you said. The question that follows from us, so we can make a conversation out of this, what are we wrong about? Now it's your turn to answer that bit.
Every planet is round but Earth. Yeah.
Was that my statement?
Your statement of what we are wrong about is every planet is round except Earth.
No.
So this is why
that you muted me. You muted me when I was
because you cut AJ off. That's why. Stop cutting AJ off when he is talking.
Can you please explain to me when I said that every planet... Oh, my God. Can you please explain to me when I said that every other planet is round except for the Earth? Because we can rewind the YouTube.
Every amateur astronomer will prove you wrong. They have no lineage to NASA, to the cosmonauts, etc.
What I've learned today is that a guy with a telescope in his backyard. I learned today that a guy with a telescope in his backyard is looking at space aliens and rocket ships.
Yeah, absolutely. You guys are absolutely correct.
All right.
Go ahead. You guys are doing great. All of you are doing great.
God. Dude, I will give you that. Okay, these astronomers, they look up and they see these round planets in the sky. That leads me back to my original question that I had to you. Yeah. Round does not mean spherical. A coin can be round. Your watch face is round. You're not walking around with a sphere on your arm, right? There's a difference. So this leads me back to my first question. When they look at these planets in the sky, what is seen that would make you believe that the Earth is just like them? Do you see people, waterfalls, rainforests?
Because the moon's orbit around those planets.
That is not the question I asked.
It's exactly the question you asked. And then I'm going to get muted again because your friend here is going to mute me.
What? You just stacked the claim of orbits, dude.
I asked what you see on those planets. I gave you the example of trees, water, etc. Yeah. Then we can talk about the definition of the planet and orbits.
Europa is known to have water. So what are you talking about?
What do you see through the telescope as an amateur that shows anything on these planets that is like the Earth to make that leap of logic that we are like what we see in the sky?
I answered it. The moons rotate around the goddamn fucking planet. But you won't accept that answer, will you?
Because it's not the answer to the question asked.
It is the question asked. I answered it.
Okay, how about I overturn? How about we try this a different methodology? Because obviously this guy does not know what similarities are. Now, Exo2s, you've gone for a walk into the forest. You look straight ahead, trees. You look to the left.
That's a strawman argument. That's a strawman argument, and I don't want to hear it.
What's a straw man? I haven't straw manned anything.
Hey, hold on. That's not a straw man. I can go outside right now into the woods, and there will be trees all around me. There's nothing straw man about what he's saying. Finish, please.
Straw man argument. Go ahead and look it up.
It's not a straw man. You don't even know what a straw man is, and I am going to
look it up. Look it up, brother.
Maybe you should look it up because earlier on you pressed AJ. You pressed. Listen carefully. You're not listening. You pressed AJ earlier about committing a fallacy. When questioned on said fallacy, you carried on like a right fucking idiot and wouldn't give the answer. And now you're claiming I am projecting a straw man. I have not straw manned you in any way, shape, or form. I'm giving you something. Listen carefully. This is your falsity. Start listening. Why are you choosing to talk shit? So let's just do it the old-fashioned way. Red flag. You go for a walk into the forest. You look straight ahead. Trees. You look to the left. Trees. You look to the right. More trees. You look behind you. Trees. Everywhere you look, there is trees. Are you now a tree?
Drama and argument.
Are you a tree when you look around you and see nothing but trees?
He asked you a question. How is that a straw man asking a question?
Do you guys know what a straw man argument is?
Obviously you don't.
It's when you say Earth is a pancake in space and the sun would light up everything.
And so we're talking about the flat Earth, and then he's talking about trees. That's a straw man argument.
No, that's not a straw man.
You said planets.
That is nothing to do with a straw man. It is a hypothetical with a question attached to the end of it. You are an idiot. You are honestly not qualified to be in this room.
Go ahead and mute me.
I don't need to mute you. I can just point out the fact. So now answer the question. If you're in the middle of a forest and you look in every direction and this is not a straw man. This is the hypothetical part.
Straw man argument.
A fucking question, you idiot. A question. Are you that
He doesn't know what a straw man. Holy shitballs. Even AJ's
I answered AJ's question.
No. You haven't answered shit. All you've done is bark straw man.
You're giving me an example, but
I'm trying to give you an example so you understand. Okay, he's one of these fucking idiots. Right. Numpty. You are stupid. Go and look up the definition of straw man. Please. It is not a straw man. Wow. It's a wonder someone hasn't posted up the definition in the side chat by now. The amount of times you've spat it out.
What happens when a bee flies away? That's a straw man.
Straw man. Can't have that. Straw man.
Bees fly.
Can't have that. Bees flying. He might fly in a way that's non-qualified. Straw man. The whole purpose of that exercise, while you're having a little mental breakdown, is so you understand things that are similar. So you're standing in the middle of the forest. You look around, there's trees everywhere. Therefore, you must be a tree. Is this statement true or false?
I'm gonna post this strawman argument for you guys, so you guys can absolutely
excellent.
understand.
When you post it, then we're going to read through it, and you can indicate to me how what I asked you was a strawman statement. So please post your definition of strawman in the side chat.
No, absolutely, absolutely.
I'm not looking forward to going through this, mate.
You have that? Do you think you have that?
You haven't posted anything.
I'm posting it right now.
I'm waiting for it to appear. You may be a level 2. I'm not sure. What level are you? There he is. So he's asked AI the definition of strawman. A strawman argument is an informal, logical fallacy where someone distorts, exaggerates, or misrepresents an opponent's actual position. Okay, so let me go through. Why are you laughing? Let me go through what I asked you. If you are standing in the middle of a forest...
Go ahead and read it. No, go ahead and read it all. Read it all. Read it all.
No, we're going to go through it one step at a time. I will read the whole fucking lot so I can make you look like the tard that you are. So, the question I put forward to you was, if you are standing in the middle of a forest and you said straw man, in what way, me asking if you're standing in the middle of a forest, does that distort? No. Exaggerate? No. Misrepresent? No. An opponent's actual position to create a weaker, easier to refute version of that argument. Your argument was looking at planets and things through a telescope in the sky. What I said had nothing to do with telescopes, had nothing to do with planets, and fuck all to do with the sky. So it is not a straw man. You are a clown. You are an idiot, and you've got no fucking idea what you're yapping on. Please leave.
I think before we move on, guys, just to see whether this guy, we can actually have a conversation with this guy, Professor Triangle, I think we need to know if this guy even knows what a triangle is to begin with. Maybe we can check that out.
Oh, I'm here. Yeah, I'm here. Hey, dude, do you know what a triangle is to start with? That's not a straw man, it's a question. You can answer anytime.
Maybe he's Googling it.
Oh, all right. I got to give him some time. Sorry.
He's typing something in the side chat.
We need the triangle examples.
What did you say? What did you say?
Do you know what a triangle is?
You can try and humiliate me, but a strawman argument is...
I asked
you're doing a good enough job.
You know what one is. If you don't, I will tell you.
Logical fallacy where someone distorts, exaggerates, or misinterprets an opponent's actual position.
This just shows... I'm going to do a gin. This just shows, ladies and gentlemen, the IQ level of the interlocutor here, because that was just read out for his convenience.
Go ahead. Go ahead. But a strawman argument, you already fucking had it.
Let's go back to my question. Do you know what a triangle is, yes or no?
I'm not going to answer your question because...
Why can't you answer these? It's not a fallacy, dude. I'm going to show you something.
It's a question.
You can do this with everybody. Why are you guys afraid to answer me when I ask questions?
No, you guys get scared. Why are you guys scared to fucking read goddamn text when I post it?
We did read it. You chose not to listen to whatever reason. I don't know.
You did not read it. You did not read it. You did not read it.
Oh, go on mute, you fucking sped. Holy shit. Sorry, guys. He's almost dog shit. Like, seriously.
Who's the other Glober then?
No, the other one ran away as well.
The other one just wanted to preach about gravity. Didn't matter what we told him about it. Gravity in space, gravity in space, gravity in space. He's some what was he learning? Physics.
I don't know.
Physics. It was some high end shit that he said he was learning, which instantly made him an expert.
It must have been his first day.
Nice. I can't believe this clown. He gets asked what a triangle is. That's a straw man. Exertus. The question was, do you know what a triangle is? So let's read it out again. A straw man argument is an informal logical fallacy where someone distorts. So being asked what a triangle is, that's not a distortion of anything. Exaggerates. Being asked what a triangle is, no, that's not an exaggeration. That's a straightforward question. Or misrepresents. No. Being asked what a triangle is not a misrepresentation.
Maybe he needs to know why I'm asking. So, I don't think English is your native language. Maybe I'm wrong, but sometimes we have to make sure. So I need to know if you know what the term triangle is or a term circle or any of that. But you can't, for some reason, you won't answer me. Can you tell me why you won't answer me? You cannot tell me why you won't answer me? Wow. It's scary. It's scary. As soon as it's a simple thing. He wants to talk about everything else in the world. I say, do you know what a triangle is? Oh, that's the end of it. End of the conversation.
Ask me if I know what a triangle is. Maybe it's some kind of magic spell you're putting on people.
I don't want to give it away now. So, if you don't know, then we can't. He's probably Googling it. Use Bing, dude. Then you won't get like that AI overview from Google. Just use Bing. It'll give you like a scientific answer. That's what you're looking for.
I just thought it might have been something in the wording. What is a triangle? Crayons are yummy.
I said, what is a triangle? Why are you making fun of me? Or whatever. It just went right to something
You're strawmanning me. He said you're strawmanning him.
Gosh, you guys are so smart. Oh my god.
Why is it you can't answer a basic question?
Why can't you answer me?
You guys are so smart. You guys are the best.
He's having a meltdown.
Jesus.
Dude, what is wrong with you?
Are you okay?
That's why nobody talks to you, dude. That's why you don't have any friends.
Yeah.
He's toast.
Just so you know, we're not a counselling service. We break people. We don't fix them here.
No,
My whole job is
I
to make
believe
you
the
cry.
world is flat
My whole job is to make you cry and stay up all night worrying about the Earth. So now all weekend, you're gonna worry about flat Earth people.
I don't worry about it.
You do.
I came here to show you guys.
You
guys are having a fucking
troll
heart
flat
attack.
Earth. You can't troll flat Earth. Earth is already flat. How do you troll it?
That's
not trolling.
Flat, and I'm the
trolling,
best.
dude. That's not trolling.
That's making yourself look like an idiot.
Yeah, it's not trolling.
That's not trolling.
Let's go, guys.
That's not trolling, dude. You don't even know what
that is.
No,
it's not. Absolutely not. Yeah, let's go, guys.
Doesn't know what a straw man is, doesn't know what a troll is. You're not very good at this, are you?
You're not very good at the internet, are you? You've never heard of the internet before. I mean, if you don't know what a triangle is, do you know what the internet is?
Don't feel bad. I've got friends that we could nail two planks together and tell them it's a computer. So you're in the same category as them.
Flat.
flat.
What'd you guys do to this guy?
We broke his brain.
What happened? And what did you say exactly? You tell him space is fake or something?
The triangle thing flipped him.
Just me asking him if he knows what a triangle is?
It's a square.
See, he doesn't even know that. Wow. Do you know what a square is? Tell me what a square is.
You.
Wow. Are both bots in here? Good. Hey, dude, you're going to be famous.
He mustn't be able to read either because your name's not Professor Square. It's Professor Triangle. He can't read.
No, but triangles are not that cool. Triangles are not as good as squares.
You can't make a square without a triangle, dude.
No, but triangles are not that cool. Squares are cool.
Clear? Or queer like you? Did you say clear or queer like you? Say which one you meant.
I mean, it's on your mind, bro. It's on your mind. It's
what
fine.
Did you
bro.
say? Did you say queer like you or clear?
Listen. I accept you.
Listen,
and you are who you are.
Conversation if we don't know what you're saying.
And I love you, bro.
It's Pride Month. I know what I'm choosing for
Are
him.
you drunk? Are you drunk?
It doesn't matter who you are. I love you.
Wow. It's amazing what happens to people. I don't hear people going crazy on TikTok. The Globers like mind their own business. They come in here and they think they can go crazy, and then when we shut them down, they just lose their absolute mind.
You shut me down. Yeah, go ahead and edit that.
Shut you down. I asked you what a triangle was, and you started talking about straw man fallacy.
No, you're so cool.
Why can't you even answer that? You
afraid? Because he can't.
You afraid?
You guys are so cool. You guys
You're
are
in the wrong room, dude.
You guys are
you don't even know what a triangle is.
Not trolling.
You're in the wrong room.
That's not trolling. When you go into a room, dude, when you go into a room and say, you guys are so cool, that's not trolling.
You get a little blessed.
Yeah, it's not trolling. So I troll you guys.
Yeah, but the blessed.
I can also speak perfect English.
The blessed.
What a spiral.
Oh man, this is classic. Classic. Now that I'm officially on TikTok, I will be doing live stream probably. I'm not going to give a date yet, but I am going to do experiments on TikTok. How do you guys like that?
I like experiments.
I'm going to prove that air pressure is what makes water turn into a liquid.
Make sure you let us know when you're streaming that. I want to see the meltdowns.
Oh, yeah, definitely. I just trying to figure out how it all worked, and now I kind of know, and want to make sure when I do it, I want to do it right and follow the right rules. I don't care about making money on the shit. I want to make. I like I get paid by Globers crying. That's my money. When Globers have a meltdown, I can sleep at night. I can sleep at night. Are you mad at me?
Yeah, I earn more than you, you fucking loser.
Why are you angry at people?
No, my bad. I'm sorry.
Turning water into liquids? Who the heck are you fooling?
What'd you say?
You do know that water is liquids, don't you?
Only if there's air pressure around. Did you know that?
No, Chrissy, don't twirl him. No, don't twirl him. He's super puppy.
He had to go Google what I asked him.
No, everything changes.
These guys can't even think for themselves anymore. All they can do is go ask AI now. I can't wait until
change the state from one state to another. by temperature and pressure.
Oh, so air pressure. Yeah, thank you.
So what holds water on the Earth? Is that
I'm glad we agree now. I'm glad we
Water is
agree.
a liquid. Water is a liquid. It's in a liquid state.
Only in air pressure.
No, liquid. No. Quizzy.
If you remove the air pressure, you won't have the liquid anymore. So I win. The end. And that's about that for you guys, huh? You guys don't know what to say to that. You Googled it and it said Professor Triangle is right.
Fuck, that's 2 in a row in a matter of
but
minutes.
by reducing that pressure, you're already reducing that temperature already. So it's just not alone pressure.
Oh, yeah, it is.
By reducing the pressure, you're reducing the temperature? Is that what you said? Are you sure about that?
Yeah, dude, I can do it when it's 0 degrees outside, or I can do it when it's 100 degrees outside. It doesn't matter what the temperature is. I can still make water disappear.
Yeah, no, this Chris, she was saying that when you reduce the pressure, it reduces the temperature. I think that's backwards, yeah?
No, it gets colder.
It does, all right. But boils off due to pressure. Or
Yeah, there's nothing pressing down on it.
Correct.
Force it back into a liquid. Did the guys cry and leave already? I'm not looking. I'm outside walking around.
I muted the other dude who was interrupting constantly, and he ran. Yes. Because wasn't there the astronauts? Some of the first astronauts that went into training, they put them in a vacuum chamber, and their suits didn't work, and I think they said their spit boiled off. Yeah, their spit boiled or something.
Yeah, one of them. They get down to about 6, and his spit was starting to bubble up, and he passed out. The only reason he survived is because they had a secondary chamber, and they could when they started raising the pressure again, the other guy that was in the secondary chamber could get into him quicker. If it wasn't for that, he was as good as toast.
I like my new Bluetooth glasses. I can hear everything. I don't have to have my phone anymore. That's because Earth is flat. That's why we have technology, Globers that are listening. I don't want you to get confused thinking that I have Bluetooth glasses because the Earth is a ball. Now to figure out what I can actually do with these things, because that's what I do for a living. Let's implement this technology to really, let's eliminate more people so they can go stay home and watch TV all day. That's what people want to do anyway. Most people don't want to work. I love working. I'm doing a bathroom right now. I just took a break. And that's not even my job. That's a hobby.
Holy shit, guys. That was the longest running clown car I've been near, like, forever. They started, I think it was about 6:30. So that stupidity was running for like nearly 6 hours.
And that was the troll?
No, there's many of them. There's, I think, in total, we probably did about 6 of them, eh?
Yeah.
Oh, I thought it was playing the long troll, because that usually means when you're there for 6 hours that you're actually afraid to even leave now, because now you're going to miss something.
Multiple clowns. Like the long bus came in.
A little clown car came into the circus tent and fucking they all started piling out.
There's where I live.
Oh, nice.
I live in a tiny house.
Is it like the Doctor Who TARDIS? You go in there and it's just fucking massive inside?
Go inside, it's 5-bedroom, 4 baths, big living rooms, all that shit. Yep. But from the outside, it looks small. So, for all you roofers out there, that's only one layer, and obviously the wind is damaging my house roof, because that's my house. I should just be able to just put a layer on top of that, right? I don't want to tear that shit off.
Corrugated iron over the top if you're in Australia.
You'd have to talk to Timbo about that one.
He's got the default 2 chairs out the front, so you can sit and have a beer with one of the boys.
Well, I don't have any friends. I'm hoping. That's a hope chair.
Oh, nice. Next time I come to the States, I'll have a beer with you then. That's a plan.
Yeah. I park all my cars are in the garage. It's right in the back. You pull in the back of it. It looks small, but it's really big on the inside. Oh, since we don't have to have our front plates anymore, I can see if I can get both of these in there. Here's what I drive all day. Yeah, Ohio stopped having us have to put front plates on cars. Black is such a nice color. Almost everybody in this neighborhood has a black car.
Yeah, black cars are tidy.
It's just really rough to keep clean, but when they're shiny, they look nice.
Where's my black car? Everyone should have a car that's... Loading. There's mine. Badass.
What is that?
2002 Ford Falcon XR6 Turbo Utility. And that one's slightly modified.
We don't even have that here.
I know.
Gray cowboy boots. I don't wear shoes when I'm outside unless there's 1 inch of snow on the ground. If there's no snow on the ground, I don't wear. If it can be freezing. If there's no snow, I don't wear shoes outside either. I only wear them to go to work. Otherwise, I never have shoes on. And we didn't have to wear them at work. I wouldn't wear shoes to work either, because I take them off when I'm in my office. You got to be grounded. That's not that phrase wasn't created just for fun. And all of a sudden, magically, 2 of the kids are listening to me, and now the grandkids are running around barefoot, and they're not getting as many things that you catch from school anymore.
Amazing how that works.
Your kids need electricity. Let them run around in the grass. They'll get charged up.
That's interesting. So I'm also getting shock therapy on my foot for torn ligaments.
Yeah, same thing. Well, your whole body is electric. I mean, without electricity, you would die.
Yeah, for sure. I didn't know they actually did shock therapy like that for healing, though, but apparently it can actually help heal bones as well. But it bloody hurts. Feels like someone's whacking you with a hammer on the top of your foot every time it pulses.
You figured you would have been used to that from the psychiatric hospital and when they were giving you brain shocks.
Yeah, but that was my head, not my foot. Now it's on my foot.
That's gotta suck. Top and bottom. Zap, zap.
Yeah.
Do they I was gonna make a joke about polarity and shit, but never mind.
I wish my saw blades would get here. I gotta put down concrete board. I gotta cut a circle, and I really don't feel like drilling holes and carving this thing out of concrete board. I want to just use my diamond blades. I'm standing here waiting and cut the circle, and then I can move on with that whole thing. I have to cut the toilet out, and then I can move. I can just do the whole thing. It only take me an hour to put down this floor. Let that dry, go get the tile, put that down tomorrow. That bathroom's done. Then we just decorate. And I'm doing all of them, by the way. So I'm doing 4 bathrooms in the house all at the same time.
Dude, in real life, you wouldn't say shit to me, you know that, right?
This is real life.
About bathrooms.
Shit.
About bathrooms? You should hear me. You should hear me at work. Dudes are like, "Why you're doing all 4 at the same time?" I said, "Yeah, but there's a reason behind it. There's a reason behind it because it's cheaper to buy all that material at one time."
Bro, but once I pull up in real life and ask you these questions, you would fucking not say a word.
Come on over.
Excellent. So what's the question? Put forward your question.
You know damn well what the fucking question is, you fuck.
What is it? What's the question? Go ahead, I'll answer it.
You wouldn't say shit, man. On here.
What's the question?
I say shit all day long.
You say this all the time, but in real life, you would not say this.
Oh, you got a violin.
Fucker.
You got a violin for you.
Emotional damage.
Aww.
You got big balls on the fucking internet, huh? You fuck. You little fuck.
Are you mad at me?
How about I fuck you in your mouth if I see you?
You like that?
Oh.
Dude, that's gross, dude. That's gross.
Yeah. Let's go now, bitch.
Only Globers like to do that stuff.
The language on you. You blow your father with that mouth?
He does. Don't keep him muted.
Son. Oh, he ran away.
What a degenerate.
Oh, we got another one. What's wrong, Poet Pat?
Nothing's wrong, dude. Everything is good.
Yeah, don't keep that guy muted. I want to hear more stories from him. I like that.
He's gone. He's broken.
Aww.
He sorted himself out.
I guess maybe
so the Earth is round.
I said this to my manager the other day because we were talking how our team just upsets the whole foundation of our company. Just these 12 people. It's just bad. The people don't like to see us coming around because it's bad news.
Get the rest of them in here.
Huh?
Get the rest of them in here.
And I said to my boss, I said, maybe it's my delivery when I tell him about automation. He started laughing. He said, it's definitely your delivery. You scare people. I said, that's my job. Make you start thinking. I think I might have gained another stalker. I bet you he's mad because I couldn't Gray cowboy boots? No, those are my white pasty legs. See, barefoot. Old dude's checking out my legs.
Anyways, Pat, welcome to the room. You just caught the back end of some excitement.
Oh, g'day, mate. How you going?
Pretty good. So you had AJ, you hot micing, or you trying to say something and it sucks?
No, I'm just hot micing. Sorry, I was going to say something, but I lost it.
What are you guys talking about? Flat Earth?
Well,
what are you talking about?
Pat, if he's got any questions, but anyways, yeah, if you want to
I've got a question for Matrix. That fucking you.
What about it?
I want to know more about it.
About what?
XR6 turbo, slightly modified, 420 horsepower up the floor.
Those rims are formidable.
AI anyway. He did that really quick. When I showed my cars, he went into AI and said, draw me like this Ford truck black, please. And he did. So don't believe him.
Oh, okay. But anyways.
Yeah. Oh, it's a nice rig, mate.
Because I've never seen them before. That's why they don't exist.
1,070 foot-pound of torque at 4,200 RPM.
What do you go sideways down the street?
Yep.
Just go sideways when you take it.
That's a drift machine. That is.
It hauls, man. It's dangerous.
It's a pickup truck. It's got no weight. I can do that in my Toyota. So you got to be just going sideways down the street.
I love the.
Yeah, but I could put a ton in the back of it and still go sideways down the street.
We got mine so I can run the Home Depot and put the dogs in the back and shit like that and not ruin the other car.
Yeah, that's fine. But you can't get in a street race with fucking other bloke. Unless you're in this type of car. And then you can.
I'll race Matrix in my wife's.
Those XR6 turbos are beasts, man. They're so quick.
Fucking A.
Yeah.
Yeah, good fun.
If you compare that to a Maloo, like it's probably,
quicker
on par.
A stock standard turbo 6 and a Maloo side by side, the 6 is quicker. That's stock, but as soon as you modify them, totally throws the numbers out to shit. It just comes down to who gets grip. When both of them are wound up, like you get the Maloo cammed up, you get the turbo boost run up, and even with the 8, you chuck a Magnus and Hart supercharger on it, Yeah, easily north of 800 horsepower. But what's interesting about the 8s, they don't seem to generate torque. They seem to get really good revs and really good horsepower, but their torque levels don't seem to go up much. Whereas with the 6, the straight 6, when they up the boost on them, the torque levels just go through the roof. Horsepower goes up all right, but yeah, the torque levels are just insane on them. So, yeah, different.
So you're a Ford man?
Yeah, I got a couple of them. 2 XR6 turbos, a 78 XC, and a 2003 XR8 sedan.
Fuck yeah. Are you
are those cars made there? You guys have Ford there? Or are they just made right there? Is that why we don't see them?
They used to be, not anymore.
I'm just trying to figure out why I've never seen that before, that car.
Specific to Australia, that's why.
Yeah, because Americans don't like these type of utes, man. They make fun of them. That's why. Like they're not common because they're a low set ute. Like,
see, there's the sedan version, a 2015 sedan version of that ute. And yes, I did swap the rims over because I like them on my sedan.
Yeah, I think it's funny. Like I think it's funny why Americans don't like this type of car.
Like these two utes went shopping today, and all they got was some chips and pop. Is that what you guys call your trucks? Utes?
Utilities.
Yeah, we call them utes, bro. Utility vehicles.
Ah, gotcha.
So think your old what is it, El Camino?
Yeah.
Same thing.
Yeah.
Basically, a car with the back of it turned into a ute.
That's what that is. Oh, okay. Yeah, I was gonna say it looked like an El Camino to me.
Yeah, exactly the same. Think that style. Yep.
Yeah, they don't have those anymore. They sent those to Australia, and then they said, "Don't embarrass us anymore with those cars." Same with the AMC Pacer and some other ones. Gremlin.
Yeah, Hemi Pacer. They come over here. They were pretty tidy. See, we get a lot of your styling over here in slightly different ways. So for us, we've got Holden. Over in the States, we've got Chev, which is under the banner of General Motors. So Holden's just another offspring of GM. So we'll grab some of the stuff from the UK, some of the stuff from the US, some of the stuff from China, and they mix it all together, and we get little bits and pieces of everywhere, and they put Holden badges on it, and ta-da, done. So we've got, what is it, the Holden Captiva over here is the Chevy Equinox in the States.
Yeah, and the Holden Monaro in Australia is got another badge in America, right?
Yeah, so what is it, something CBC?
Crazy.
Yeah, it's a Chev.
You guys drive on the wrong side of the road in Australia too?
No, we drive on the right side of the road.
Yeah, on the right side of it.
Okay.
We drive on the right side.
I went to the States. I've seen you bastards driving on the road. I've witnessed it myself. It was fun.
We drive on the right side of the road, which is the left side of the road.
Yeah, exactly. Yeah.
Yeah, so the right side is actually to drive on the right side of the road, so you don't hit anybody else. Because if I drove in the left lanes that are coming at me, I would hit somebody. I don't know what you guys get confused about.
Actually, when I was driving over in the States, it did actually feel quite normal sitting on the opposite side of the car, driving on the wrong side of the road.
You're not taking into account, Professor Triangle, that we're all driving upside down over here.
Exactly.
Are your cars like European cars, or are your cars like American cars with the steering wheel? Or you got both?
No, it's
right-hand drive.
It's on the right side?
Yep.
I've seen a couple of people driving cars around like that. It's funny. Like
it stands out, doesn't it?
Brought over.
One of the funny things when I went to the States, I'd just driven from the airport, LA, all the way up to Portland, Oregon, visiting one of my mates up there. I get out, go inside for a while, and he goes, "Oh, we'll go for a drive so I can show you around town." It's like, "Oh, mad." I walk outside, and my natural thing is, as a passenger, to walk to the passenger side of the vehicle. Nothing out of the ordinary.
Yeah.
I walk there, and he's like, "Dude, you're not driving." And it actually felt super odd sitting in a car knowing where the steering wheel should be and it's not there. It's a really weird feeling.
Yeah, no, the steering wheel is supposed to be on the left side.
Yeah. When I went to America in I think it was April 2 years ago, and I drove around Hawaii, the big island of Hawaii in a Jeep, and as soon as I left the airport, I was like, "This is not right. I don't feel in my element." It fucked me up. Like, it was difficult to get my grip on that side of the road. And then went to America and drove from Palm Springs all the way up to Horseshoe Bend, and then back down to Las Vegas. Like, did that big loop, and yeah, the States is dope. It's cool, but one thing that I noticed is I was on the highway, like coming into Las Vegas, and it was just like, bumper to bumper, because there was a guy that had a fucking screwdriver as a weapon trying to fight the police as he was jumping like over the barriers of the highway. And I was like, all right,
want to go to jail.
I'm in America.
Yeah, he didn't want to go to jail. Las Vegas jail.
Yeah, dude. That happened like a few times on the highway as well. Just like,
I don't know how fast you guys drive there, but the other day somebody said, "It's 87." I was just driving my normal speed. It's just part of the highway. If you're in the left lane, you're doing between 80 and 90. That's
Our speed's over here.
Or move. That's miles per hour. Yeah.
You would do your head in over here with how slow we're.
Oh no, yeah, that can't happen to me. I got to drive like an hour every day. I want to do it in like 45 minutes.
People fly here in Europe. The speed limit's like 160. So I'm used to Australia. So I'll be thinking I'm flying doing 120, and then these freaking soccer moms will just fly past me at like 180
in their Porsches, in their Porsche Cayennes.
Yeah. There's so many like high end BMWs and Mercedes. Yeah, they just fly past these things.
Well, it's like almost like people turn their follow the person in front of them on, like I do. It's almost like it's what we use the left lane for. Once you get in there, you just hit. I set it for 100 miles per hour, and whatever the guy in front of me does, I'm doing that too, and I set my distance. That's it. And touch the steering wheel every once in a while so it doesn't yell at me. I just go with the flow, basically. If they're doing 87, then so am I. I don't know what that is in kilometers per hour.
I think it's 160.
Okay.
I think so. Yeah, I think it's 1.6 to 1.
140. 87's 140. Bang on.
Oh no, I meant 100. 100 miles per hour is 160, isn't it?
So I live in Japan right now. I've been in Japan for 3 years, and driving on the highways here is a different type of experience. Like if you merge into traffic, people like put the hazards on to say thank you, and I'd say like maybe 60% of people will do that, but then you're in the fast lane and you're going like 100 k's an hour, and then you've got like a dude coming up behind you going 160. Like, like the fast lane in Japan is like fucking no holes barred. It's like whatever your speed, that's okay.
Yeah,
So our
yeah, it's
speed
like
limit on that highway is 60 miles
Right.
per hour, and for
Yeah,
us,
yeah.
the one that I do 87 on, so I'm doing 27 over, and that's I think they just gave up trying to give out tickets to people because all the new cars will just do that fast and stay. Everybody,
Yeah.
there's less accidents now, especially the route I take. I used to hate driving that way because people don't know how to drive. So I go to work earlier than everybody else, so I'm not in their traffic. So when they're learning how to drive around Dead Man's Curve and with sun glare in your face because it's your first time driving, I don't want you to hit my car.
You know something really interesting? When I was in the States, one thing I actually found, which is absolutely phenomenal, was driver etiquette. If you think people are fucking idiots in the States, you want to come over here for a visit. Drive through Perth, drive through Sydney, drive through Newcastle, drive through Melbourne, and you'll get on the plane and fly back and go, you know what? I'm so glad I'm going home.
Oh, fucking A, bro. I think I actually appreciate being in Japan, not being in Australia in terms of the road rules, or in terms of being on the road as a driver, because what I realized about Japanese people is like, even if they're dumb, they have like more cognitive ability than most Australian drivers do when it comes to fucking like being on the road.
To give you an idea of the awesomeness of some of the drivers, we've all been on the freeway before, or highway, whatever you want to call it. There is on-ramps. So you're coming from a suburb onto the highway so you can get to where you're going. Now, our problem over here is because they are so hardcore about people speeding, they will put the sign to tell you what speed to do at the merge point of the highway and the on-ramp. So we get these fucking idiots that will come onto a highway that is already doing 110 plus, and what will they do? 55, until they get to the sign that says do 110. So they are coming round a corner and they are hitting the dotted line to merge, one of them doing 55, the other ones are doing 110. This is what we get here on a regular basis. So in order to combat that, your average driver will sit in the fast lane.
Yeah,
crazy.
It happened to me. It happened to me like 3 days ago, man. I was on the left lane because I just got onto the highway. On the left lane, going about, I'd say 80, and then the merge lane starts, but this dude like fucking was going about 40 kilometers an hour, like already merging into the lane with his blinkers on. That's like the thing in Japan is like there's so many old drivers. Like most of the incidents that occur are from older drivers because they don't like maybe like they don't really like check older people as much as they grow older, whether they can still fucking drive like at all. And majority of the accidents that occur are from older people that just like fucking merge onto the highway going at 40 kilometers an hour and get hit in the side and then roll their car. Common occurrence.
So the old guy cannot get to his destinations because the fast guy wants to get there first. Got it.
Yeah. I think the old guy should get a taxi instead of trying to drive himself.
You should stay home.
I should stay home.
And get Uber Eats.
Oh, should I?
Yeah.
Yeah, okay. Thanks for your input, bro.
Yeah, instead of bashing into the old people.
I didn't say I bashed into it. I just told you what happens when I look on the news every day.
Yeah, it's not one party's fault. It goes
Yeah,
both.
I agree.
When my grandma was about 80 years old, she was still driving her first car, which was a 1966 giant Valiant, and it was freaking immaculate, beautiful car. Anyway, she got to the point where we were getting calls from people, and they're like, "We just saw Mari driving down the wrong way, like the wrong the wrong way down the highway," and she would just be cruising in this giant car. She was about 4'11", barely see over the steering wheel, and she ended up just cruising around in this giant car. It's the biggest traffic hazard you could ever imagine. Somehow her car didn't have a single scratch on it, but yeah, old people should definitely take taxis at a certain point.
Maybe the highway was designed wrong.
Yeah, maybe that was the problem. See if I can find a picture of the car. It's a freaking awesome car.
Maybe it's the fault of the highways. Maybe we shouldn't have any highways or cars. It should be all trains and bicycles. That's the problem.
Yeah, maybe Jamesy.
Or also saplings, you know? No car accidents if everybody was traveling on saplings. No car accidents. No car accidents if everybody was on trains or bicycles. Problem solved. I mean, we got teenagers killing families, you know that, right? They're not old. They fully capable of driving correctly. They get in the car, murder people. You got military people killing people as well in their cars, just going fast and hitting a family. They survive, but the family's dead. Very fully capable people. It might be brainworms. Who knows? And here there was this lady just driving her car, not old, just like, mid-age, and she pressed the gas pedal instead of pressing the brake, and she killed a mom with her baby. Run them over. Mom was on her way to Target just to buy groceries with the baby. That's why we should test all globers. And whenever you get the test, do you believe the Earth is a globe? Yes, you failed the license test. You wanna get a gun? You believe the Earth is a globe? Yes? No gun for you. Can't figure out the floor. How are you gonna figure out how to use a car or how to use a gun? If you're a globe believer, no driver's licenses, no gun rights, and no voting rights.
Gravity.
What, the gravity of the situation? Yeah.
Refraction.
Imagine Glober has an accident in the car, argues refraction. It was refracted. It's not my fault.
I was just telling you what the globe arguments are. That's all they got, really.
You're saying they argue like parrots? You know how parrots say words without knowing the meaning? Gravity. Refraction.
That's the one.
Bucko.
It's a globe.
Bucko. Caw.
Science.
That's a good one. That's the best argument.
Max is science.
How do you know the Earth is a globe? Science.
Why would they lie?
Why will they not lie?
Why would they lie about not lying? I want to know what happens when we fall off space and what's underneath space and what's above space.
You fall to the floor, obviously.
Because you have to have an edge if you got space.
Bro, what are you talking about, man?
I wonder how many globies can tell me where the end of space is. What does the edge of reality look like? It's Sunday today. It's half an hour into it now, but it's probably not officially Sunday for you guys. So
Are you in the future?
Yes, I'm from the future.
So Saturday for me.
I'm here to tell you that the Earth is not a globe because I'm in the future now. And if we're traveling through space, where are we going? And where did we come from? All these silly questions we get asked right back at you. And how does your life benefit you knowing that it's a globe? How does that improve anyone's lives?
You enjoy
Another
sci-fi
question.
better. You enjoy sci-fi movies more.
Me personally, not really. Because I could watch a cartoon and it'd be the same sort of thing. Just as real.
Yeah, but if you believe in the globe, you know that somewhere in a galaxy far, far away, Star Wars might be happening.
It's so far. So big. So you guys, is it, what time is it over there, roughly? Is it
Midday.
noon or midday? Yeah.
Noon.
So you have stars below your feet.
I got ground below my feet, bro.
Yeah. But under the ground, there's stars.
I don't know.
That's what people tell me. I think it's funny as well, but people actually believe there's stars below the ground, under their feet. Very weird.
Every time I look below my feet, there's ground, bro. No stars. To see the stars, I have to look up, not down.
Yeah, they're always above you. I don't know if you can see the moon at all out there, but it's set here about half an hour ago. About a 3/4 moon. So the app is telling me that the moon has 13 hours of visibility throughout my day from moon rise to moon set. So it's 13 hours. So that means it'll go right around a silly globe in 9 hours. No, 11 hours, sorry. So it takes 11 hours to go back around, and then 13 hours I'll see it for. And the sun is just under 10 hours from sunrise to sunset. So then you guys have it for 14 hours in the north. Generally, the moon lags behind the sun by about an hour, like give or take a bit, maybe 50 minutes or so. So it's kind of weird. It doesn't really, you know, something's not adding up. But yeah, that's just interesting observations. Doesn't really matter. Not flat sky, it's flat Earth. I need to get a good camera to get good visibility here. And this Great Australian Bite. That's what it's called. A big giant took a bite out of Australia, and now it's called the Great Australian Bite. Which there's this really weird looking alien face in Antarctica. I don't know if you've seen it. It's kind of freaky looking. You could probably Google it and find an image of it.
You mean like a Mexican face?
A space alien kind of face.
Also, it's a fantasy thing then. Because the only space aliens we ever seen is like cartoons, right? Or movies. The only idea of space aliens that you have is TV. Hollywood. Disney. So if you see something on the Earth, that's not a space alien, is it? It might be alien to you, but not from space. If you see a Mexican in Australia, that will be alien to you.
Yeah. Yeah, I just posted it. That's sort of on Antarctica, sort of south of New Zealand.
Let's see this alien.
So that's about 700 meters from its chin to its forehead, or top of the forehead, 700 meters. Anyways.
Finding these shots. Okay, there it is. Where's the alien you saying?
Did you see the image I posted?
I see the image, but I don't get what you mean by alien face or...
Tilt it to the side.
Oh, okay, I see it now. That would be like a giant face, not an alien face, bro. A giant.
Like an elongated head almost. But yeah, I don't know. It's pareidolia. You can make faces in all sorts of things, but I just thought it was kind of funny.
See, the snow is falling from the top, so it's like half a head.
It's like it's melted or something, or
yeah. So it's definitely a bunch of snow. Cool one. I've never seen this one before. Looks pretty cool.
Yeah. Yeah, seen some weird stuff down in Antarctica over the years. Like,
So was you
even like
looking around on this? Someone sent you this?
I found a video.
Okay.
Yeah, it's in my video feed, and so I looked it up myself just to see if it was there or not, and it was there.
Yeah, in probably that year's Google Map imagery. Well, I wonder if there's an updated imagery that shows the same location.
Yeah, well, a
Because you know
couple of years ago there was.
the topography changes, the snow melts and then snows again, that kind of stuff.
Yeah, a couple of years ago, it looked like there was something that had skidded and crashed into some ice somewhere, and it kind of looked like some object. Yeah, who knows? It's a weird and mysterious place.
Yeah, there's some maps that show birds carrying elephants in the Antarctic region.
Haven't seen that.
You know how people talk about giants and giant plants, giant animals.
And that next image, it's just a zoomed out version, just to show you what it kind of looks like around it. Welcome to Flat Earth.
Hello. I'm just here to listen today, but it seems like no one's talking.
Yeah, that's okay. I think we're all kind of sort of listening, waiting for some action.
Okay, let's start basic. Red pill me on the flat earth theory. No one.
Well, first up, the Earth isn't a disk floating in space, and there's no claim to any edge or shape, but the Earth does measure to be flat over water, because water keeps its level. We see further than we should if the ball that we're told that we live on has a radius of 3959 miles. And when you break that down into smaller numbers, we, over a 10-mile distance, it's a 66-mile. You won't be able to see, 66 foot of like if you had something that was 66 foot at a 10-mile distance, you wouldn't see it. But we can clearly see over a 10-mile distance over a lake, for example, and we can see the shoreline. So that's basically it for me. That's all I really care about. This disproves the ball.
What disproves the ball? See what you guys
the fact
got.
That we can see
the ball. You mean the magic ball? That the globe is not a ball; it's a magic ball.
Well, I don't know. I don't know what you guys are talking about. So what do you claim has disproved that the Earth is a globe?
The globe is something that you buy at the store, like for decoration
Yes.
purposes.
You're capable of making a distinction with the right context.
You're incapable to figure out the ground below your feet. So.
Well, it's been figured out. You just don't accept it.
You figure it out?
I personally, I've come to an understanding.
You personally haven't.
Well, maybe not to your satisfaction, but I'm satisfied with it.
You're satisfied to not figure it out? Okay.
No, I figured it out, but not to your satisfaction.
I doubt it. I'm skeptical.
I don't care.
Cap.
I don't care. I don't care what you doubt.
Why you capping?
Cap right back to you. You lie every time you're challenged. That's why you guys hoard yourself here instead of having a real debate in a neutral space.
Is that your argument?
That is one of many.
So what's the evidence of the globe again?
Just whining about flat earthers is the first evidence of the globe.
Well, you definitely have objects going over the horizon, and you have enough evidence of that you can't claim that it's refraction or perspective effects, because there's no such thing as perspective effects that would cause that. And whatever other flimsy excuses
right.
See, this is what you guys do. Go ahead. No, do it again.
Yeah, because you're trying to like scattergun, right? So just stick with
I've
one thing.
listed. I was going to list 3 evidences, and that was
you
it.
You disagree with mainstream optics experts that are global.
Not a disagreement. It's an observation that is objectively.
All right, so
you're just denying the facts.
You're when simply asserting your position with no evidence.
When an expert in refraction like Andrew Thomas Young says that sinking refraction can make things look like they're hidden behind the horizon, or make things completely disappear behind the horizon, even though they're not actually physically obstructed, you would disagree with him?
I would disagree with how you're characterizing him, and once you allow me to speak, I'll tell you why.
Yeah, so let's just get the exact quote from Andrew Thomas Young, right?
Sure.
So Andrew Thomas Young, 1994, Optics of the Atmosphere, Reports on Progress in Physics, page 57. Atmospheric refraction can bend light rays such that distant objects are displaced vertically, causing parts of these objects to drop below the apparent horizon or become partially obstructed, even though the line of sight is geometrically unobstructed. This effect results from vertical refractive index gradients near the surface that produce curved ray paths.
All right, let me know when I can respond. Done?
Perkins, David, and
he's not done.
Atmospheric Refraction in Geodetic and Astronomical Observations, Surveys in Physics, 1995.
Moderator, I'm going to step away for a minute. Let me know when I can talk.
Oh, so you're not listening because you're running away?
He's not listening.
You've made your
He has
point, and
his fingers in his
Where are you stepping away
in
from?
his
You're on
ears.
a voice
I'm
call.
bored with you reiterating.
Oh,
your
you
point.
don't like citations? You don't like citations?
I could read a 3-hour citation. Are you willing to listen to it?
Well, this is not a 3-hour citation.
How
This is
much
just
longer are you going to talk? A minute,
just reading
2 minutes,
two
3 minutes, 4 minutes?
Just 2 citations.
How long are? I don't want to know the number of citations. I
I
want
would
to know
have
the
been
number of
done.
seconds.
I would have been done right now.
Okay, good. I'll give 30 seconds. Go ahead.
Maybe you get step away to get some
29,
cheese.
28.
You could get some cheese to go with your wine.
26.
Did you get step away to get some cheese to go with your wine?
24. 23.
Wow. Big
22.
counting for such a.
Yeah.
Is this
You
your
haven't done your
IQ?
citation, and I'm just counting how many seconds it's going to take for you to get it over with.
Yeah. Well, how can
I
do
got you. I
it
got the
while you're
point, and you're still
yapping?
talking about
You're
me,
just
talking about
yapping.
you, talking about
All
the
right.
citation.
All right. Stillman the point. Stillman sinking refraction. Go ahead.
Okay.
I don't think you
So
understand.
So he said partial obstruction, not complete obstruction. He said it twice from your citation. So that's the end of that. Because clearly, and this is a logical.
That's the end of
It's logical that if something is completely obstructed, you can't even tell if it's there or not. So someone would have to verify the object is at that location. So that's where you use, line of sight to say cityscapes, things like that, like seeing Chicago from Erie, Indiana, or even
Yeah.
across.
So it's partially obstructed,
I'm
right?
sorry, you're
Partially
interrupting me.
obstructed.
I'm in the middle of making a
Well,
point, and I
actually, you
spent less
interrupted
time making my
me.
point than you did to do your citation. This is part
You
of your tactic.
interrupted me.
One.
You interrupted
I'm gonna
me.
count again. I'm gonna count again. Go ahead. Interrupt.
All right. So, visible
Go ahead.
above
I
the
don't want to interrupt
horizon,
you.
or appear lowered, compressed, or completely hidden from view. There you go.
Okay. So compressed is an evidence
Completely
of
hidden
refraction.
from
Up,
view.
and I didn't even get to finish the sentence.
All right, bro. Guess what? This
All
is
right,
what's gonna
bruh.
happen right now. Guess
Bruh.
what's gonna happen right now, bruh?
don't
70
care.
IQ, bruh. Shut the fuck up. All right, you're banned. Fuck off. Dumb motherfucker.
Wow, what a clown.
Every time, bro. The same guy.
Yeah, I didn't know who it was at first, and I clicked on his name, and I'm like, I'm not that dude.
Yeah, man. That guy's he's too dumb to bother with. Same shit every time. Just copium.
Yeah, if I knew it was him straight up, I wouldn't have even bothered. I'm too tired to argue with idiots anyway.
But you can't argue with that guy. He just does the same thing every time.
Well, how can he disagree with his own experts? Like, what's he doing?
Yeah, he doesn't understand what his own experts say. He's just got BYO, anti-flat earther brain, where he just invents maybe he gets his knowledge from like anti-flat earth videos. Yeah, well, even McToon, I forced McToon to admit that you can have bottom-up obstruction on a flat earth. He'd been saying for the last 7 years that you can't, it's impossible to have bottom-up obstruction on a flat earth. But he was forced into saying it because obviously you can have it. We can just show it.
7 years. You can throw his 7 years of denying it to the trash then.
Yeah, I wish I could somehow get like a compilation of him saying it every time. I got a few clips of it that I added into my video, but
it hurt him to say it though. It was feeling pain when he said it.
It was immense pain. He paused for like a minute of awkward silence before he said it.
Yeah, it was like a bit of constipation and finally got the poop out, you know. I know.
Yeah.
Mm.
Rich Evans challenged me to a debate the other day in Worldwide Debates. I was like, yeah, get in VC right now. It was painful, man. That guy's such a clown. So glad
these
he's not
guys
working.
they're gonna be coping forever. It's kind of sad and funny at the same time. Like they're gonna be old men and be like, "Oh, flat Earth."
Yeah, they have the funny things that such different standards of evidence. Like they'll present a test that doesn't mention refraction at all, and doesn't account for anything really. And then we'll present something, and then all of a sudden we have to like measure everything perfectly that they didn't have to do in their test.
Yeah, I've never heard of anyone talk about like Eratosthenes with his refraction stick, or you know, they never factor any of those in with their stuff. Exactly, it's always about refraction with us to make an excuse and just try and, you know, any excuse really. Crazy. It really is delusional. Like the more I hear it, it's just like you guys are just delusional. Just who are you trying to fool? Like yourself? Or?
Yeah, I think they have fooled themselves, and they're just delusional.
Well, it has to be because if they're
like Genty says,
because if they're denying, like I've seen all those screenshots you've done from all about refraction, and it clearly states what you say, and they still deny it. And
yeah,
sinking refraction.
It's just a hostile witness. It's just a hostile witness. It's their own experts that are saying this can happen. So it's like, all right, so if you guys show a ship and the bottom of it's missing, did you take this into account? Because your own experts say that this happens. And was that accounted for? And the answer is always no, it wasn't. Because refraction's actually their worst nightmare, because it invalidates every single observation that they show that shows bottom-up obstruction, because it fits their textbook definition of sinking refraction 100% of the time, and 100% of the time they didn't account for that at all. So it just completely invalidates their claim. And they have to agree with that. Otherwise, they have to throw mainstream science under the bus.
Yeah, I mean, that was always the argument with the ships over the horizon. They never said, oh, due to refraction, it's, you know, sinking due to a light phenomenon. It was just, Earth curve, like, straight away, like, without even investigating. Like, these guys make the worst investigators, that they don't even dig into it and want to know really what's happening. They just want to make up a convenient excuse, like a hand wave, and think that's going to be good enough. Yeah. It's annoying.
And then they also think that refraction can just flatten out giant curved surfaces. Like it's like 400 foot of curved surface, and then they think that refraction can just make it look flat.
Yeah.
And they don't have any evidence that it can do that at all. Not a thing.
Yeah, it's like thinking you could put a basketball out somewhere and use the refraction excuse to make the
Flatten it.
basketball into a pancake or make it
Yeah,
flattened.
exactly, man. Or it's like a hallway that like curves around a corner, and then all of a sudden refraction just makes it look like a straight hallway.
Yeah.
It's dumb. It's the dumbest shit ever. And like when they claim it, this is what they're claiming. Let's say you have 10-mile observation. The geometric horizon has to be at, say, 3 miles if you're 6 foot tall. And that doesn't go anywhere if you add refraction or whatever into it, atmospheric conditions, whatever, right? That geometric horizon would still have to be at that exact spot physically if the Earth's a globe. So all of the water beyond that point is physically obstructed behind the curvature of the Earth. Now, we can just see 10 miles of flat water, and they're claiming that really that geometric horizon is there, but all of the water is being lifted up at the perfect amount the entire distance and lifting up a completely different amount every centimeter just to all perfectly be refracted up to completely hide the geometric horizon from detection 100% of the time.
Yeah,
and
to make the image look perfect.
Yeah, just to make it all look perfect. And if there's mountains in the background, then they all perfectly get lifted up to the exact right height as well. And everything just gets flattened by this it's like their refraction demon that is conspiring against them to just make the Earth look flat.
Yeah, because the further away that an object is, it would have to have more and more extreme
lift
refraction. So yeah.
Yeah. Every single point along the way. Yeah, so the water's being perfectly lifted up 66 feet at 10 miles. It's being lifted up 266 feet at 20 miles, and everything in between, just to completely disguise the globe as a flat plane.
Yeah.
That's why I always say refraction's their worst nightmare, because it debunks. That's their only excuse to these observations. They're not saying anything else. They're only saying refraction is the reason. So that has to be addressed. If we don't address that, then they'll laugh at us and think, oh, you avoided the question. So it's like, okay, well, according to your own experts, right, according to your own data, throughout all of history, you don't have any observations where you've accurately accounted for the refraction that you claim exists, and you don't have any evidence showing that it can do what you're claiming it does. So until then, you're just making a baseless claim, and most of the time they just learn how to say that word, refraction, right? They learn how to make a noise with their mouth when they get showed an observation that destroys the globe, and they don't really know anything about it. They don't know what their experts say, and they're screwed.
It's almost like a computer code put into their head going, if they say it's flat, then you go, it's refraction, like it's a logical string. But yeah, I was thinking about a string that the refraction is like the last string holding their globe, and if that string breaks, their globe's going to fall and break. It's going to smash into a million pieces. So it's like they're holding on to it for dear life.
And their only response, right? Sometimes they use this tactic. They're like, well, how come? Well, you guys didn't account for refraction. You guys didn't measure the refraction. So your observation's also invalid. But that's actually a completely false argument, because we're not the ones claiming that the Earth is a shape and a size. They're the ones claiming the Earth is a shape and a size. And we're testing that claim. Right? They made the specific claim. We're just checking we all experience the Earth as flat. Even if the Earth's a globe, we're so little and the globe's so big that you don't see any curvature. So even the globers, according to the mainstream, don't see curvature. So we have this like baseline to start at where we just see everything as flat. So all we're doing is trying to find the curve that they claim. And when we do our observation, we're like, okay, well, it's not there. The curve's not there. Right? So where's your globe? We're not saying this observation proves that the Earth is flat necessarily. Right? This is just reconfirming that exactly what everybody experiences is that the water's not curving. We don't need to prove what's obvious. It's the base reality. It's the base axiom. We're just checking for their claim, and their claim fails the check. So if they want to make an observation, they're making a very specific claim. They're like, oh, because the Earth's a globe of this size, therefore this thing in the distance is 2 foot lower than it should be, therefore the Earth's a globe. We're not doing that. We're just checking. We're just checking for their globe, and it fails every time.
Yeah, so with that Indio observation with the 30-mile boat, that should never have happened. With that temperature difference, which was not really much difference, was there, between the air and the water? That
the water was a little bit
should
warmer
have
than
been
the
it.
air temperature. So
Oh, it
according
was,
to
was
that
it?
one, yeah, it was. Well, yeah, exactly. So that works against the globe. So if according to the globe side, right, when you have warmer air down lower and cooler air up higher, then the light bends upward, and that would make the horizon be closer because that's negative refraction. They call it subrefraction. So that means that instead of the horizon being at 5 miles or wherever it should have been in that observation, it would have to be closer. It can't be further away. You can't have upward refraction, right? You can't have subrefraction and a horizon that's further away at the same time on a globe. It's impossible, according to their own bullshit. And yeah, it fails. The horizon is the best thing to check because the horizon kills the globe every time. If we just check for that geometric horizon, it's never there. And that's why India's observation is good because they can't use refraction as an excuse on that one because we know the water temperature is warmer than the air temperature. So you can't have downward bending light according to their own experts, according to their own definitions and citations.
Yeah, but they will deny
according
that
to-
till the cows come home.
Yeah, it's all they can do is like be ignorant and butcher and throw their own experts under the bus because they haven't done the research. And they'll just start like being dishonest. That's when you start seeing tactics start to come out. They'll just try to shift the conversation. They'll try to move the goalposts. Like all of their little tactics will start to come out. That's when we have to be sharp and aware that they're doing that and just hold their feet to the fire.
Yeah, they'll always throw Neil deGrasse Tyson under the bus when he says you don't see curvature from 120,000 feet.
Yep. They'll throw anyone under the bus in 2 seconds. They'll throw Andrew Thomas Young under the bus. Just anyone that goes against their claim. Basically, they'll just instantly throw them under the bus, no matter who it is.
Yeah, well, who isn't under the bus?
Oh, I mean,
who do they appeal to? If everyone's under the bus, who do they appeal? What are the experts then? Nobody.
Yeah,
Mr. Nobody, faceless, nameless.
They'll appeal to some anti-flat Earth surveyors who throw around surveying terminology that the glober doesn't understand. And they'll think that, oh, this surveyor really knows what they're talking about. Even though the surveyors just guess refraction. They don't, the theodolite's not a refraction calculating measuring device. Refraction just takes an angle and then they just guess the refraction. They'll just include 0.13, which is like 15% added to the radius value of the globe. And they'll just go with that because they're just like basically trained monkeys that learn how to operate a theodolite, to take angle measurements and then use mathematics to fit their data over very short observations onto a datum, onto a like a coordinate system that preassumes a globe. So yeah, surveyors suck when it comes to understanding optics and that kind of thing, refraction. They butcher it every time, and they've not once ever accounted for it correctly, how they should, because it's like a huge undertaking if they wanted to account for refraction accurately over a distance, especially when they're doing these giant long distance shots with the Autolite over 20 miles or 100 miles or something like that, because there's so much to account for between point A and point B.
Yeah, they pretty much ignore the difference between specular and diffuse refractions. They ignore atmospheric transmission, atmospheric extinction, all those factors that limit what we can see.
Yep. And then we've got all of these. Go ahead.
I was just going to say the average surveyor wouldn't be aware of the drop over distance to match the 3959, though, would they?
I think they're generally aware of the drop over distance, but they
but the fact it doesn't match reality.
Well, actual surveyors in modern times just do very short distance tests where it's hardly any difference at all between flat or globe, right? Like 400 meters or something like that at maximum. Usually it's even shorter than
500 meters, you got less than 2 centimeters of curve.
Yeah, exactly. So they can add in their Gaussian refraction coefficient or whatever, 0.13, which just makes it just makes up for that tiny little bit of flatness, right? It's a little bit too flat, so they'll just add standard refraction, and then all of a sudden their flat Earth's a little bit curved again. Whereas the normal is the opposite of that. Anyway, it's basically all they're doing is that they're taking they'll use instrument error and refraction as these like little knobs basically, and they can turn the knobs to make the math fit their geoid model, and then they'll just put it down and they'll think that they'll think that their measurements that they did aligned perfectly with the globe. It's crazy.
It just sounds like they're adding in a bit of dark matter here and a bit of dark matter there.
Exactly. It's exactly the same kind of thing. Exactly. They're just using like little, they've got instrument error and they've got refraction as their little dark matter and dark energy that they can, just use to fudge the maths a bit so it fits their model to please their boss, and then they go home thinking that they're real smart.
Like if they were building a brick house and, oh no, I've run out of bricks, so I've got to spread the bricks out and I'll just fill up the gaps with more concrete, just to make up for it.
Even like an engineer or an architect, when they're building like a big bridge, I forget the name of that particular bridge, but they say, oh, the pylons, right? The pylons are like 1 1/4 inch further apart at the tops than the bottoms to account for earth curvature. And that engineer might have the engineer might have thought of that and thought he was real smart, and he's like, oh yeah, we accounted for earth curvature when we built this bridge. But it wouldn't have made fuck all of a difference either way, because the general tolerance and stress, the amount that it can warp and bend and stretch and contract and retract, just due to temperature changes,
those
completely overrides.
Those bridge towers weigh 27,000 tons. There's no way you can build those to any method of accuracy.
Exactly. And even if the Earth was a globe, you wouldn't have to build them tilted, because it would be locally plumb at that point anyway. So it would just be naturally like that. You wouldn't have to account for it, because at each point, the plumb line should be automatically curved anyway.
And when they string the wires for the support cables, they just string them until they get to the other side. They don't account for length.
Yep. Exactly. And those metal wires, they change by like 13 feet just due to temperature between winter and summer.
Yeah. Exactly. The deck height changes by 12 to 13 feet in the heat.
Yep. Huge.
So
Huge
41
amount.
millimeters means nothing.
Mm-hmm.
Well, that's just mainly an argument now because they saw it in some documentary thingy, wasn't it? Isn't that where it came out from?
Exactly. That's all it is. It's just a they just parrot what they saw in some anti-flat Earth documentary or read on some article online. Like they'll Google it. That's all they'll do. They say, "Oh, do bridges account for Earth curvature?" And then that one will come up. That's why they all bring up the exact same one.
When there's longer bridges, that they should be more focused on the fact that they're side on, they're pretty flat. The water's flat underneath it.
I mean, we contacted the engineering department for Lake Pontchartrain Bridge, which is over 20 miles long, and they said that they didn't account for Earth curvature at all.
Yeah, what would be the point?
Have you got that anywhere? Is that in your files section somewhere?
Yeah.
I haven't seen that, but I've heard you say it.
Yeah, I'll probably make a full video on Pontchartrain, but here I've got the posted in the side chat.
But there's side on pictures of Lake Pontchartrain, isn't there? Where it doesn't
Yeah,
show a
side
massive
on.
curve like what Soundly shows.
Yeah. So there's the email, and here's the side on picture.
Or Fraudly.
So even Dawn, I was having a little chat with Dawn in a different server today, and even he said this completely debunks Soundly's tests, and he's like an anti-flat earther. He admitted that, yeah, I was presenting the Pontchartrain stuff. He said this completely destroys Soundly's stuff, which is the Lake Pontchartrain glober.
Yeah, thanks for sharing that.
Yeah, no worries. So, good afternoon, sir. I spoke with one of our lead engineers in reference to the questions you had pertaining to the Causeway Bridge. Please see our engineer's response in the red font below. Does the causeway hold a uniform altitude above the water level throughout its entirety? No, there are 5 locations, 3 humps, and 2 channels that allow passage of boats through various size. The north, center, and south humps have 25 feet of clearance. The north and south channels allow 45 feet of clearance. The normal bridge level has about 15 feet of clearance. Over the 24 miles of distance, how much earth curve is the causeway accounting for? Seems to be a rare occurrence where Lake Pontchartrain is actually long enough to experience this geometric drop-off. Says there is a drop-off of 522 feet, but the bridge is constructed in spans that are either 2,240 spans that are 56 feet long on the southbound bridge, or 1,500 spans that are 84 feet long on the northbound bridge. So the drop-off per span is negligible. The difference between a chord and an arc of 24 miles is less than 3 inches. 24 miles is long, but not when compared to the entire Earth. So yeah, the way that they make the bridges, they didn't need to account for any curvature, even though they
the
believed
most
it
important
exists.
measurement they take is the very last one where they connect the last 2 pieces together. They have to be dead on for that one. Other than that,
Mm-hmm.
I mean, there definitely are. I just joined some a little bit late. I'm not sure. There definitely are bridges that they use that the curvature of the Earth is accounted for.
Yeah, cool. Grab us that, and let's go over it.
You just saying that, or do you actually know of a case?
Yeah. 1 second. Let me find it.
I wonder which one he'll find.
You might have just missed a few minutes before you jumped in. We were talking about the one I think you might be about to share. That's the hunch. Yeah, that'd be kind of freaky driving on that bridge. I mean, water all around you.
I'm freaky about it.
How deep is that? Do you know how deep the water is?
I'm not sure.
Yeah. I wouldn't want to find out.
I don't think Pontchartrain's very deep.
Does it really matter how deep water is? Like, is that really relevant to like?
Oh no, I'm just like if your car, like if the bridge collapses and you end up in the water, you know, things like that can happen sometimes.
Right, but I mean, like fundamentally, like if you like if your car goes off a bridge into the water, like the depth of the water is like one of the least important factors for whether or not you survive, right? Like the fall off of the bridge to the water, far more important. Whether or not you open your doors or windows or create a crack in the vehicle so you can actually open yours when you're in the water, way more important than either of those factors, right? What your reaction time is, way more important, right? Like whether you're wearing your seatbelt, more important, right? Like I don't know.
Right, but if you don't,
It was just a simple question.
Yeah, the depth of the water just almost irrelevant. So it's just.
I wasn't trying to argue at that point, but whatever.
No, I know. That's why I was just asking why you're surprised. I was just surprised.
I could have just Googled it and not said it.
So if you couldn't get your windows open and couldn't get your seatbelt off, right, but you were still conscious, and the water was 10 feet deep, and then the car just lands on the bottom, you're able to get out of the car.
I mean, you're super unlikely to do that, even at 10 feet, right?
If you just keep sinking to like 100 feet or something like that, then you're just screwed, right? You're just gonna die from the pressure. And you're not
but I can't swim that far. 12 to 14 feet, the deepest point, roughly 60 to 65 feet in certain areas.
It's pretty deep.
But that's a long way to swim.
Yeah.
But anyway, it was just
I think the average depth under the bridge is 12 to 16 feet.
Yeah.
Did you find that bridge yet?
Actually, I know of a couple. But the first example we can talk about is the which bridge were you guys talking about first before? If you're
Verrazano Narrows Bridge first.
The one in New York City.
Yeah.
So first of all, what is your claim that's wrong about like that is not an example of exactly what I'm expressing? What's your claim against that?
It would be that adjusting for Earth curvature would be unnecessary for it, because the bridge itself.
So then, why did they adjust for it? Like, why
changes hugely in size?
But like, why do they account for it? Like, why are the tops of the towers different?
Well,
the bottom of the tower,
architects accounted for it, but the builders don't.
So your take is that if you went out there with two measuring tapes and you measured the bottoms of the towers and the tops of the towers, that they're the same distance apart from each other? Is that your?
They would variate greater just based on the temperatures, because one side of the
right. Assuming they were the same, even if they were the same temperature, take that out.
Because they found during the construction that they had to take all their measurements at nighttime because the difference in heat was just screwing up their measurements.
Of course.
So just between the seasons, the bridge can contract like 13 foot. The cables can have 13-foot difference in length between summer and winter. Right? This 41 millimeters, right, that it's allegedly further apart at the top over this huge distance.
No,
it's not something that there's any evidence. Yeah. So it's completely irrelevant, right? When it comes to the stress of the bridge, right? Nobody's been able to measure it. People have gone there and tried to measure it for some reason, and it was inconclusive. And it depends what time of the year. You would never be able to validate that actually happened. In fact, no one's even been able to present the blueprints that said that it was actually further apart at the top. It's just an article that came up in a magazine or something trying to debunk flat Earth once, and that's why it pops up as the first one when people Google it.
And there's not evidence of it. The stress factors way outweigh the tiny little amount of curvature. Even if it was a flat Earth, right, and they had 41 millimeters difference between the pylons, it wouldn't make a difference anyway, right? Let's say the architect thought the Earth's a globe, and he did that, it wouldn't make a difference.
Yeah, I agree
So,
there. I agree. The
yeah.
difference is small enough that it wouldn't matter either way. You were living under either perception. Yeah, I agree.
Right. Cool.
Yeah, the expansion joints in that bridges are made to absorb up to 9 feet of horizontal movement.
And even if it was a globe, they wouldn't have to build them on angles or anything like that, because the plumb lines would just be naturally, apart. At each point, right? If you make a plumb line, you build the tower based off the plumb line. If the Earth's a globe, they would just naturally be that distance apart at the top compared to the bottom.
I think I'm understanding what you're saying there. Not 100% certain I'm on the same page, but I believe I. So essentially, you're saying that if the Earth is curved, you wouldn't account for that; it would just naturally occur. That's what you're. Is that what you're meaning, or?
Yeah, because at the top of the towers, the only part that connects there is the suspension cables. That's it. The roadway is hundreds of feet below the top of the towers.
So that was the only bridge, was it, that you thought of?
No, I mean,
Moses?
there's plenty. There's plenty. I mean, if you're just gonna just use like those kind of arguments against us, like it doesn't matter what somebody says, right? Like fundamentally, right? Like I don't like
So it was the only.
I've been here long enough to know you guys will have an excuse for all of them. Let's
Not an
see.
excuse.
Whatever.
Well,
Like
you
just
guys have the
whatever you want to
excuse.
call it. Sure, if you say so. Yeah, there's other bridges. Like I'm pretty sure
1 to
like
2 inches? You
any
serious?
bridge. So what's your issue with the fact that it's 1 to 2 inches? Like what is your expectation that it requires it to be before you'd be like, yeah, that's a curve?
Well, it's a construction, so there's going to be tolerances, and it's obviously they've just told you about expansion, which is far greater than any of that.
Oh yeah,
So
you're right. I had no idea that was a possible thing that could exist. Thank you for the enlightenment of the wisdom and knowledge. I'd never considered such things.
that's why they make bridges with expansion joints in them, so they can shift back and forward. You know?
Yeah.
So I don't know why you would think that would be a proof of the globe, really.
I mean,
Like if they were to
trains
bling,
have expansion line joints in them as well. It doesn't mean every railway is a straight line. Like it doesn't.
we just think about it though.
Expansion
Like
joints doesn't make something
if
not curved. Like I don't know. Like
it was a globe, don't you? And they wanted to have it on an angle, don't you think they'd have it more noticeably on an angle, like it's almost a V shaped? That I mean,
the curvature is very
rather
small.
than an
Right?
inch
The curvature is
and a bit.
very 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 small. Right.
Yeah, no. I just can't take that seriously.
Yeah.
That's really scraping the bottom of the desperate barrel. I'm sorry. It's not a good argument. I would get rid of that one from my kit, my globe, my debunking kit. I'd get
What's
rid
a
of it.
globe? What is a globe? Never heard
It's the thing you believe in.
I don't know this meaning. When have I stated something as a globe? When did I state that? What is a globe?
We all know
Please
you're a
define
glober.
that.
We all know that you think we're on a spinny space ball. Come on.
Oh, we're definitely in space. If you mean an area with less matter in it outside of the area we're in, outside of our atmosphere, yeah, we definitely are.
So you think that stars are under your feet?
I wouldn't say that. I think that
Well, they would have to
stars
be
are outside of us. They're outside of our
below
atmosphere.
us.
Yeah, they're outside of our
Stars are
atmosphere.
below us too, though, aren't they? On a ball. Apparently, they spin in opposite directions below our feet.
If that's what you're talking about, yeah, I'm obviously aware that that's the case. Yeah, I mean, I do recognize that there's two sides, if at that most basic understanding. Yeah, yeah. The sky definitely works different in the southern hemisphere than it does in the northern hemisphere. That is true. I appreciate that acknowledgement.
No, I'm not agreeing with you. I'm just saying that's what
So
you guys think.
it doesn't work differently? Does it work the same? Is that your take?
They go the same direction as far as what the education system's told me.
Oh, gotcha. You're one of
those. East to
those.
west.
You believe with the education
Well, the sun
system.
goes east to west. The moon goes east to west. So do the stars. And when you turn around the other way, they still go east to west. They just come from a different side because you turned around.
I totally agree. I just totally agree. I totally agree. When you're on the bottom of the planet and your head is facing down, east and west are different directions to you than when you're on the top of the planet, your head is facing up, which is what creates the phenomenon you just described. I totally agree, dude. Could not agree more.
It's a bad habit. For some reason, I don't like talking about the sky, but for some reason, it just, you guys, I don't know. It's just that you guys love it, so I can't help it.
Well, I mean, you just fundamentally completely agreed with the fact that the Earth isn't flat with what you just said. So yeah, I get why you would not want to talk about it.
I'm just coming from your position. Yeah. I used to be a glober, bro. I understand what you think.
No, I never said I was a glober. I don't know what does this word globe mean.
Globe believer.
Yeah, you're a globe believer.
Earth spinny ball.
Yeah, you're a globe. You're a globe believer.
Because I'm not a flat earther. I'm a glober, right? That's your.
Yeah.
You're not one of us. You're not one of us. Therefore, you must be one of them. There can't be anything in between. There can't be other options. We believe one thing, and we believe that everyone else believes something else. Therefore, those are the only things people could possibly believe. That's it. Those are the only two things.
Maybe you're a concave.
He doesn't want to admit it because he doesn't want to defend something that he doesn't know how to defend. So he's trying to be like, "Oh, I'm not a glober. Like I could believe."
I'm saying I'm not. I'm just the globe has a specific meaning. I don't believe that it's a globe. A globe defines it as a sphere. I don't believe it's a sphere. I think that's foolish.
Oh, so it's the word globe you've got a problem with?
Yeah, absolutely. Which is what I said. What is this word globe right from the beginning?
Really? So you hear global all the time, don't you? Global on the news, global this, global that.
Global
like,
and global are the same thing.
Really?
Yeah, here when we say globe, we mean that you think that the surface of the Earth is roughly a globe shape or roughly spherical. So that's how we use the word globe here.
Yeah, I just think it's not flat. That's what I think. Yeah.
G'day, Matthew.
What shape do you think it is? Hey.
I believe it's a connected shape in which you can transverse all the way around it. That's what I believe, which fundamentally can't be flat. So.
But if they were looking at the whole thing all at once, do you have any opinions about what it would look like, the surface of the Earth, if you could see the whole thing at once?
Not flat.
Right.
Yeah.
But I'm asking what you think
flat.
it is.
Yeah, not flat.
That's what it's not.
What I think it is. Yeah.
Well, there's an infinite number of not flats, so.
Right. Yeah, it could be any of those continuous shapes in which you can walk around. Yeah, I mean anything that allows for all the known physics phenomenon that are very clearly tested and true. Any model that allows for that to be the case could be the case. Right. So I'm not going to say I know with an absolute certainty exactly which one of those shapes it is. I've not had the experience of knowing that. But to say that the thing I can say with certainty is that it's not flat. Right.
Really?
It's some kind of continuous connected shape. Yeah. It's not a flat shape. Yeah.
Right. So
unless you would describe
could it have flat surfaces?
Well, it depends on what we mean by flat. It's important to define this. Like if we took a
All right,
piece of
let's say it was
paper
a
and we said
giant
that's
sphere.
flat,
Let's say,
right? It's not that,
bro,
right?
listen
Now, if we
for a
took the
second,
paper
right?
and we
So let's
folded it on itself
hold
where it
on,
connected
hold on,
back,
bro.
we still call that flat? Maybe it
Yeah,
could
yeah.
be flat.
Let me give
You
you an
call that flat?
example, right?
Like, is
Let
that
me
flat
give
in
you
your
an
mind?
example.
Like, if I took
Let me
one
give
end
you
of
an
a paper and I
example.
folded
Let me
over the
hold on.
other end of the paper and there was like a gap in the middle, is that a flat? Is that shape still flat?
But I don't know what you're talking about. Just listen to the
Like if I
example.
just took the end of one
I don't
paper
care.
and the
Just
end of the other
listen. Just
paper.
let me give you a
So wait, I'm
scenario.
just asking you. I don't like. Do I like? Why can't you just answer that
Are
question?
you drunk
Like,
or
is that
something?
flat? No, I'm just asking a super simple question. Like,
It's you
because if that doesn't
naturally.
count, because if that doesn't count as flat, then it's like, no, it can't be flat. But if you count that as flat, then it's like, okay, I could see the argument that maybe you're saying
All
it's
right, I'm
flat.
just trying to give you just asking
So
you a
does that
question.
count as flat though? Right. And but I already asked this question first, right? And then you
Flat's
tried to
just a surface, a description of a surface that's not curving. So if it's curving, it's not flat.
at any, it has to be. You're taking like basically a 2D line. Basically, that's what you're calling flat.
No, a surface area. In this
Right, a
context, we're
surface area
talking
is a
about
2D line.
the
A line
surface.
is a one, it's a one-dimensional
No,
flat thing,
like
and then when you
like a
expand it to 2Ds,
tabletop or
and
a
then if you went to
mirror surface
tabletop, a
or
flat,
something.
exactly. But your take is that it has to be absolutely flat, like laser edge flat. Any percent of variance,
No,
now that's a curved thing,
no,
or what?
no,
So
approximately flat. Just not curving over
approximately flat.
distance. Yeah, like
How
there
much
isn't
distance?
any
How much
surface.
curve can't exist? Because I'm
What do
like,
you
there's a
think
hill
a
next to my
mirror?
house. The hill
You
goes
think
down, and that's clearly curved. So,
yeah, so it's not
why
flat.
isn't that? Why?
We're
So
not
why?
talking
How is
about the
that still
land.
flat? But that's what
You
I'm talking
know,
about. It's talking about the land.
I'm
I'm talking
being
about
so
the ground
nice
I
to you
stand
right
on.
now, not muting you, bro. But I'm starting to get annoyed with you. I'm gonna start muting your dumbass in a second.
So Moses, the other way to think about it is this: do you think that the direction of down is parallel in Los Angeles versus the direction of down in New York?
No, I do
That's
not.
another
Yeah, no, I do not. Yeah, I think that's a great way of
Right.
looking at it. That's a great way of
Right,
looking at it.
right.
That's kind of
So
what I was asking with the 2D.
I'm gonna make my point. You got to go on mute to listen. Right. So you don't need to be unmuted while I'm talking anyway. Right. So if you lived on, say, a giant ball, right, and it had a flat spot, and that flat spot is where all the continents are located that you live on, just hypothetically. Right. Could that be possible? Okay, good. Oh no, he left. What a shame.
I'll answer what I would think. I guess it could be possible. You'd have to have a pretty large sphere.
Yeah, like really, really big, giant. Matthew, are you unbanned from English Home?
I don't think so. No, I would like to be, but
Oh, I'll do that now. Just a sec.
I'm gonna head off. It's good chatting to you, DJ and Rayleigh, and
Right, man. Good to see you. Catch you next time,
yeah,
man.
yeah. We'll check out that video maybe tomorrow or over the long
Oh,
weekend.
it's really good. Yeah, man. It's awesome. Yeah, check it out.
Just some of the biblical stuff kind of puts me off a little bit, but
Oh, yeah. Don't just ignore
not
that.
too
Just
painful.
ignore that. Yeah. I'm not into all that myself, but just it's got nothing to do that much with that. It's just basically showing how the continental drift could have happened over a much earlier period due to a cataclysm. And then he shows a bunch of evidence shows how different parts are perfectly connected and different land features match other land features like they were connected once. It's like a jigsaw puzzle, and it's like it's come apart. It's and how certain cultures, modern cultures, align with each other in these parts that would have connected together. Anyway, man, I'll let you go, but check it out. It's
Yeah,
it's really worth watching.
it sounds interesting. Cool. Thanks heaps. See you later.
Hello? Chat with like 20 people and no one's talking. You're crazy. Rhetorician, there's just no one talking in here. I don't think anyone is up to defend the flat Earth worldview.
I think they are. Do you wait? What's
I
your
literally,
best globe argument?
I don't have one. I was gonna ask about maps again because I came in here before to ask about maps and nobody would tell me anything, and then I had to go. And I wanted to learn about flat Earth maps. I want to understand what their conception of like geography is. Because I feel like it just makes like.
Do you know anything about maps in the first place? Like if I was to ask you about the Mercator projection or
Yeah,
the
that's the like typical one we use.
Do you know how that was created? When it was created? Do you know?
I don't know
what
when it was created.
Do you know if it's based off a coordinate system or if it was actually someone actually went out and actually mapped
I just want to
Earth?
know what the conception of the flat Earth is, or like what the Earth looks
We're
like.
not claiming to have a perfect map. I mean, we can all use.
Well, could you have any kind of map?
There have been maps that were made by flat earthers, but by cultures.
Are there any that you think are anywhere near correct?
Well, there are also maps that have been made in modern times by flat earthers, but they're based off of transit times and that kind of thing. And if I showed one to you, then you wouldn't be able to validate it or not, right? And I wouldn't be able to validate it or not either as a whole, whether the whole thing's correct. And then when it comes to distances and that kind of thing, I mean, look, we're not claiming to know the shape of the Earth or the size of the Earth as flat earthers. We're just talking about the surface of the water. It doesn't curve over distance. It's like you guys are the ones claiming like the size and shape of the Earth, not us.
Well, you're like trivially claiming the shape of the Earth. You think it's flat.
Right, flat's not a shape. Flat.
Yeah, but it's like a
just
subset of shapes, right?
No, it's the description of a surface.
You don't think that there are some shapes that are flat and some shapes that aren't flat, and you're just claiming the disjunction of all flat shapes?
You could have any shape, and it could be also flat.
What about a sphere?
Well, no, not a sphere. I mean any 2D shape, right?
Yeah, so that you're claiming some subset of shapes are the are how the Earth is constituted.
Think about this, right? Like what shape's a lake? What shape's a lake? It's like each lake's a unique shape, right? Like each lake, every single lake's probably a completely different shape, and they're all considered. You could call them lake shape, or just an odd shape. No specific name for the shape. The Earth is probably the same thing, right? It would be Earth shaped, although we don't know. We're not claiming to know the entire shape of the Earth. But whatever shape a lake is or the Earth is, it doesn't change the fact that the surface of the water is what we're talking about. And over a given distance,
you think the Earth is like 3D, right?
It's like a topographical. Yeah, obviously, it's exactly what you experience when you go out in reality. Like you already.
Do you think you could like dig to the out of the bottom of the Earth? Like if I just dig long enough, I'll like.
No. The Soviets already tried to dig the deepest hole that they could dig, and they only just got a little bit deeper than the deepest part of the ocean, and then they couldn't get any further. And all of their predictions were wrong when they dug the hole as well, based on the globe model. They got everything wrong. So, I mean, 7.6 miles is the deepest hole.
Theoretically, if you had like the best drill heads possible, do you think you could like dig all the way through and like come out the other side of the Earth on like the bottom of it?
No, I don't know. I'm not claiming things that I would have to just guess.
Do you believe in like space?
Not necessarily in the heliocentric model of outer space, right? So not in the heliocentric model of outer space, but space is just anywhere that you don't have physical matter, right? Like, you've got space all around you right now. You wave your arms around.
Do you believe in like satellites and GPS?
Yeah, but I don't believe that they're orbiting around a globe. But I do believe.
Do you think they're orbiting around something else?
No, I don't think they're necessarily orbiting right? I think that we can't confirm when it comes to satellites. Like if I was to say, can you pick a satellite right now and confirm that satellite is where they're telling you it is and doing, and it's in the medium that they're telling you it is, you wouldn't be able to do that.
Okay. Bro, these
So
people in the side chat are like, I'm gish galloping. I'm not like.
No, you're good.
I'm just trying to pick this person's brain about what like the flat Earth idea of how the world works.
Yeah, I have no problem with the questions that you're asking.
But these people seem to. That's why it doesn't matter. No, I don't know. It seems like there are so many things that are in my like daily life, and that okay, the idea that the Earth is flat seems like it would discredit almost every single epistemic authority on Earth, and on the flat Earth, and would basically make a lot of like my understanding of a lot of things not make sense. So it seems like you'd want like a more developed theory of how things work under a flat Earth model.
Right.
Like,
So yeah, I can give you some basics, right? So large bodies of water at rest, flat on the surface. Water requires a container. Gas pressure requires some kind of containment as far as we can test. And most people just believe the Earth's a globe and they've not tested it. And that doesn't mean they're lying or anything like that. They're just repeating information, and they treat the Earth and live on the Earth every day of their life as if it's a flat plane anyway.
What about like geologists? Do you think geologists are like do you think they're lying or have been lied to?
Yeah, there's a famous. Just give me 1 second. I just got to go on mute for a second.
For large-scale geological surveys, they assume a flat plane. They use lasers over distance. I don't know about geologists themselves, like their personal take on that.
Well, my assumption would be that like the field of geology,
The study of rocks.
Yeah, makes assumptions about how the Earth was formed that involve space and collisions and that kind of thing.
Yeah,
and then
but
being like shaped
geologists
into a globe.
other than using, I forget the name of it, when they send frequencies into the ground to listen for different layers of stuff.
Yeah.
Like whether it be basalt or natural gas or oil or water. We only do like surface level surveying. I'm not talking like at the surface. Even if you dig down, you're still only at surface level. We don't send guys down into the so assumed layers of magma and the core. That's all theoretical,
So, sure, but like, yeah. Well, what I mean is that the geologists doing this, when they're learning about these things, make assumptions about how the Earth was formed. I'm assuming.
Yeah, assumptions is the key word.
Yeah, because I mean,
Well,
like
assumptions can be
the
based on some
theory of
evidence.
gravity. There's like over 80 different theories of gravity, and a lot of people believe a different theory than the next person. Like they're all theories on the same exact subject. It's because it's a force that is not testable within the scale that we're in. We'd have to be on a much larger scale to test the theory of gravity if we could get to that scale. But that's on like the whatever you want to call it, the celestial scale, the universal scale. It's an untestable scale that we just make assumptions for, and that's where gravity takes priority. Gravity this is what's taught, is that in the theory of gravity, gravitational forces are 10 to the 37 times more powerful on the celestial scale or galactic scale than they are on the molecular scale. On the atomic and molecular scale, it's electrical forces that take priority, and they are it's a consistent 10 to the 37 power more powerful.
I don't know anything about this. And I'm sure there's like disagreement on the exact shape of the Earth within like the scientific community. They probably think that the globe has like different actual spatial properties, and that maybe there's certain parts of it that are more extended than other parts. I think the general consensus is that it's not a perfect sphere. It's like a very rough kind of sphere with like
earlier you said the flat
imbalances.
Earth model. Personally,
No, I would, yeah, but I'm saying whatever you're saying about the flat Earth model. I'm saying that I think there is disagreement about how exactly the round Earth is constituted under.
See, I don't think there is a flat Earth model because I don't think we know the entire. I don't think anyone knows the entire shape. It doesn't have like a side or a bottom. You could like go out and
It's
take a
spheroid.
picture of the whole thing. You know.
Yeah,
the
it's
area
like
in
a
which we live is
pear
a flat
kind
plane.
of, right? I'm
No,
sorry,
what
I'm
I'm
talking to
saying
somebody.
is
No,
It's
I'm talking
basically
to
like
somebody else.
just quickly. They say it's a spheroid. It's just a technicality, right? So they say it's so close to being a perfect sphere. It's only 0.3% off being a perfect sphere.
Yeah.
But yeah,
an
so it's
oblique
basically
spheroid. That's what they call it. They call it an oblique spheroid.
as
that's
a
what I was saying.
technicality. So they say if you were to shrink it down to like the size of a billiard ball, it would be the world's smoothest billiard ball.
Okay.
And if you draw if you get the pictures that NASA gives us, and you put a perfect circle around them in Photoshop, it fits perfectly in with no gaps. So it is basically a perfect sphere. They just call it an oblate spheroid as because it's not quite. It's a tiny little bit fatter at the equator than the poles, is what they're telling us. But just really quickly, right? So I just put two links in the side chat. So look, here's a PhD geophysicist, pretty decorated career. There's also a scholar, whatever, link showing you all of his educational achievements and that kind of thing. He's a flat earther. If you want to learn a bit more about it from the point of a geophysicist who has a PhD, I mean, he explains a bunch in the video. It's subtitled, but that's just
Is he
an
a
example.
Brazilian?
He's from Brazil, yeah.
Okay. Oh, Sao Paulo, yeah.
Yeah.
I mean, okay.
Most people are working off a spherical coordinate system, and that's essentially what the globe is if you dig into the history of the globe. It's a very convenient coordinate system based off the way that we observe the sky and the use of the celestial sphere, which
But
is
is
a
it like
conceptual.
accurate though?
Well, not really. It's not really that accurate. They have to make all sorts of adjustments, right? Because the celestial sphere doesn't really align, right? But this is the thing. It's just a coordinate system. It's not accurate in the sense that when we actually test for the curvature, it exists in the real world. Sure, you can use a spherical coordinate system to get around and that kind of thing. Just like you can put coordinates onto any shaped surface and you could get around, assuming that you're on a dinosaur. As long as the coordinate system conversion was consistent, it would be internally consistent and you could get around using that coordinate system. But that doesn't mean that that's the reality that we live in. Like the map's not the territory, the coordinate system's not necessarily like the actual territory that we live on, because when we check it for curvature, 100% of the time there's zero curvature over these large distances where there would have to be a certain amount of curvature present.
Yeah, I'm skeptical of that, obviously, but
right.
So do you guys think that just like the vast majority of scientists are just like either mistaken or lying?
I don't think they're lying. I think the vast
Well, I said
majority of
mistaken or
scientists.
lying.
Yeah, no. So I'm saying like mistaken, yes, but lying, no. That's what I mean. I'm not saying what you said was wrong. So yeah, I think that they go to university, like they grow up thinking the Earth's a globe. They probably never questioned it, and then they go to school, then they go to university. They get rewarded for repeating the information in the textbooks on their exams, and then they get a very very specific job in whatever field they decide to go into, and then they learn the textbooks, they memorize the textbooks, and then they can go and do their job. And they probably never questioned whether the Earth's flat or a globe. They probably just assumed that that's something that was worked out thousands of years ago by some ancient Greeks because that's what they got taught while they were growing up. So they're not lying when they're teaching people that it's a globe, or they're professors. They're just repeating information.
Sorry. I mean, how do you guys like? I feel like that could also just be like applied to like a lot of things though, where it's like, oh, people kind of just take this for granted.
Oh, they
So
do,
like a lot of
100%.
like mathematics. Do you guys like feel like that? I don't know. Hodge can correct me, but it feels like a lot of mathematics. Like there are some parts of it that just can't be proven, and then a lot of people don't know the proofs when they're doing math. They just kind of take it as a granted that it's true, and it seems like they're just as plausibly mistaken. That
There's
seems like a
probably lots of
problem.
instances. Yeah, there's probably lots of instances that are similar. But
I
if
can give you
someone
one.
tells us that, yeah, go ahead.
Yeah, I took aquatic biology, and my professor mistakenly told the class, and then someone questioned it, and he reassured the class that the tuna is the fastest fish in the sea. That was just a mistake on his end. He was thinking it was the blue marlin, but he just said tuna, and so there was like 3 years I was just telling people like, no, you're wrong. The tuna is the fastest fish in the sea, without even fact checking it or like searching. It's just because my professor had told me and reassured the class after someone had questioned it, so I was so certain. But then,
but the
like a couple years later, do some research myself, and you find that's a very simple.
Yeah, great
The
example, man.
Sometimes
well, the issue with this is that seems like a qualitative difference between one professor messing up and like systemic error in a field,
Yeah,
right?
but like we were saying earlier, like in each different field that is based off of theories, you're gonna have you put 100 of those same scientists or people in that field in a room, and I guarantee you that most of them are not gonna believe the exact same thing. They're gonna have a disagreement upon discussion at some point, where they
That's
just
fine.
and that's I think that that's more of where you're getting at.
I mean that's completely fine. But the idea I'm just saying there seems to be equal room for error in a lot of other fields, and that we don't think that those fields are an error. So why is the flat Earth an error? And then
Give an example of another. Give an example of like another. Because I personally, I get what you're saying, but we know that there's like a lot of those issues in almost every single field, even when they're factual fields, even when they're a field that everything's testable and provable, like a trade like plumbing, but either way, regardless of what the plumbing texts say, like what the code says, every plumber is going to plumb their job to code, but every plumber is going to plumb it just slightly differently than the last guy. They're going to all do it differently. They're not going to plumb it the exact same every time. That's a factual, like
Sure.
all of that. That's a trade where everything is like proven, and they go out and they do the work, and it actually happens, versus something that is just people doing studies on information, and they can't come to a straight, provable conclusion, so they run with a theory. Well, they have their theory. The next guy that believes the same base that they do has a different theory, but they get to the same conclusions within their theories. They're just about something that is it's untestable. You have to
Well,
make theories about it. It's not
it
provable.
seems like you can't. This is testable, but a lot of these things are testable. But what about like someone saying that like nitrogen is the vast majority of the atmosphere? I think if I made like a Discord call on here and said nitrogen is not the vast majority of the atmosphere, prove me wrong or something, And then you said all of science is mistaken about the composition of the atmosphere. Or
Well, it's not
something.
like that. This is something that anyone can go and test themselves. Now, if you
Yeah.
can find scientists that have actually gone out and physically tested the mathematics against reality and validated that there's actually curvature, then that would be great. But they haven't done that, and some have, right? Like Dr. John Dee is a PhD scientist in the specializing in spectrophotometry. So he's an expert when it comes to lasers and that kind of thing, light propagation. And he went took a bunch of his laboratory equipment and went out to try to debunk flat Earth. And he did a year's worth of tests, and he documented all of them and filmed all of them. And he was forced to leave the globe, right, because he couldn't find the curvature. And he's got tons of videos, tons of tests where he goes over all of the specifications of light propagation through the atmosphere, lasers, this, that. And he shows you real tests where he's like, okay, over this distance on a globe with gravity, right, pulling everything towards the center of mass, there has to be X amount of curvature. And this test proves that there is actually zero curvature and hundreds of feet of curvature absent. And then he repeats it again and again and again and shows, look, every time I'm checking it, there's no curvature there, right? Let me go and try different spectrums of laser beams, all sorts of different things. And he encourages, he says, look, anyone, challenge me on these tests. Come out with me in the field. I'll show you how to do it.
Yeah.
And nobody has been able to invalidate these tests.
If I like look up like flat Earth scientist test, I'm not gonna find anything.
Yeah, just type in Dr. John Dee into YouTube. His channel will
No, I
come
mean
straight up.
like if I'd find scientists who came to the conclusion that it is round, if I like look that up, I'm not gonna find any who've done these tests and they found out that
No.
it's round.
No, you'll just find them showing stuff and stating information.
Presumably
They're not
that
going to be like
information
showing in
proves.
the field tests.
Okay.
They're just going to be showing. They're going to be showing past things that people have done and combining them to make it to give you the conclusion of their theory.
What about those guys that went to was it Antarctica and then like the sun moved in a way that was only possible if the Earth was round or whatever? What about those guys?
No, that's like a right. So what a lot of these flat Earth
Well, they left
debunkers
the
do-
flat Earth because they found out the globe was true.
No. Only one of them did, and one of them was a retard called Jaren, and we're happy for him to have left because he's been pissing everyone off for years because he gets tricked into going into these hit piece mockumentaries, right? He's
Yeah.
already done that in the past, right? And it's great that we don't have to clean up his mess anymore. And the other people that went, right, like the smart guy that went, Austin Whitsitt, of course, he's still a flat earther. He still makes content, and for flat Earth. Right, it was only Jaren.
Okay.
Yeah,
Only
Jaren. Yeah, it's the same guy. If you type in flat earther debunks
what
himself,
actually
right, it's
was
always
the
gonna be pictures of
phenomenon?
Jaren. Well,
Was
okay,
the
so Jaren used a globe map, right? Jaren used an azimuthal equidistant globe projection, which is a polar projection map, and he says that that's the flat Earth map, which a lot of flat earthers were saying this is the flat Earth map, even though it's a spherical coordinate system projection. Anyway, he envisioned that in his flat Earth model, there was a little sun and moon that orbited around in a certain way, and that all of the stars also just orbited or circled around the North Star Polaris. And he had concluded that on his own model, right, that you wouldn't be able to have a 24-hour sun in the sky in the south. Now, there were videos that showed the 24-hour sun in the south, and it turned out that they had been faked. And then we had interviews from people. It turned out that there were interviews from people that said that they went there and they never saw a 24-hour sun. So he had a lot of reinforcement of this idea and this model that he had. And then he went there and he saw a 24-hour sun, and he's like, oh, that goes against my model. My model's the only way that it could possibly be laid out. So therefore, the Earth must be a globe. Right, the same guy that's been whining about being broke ass for years and begging people for money, right, goes there with a bunch of anti-flat earthers, and then all of a sudden turns around and says every single thing that he's said over the last 10 years was completely incorrect, and now makes anti-flat earth videos, right? So yeah, that's just one instance, right? So look, check this logic out, right? So if you can measure your floor flat, right? The ground's flat. You can measure it in all different places all over your floor. But whatever's happening with the lights up on the ceiling is never going to change the fact that you've tested the floor over and over again. You can confirm it's flat. It's the same thing. Whatever's happening with the lights up in the sky, right? The celestial bodies, the big clock in the sky, it doesn't change the fact that we can test the surface of the Earth over and over and over again and confirm that it's not curving. If that makes sense.
I've
Yeah,
been people.
who here? Ooh.
No, it's okay.
Well, I was gonna ask who here is a flat earther.
Yeah, there's lots of people. Yeah, it's a bunch
Okay.
of yeah.
Yeah, I mean, could you guys explain why when we express the Earth formally as an oblate spheroidal coordinate, using oblate spheroidal coordinates, things we predict are much more aligned with reality as opposed to when expressed as a flat plane? Could you explain like why that's the case or not?
Yeah, it's not the case, right? When we go and test over certain distances where there would have to be a certain amount of curvature, it's never there at all, right? Like we
Wait,
could
how
zoom
do you
in
express it formally? You're saying it's not the case, which just suppose that when you express it formally, the
Formally?
predictions they're made on the flat plane understanding is just such
Yeah.
that they align more with reality. So how do you express them formally then? Could you explain?
Well, look, I can give you just a really basic rundown. I don't know how formal it's going to be, but if the Earth is a globe with a radius of
It's like in
3,950
mathematics, I think.
If you can't express it formally, you wouldn't know if it's you wouldn't know what the predictions are.
Yeah, I do know the predictions. Okay,
Well, no,
so
you
if
just
the
could if you
Earth
don't
is,
express it formally because the predictions are made from the
if you
formal
shut up for a
expression.
second and let me talk,
Why are you tweaking
right? Let
out?
me explain it.
Do you even know what what's a
Because
coordinate?
you're talking about a coordinate
You don't
system
know
that
what
was based
coordinates
off the celestial sphere. We're talking about the lat long coordinate system.
It's not even true
Okay,
either.
which is it's a spherical coordinate. You keep over talking me. Notice how the other guy was polite,
That's not even true at
respectful,
all.
and
It's not even
right.
true
So
at all because the only relevant difference.
if you talk over the top of me, right? So this isn't your channel. This is our channel, and you're a guest
Well, actually,
here.
it's my
So
channel.
if you want to be really, so what happens
Yeah.
now? Now you can't talk, right? So if it's your channel, how come you can't talk and I'm the one talking? Right? Because it's not your channel, is it? Now, if the Earth is a globe with a radius of 3,959 miles, over a 20-mile distance, there should be 266.67 feet of curvature, right? If gravity pulls everything towards the center of mass, this would have to be the case. And if that's not the case, and we can go and check over and over again using different methods that there's actually zero curvature over this distance, that would debunk the globe. Right? We've tested this in countless amounts of locations over different bodies of water, the ocean, the lakes, this kind of thing, all sorts of different methodologies, and there's no curvature. So therefore, the Earth cannot possibly be a globe, and the entire heliocentric model basically relies on that radius value being correct, the entire cosmic distance ladder, and so on. So if the water's not curving, the Earth's not a globe. You can cope about it all you like.
Well,
and
it does seem like a problem.
Uh-huh.
And if like mathematical systems based off the assumption that the Earth is round better predict reality than ones that are based off the Earth being flat, it does seem like a problem. I don't know how true that is. You can send the
Right. So if I stood at a 20-mile lake, right, and make a prediction based on the Earth being a globe, and let's say on the other side of the lake there's a 25-story skyrise building, right? If the Earth's a globe, the prediction would be that that building would be completely hidden behind the horizon. That would be the prediction on the globe, right? I would make the prediction that if the Earth was flat, I could zoom in across that lake and see the whole building. Now, when we put those two predictions to the test, one of them does happen and one of them doesn't happen. And the prediction from the flat Earth side is the correct prediction 100% of the time.
Is it possible that it's just the case that these tests are being done in a way that's like biased towards flat earthers? Like maybe the thing is close enough where we actually wouldn't expect it to be hidden by the curve of the Earth or something like that?
No, that's not possible because they tell us this is the math that we're testing that's based off the 3959 mile radius value. I mean, if you wanted to say the math is wrong, then you could just check the math and then confirm that it's actually correct. If the Earth was a globe, then you would have to have 266 foot of curvature approximately over any 20-mile body of water anywhere on the globe. And if you think that that's incorrect, then just look it up. and do the math and that kind of thing, and you'll know that that is correct. The correct
I was
prediction
just
is
curious.
correct.
I looked up empirical evidence for the round Earth, the shape of the Earth, and the Wikipedia has a series of photographs of a tanker going through the Strait of Magellan. What do you think about this?
Okay, how would that only work on a globe?
Well, presumably it's hidden by the horizon, and then it becomes
right.
less hidden as it gets closer to the camera, right?
Oh yeah. But that's we can if you have certain conditions, then that's also exactly what we would expect on a flat surface, and we can actually just use mainstream
Gimps.
optics.
You're all a bunch of fucking
definition.
retarded
Fucking
gimps.
niggers.
You're all a
Supposed
bunch
to
of
be dumb fucking
retarded
niggers
gimps.
together.
Retarded,
Fucking faggots.
retarded,
Keep
retarded.
joking
You're all
each other's
fucking
fucking
retarded.
stupid.
Can somebody mute the?
Yeah, very angry young man. Yeah, look, so we can explain bottom-up disappearance on a flat surface, and even according to the experts that believe the Earth's a globe, you can have bottom-up obstruction on a flat surface due to certain atmospheric conditions, and also due to physical obstruction caused by topographical features or by ocean swells. And most often that doesn't happen. Most often we can see boats that are far beyond where we should be able to see them, and quite often they'll just go out of view by getting smaller and smaller and smaller. Once they get below 0.02 degrees, they are too small for the human eye to resolve. But then we can zoom in with a nice camera or a telescope, and we can see the whole boat again, unless you have those certain atmospheric conditions present to
But hide the
cause
bottom of it.
yeah, like sinking refraction, which is basically defined as something that would normally be visible, appears to be obstructed behind the horizon, partially or fully, even though the line of sight is geometrically unobstructed. And it happens when you have a normal lapse rate, basically, right? So it is actually a normal condition where you have warmer air getting colder as you go up vertically, and the colder air is more dense, so the light deviates towards the denser air, and it basically tricks the human brain, because the human brain interprets light rays coming in straight lines, so it makes it look like the thing is sinking, and that's why they call it sinking. It's the opposite of looming, and yeah, that's just something that happens, and we can recreate that on a flat floor as well. Like, we can set up a little boat on the other side of the room, and if we manipulate the temperature conditions in the room, it can look like the whole bottom of the boat gets hidden behind a horizon, even though the floor's flat. It wasn't hidden a moment ago, and then all of a sudden you'll see, bam, the bottom of the boat's missing.
Okay.
Yeah. So boats over the horizon, I can see why they may have used that as like a globe evidence back in the day, but we have pretty good optics now. We have a better understanding of how optics work, and we can zoom them back into view, or we can explain why it's happening.
This is another picture from the same Wikipedia, and it's again at the Strait of Magellan, and it just has like only it's an extremely zoomed in camera showing only the top of a ship, and it doesn't look like there's any
Right.
miraging in that one. So we would expect that under flat Earth.
Yeah. So you can actually see the miraging effect in the bottom of where the ship starts to meet. Now, this could also be a combination of ocean swells as well as some sinking refraction. So we'd need so you can see it's very windy and choppy. It's definitely not just nice flat water. Now, it would be good if we knew the distance to the ship, okay, because we can
It says
track the
15
distance.
kilometers.
All right, so that would be nice to get, the confirmation of the ship tracking radars, rather than someone just telling us it's 15 kilometers. We would also need to know the height of the observer and how big are the ocean swells on that particular day, and what are the refractive conditions, because this perfectly matches a textbook definition of sinking refraction right here. And we have footage very similar to this, so I'll show you some footage right now. Of a similar situation, where instead of just taking a still shot and saying, "Oh, must be hidden behind the curvature," the cameraman actually stayed there and monitored the boat over the next 3 hours, and the boat completely came back to view. Even though the boat was anchored, it didn't move. No, I'll show you. I'll show you quickly what I'm talking about. Proving that it was just just an atmospheric effect that was taking place. Right. So have a look in the side chat. So this is another big boat, right? This is the boat. It's called the Mandarin Arrow, and the boat's anchored. Right. It says in the ship tracking radar. So it's actually over 20 kilometers out into the ocean, about 23 kilometers. So much further than the ship that you posted. Now, in the morning, he goes there and he zooms in on the ship, and look, the whole bottom of the ship's missing. He zooms in a bit further. The whole bottom of the ship completely missing. And it's not unreasonable for someone that thinks the Earth's a globe, right, to take this footage and say, look, where's the bottom of the ship? Okay, but you need to understand how these effects can happen. And you can tell on this particular day, we don't have choppy conditions, we don't have waves. So we can kind of eliminate that could be the cause, because that's a common cause, right? But what happens over the next 3 hours, he keeps zooming in on the ship, and over the next 3 hours, you see the mirage starting to break up, and more of the ship starts to become visible, until 3 hours later, we can see the entire ship again.
Okay. How do you know that he didn't like elevate himself or move closer or something?
Because in the footage, I've got the video. I can post the video footage. In the footage, you can see exactly where the camera's set up on the tripod, and you can see him zoom in from the shoreline. So you can tell that he stays in the same spot for all of the footage.
Okay, I have to go now.
All
This
right.
is fun. I was
All
just
right.
here to kill time.
Yeah, you're good. All good. I appreciate you being respectful and polite.
Yeah, they're still thinking that ships disappear hull first. That's the state of our physics education these days.
Yeah, I mean, even Professor Phil Bell sent me big angry cap locks DMs saying that you can't have sinking refraction over a body of water. And then about an hour later, he came in VC, and about 20 minutes after that, he admitted that he was wrong and that it can absolutely happen over water.
Lots of strange things happen over reflective surfaces.
Yep.
It's the worst way to take photography. That's why I like the Skunk Bay time lapse, because it shows you how sun angles and slight weather changes, temperature changes, can really distort an image.
Good afternoon, everybody. How are you all? Just want to drop a little hello to Yoda and Batman and Kathos and Timbo and Jaeger. Hope you're all doing well.
Doing good, thanks, man.
Yeah, thanks for leaving me out.
Yeah, what about
I didn't even
refraction?
see you, Rayleigh. Sorry, bro. And Jackson. Yeah, what's up, guys? And Talon as well. Sorry, I'm being rude. Debate Daddy as well. What's up, man? How are y'all's day going today? You had anybody interesting in?
I had a question for DJ.
Mm-hmm.
In your server, where can I find that image of the horizontal, like the laser from like shown horizontally across the lake?
Across the frozen lake. It's if you type in lanolin, a channel will pop up. Type in lanolin into the search, and then a channel will pop up. It's like lanolin, ice lake, or something like that, or frozen lake. Click into that, and then you'll see an image that's a .nef, and that's the raw image straight from the camera. It's like 50 megabytes.
Oh, okay.
You can just download that one. It's the raw image straight out of his camera.
Yeah, okay, I got this one. The question was about this image. When I'm looking at this, I see on the right-hand side, the laser is kind of like it's like in the water almost, and then on the left side, it's like in the mountain, so it's going up.
Right. So this is a frozen lake. And what this is like. So usually when you look at a long laser transit, you can't really see the entirety of the beam. So what he had to do was take a long exposure photography. That's why you can see the star trails. So he had to set up the camera on a tripod and leave the shutter open for a really long time to be able to capture the laser beam. And because the laser beam's much more intense towards the end of the beam where the source is, it's actually there's like a bit of like a it's capturing a lot more light right from the laser. So that's why it looks like it's like lower to the ground. It's thicker at that end.
But one of them on the right-hand side, it looks like it's like below the mountain in the background, and then on the left side, it's like in the mountain on the background. It looks
Well,
like it
those
will
those
actually.
mountains are way off in the distance.
Right, they're
Yeah.
not perfectly parallel with the horizon, dude, because you got an even shoreline, and that's what you're comparing it to.
What was the angle of the laser that they took, that they recorded?
Just one thing to the next.
Well, I mean, that would help me understand the.
All right, so you're conceding that point. Good, move on.
I know it looks like it's going up.
It was
but
3 foot. It was 3 foot to 3 foot. It was detected at a 3 foot target.
No, but
3
the
foot to
angle
3
at
foot.
the laser, like the angle of the laser parallel to the ground, like what was it parallel, or did they just?
No, it's high enough to lob the laser over the curve.
No, because like if this laser is going up and then curving downwards over a flat plane or a globe, like that would be a problem.
Well, it's not curving downward because we have firstly, if you have a look at the raw image, you'll notice that he's actually purposely taken the beam shot way above the center of the frame. So we can't say it's barrel distortion. He's also used one of the best quality rectilinear lenses in terms of mitigating distortion. And the laser, when you compress it vertically, the picture, it actually is very slightly bending upward. So any notion of the laser bending downward is
No, it bending upward in this frame would make sense if it were like later towards the target, but it would have to bend downward to like hit.
No, this is
on a flat
basically-
plane or a globe.
This is basically the entirety of the 6 miles, right? So he went really far back on the lake, so he could fit pretty much all of the 6 mile laser transit in. So it was detected, shot from 3 foot, hit the target at 3 foot. The beam very slight, very slight upward bending when you like compress the shit out of it vertically. But it would have to be bending down.
But did he take like a theodolite measurement of the laser, like of the angle of the laser?
Nope.
At the
Laser
station?
laser just hit the target.
That seems like pretty crucial though, right? It's like
You
if
think it's gonna lob over the curve, dude?
Because for example,
the centroid of the beam hit the sensor on the target.
Yeah, but when okay. If you're getting
Back, you're echoing yourself.
Someone's echoing. But if you're pointing the laser upward at the station, then you would know that whether it's flat or not, that the laser would have to bend down. So it would be good to know that angle so that we could roll that out.
Well, even if so putting the laser up, down, anything like that, it's not going to hit the target if the Earth's a globe. If you bend it down, obviously that's not going to help, because from 3 miles you would have a horizon. 3 foot you would have a horizon at less than 2 miles away. And if you point it up, right, that's going to be even worse, right? Then it's not going to get anywhere near that 3 foot target, and then it would have to be bending down, which it isn't bending down at all. So what they do is they can slightly maneuver the laser around until they get a direct hit into the sensor with the centroid of the laser beam into the target. And to know it's not bending down, he took the side view.
Hey, I'm getting in here a little bit late. I'm just trying to figure out, are you talking about lasers bending from gravity? I'm just making a shot in the dark.
No. Like lasers and light over these sort of distances wouldn't bend due to gravity in any amount that would be useful for any type of mathematics, right? It would be such a small amount that it would be just negligible in any situation if it was gravity as the cause of the bending that you were talking about.
So if the laser angle at the station is angled upward, then whether it's flat or not, it would have to curve down to hit it to get a hit. If it's bending downward at the station, then it would have to
just
curve
run into the
up to hit
ground.
it would have to curve up to hit the target, and it would be easier on a flat plane because you'd have a drop over distance on a globe with that. If it's level, if it's completely level, then you would have the kind of experiment that you guys are talking about. But like, did they even record that angle, or did they
You
just
could watch the documentary. The documentary is also in the channel, and he actually has much more technical documents on this particular test as well, with all the calculus and everything laid out. But
because to omit that or to not take that angle seems kind of like strange that he wouldn't take that. Like, obviously you have the station, you could easily take the angle, but omitting that angle,
what angle? Like what angle do you think he should take?
The angle of the laser at the station, like the theodolite angle.
Right. So if the Earth was a globe, how would that angle make the experiment work?
Well, it seems like on a globe, if the laser is able to curve downward, whether it's pointed up on a flat plane, you could point it like kind of like to get it to go further.
Yeah, keep it simple. Don't worry about flat. Right?
Yeah,
Just
because
say
like you could
if the Earth's
if
a
it's able to
globe,
curve, but you agree, like if the laser's able to curve downward and you point it up, you could get it to get a hit like artificially further than you otherwise would.
it would have to be bending downward. That's why he took
Yeah.
the side view. Yeah, it's not doing that.
Well, I can't really see from this. Like, it looks like it's
We'll take the 50 megabyte image. It's 8K. It's over 8K, right? And you can put that into Photoshop, and you can squish it horizontally, and you can see that the laser's not bending downward.
Hey, so I've stated in here before, like I've done a laser experiment across water at 16 miles of the ocean with no change at all in elevation, just throwing it out.
Hey, Debate Daddy, you keep posting that windmill picture. Why don't you have the viewer height, target distance, and all that kind of info for that one? Don't you think it's just as important as the lanolin picture?
I just posted that because before Regan was here, and
But don't you think that information's important?
yeah,
The viewer height, target distance. I mean, you put all this scrutiny on lanolin's picture, but you don't have any of that same scrutiny for what you posted.
yeah, but I just have this source here, this Wikipedia source.
But I looked at the source. Viewer height, target distance, and claimed curve amount is not in there.
It says 50 kilometer distance.
much curve are you claiming to see? Or how much between the furthest and closest windmill, how much curve is there? How much curving drop over that distance is there?
Over 50 kilometers?
Between the furthest and closest windmill in your image that you shared.
I mean, we could look up the Thornton Bank wind farm to like figure that out, but like.
But don't you think that's important to know before you post those kind of things?
Oh, I was just posting it because Regan was posting other similar images and asking questions.
Okay.
Does it say the observer height as well? And do we have confirmation of the distance and the observer location?
Are there globers in chat right now?
Yeah. Yep.
So I'm just curious, like when you Google like Earth curve calculator, do you believe the math on all those results to show up as truth, or at least close to truth?
Any globers want to answer that one?
Do you mean
Like if you go to if you just go to Google and type in Earth curve calculator, the first result I think is from GitHub, but there's multiple below that that are all the same, and you can put in like the viewer, the eye height, the target distance, etc., and it does the math for you. Do you think that math is correct? Like, do you think they're using proper equation to measure the type of distances we're trying to measure? You know, like less than 500 miles.
Oh yeah, generally, yeah.
Okay. Yeah, I've just had a lot of people say, you know, that's not true.
Doesn't Walter Bislin's one even factor in just like a refraction dial that you change?
Yeah, it's all it is a globe inflator. So it just inflates the radius until the observation has no hidden height. But for all of these observations that we present, you basically just have to max out the refraction slider, essentially to the setting that's just the flat setting, as Walter Bislin states, that if you have to max the slider out, that means that there's so much refraction, the Earth would just appear completely flat. It would have to have a radius of like 40 million miles or something like that. So just unrealistic, unverified levels of refraction that just don't have any evidence to be real. But for this one, right, with the Thornton one, so let's say the observer's 6 foot high, the target size, right, they're 157 foot tall. I just looked them up, and that's to the you know, the top of the, like the center of the blades. Okay, target distance is 31 miles, which is 50 kilometers. So that hidden height is check 522 feet, and the height of the what's 100? Yeah, so 515 feet. Yeah, so I mean, firstly, we can see that there's a mirage taking place, right? But if there wasn't, then you shouldn't be able to see what we're seeing here. And then once again, you would just have to start guessing the refraction. So it's just a super invalid observation, missing all sorts of stuff. Because the globe earthers, right? This is the huge difference between flat earthers' observations and globe earthers' observations, right? You guys are making a specific claim of the size of the Earth and the shape of the Earth. We're not doing that. And globe earthers and flat earthers alike all just experience the Earth as flat, right? They teach us that, oh, you don't see the curvature of the Earth because we're so small and the globe's so big, and from your local perspective, it would just look flat, right? So we have this flat baseline that we start with. It's not like we have a curving baseline to start with. And flat earthers are saying, oh, I know it looks curved, but really it's flat. That's not what anyone's doing, right? We can both agree, we can all agree that it looks flat. It's flat from our perspective. But the globe earthers are saying, well, actually, it's 39, 59 mile radius and there's X amount of curvature and it's a big ball. So what we're doing is we're taking that hyperspecific claim that you guys make and we're just testing it. But we just detect flatness when we do it and we don't detect any curvature. Right? But you guys claim that maybe there's some type of refraction effect that could make that work on a globe. Once again, that's your guys' claim. And we could just say, hey, do you have any observations that take that into account that match up with the globe and consistently and that kind of thing? And that's where there just isn't any. And then the globe earthers sometimes say, oh, you guys didn't account for refraction. It's like, well, we're just testing your claim. We don't claim that there's radius-based refraction, right, with some sort of spherical atmosphere gradient. We don't claim that. You guys claim that. And the refraction slider takes also presupposes a globe, right, because it has little k, the refraction coefficient. So we're just testing that, and we can't find any confirmation of it to exist in reality. So you guys are the ones that have to prove that there's curvature and account for refraction. We just detect flatness, which is like the base axiom.
Hey, I live in East Tennessee, and I dare you to come here and just find one piece of flat ground. Everything's on an angle. I'm being
Right, that's why we
facetious.
just. Well, that's another tactic. They're like, yeah, so exactly, man. You know, we just talk about the water, surface of the water.
Yeah. Well, what about places like the Bonneville Salt Flats? You know, like when it rains and there's like an inch of water and it looks like a perfect mirror, not a convex or a concave mirror. It's like a completely distorted, perfect reflection of the sky for miles and miles.
Yeah, it's insane. It's freaking awesome. Oh, yeah, I would have gotten a beautiful picture of it in the side chat.
And then another, like up in the central part of Canada, there's a road and a railroad track that runs parallel, like in a northwest southeast direction, for like 100 and something miles, and it's like supposed to be the flattest place on Earth. We're able to see lasers at like 50 miles or some crazy number. How like the Earth would have to be like a huge geometrical shape. I don't even know what the shape's called that would have like all kinds of flat sections on it, like a huge soccer ball.
Yeah, those specular reflections are one of my favorite proofs, especially when they do it at night. You can see the overhead stars and they align perfectly with the reflections in the water. There would be a difference in, obviously, in the reflection with the claim distance to the stars. It would distort them.
Oh, yeah, a ton. I can't stay, but I hope you all have a good day. I might be back later.
Awesome, bro.
I'm on the moon right now in Minecraft.
You're on the moon in Minecraft?
Yeah.
Check.
This is my moon base. to my oxygen system. I'll be flying back to Earth here soon. The cube Earth. My oxygen system.
Is the moon also a cube in Minecraft?
Yeah, in this mod, yeah. You can't. It's just a flat surface. It's really not even a cube. It's just a flat plane. So, but when you leave the surface, of each planet, it shows as a cube. Here, I'll try to. I can't remember what I was doing. I think I was just dropping off stuff. Basically, my rocket exploded last time I came here. I'm trying to get back to this. Yeah, until for some reason as well, there's like day and night cycles on the moon, which doesn't happen in real life, but I think I'm stuck on the moon. The moon also, when it's dark, it has 14 days worth of night, basically. I don't know if that makes sense, but like it's a 14-day period. So it's really long on the moon in Minecraft. Wait, what? I thought the Earth was already flat in Minecraft.
In which world?
In Minecraft.
Yeah, but you can have two different worlds around.
Oh, the Nether's flat too.
Actually, if you make a flat Minecraft world and then go to the Nether, it's just the same as the normal Minecraft world.
Oh, you mean flat? Okay, I see what you're saying. You mean like the actual like flat version or like the regular terrain generation?
Yeah.
Yeah.
Of just Minecraft, not I mean, there is a different version that you can play. The crazy thing is I actually played for like 3 years on the flat version because I didn't know the other one was available when I was younger. Me and my brothers.
Dude, the flat one is. I like the flat one because, especially if you're in creative, like I don't know. There's just more like space to create things. Like I would just make dumb shit for no reason.
In some ways, I wish I was a kid now that with like more technology available because maybe I don't. But like for example, if I was a little kid playing Minecraft today, there's so many different. Like there's just so much, it's like, oh my god.
I'd probably be hooked to the game. There's so many different like, especially now that Microsoft owns it. There's so many different microtransactions and servers and mini games. I only had it on their Xbox as a kid, so.
Well, I mean, like we never had worlds that you could play on like hundreds of people and stuff. So it's kind of like it didn't exist.
Not until servers have gotten bigger.
Yeah.
People's computers have also gotten better. You're digging up fucking cheese. They have cheese on the moon in this. I think it's like some copper or something, and it's fucking cheese.
Mm.
Alright, who here believes in the sphere? Any sphere believers?
I do, bro.
I believe in a sphere.
Okay, let's see the evidence. What's the evidence?
What do you mean?
Mm-hmm.
You're a sphere enjoyer?
Yeah, I like spheres.
Alright, where's the evidence of the spheres?
Which sphere?
The Earth.
Oh. No, I'm playing stupid, my bad.
Are you a Earth sphere enjoyer?
No. I just enjoy the Earth.
We need a globe defender, a globe enjoyer.
What if you're like a globe attacker and you make an argument?
Yeah, globe attacker. That's what we're doing. We're attacking the globe, yeah.
Right, but like again, there's nothing to defend because there's nothing that can't be attacked. So like, I don't understand the point.
Oh damn.
In some ways, like if there's always an answer to the available sets of evidences, then like, okay, just make us a map already.
Here, look. You see my stream?
Right.
Checkmate Globers.
You feel me?
Yeah, checkmate globe earthers.
Checkmate Globers. I didn't realize I could look up at the moon. Or sorry, the Earth.
That's the funny checkmate atheist meme. That's really funny.
There's not even an ice wall.
Not even. If you okay, let me ask you this: have you ever looked up the Wikipedia for Antarctica?
The Wikipedia?
Yeah.
No, I'm not.
Let me just see, because I'm pretty sure.
I doubt he has either. I doubt any of us have looked at the Wikipedia.
If you type Control F in the Wikipedia of Antarctica, it will say, you'll see ice wall. It'll give you a like it'll actually return something. Like if you search that phrase in the Wikipedia for Antarctica, it will say ice wall, which is kind of funny. Think about it.
But like, as a flat Earth person, you don't believe in the ice wall, or you think this possible?
No, it's not like an edge.
Mm-hmm.
Because when you say ice wall, you're talking about this edge, right? But that's not. There's no proof of an edge. You know what I mean?
Mm-hmm. There's no edge.
Yeah, because
Oh,
that's what they really mean when they say ice wall. They're not just talking about. They're not just saying, "Oh, look, there's a bunch of ice." Like, yeah, it doesn't, because it would be irrelevant. You know what I mean? What you
Mhm.
really need to ask is there an ice wall that represents a physical edge? That's what your
Like,
question really is.
yeah, but is there an edge at all? Like, you think? So you think there's not
No,
an
we
edge?
we don't have to assume anything. That's the thing. We're not gonna make a claim that we can't prove. So if I told you Santa Claus was real,
Right, but
like,
a
that's
flat
not.
Earth is either infinite or has an edge.
Yeah, either way, yeah, both of those, yeah, both sides to what you just said, there's no evidence for either side.
But there's no other options.
I think the edge of flat Earth is over there by the edge of space.
No, look, it's right there. It's right there.
It's right there.
Yeah,
Where?
well, this is the thing. If you're at the North Pole and you just went in a straight line directly away from that, right? If the Earth's a globe, then you would come back to where you started eventually, and that would be a north to south circumnavigation, a great circle all the way around the globe. But no one's ever done that. No one's ever just kept going away from the north in a straight line and see what happens, right? Nobody that we can verify anyway.
Yeah, but if no single person had driven around X city, we could still figure out that X city has borders. We could add
Yeah.
up the people who have gone around it. Not that
Yeah.
it's not that complicated.
Yeah, you don't need one person for that. That's true.
What do you mean by borders?
He's saying
Like
he's
if
saying
you're
first.
trying to trace the edges of a city, and no
First of all,
single person has ever driven around it or walked around it.
listen,
But let's say you've had everyone, like people go around the city all the time, not the entire thing, and then you add up those numbers, and then you can get the border of the city. It's literally just mapping. It's
yeah,
not
but
that hard.
also, even if we had
the,
one person, we had one source, we couldn't. It would be incredible, right? We need more than one person to do it. So
Yeah, there isn't even one source, so that's the thing.
Surveying
I've
is not
never,
one guy map the globe or map the earth. Like it's just
no
one
just being
said that,
honest,
bro.
I've never heard someone use the word incredible in that context, and it's actually kind of crazy.
Yeah, this
I
is
mean,
what I'm
also,
saying. Right?
like
also, it
imagine
would.
saying find me one person that's traveled to every single like spot in like Europe, like every single
Yeah,
foot. Like
He
they've
nobody's
walked
actually
to
saying
said
every
that.
he
single.
said
Hey,
uncredible.
this is
Oh,
what I'm
okay.
saying.
Well, I mean,
Right?
wouldn't incredible mean like it's not
We
credible?
don't know. We don't know where some edge is. Well, there could be some kind of edge, whether it be some sort of shoreline, some sort of edge of some kind. We don't know that because no one's ever just kept going south, right?
What?
Even on the globe side.
Yeah, but
Yeah,
No one's
why?
ever
Why
done
would
that?
the
You have
edge be
evidence for that?
south though? Why would the edge be south?
because that's every direction away from the north, right? Is going to be south on your
Yeah, but
compass.
that's
If you go in
assuming
a
that
straight
compasses
line.
actually work correctly. Like that's
All right, so just that's the claim, right? So if you went away from the north in a straight line and the Earth was a globe, then you would come back to where you started again, unless you think compasses are lying to you.
right. Well, that's what I'm saying. Like we don't. There is no. We don't have proof of alignment for compasses to the north, right? So like the edge technically could be to the south. I mean, to the east or west, right?
No, east and west is circles around a north pole.
You have to
No,
go in a straight line.
That's only.
That's the point.
That's only on the globe. That's only on the globe proof. Like we need like a flat earther to prove
No,
this.
bro. East and west are circles around any north pole on any
I don't know where
surface.
you're getting that from. You got any
Right. So
evidence
if you
for that?
took
He thinks that you can't fly or move straight.
Donald,
That's the
shush.
issue. That's that's what he's saying, that you're
No.
not.
Shut up. Don't say what I'm saying, idiot. This is what I'm saying. If you just chuck a magnet down on the ground, okay, and get a compass and go east to west around it, you're going to go in a circle and come back to where you started. Same on the globe, same on a flat Earth. Go chuck a big magnet on a football field. Go chuck it on
Yeah,
any
that's
surface.
fine. What I'm saying is, how do we not know that the magnet that they're using is moving, right?
What magnet?
That's what I'm saying. The one that's moving our compasses.
It's not moving the compasses. The compass only moves if you move, right? The magnet's always going to point towards where the magnetic north pole is.
Right, but how do we know that, right? That's what I'm saying.
Well, all we know is that the compass
It's
is pointing
defined as
to
the
it.
magnetic north. It's where the magnet points. So it's
Yeah,
just
but that's only defined by people who believe in globes.
No, it's not.
It is.
If the Earth was flat and there was a magnetic pole, it would be the same thing. The compass would just point to the north magnetic pole. It doesn't need to be a globe. It just needs to have a magnet.
Yeah, but the problem is like in a flat Earth, it would turn faster.
What would turn faster?
The
What would
further,
turn? What do you think
like the
turning?
closer you get to it. On a globe, it's
what's going to turn? What do you think's turning?
right. So
You don't think the Earth
the problem is I don't think you understand is that like if you're at the equator, it's going to turn differently than you are if you're going to be closer or farther away from the North Pole.
What is turning?
The compass as you move
every
east to west.
69 miles at the equator. 1 degree every 69 miles at the equator is what your compass would turn or change.
Okay.
Right. Okay. So what would it change at the South Pole?
If you went in a straight line.
South Pole.
Yeah.
Yeah.
We
Well,
have no,
look,
I have no idea.
This is the problem, man. Like
Right. So
on
it on a flat Earth, it should turn, slower than the equator.
what I don't know what you mean by turning.
It would turn 0. It would just spin in circles.
Yeah, compasses just spaz
No, what
out
I'm
when
what
you
I'm
get
saying is on a flat Earth, if you keep going south, well, okay, let's just talk about let's talk about the globe version, which actually happens in real life, right? So if you're at the equator and you're walking south, your
Uh-huh.
compass will become slower and slower. I mean, it'll go faster and faster as you walk east to west. See what I'm saying?
What do you mean
You're
it'll go
talking
past?
about the 1 degree change every 69 miles if you're walking east west on the equator. So let's say you go 2,000 more miles south past the equator. You think it would be like 80 miles for 1 degree or something?
Right. If the circumference of the south side of the Earth is larger than the north,
Well, you need to
then we
get in an
wouldn't see
airplane
that.
to test that.
But if the circumference of the south is identical to the north, then it would.
Has that ever been confirmed to be identical?
Well, all you have to do, so basically, let's start at the North Pole and let's measure east to west differences in the compass over like a mile at a certain speed. And then you go and you keep going further and further all the way to the equator.
At the
You
North Pole,
would expect on a flat Earth that it would just continue to grow. It'd take longer and longer and longer.
no
But it
one's ever
doesn't.
tested or
It
confirmed
speeds
that.
back up when you go. We have.
No, well, show us. Post it in the side chat. And if you at the North Pole, your compass needle should be pointing down towards the ground, and it doesn't.
Right, we're not talking exactly right. You could
Wait.
say like a whole
How would your needle
longitude
point at the
line
ground if it's
off.
fixed on a plane? What do you mean
What I'm
pointing?
saying is like on a flat Earth, they won't be the same, right? It's impossible.
So show us the evidence that it changes in the south.
It doesn't. That's the thing.
Well, show us.
Yeah, prove it.
Okay, so at what longitude line do you want that? Like which one do you want
And
to
you
pick?
you can choose. You can choose, right? Okay, firstly, have a look in the side chat at this magnetic declination chart. Okay, you could be
Okay.
pointing south and going east, right? Like it depends. The magnetic field lines are all over the place.
Yeah,
It's crazy
right.
chaos,
So
and they get
we're
even
just
more chaotic when you get into the south.
yeah.
So yeah, good luck testing out your theory.
Why am I so scrolled all the way up? It's crazy.
Scares me that the poles are shifting.
Yeah, the scientists have no idea what's going on with the magnetic field on Earth, right? Like the NOAA scientists, they say, yeah, we have no idea. It's an anomaly.
I don't
We
think
have
they
no
say that. They
idea.
have theories, but
Yeah, no. They literally say that word for word. Like we can't even predict what it's going to be doing in a year from now. We have no
Oh
idea.
yeah. So on this map, that's what the green line. That's what that represents.
What?
why the fuck do they want jungle sap?
The green line represents what?
Wait, no. What is this map? Where did you get this map from?
It's a magnetic declination chart. Look it up yourself.
Wait, so what source are you getting this from? I'm just wondering. I'm not digging into you, bro.
I don't know where the source is, but just type in magnetic field chart, and you'll get like tons of different
Okay.
ones.
How to read that map, I'm gonna be honest with you.
Here's one from the USGS.
what's being said here? Like, if I'm using a compass, depending on where I'm at, my compass won't be completely accurate.
It originated from saying that where's the edge of the
Well,
flat
that's
Earth,
what
and
I think. That's what he's saying. That's what you're saying,
No,
right?
but
You're
I'm
saying
I'm asking just about this specifically, like with
the
these
map.
magnetic forces. Are we, yeah, with the map of these magnetic fields? What are we stating that? Depending on where you're at, a compass is not completely accurate because of the fluctuations.
Yeah, are you saying according to this map, if I'm in Asia,
like you
my
could be
north
traveling it
is
completely,
pointing
like
towards south?
yeah, you could be pointing towards like south or north or something like that, and
That's not how
actually
this
your
works.
compass
I
is
think this is the strength model.
right, but that's how the magnetic field is claimed to work, right? There is all of these crazy anomalies, and it gets worse when you get into the south.
Mm-hmm.
But doesn't your compass still work just fine?
You're saying
Well,
a
it works just
compass.
fine. It works just fine in relation to the magnetic field lines, and the magnetic field lines go all over the place in certain
So you're saying it
areas.
may not be accurate. The compass still works,
Well,
obviously, because
there's
the
just a big
magnetism.
anomaly. It's not as simple as if you throw a magnet down on a desk, right, and then you get a compass,
Yeah,
and it's
that's
Well,
not what
it's
I'm
very
saying. But
straightforward. It's completely different than just a straightforward magnetic field that you would
with the
expect just by
magnetic
the
fields,
basics.
When you say an anomaly, what do you mean?
well, I think
Well,
he's
they don't
saying it
understand
changes.
how it works. Yeah, there's all sorts of weird like anomalies. It's just not just a uniform magnetic field like if you had a regular compass and it
So if
had
I
different
was,
magnetic.
And when you say an anomaly, they don't understand like what.
here's my question. If I'm standing, let's say in the location I'm at right now at 62 degrees north, 51 degrees west, and today my compass says that this is north, this is south, or I get it only points north, but let's say it's saying this is north. Are you saying that, let's say a year later, I'm in the exact same location? Will my compass, even if there's a major influx, a major anomaly that happens, will my compass still be pointed at the same north, or will it change? That's my, just answer that. Like, will it change, or will it still be pointed in the same direction, even with a major anomaly happening on a later day? Because if it doesn't change, then all of that stuff doesn't matter.
okay, yeah, that's irrelevant. That map is irrelevant to how compasses work. That is a strength. That's a strength map.
Then I'm trying to understand what are we even talking about?
Okay, so your compass is
Because
aligned to magnetic north and magnetic south, which
so
are
how come?
which
Okay,
are
so who
the
brought up the map, and what is the
uh
relevance of this map?
that's what I'm saying. I don't think he understands what the map is doing. That's
Exactly,
why I
it's
asked
not
for his
relevant.
source.
That's what I'm trying to get at. Is no matter
That's
what.
why I was asking for his source, but he never gave it.
Dude, I
The
did
problem
give
is the from what I understand here, and the little 5-minute research that I've done is that the colored map it gives you like it should have like a number or a letter on it, and that's the strength of if you have a weaker magnet, it'll pull it in that area, and it might not pull it in the other area. Is
yeah,
basically what it's
look,
saying.
this is the chart is showing Earth's magnetic field. That's what it's showing.
Right, but it's not showing the direction of the compasses. It's just showing the strength.
Showing. Okay, so there are all sorts of anomalies when it comes to the magnetic field on the Earth.
Right. That's the
Right.
strength.
You made a claim, and we just asked you to back the claim up, and you're meant to be backing the claim up, right? Don't worry
Right.
about
And I'm just
these charts.
okay, I said I was gonna do that. And he said, well, first look at this map. I said, okay. So that's what we're going through.
Right. I understand their different strengths at different points, and this chart
Mhm.
is showing the different strengths as well with the different colors, right?
Yeah.
But it's also showing the magnetic field lines on the Earth as well.
No. Those are not the main those are topographical maps for the strength.
All
Not
right. Well,
height of land, right? Those are just like the areas where this
it
strength is
says here,
most
right?
prevalent.
It says chart showing Earth's magnetic field.
Right, the strength of it. Like the actual magnetic field is the one that's it's perfectly aligned with the poles. You know, it's got circles around the Earth.
Oh, really?
Yeah,
That's incorrect. Where do you think the south magnetic pole is?
it's not on the North Pole and South Pole. It's a little bit off from it.
Right. So the
Yeah.
geographic
Checkmate,
South
liberal.
Pole is not the same as the magnetic South Pole.
Checkmate.
This is a better map right here. I'll show it to you. This is the map of the direction that your compass will face if you're how do I not copy it? There you go.
This is showing the North Pole magnetic field.
Yeah, look, this is the same thing plotted out on a different
Yeah,
projection. Right. Use any of these charts that you want to choose, right? And use any of them to back up what you said that validates the Ursa globe. Unless you just
Let
want to
me
go
see. Let me
whatever.
see. Let me see this. Hold on a second. This is the same. This is the same thing.
yeah.
Is this the South? This is just the South Pole version of it, or the North Pole? I'm
No, it's
sorry.
showing the north and the south. If you look, they actually like manipulated the map to show the North and the South Pole very close together. Like you can
Oh,
see
I see. I
Alaska
see.
at the
I see.
top
I
of the
see.
U.S. and then you can see the Antarctica it's a very manipulated map.
Yeah.
Really quick question: is DJ here?
Yeah, I'm DJ.
Refraction. Okay, Refraction Jackson. Have you ever have you seen that link that Shane posted with his with the test where he fired, instead of firing the laser at like a target on the shoreline, he's firing it at a drone, and he's using like the altitude. Have you ever seen his
Shane St. Pierre? Are you talking about
Shane? And yeah, he's
Shane and Alan Shane? Oh, this Shane in here right now.
Yeah,
this Shane. I haven't done the experiment yet. I'm designing the experiment. I'm just trying to get some feedback about it. I'll post a link again.
Has it been done before?
I don't know. I haven't been able to find one that's like this, but I don't know if I just either overcomplexed it or if I'm missing something.
Change my name back. It's getting confusing.
Can you give a brief summary of it?
Okay.
Shane?
Okay. Here we go. We got it, guys.
I like your documentation. It's pretty neat.
Here's the compass map we're looking for, guys. There we go.
I don't see.
No, that's showing that the
The direction of compass, wherever you are on Earth.
What are the little red and blue things? Right,
North and south.
Okay, so what are the you're showing the what are the black lines for?
They're to give you like the north and south poles. Like they're showing you the direction of the north and south poles, which you see
Right,
they're
but then
not
that's
aligned with
not
the compasses. That's
right,
because
right,
the magnetic poles are off of them.
right. So
Yeah.
that's not showing. It's not even showing where
It's not, the lines on the Earth are literally just pointing towards the north and south centers of the Earth, not the like
Yeah. So this
yeah.
this backs up what I was saying. So there's certain see how the it's not uniform at all. There's all sorts of anomalies, especially when you're getting into the south. So you could be
No,
pointing a different
they're just
direction. Your
pointing
compass is
directly
pointing
at.
you a direction.
They're just pointing at
No, they're
the
not.
South Pole, magnetic pole.
Right, but you
Like
can see in the
they're all pointing straight at the South Pole.
they're not all pointing straight.
They are. It's just the map is it's in a flat version. I mean, it's not a round. It's not a globe, right? Like if you were to stretch this
Yeah.
out and put it on a globe, everything would be pointing
Yeah.
directly straight.
All right, great. Well, grab us the globe one, and then show us the
A globe
confirmation.
version?
Yeah, globe version.
What do you mean?
Well, a globe, right? Show
This
us it
is a
on a
globe
globe.
version. This is a globe version.
Yeah,
So
we don't want a
if you pick
projection.
one of
Show us
these,
it on an actual
if you pick one
actual
of these
globe,
things,
bro.
right? Okay, if you pick one of these things, like let's look at the ones in Africa. They're going to be pointing that direction in the real world. And so if you go over the United States, see how they're all pointing toward Mexico?
Compasses only align with local magnetic field lines, which rarely point directly to the geographic north or south poles. This means that in most places, your compass reading will differ from the true directions.
Wait, what's
Well, that happens when you
Right.
get
So
closer
the
to
scale,
the center.
I'll just read it out just really quickly, right? So the scale, the declination varies wildly depending on where you are. In some areas, it's minor, but in other areas, the difference is massive. For
Yep.
example, in some parts of Alaska, the declination could be up to 25 degrees to 35 degrees.
Mm-hmm.
How to fix it? Because maps are aligned to the true north, using unadjusted compasses in high declination areas can lead you significantly off course. Navigators must add or subtract the local declination value to align their compass with the map. And then there's blackout zones near the poles as well.
Yeah, because your map is
And then
aligned. So like they're not saying that it's not pointing where it says it's pointing. It's just when you try to use a map, the map is not aligned with the magnetic north.
right, but there's also areas where you have huge amounts of
he's saying there's localized
things
bias
under
due
the
to
surface. Yeah, look,
this.
there's places where you can have like local magnetic anomalies and that kind of thing, and it varies depending on where you are, depending on what's under the ground. If there's like huge amounts of iron ore or magnetite or volcanic rock, all sorts of
Wait,
different things. So like they just make the magnetic field lines wonky in certain areas, and it throws compass readings off by like dozens or even hundreds of degrees.
Yeah, sure. Yeah, when I
Yeah.
sailed through the Bermuda Triangle, I mean, you can't even fucking trust the compass, bro. That's just wild.
wait,
Yeah.
100 degrees, hundreds of degrees.
Well,
Yeah.
like
So when
literally, if you sail through the Bermuda Triangle, bro, I don't know what the fuck it is, but your compass, that shit will not work. That shit will not work. I mean, it does sometimes, but sometimes it's just something, I don't know, something spooky going on with it, bro. It's crazy.
yeah,
I don't know
and
if
there's
there's
also
something way in the
places
bottom
like
of the ocean that's affecting it or whatever, but
exactly, man. And there's lots of places like that in the south as well. Gets really crazy in the south, like Bed Out Island, places near Australia, um, all sorts of different places. And that's
it's
why
like
when
environmental
they
things affecting the compass. But the biggest thing is like you can get compasses that aren't affected by which is what those massive compasses do. They're like I can't remember what are they called, those big compasses?
sure, man.
Yeah.
Let's just call them big ass compasses for now.
Yeah, basically if you didn't have like
a Google Earth map, bro, that we use like GPS tracker. There's no way, bro, like to fucking it's like when I sailed for around 8 months, and the shit we did, bro. I tell you, it's crazy, dude. I don't know how the fuck they did it on sailboats, bro. I'll be honest with you. Back in the day, them old wooden boats, I don't know how the fuck they did that shit with maps. That maps that weren't even right. I tell you.
Stars.
The boat I sailed on, we had autopilot, we had GPS, we had Starlink, we had all that shit. And now we did plot maps, right? Because you use two different modes, right? You use map plotting just to verify what the GPS is showing, and because you want to be safe, you only have so many days of food with you. You gotta make sure what you're doing is right. But if we didn't have the fucking maps they have today, bro, there's no way we could have got to where we needed to go. Like the globe maps, it's impossible.
Yeah,
Right. Well,
cartography is
using a
really good
coordinate
science.
system. You're using a coordinate system that's based originally from the sky coordinates. Right. So it's going to be internally consistent. It doesn't mean that the actual reality matches the map. The map's not the territory, but you can use the map to accurately get from place to place. It's going to be internally consistent. But it does originate from, what was
No,
originally.
the maps are not accurate. Absolutely not. If you go from one map to the next, bro, you have to readjust the maps.
Exactly. That's why you use like charts, right? Like you got like if you
Well,
use
no,
like an
they're
overall
flat
system,
maps.
it's not going to work.
They're
Yeah,
not
yeah, yeah.
globe maps. They're flat maps, like the charts.
Yeah, yeah. No, I
So,
know
like
you.
when you go from one edge of a chart, like the New York area, those are smaller charts. Then they've got like the Pacific charts for the north, south, and all the different areas in the Pacific or the Atlantic Ocean. I'm sorry, they've got different charts for out there in the middle of the ocean. And every time you move from chart to chart, you've got to realign where the fuck you're at on that chart because you can't put them side by side and just sail over. It don't work. They don't match up because they're all distorted.
Gotcha. Yeah, I
They're
agree.
not a
Yeah.
globe projection. They're just flat projections.
Yeah.
Has anyone in here taken like a GIS course?
I haven't. No.
If it was a globe, if you had an actual globe map, like in your in your hand, you could actually use it. But that shit, I mean, you can't use it at the scale you need to sail with. Like the charts have so much information on them, and they've got weather patterns. Some of them they've got um, wind patterns on the charts. They've got wind speeds, wind predictability, wind averages for each area in the ocean. They've got they're like little circle. I can't remember what they're called, but they're like little half circle. They're like full circles, and like within a full year, you'll have wind this direction at this speed most of the time, and that's kind of how it works. But and then on top of that, you've got the charts also show the currents as well. So
Yeah.
but like we don't have a globe projection, like a handheld version of a globe that you can buy that has all the information on it that I know of. I mean, it would be fucking massive.
Right. So people can use a nautical almanac and use the stars in a sextant. And everything's based off the spherical coordinate system, which is from the sky.
I mean, isn't
Oh,
that
we didn't do that now, but you
hasn't
could.
that been hasn't that been updated now that we have like
We have
satellite
charts
tracking
now. We have
systems?
charts that you can use a protractor to measure what you're doing, where you're at, all that kind of thing. And it's basically
Yeah.
guesstimates at best.
Yeah, but to utilize that correctly, you would need to, you know, change the magnetic declination every so far that you go. There's even a key on the bottom of the chart. And yeah, as far as being accurate, you'd have to take dead reckoning every once in a while to like
Yeah, of
3 or more
course.
points to get it
Of
accurate.
course, bro. You're absolutely right, dude. Absolutely. And then another problem is like, okay, sure, we can trust our instruments and kind of take some of that out that the boat is measuring, like our distances, our speed over time, that kind of thing. But all that is subject to, failure.
My question is though, is like the using the stars for mapping and stuff like that, hasn't that been like, isn't the alternative of having GPS systems and satellite mapping, like, doesn't that also give us an alternate
Yeah,
perspective
it's
on
very helpful. It's all based off the same thing originally. At the end of the day, it's all sort of being based off that spherical coordinate system, which originates from the stars, the sky.
well, wouldn't
That's
it
what the
be
globe
from
is.
well, yeah, I know, but isn't it like I'm I guess I'm really confused, like, how is the perspective of a satellite orbiting around Earth or orbiting above Earth, like, how is that connected with like a star like projection?
Well, the coordinate system that the satellite's using is based off a center of mass, which is using like a WGS84 type of coordinate system projection. And if you look at how that originated, it's basically from taking the, like the celestial poles and the celestial equator and that kind of thing, and then inverting them onto into a terrestrial coordinate system. That's how the globe became a thing, right? Like the ancients had conceptualized the celestial sphere long before anyone even suggested that the Earth's a globe, because they needed a convenient way for navigation, for mapping the sky. And so they made an imaginary conceptual sky coordinate system. And the best way to do that is to envision it as a celestial sphere. And then you can plot out, all of what the sky is going to be doing inside that imaginary sky sphere. And then people like Pythagoras and Plato and Aristotle came along, and they, through philosophical reasoning, they reasoned that because the sky is envisioned as this sphere, right, this perfect sphere, therefore the Earth must be a sphere, because Pythagoras kind of worshipped spheres and numbers and things like that. He was a cult leader, the cult of Pythagoras. And look, other people adopted that sort of framework, right? They took the celestial sphere, they inverted it into a terrestrial sphere, and that's still what we use to this day. It's actually a convenient coordinate system, mistaken for reality based on the way that we see the sky. Right? We see the sky like a dome, like a half sphere, where we're in the center, and it's unique for every single person exactly how you're going to see the sky. So you're placed in the center, you assume the ground's an infinite plane, and then you've got a big giant hemispheric dome of vision above you, and that's your personal celestial sphere. And over time, they were able to plot that out, turn it into a celestial coordinate system, and that's still what we use now, the WGS84. That's what all the projections that we're using are based off of, right? Like the Mercator projection, the AE projection. There's hundreds of different projections that have different purposes, different uses, and they're all based off the same kind of thing. The lat
Yeah, but
long.
not for our ground mapping though. That's like, especially from like the
Yeah, different
30s and
types of
40s.
maps. Yeah, like I mean, you've got the MGRS military grid system maps, which don't assume a globe.
Yeah, that's what I'm
And
talking about. Those are just pictures of
it's
the Earth.
similar. It's kind of similar to what you were talking about before, where you can use them locally, but if you try to use them over a large distance, the grids won't align with each other properly.
Yeah, and those are just flat maps.
Yeah, and same with those terrain maps where they take like high altitude pictures, and then you can use those for certain like a grid system once again, but over a large distance they won't align properly and that kind of thing.
Yeah, that's
Also,
just because of the curve.
yeah, when we test for the curve in reality, well, they're not going to align with the. This is the problem, right? When we go out and test for the curve in reality, there isn't any ever.
But in the map, there is over a massive area.
Well, the map's not the territory. If you're assuming that the Earth's a globe and you're using a spherical coordinate system based off an imaginary sky dome or a
No,
sky
like
sphere,
literally the photos of the photos that we were taking, like the military grade photo. They're just photos of the ground. That's all they're doing. They're taking a plane and they're just taking photos in massive patches over, and they're overlapping them and stuff. But the problem is the Earth is not flat, so you can't. They don't line up. Like if there was a flat Earth, that process you would get a perfect map.
no, you wouldn't get a perfect map because you've got
You-
you've got all sorts of changes in elevation and that kind of
The
thing.
elevations are irrelevant. They're above it.
Yeah,
They're
but
above the elevation.
Wait,
no,
you can maintain it. You can use an altimeter. You can maintain elevation. How is
Yeah.
that complicated? But
It's
planes and
not.
balloons can't
It's really not
can't
complicated. We
maintain their
live
own
on a
elevation.
ball.
Yeah, this is one of the things that's the most bizarre. It's like about the whole map denial is that if you just take images from above, you can pretty easily just put those images together. And
Yeah,
then
but
if
the problem
the whole Earth is a flat plane, then that should extend indefinitely towards the entire observable
They're
it
Earth.
doing
can't
that
though,
in the
because
ocean.
like even if you took, like, let's just say you took thousands and thousands of samples of these tests, like if you mapped out the whole America like that, and then you did it 1,000 times, so that way you could take out the deviations between flight altitudes, and because I mean they're going to get pretty close on altitudes, but they're not going to get 100% perfect, right? There is going to be
You can
some
measure
basic.
altitude. Yeah, you can correct. Yeah,
Right.
go on.
Right. So, but like either way, it's pretty fucking close. And the measurements we get from altitude changes, if they do have altitude changes, don't display the crazy differences in the curvature problems that they run into.
Cool. So how come you can't just use a globe map then? You have to use these other types of maps that
You can't.
aren't
Again,
based on the sphere.
I explained to you why. Like if we had a globe map that had all of the items that I would need to sail with,
Yeah,
it
why
wouldn't
can't
fit in
they
the
plot
boat.
that out onto why can't you just plot that out onto flat globe projection maps? Because it
That's
doesn't
what
work.
it is. That's what it is. Flat globe
Yeah,
projection maps. That's what we're using. That's what we're talking about. That's
but
what
you
the
said
military uses.
you said they're based off taking high altitude pictures. You just said that a minute ago.
Not and over land,
You're talking about sailing,
right?
right? You're
Right. But
using
I
like
was just you were just
shipping
saying
charts.
why couldn't we? You said why couldn't we have all that on a globe? The globe would be a massive globe,
Right, that's where you would have it set on flat maps on charts.
right? Because so if you wanted a zoomed in version, right, of like let's just say a, a, a county in South Carolina, and you wanted it zoomed in, you know how big the damn globe would be? Like it would be fucking massive. Like it would be bigger than almost your house. That's the problem you run
Right.
into. Like if you want to add in the curvature, the like you could cut out a piece of the globe where just this county in South Carolina, it would be so big. Like it's you couldn't even you would, I don't think it'd be as big as a house, but it would be definitely too big to fit in a car. Um, and then the problem is
Right.
like once
Are
you
you
laid it
saying
out
that
on the
each of
ground,
your
it would be
individual
wrinkly. So then,
right, but you're
like,
saying
what
that
do you
each
put
of
it
your
on?
you're saying each of your individual maps, if you put them together, they're not going to line up.
No, if you want a globe projection of a small area on the globe, it just the maps keep getting bigger and bigger and bigger and bigger because you need it to fill in the curvature problems. Like you can do it for a
Right.
big globe. Like a globe is easy. That's why you can make them so small. But as soon as you zoom in on it, like imagine like a kind of like a rectangle, but it had like a I don't know how to explain it. If you had a
Look, man,
yeah,
this
so
this
basically
is
the curvature of Horry County, like a county in where I live, South Carolina, the the curvature it would fill your whole room up, bro. That's the
yeah,
problem.
prove there's curvature. Prove there's actually curvature anywhere on the earth.
Well, either whether it is or it isn't. Like if we put the curvature that is supposedly there, you can't. The map won't exist. You won't be able to move it anywhere. You won't be able to use it. And then the problem is like, sure, we could make it in a paper form where we could fold it up. But then how do you unfold it? Because now it's going to have a massive curve that you're going to have to hold up somehow with like a curved table. It's like there's no
Right.
way to
So
use it.
so if we're trying to determine whether the Earth's flat or a globe, right, we could just actually go and physically test for the curvature that should be there between points.
That's
Yeah,
not
but no
true.
one's
No, that's
trying
not
to.
true. That's not true.
First of all,
It's not true that there would be curvature there
No,
if the
that
Earth's a
your
globe.
method of testing curvature is going to measure
Well,
curvature.
Oh
I'm not
yeah.
even here to argue
Yeah.
that 'cause I don't care. I'm not even into testing it, bro. I'm just
Well,
saying
that's what we're here
for a
for.
fact, if you make a map that's zoomed in and it still fit the requirements of a globe, like the curvature was, it would be massive, bro.
Yeah,
Okay,
that's
yeah, you
cool,
keep
right?
you keep
That's
spamming
fine.
that. But
Yeah, that's
to
fine. That's
address,
Well,
sorry,
you're
sorry,
asking. He
DJ,
said,
go
"Why
ahead.
don't we have a
you're right.
version of it?" And I'm like, "That's impossible."
I know you keep
Well,
spamming that point. So
well,
to
the thing
address
is,
that guy, to address a guy who just said, your method of measuring wouldn't work. Okay, well, what is your method to measure the curvature? What can you come up with?
This guy's a clown show, this Donald J. Epstein guy. No way we even allow him. I don't know how he got off mute, to be honest.
Isn't that JJ Fish? Ice Fish?
Yeah, it's JJ Fish, bro. Just Dunning
Is
Kruger
he
clown.
is he the one that said your method of measuring curvature just doesn't
Mm-hmm.
work?
Yeah, when I didn't even state a method.
Yeah, clown shoes.
Clown shoes. Get the hell out of here, clown shoes. So, Deck, like, let's say we had a globe and had a certain size, 39, 59-mile radius. Gravity pulls everything towards the center of the mass, etc. Any 20-mile body of water anywhere on the globe would have about 266 foot of curvature. Right. So if I was standing on one side of a 20-mile lake that's 6 foot tall, and there was like a 25-story building on the other side of the lake, I shouldn't be able to see it because it should be hidden behind the curve on a globe. Right. So we can go and test for that curvature pretty easily, and we can test it over and over and over again using all sorts of different methods, and it would have to be there if the Earth's a globe. But 100% of the time when we go and test it, there's actually not just a little bit of curvature missing, but 100% of the curvature is missing 100% of the time.
Publish your results.
Publish them where, sorry?
So everyone else can see them.
Yeah, they're published on the internet. Anyone can
Where?
see them.
You've been here for years, Twonger.
Wait, so you're saying
Yeah.
you're saying at 20 miles? Is that what you said? Is that what the number you gave?
Yeah, 20 miles, 266 foot of curve.
Mm-hmm.
Hey, Twonger, let me ask you a question. When's the last time you actually picked up a piece of paper and read anything off of it?
Okay, so why are you doing it at 20 miles? Like, why not do it at like 100 miles?
Because we have the atmospheric conditions prevent you from being able to see things that are that far away. Usually the visibility through the air
That's
is
not true.
much less.
You can get two helicopters. You can see two helicopters at that distance away.
Right. I mean, we've got so
Welcome to
if we're
Flat
talking
Earth.
yeah, so if you
You
go
can
up
literally
above
go
a
up.
lake,
You can get into skyscrapers and you can see that far away.
Okay, these are great Flat Earth arguments, brainless deck.
Yeah.
hey,
Like if
so
we go,
yeah,
if we go,
like,
if
for
we go
example,
to,
hold on. Let me
yeah.
say something
Go
real
ahead.
quick,
Go ahead. I'm
right?
not trying to stop you, man. Go ahead.
Yeah, you're good. So if we go up to the top of Mount Canigou, right, 9,136 feet to the summit, then we can use like beautiful infrared camera that cuts through all the haze, and yeah, we can see things that are 250 miles away that should be completely hidden behind the curvature of the Earth, and that horizon that should be a byproduct of the globe should be at about 120 miles away, but we can see that there's no horizon at all at 120 miles. So we can do observations from planes, from the top of mountains, from the shoreline of lakes, and every time we go and test for that curvature, it's just not there.
Hey, Deck, your contrarianism just walked you right into flat smacking yourself. That's what happens when you say words without thought.
Again, are you saying that we can see that far or we can't?
I don't know. You're saying you're saying you're seeing helicopters hovering 100 miles per hour, 100 miles from each other.
Mm-hmm. There'd be a mile.
No,
There'd
I'm
be a
saying-
mile of downward curve at 100 miles.
Yeah, I'm saying
Like
that when we
6,000
go,
feet.
we can when we go up in a plane, for example, we got infrared photography and video footage from planes, we can see things that should be hidden by miles below the curvature of the Earth behind the horizon. And then from the tops of mountains, we can see things that should be completely hidden behind the horizon, but there's no sign of that horizon. At these distances, we can see mountains that are 250 miles away that we shouldn't be able to see, that kind of thing. Every time we go out and test, we can't find the curvature. We can see way too far, and we don't find any curvature.
Right. Well, they're not measuring curvature at that height. But
yeah, but we can because we can take the elevation height, and then we can calculate how far away the geometric horizon distance should be, and then we can calculate what the hidden height of something beyond that should be, just based off the
but the
radius.
elevation is not based.
Deck,
Elevation
you
is
are
not
correct.
based off of.
Deck, you're correct. They're not measuring curvature; they're measuring flatness.
Hey, Deck, are you new to the
right?
Are
But
you new to this
that's
conversation, bro?
the problem is
No, that's a
the
problem for the
elevation.
baller.
The elevation at the okay.
Elevation
So
above
you're
what?
saying that if you're in an airplane with infrared and you're looking 200 miles away, whatever, that you're taking the elevation of the airplane and then you're taking the elevation of the thing that you're looking at and putting those into.
Yeah,
Like
yeah.
a-
Okay, so we know that the airplane's at say 35,000 feet, and then we can see, we can zoom in using infrared, and say we can see the Colorado Rockies, for example, and then we can take the location of where the plane's at, and then we can calculate exactly how far away those Rockies are. Say the Rockies are 500 miles away, and then we can do the calculation based off the radius, and we can see that we shouldn't be able to see any of the Rocky Mountains because they should be hidden way below the curvature of the Earth if it's a globe.
Right, but there will be a point where you can see the top of the Rocky Mountains, but not the bottom.
Yeah, sometimes that can happen, but we can have bottom-up obstruction on a flat plane as well.
Yeah, of a mountain.
Yeah, of a mountain, of a boat, of a building. Especially of a mountain. Mountain's the easiest one to explain because usually there's a lot of topographical features between point A and point B. It's not like it's just flatness and then a mountain, so it can be hidden behind physical obstruction. Then we've got compression due to perspective, and then we've got atmospheric conditions, which can make the bottom of things look like they're missing as well. So all sorts of things to take into account anyway. Right, like we can set up like let's say we get a camera and we put it down on a flat floor, and then we get a little toy boat and we put it on the other side of the room. We can manipulate the temperatures in the room, and then all of a sudden it'll look like the boat's disappeared behind the horizon, even though it's a flat floor.
But again, you're using like the globe projections of the altitude for like the place you're looking at.
Yeah, so if the Earth's a globe,
what does that even mean?
Like altitudes are
above
the
sea
same.
level, not above globe.
Right. So
right, so above the height that the sea would be at, according to the air pressure, you can use an altimeter, and you can get an idea of how high you are But they've done extensive tests on, say, Mount Canigou, for example, and determined that the summit's at 9,136 feet high above the sea level. So if the Earth's a globe, right, and I can see Peak Gaspard 255 miles away. If the Earth's a globe, I shouldn't be able to see it because it should be hidden behind the curvature, for example.
Right. But what I'm saying is like what sea level are we talking about?
But there's only one sea, there's only one sea
The
level,
level
and
of the
if you
No,
live on a globe, if you
there's
hold
like
on, let me
hundreds
explain.
of
Right?
meters differences in sea levels.
No, mean sea level, mean sea level.
Right. That means there's differences.
No, what do you think level means?
What do you think mean means?
Medium. It's like the average. I think they take it over a 19-year period, and then they average out the difference between the tides, and then they get like a
Right.
mid range base, and then they say, so okay, so on average, this is like the midpoint that the water's at, and they'll call that mean sea level.
Okay, so he just answered that. So now you answer his question. What do you think level means?
Well, the sea levels aren't level. I mean, they're not the same.
What do you think level means?
Level means the exact same
Why do they call it mean sea level?
because it's the average.
Right. The average level. If you think you live on a globe, then it's the average level in regards to the center of the globe, right? So it would be the same distance to mean sea level from the center of the globe to the sea level in Alaska or the sea level in Thailand or something like that. So they call it mean sea level based on the globe. If you think it's a globe and you think level means curved.
Right, but like the sea level on one side of the United States is drastically different than the other side.
When you mean drastically different,
They're different. They're different
you mean the
altitude.
height, right?
Yeah, the height of the water. Yeah.
Okay. What's the characteristic of level? That's what we're asking you.
Like so, I think the Indian Ocean is like the most drastic of this, but the Indian Ocean can get like 100 meters different in level and height than
Okay.
the rest of the
We're
world.
not talking about the difference in elevation. We're talking about the characteristic of level.
Right, and so what I'm saying is
that's a lie.
what if you're 200 miles away from a mountain range? Is the mountain range based off of this sea level? And then you see what I'm saying? Like, where is it based off
Are
of?
you still talking about elevation, bro?
Yeah, we're talking about sea level.
Yeah, we're talking
That's the
about
elevation.
we're talking about the characteristic of level. What do you think level means? Doesn't matter that different sea levels are different elevations, bro. What do
It
you think
does.
level means?
It definitely does matter. What do you mean? They're not level.
Does level mean curved?
No, we're not talking about curved. We're talking about in reference to the center of the earth.
It has to be curved. For it to be a globe, it has to be curved. So do you think level means curved? Or do you think level means flat?
And like what object are you talking about? You talking about like a building level?
Water.
You talking about water?
Talking about
Yeah,
sea.
water is neither level nor flat.
Okay, aside from the waves and aside from, the tides, does water seek its level if there's no
I am
outside?
not talking about those two objects. I'm talking about just the differences in like atmosphere, gravity, like all that stuff.
Okay, here's a moment of honesty for you. Are you new to this conversation?
No.
Well, hold on. Okay, good. Then if you're not new, you made the claim that the Atlantic and the Pacific are drastically different. What's the drastic difference?
Like 40 to 50 meters in difference.
I don't think so, bro. I think it's like
You're talking out of your arse.
Like centimeters, like 60 centimeters or something. just due to densities in the water or something like that. But when they say above sea level, right, they're not giving you a specific sea
I mean,
level.
like we literally the sea level is drastically
Hey, no,
different in the
hey,
city, bro.
literally, we just caught you in the middle of you spewing bullshit. You want to concede on that?
No, I mean it's a fact. Like the sea level could
You
be
said
like
drastic.
lower
You
by
said, dude,
drastic.
you said drastically from the Pacific Ocean to Atlantic Ocean, the coast of
Yeah,
the United States.
yeah. It changes every day. Sometimes it'll be higher.
So,
Sometimes it'll be
but
lower.
do you know what the word drastically means?
Yeah, like tens of meters.
Well, then you're wrong. Do you want to concede?
No, I think, how am I wrong?
Okay, then go on playing stupid. It's quite the act. Carry on.
See, this is the problem. You're not new to this conversation, yet you cannot concede when you are wrong. Is it your
Yep,
ego
and
in the way? Is it your fragile worldview? I don't know. What is the problem here, man? What is your malfunction?
well, that's how they remain thoughtlessly locked into the outer space water ball. Proof and point right here, Deck. Way to go. You think you're doing a good job, but you're not. You've done nothing to save the idea that the Earth is a ball.
Do what? It's not
I
necessarily
said
like a
your
ball, bro.
desperation does nothing for the globe argument, and your dishonesty shows how it kind of demonstrates
No,
your
like
desperation.
so, like for example, when we look at the magnetic field or
Yeah,
whatever.
just move on to something else. How about concede on the first thing that you got caught in a lie in?
There's no lie, bro. Like the
So
differences
you
can be
were just
drastic.
wrong then. So
It
you
can
were
be.
just wrong.
All right. So
No,
look, I just looked
This
it
is
up
yet.
just to confirm. I just looked it up to confirm this, right? So basically, when they say above sea level, right, they're just talking about
the local sea
like
level.
a mathematically smoothed geoid.
Oh, okay.
Yeah. So while it might not match the exact level of the sea in every different place, right, they're just using like a simplification, a
Gotcha.
mathematical simplification. So when they say Canagoo's 9,136, and then the other mountains 1,200, they're just basing it off like a simplified
A mathematical like constant. I
yeah,
got you. Got you. Got you. That
smooth
makes sense.
geoid version. Yeah. So based off the globe model, there should be a horizon at a certain distance, depending on how high you are. And anything that goes beyond that horizon, like the horizon is like the line where the sky and the ground appears to meet. And then anything that goes beyond that should start to become obstructed behind the horizon. Like if we're looking out over a water horizon, then that would be the maximum distance that we can see the surface of the water on a globe. All of the water that's beyond the horizon should be hidden behind the horizon.
I see.
Right. So when we go out and check for that horizon, it's not there. And we can see the water going like huge distances beyond where it should on a globe. For example, if we put the camera at 1 foot height on a still day at a lake and there's no wind, beautiful conditions, the horizon should be at 1.225 miles away from the camera. And then all the water beyond that should be physically hidden behind the curvature of the Earth. But we can see the water just completely flat over the entire 10-mile lake. And that geometric horizon that would have to be there if the Earth's a globe isn't there. And then we can test it again and again and again and again. And then we try 20 miles and 30 miles and 40 miles. And then we go up on a mountain and then we go up on a plane. And then we keep testing it and testing it and testing it. And we can never find that curvature. And that's why there's hundreds of millions of flat earthers now, And most of the globe earthers that we talk to have not looked into this. They just believe it's a globe.
So what do
because
people
that's
what do people say that do look into it? What do they say?
the only thing that they can say in response
Uh-huh.
to this is that there's some type of atmospheric conditions that just make the globe look flat.
Mm.
And once you start digging into that claim, it's like, okay, all right, you claim that there's some sort of atmospheric conditions that can hide the curvature of the Earth consistently.
Uh-huh.
What evidence do you have of that? And then that's where they don't have any evidence of
Uh-huh.
that.
And
they have
so
to,
basically what you're saying is you've got like this whole laser thing. They've got a laser that's leveled.
yeah, like a laser that's, yeah, you can get like, let's say we have a 40-kilometer lake and we have a laser set up on one side of the lake, a couple of meters above the surface, and then we
Mhm.
have a target 40 kilometers away on the other side of the lake. Then we're going to shoot the laser across the surface of the water. Like first we're going to level the laser, then we can shoot the laser across the lake surface and see if the laser hits the target on the other side. If the Earth's a globe, there should be 443 foot of curvature over that distance, like a 45-story building worth of curvature. So the people at the second point where the target is, they should see the laser about 100 meters up in the air.
100
Right?
meters.
Yeah, like
What's that distance? What's the distance of it?
40 kilometers, 28 miles.
28 miles. I didn't know kilometers. Okay.
Yeah. I'll
28
check exactly how much
miles.
curvature there is. I'll check now on Earth. So I just typed in Earth curvature calculator on Google. So at first thing it says distance to the target. So that's 28 miles. Okay, eyesight level, that's the height of the laser. 2 meters, which is 6 foot. Okay, so the horizon should be at 3 miles, and then the target on the other side should be hidden by 416 feet of curvature. So that means that the laser should be seen 416 feet up in the air. But the laser doesn't get seen up in the air. It hits the target directly as if the Earth's flat. And then this is a team of engineers doing the test that I'm talking about, and they're using a $30,000 laser. And there's tons and tons of different tests, right? So this team of engineers actually did 6 different tests on different distances, different weather conditions, and different heights and that kind of thing, and they hit the target each time. And yeah, it's a huge accumulation of evidence now that shows that the curvature is not actually there. And just last thing really quickly, I just wanted to restate that curvature has to be there if the Earth's a globe, because of the way that they say gravity works and the size that they say the globe is. You can't have any 20-mile body of water, for example, that doesn't have approximately X amount of curvature anywhere on the Earth, right? 266 foot. Anywhere on the Earth, any 20-mile body of water would have to have 266 foot of curvature, approximately. It's 266.67, but some places you have slightly different elevation or slightly different latitude, and it just makes a slight difference, just a tiny bit. So
Just a
just
tiny
like
bit.
a couple of points, like instead of 266.67, it might be 266.6 or 266.7 or something. It's just this is a bit of a difference. Just if you're at 4,000 full elevation, then you got a slightly different radius to work with, right? So instead of 3959, now it's like 3959.5. And then so you get a slightly different calculation. That's why I say approximately 266 foot anywhere on the globe. And it's not just off by a little bit. Every single time there's just 0. And then the only excuse by the globe side is to say, oh, there must be some sort of atmospheric conditions that just flatten out hundreds of feet of curvature and just make it seem like it's completely flat. And then we say, okay, what evidence do you have that that's possible? And that's where they'll say, oh, I'm not a scientist, or I need to look into it further. If they are a scientist, they'll say, oh, this isn't my area of expertise. I'll have to get back to you. Or they'll try to divert. They'll say, oh, what about satellite? Or something like that.
Bro, Kane, you're hot micing, bro.
Disrupting.
Yeah, don't
How
you
y'all
love
feel
when
about
they say, I'm not a scientist, but they want to, try to stand on whatever some other scientist said?
How y'all feel about Trump doing that stuff to children? Y'all fuck with
Yeah,
Trump?
this is
Get out of here.
this is
Get
how I
out of
feel
here,
about
dude.
your comment. You can check the side chat. I'll write my response.
Wrong server for Trump talk.
That's awesome.
Are you still there, Brian?
Oh, hey
Yeah.
DJ, real quick. I saw the you versus McToon for the first time the other day. That was absolutely brilliant, bro. You had him speechless, and he was swearing like he didn't know what to do, bro. That was awesome. Good job on that one.
Thanks, man. That guy's been pissing me off for years.
Bro, so
Yeah,
do you have one of these tests that I could look into?
Yeah, for sure, for sure. Give me a second. All right, so there's a guy called Dr. John D, and he does some pretty good tests.
Yeah, I mean the main thing I'm looking at, if the test, like, it's just mainly how he leveled the laser. I guess. I mean, I think that's
Oh,
pretty important.
yeah, if you want a laser, like, look, this is the thing. The laser doesn't even need to be leveled correctly, because think about this, right? Between point A and point B, there's a huge hump of Earth curvature. So if you point the laser a bit too high, the laser's just going to go way up into the air. It's never going to be seen anywhere near the target. And if you lower the laser downward, it's just going to go into the water, right? Because the horizon should be at 3 miles. So if you lower it down, it's just going to hit the water. It's no way it's going to hit the target, because all of that Earth curvature should be in between point A and point B. So
Not in the water. But the water's
Well,
level though. It's no curvature, right?
that excuse
No.
backfired, Deck.
So the water's like
If the
level
water's
on a
level,
flat
then you're
Earth.
not going to see curvature
No, level on a flat Earth is
over the.
flat water. Level on
Right.
a globe Earth means curving water for some, right? So they say because each distance is equal distance to the center of the globe, therefore it's like level is in curved. So there's different context to that word level. I don't want to like argue about definitions, because if you think it's a globe, it can mean like each distance is equal to from the center of the Earth, so it would be curved. But on a flat Earth, level would just be flat, horizontal, like the definitions of level used to say. Um, so just quickly, so this is what we should be dealing with if the Earth's a globe. If you have a look at the graphic in the side chat that I'm just posting now, and then I'll grab you the laser test as well.
But like, I don't
Personally,
understand. If you just level the laser though, then it's self evident. Like it's just going to be way up in the air, really, right? The laser is
yeah.
pointing up in the air.
So look, this team of engineers, they actually they do level the laser, and in the documentary they show that they actually level it to some really crazy degree of precision. So this graphic in the side chat basically says if the Earth were a globe, gravity would pull everything towards the center of mass, including the water that covers 72% of the surface. Gravity acts towards the center of mass. Everything on the surface, including oceans, pulled inward. And then it shows you basically like a little chart there, exactly how much it should be covering over a certain distance. I'll just grab one of the laser tests. So it has an hour-long documentary, and it also has a 120-page PDF that shows a lot of the technical specifications. So this is a group based out of Europe called Field Engineers Corps. So I've got the.
Hey, so I did the laser, like in 2017, I did the laser experiment at the beach. And a buddy of mine I grew up with has a charter fishing boat. And we went, so like I set it up on a tripod at 6 feet. And then we went out like quarter of a mile and checked that it was 6 feet. So it's kind of a very rough way of quote unquote leveling it. But we ended up going 16 miles out and it was still 6 feet. I went into the argument back in like, I saw the topic in like 2015. I decided to engage in like 2016. Like most of us, I was a glober and I was kind of sick of seeing people like just calling names and like nobody was getting anywhere. I was just like, you're stupid, you're stupid. And I was like, you know what? I'm going to go into this and like be Mr. Nice Guy and like actually try to use math because you can't argue math. And
so now you're Mr.
everything.
Angry Guy. When did that happen?
I'm not angry at all, but no, I found out that everything. I mean, I grew up 20 miles north of the launch pads in Cape Canaveral in Edgewater, Florida, and I watched everything launch from 1982 to the late 90s. And you know, I wanted to be an astronaut when I was a kid, like lots of kids in that area, and I just thought there's no way. And then experiments that normal people like us can go out and repeat consistently follow the flat Earth ideology, and I couldn't do any experiments that actually would show me any kind of curve at all. And the other one I did was there's a lighthouse at Ponce Inlet, which is like the inlet between Daytona Beach and New Smyrna Beach. It's 175 feet tall. The ground that it stands on is 4 feet above sea level, so call it 180 feet. I went down to Melbourne, Florida, and we went about 12 miles out there, which put us about 62 miles from the lighthouse at night, and we could still see the lighthouse, no problem.
Well, Deck, remember a while ago when you asked if there was a mountain and it was 200 miles away and its peak was so many feet above sea level? You asked, is that the sea that's at your toes 200 miles away? Yes, that's the same sea level.
Yeah, I understand.
Okay, so then stop arguing for the globe. It doesn't
I'm not
exist.
arguing for the globe. I'm telling you I could see a lighthouse.
No. I'm talking to Deck.
Oh, sorry. I'm sorry.
It's all right. Because he asked earlier, he goes, so this mountain that's 200 miles away above sea level, is that the same sea level that you're standing at 200 miles away? Yes.
Oh, you said tech. My bad, bro.
No, my bad. It might have sounded like
But we were
Deck.
just specifically talking about which point they use to measure it, right? Because they're a little bit different. That's all I was asking. And he was saying that they don't use any of them; that they use like a mathematical calculated version
mean
of
sea
the
level.
globe. No, they don't use that at all. That's what your guy was saying.
I
They
mean,
use
we
a
got to admit the
mathematically
sea is a
formulated constant for all of the globe. What it should be if the globe was a sphere and not a geode is what he was saying. I think.
I mean, you got to admit, like the sea is not perfectly level. I mean, you got wakes, obviously, but uh, I mean, there's days when those wakes are only inches. So we can get quote unquote sea level
Mm-hmm.
within, even if it's within a foot. I mean, that's going to be close enough to do the kind of measurements we're doing, which is miles. I mean, like even after I did those experiments, I questioned if I was still like tripping from a rave I went to in my 20s. I mean, it's a hard pill to swallow, um, because since the time you enter kindergarten, there's like a globe sitting there, and this is where you live, and it spins around this, and it does this, and people that are way smarter than you already figured this out, and finally when you go out and even then though I used to question it because I think like I don't see any curve. Like I'm standing here at the beach. I grew up at the beach. I can see 180 degrees of water, and I don't see any measurable curve. And they're telling me 3 miles away, if I'm 6 feet tall, is the edge, or the hill that you start to go over, and you never see that. And then even like Neil deGrasse Tyson said, he was showing like, hey, if you're 400 miles up, I think he was talking about the ISS. He's like 225 miles up. You're only this far off the globe. You're not high enough to see any kind of curve. Then you got people saying, well, I can see the curve from the window of a commercial airliner at 35,000 feet. No, you don't. I mean, you want to believe it because that's all you've ever heard.
Mm-hmm.
But then when you start like actually measuring these things, it's mind blowing. I mean, it really is. I'm still 10 years later, like, holy shit, like what's going on?
Yeah. Well, I mean, if this like whole refraction argument is true, which I don't know if it is, probably not, maybe, I don't know. I mean, that's a problem.
And the other thing I think is funny is so many people like finally when they're faced with facts that's supporting a flat Earth, they're like,
Mhm.
well, what's it really matter? I mean, it's everything. If they can deceive you, like who you are and where you're at, they've got total control. They can now control like your belief system, your political ideology, how to compose yourself as an American or whatever country you live in. And I mean,
Well, I'm
it's
a
like the
religious
ultimate.
person. I'm a religious person, and I think that I mean, I kind of have different opinions on how people can. Um,
Did you learn to
Try to
chant
deceive me.
refraction from the Bible?
No, I haven't said anything about refractions other than y'all brought it up. I mean,
Well, now, if you say, now I believe in God wholeheartedly. I mean, I live every moment of my life thinking about what I need to do, what He wants me to do, and I don't want to go into that too much, but I'm just telling
right.
you my belief system. And one thing I've noticed is a lot of individuals that I've found on like YouTube videos that are now gone, they started out as like atheist or agnostic, and then once they started doing experiments and they found that it was flat Earth, they've completely devoted their life to the Lord, because I think it supports us being created. If this is all there is, it proves that we are significant and we're not
Oh, so
just
you
like
you are religious,
absolutely.
right? Okay.
And I think that flat Earth theory, I'll just put it in that bubble. Uh, I think it supports being created because the other heliocentric model is telling us like, number one, the law of entropy is BS. We had chaos and it produced perfect order like the human eyeball. I mean, how did an explosion eventually turn into something so sophisticated and perfect as our eyeball? I mean, think about how complex it is. And
Right.
that has to be created. There is no possible way, like dust turned into an amoeba, that turned into a lizard, that turned into a bird, that turned, you know what I mean? Like, there's no way. So even in our teachings of the Holy Bible, it supports the flat Earth
ideology in that, he created this. He separated the waters. He made the land rise up out of the water. He put the animals, he put the plants, he put us here. And it proves that we're significant and created. I mean, it literally says the Lord sits above us, like above the firmament, above several layers above us, looking down at us. His throne is above us, and that would fit better on a. I know we don't really have a model for flat Earth, but some of the ideas you might have in your mind of what you could imagine it looks like, it would support that physical uh, thing with him sitting above us. You could never sit above us on a ball because it's all relative to the ball. I mean, would he be upside down above Australia, or would he be? But I argued for the globe for a long time because I just did not want to believe it. But the only proof I found out on the globe argument is hearsay. And like, if you've ever been through court, that doesn't hold up. You can't say, well, I know a guy who said this happened.
Mm-hmm.
That they're gonna be like, get out of here with that crap. So, but then if you walk in there and say, hey, look, I went outside and I did this, and this is what I observed with my own eyes, and here's the evidence. You can do that with experiments leaning towards the flat Earth, but you can't with the globe. It's just like you have to believe a group of people that said they went up in a spaceship. And after I started looking into it, think about, like, again, it's a touchy subject. I don't want to go down this path, but just as an example, like the Epstein files, we're now seeing people that people have always looked up to as being like powerful or smart that are ultimately evil. So obviously there is a conspiracy of evil people, and those are the same folks that are at the top of the education system and money and banking system. They're over everything. And do you really want to believe those same people that are taking little kids and doing the most disgusting acts there are? I mean, more proof that it's just all lies. So,
Mm-hmm. So you think light refraction in general is a lie?
no, I believe light refracts, but for refraction to occur, you have to go through two separate mediums. Like, for example, a glass of water with a pencil in it, like the proverbial example. The pencil is in one medium, which is air, and the second, which is water. And because light travels differently through those two mediums, that's what causes the refraction. But like, if we're looking at, like my example with the lighthouse from a distance of 62 miles, the light from the lighthouse isn't going through air and water. It's simply air, which, okay, it has some humidity in the air, but it's even the whole way between. There's not two totally different mediums. So
Yeah. But hold on a second. Hold on a second, man. Right. We can have a gradient in a single medium where the refractive index does vary.
Agreed, but not as much of a gradient
It's
as.
completely different. Yeah, no, I get you. I agree with what you said with the two mediums thing, right? But we can have a single medium gradient as well. It's actually a
like a
good way to
mirage.
invalidate. Yeah, like a mirage, or like sometimes when like half a ship's missing behind the horizon, that can be also attributed to a type of refraction called sinking refraction, for example. So I just wanted to point that out. That's all. Seems like we're pretty much in agreement anyway.
Yeah, I think just for argument's sake, though, like and I agree wholeheartedly. I'm not denying that refraction exists, but for the amount that would have to exist for me to be able to see that lighthouse, I mean, you're talking like thousands of feet, like a mile and a half or something, that it would have to be bending or refracting this light over a hill. And, even even the laser experiment. Can gravity affect a laser? Yes, but at 20 miles, it's going to be like millimeters, not
Or
hundreds
not
of feet.
even, yeah, not even millimeters, like even less than that. But
Right,
we
right.
can see, like Dr. John Dee. You know Dr. John Dee?
I'm not familiar.
Oh, okay, he's he PhD in spectrophotometry. He's a flat earther. You've probably seen his tests, peer-to-peer laser tests. He's got tons of awesome information about lasers and long distance observation. You've probably seen the one with the windmill farms where he zooms in on the windmills and you can see the base of the windmills at 11.2 miles away. Should be
Yes.
completely hidden behind the curve. Yeah, that's Dr. John Dee. But yeah, he
Okay.
says that he shows a lot of footage of lasers bending. But he says in years of him doing laser tests, he's never seen a laser bend downward through the medium of air. And he's seen them occasionally bend upward, but he said most of the time they go perfectly straight, and occasionally they can bend upward. But he's used all sorts of different lasers, different spectrums, and he's an expert. He's never seen one bend down, which is interesting.
Yeah, I even did 3 different colors of laser just because I'm not a laser expert. Okay. I'm a network engineer. I can tell you all about subnetting and creating networks, but, I didn't know if possibly the color of the laser, because it's a different frequency, would have any effect on quote unquote bending. So I used red, green, and ultraviolet, and got the same results with all 3.
That's pretty cool.
But I love those photos of the boats floating. I think that's the funniest shit ever.
Yeah, yeah. If you adjust the like the contrast and stuff, you can actually see the horizon is still behind the boat,
Mm-hmm.
and what you're seeing is like a mirroring effect.
Mm-hmm. Yeah, because the boat's not that far away, bro.
Yeah,
Yeah, that's one of the first
exactly.
things they'll try to teach you as a kid is the,
Like, look how big the
first,
boats are.
Right.
Good afternoon, everyone.
Good afternoon.
Oh, hi, DJ.
I'll tell you one thing I wish I could see.
Hey, buddy.
I'm gonna go sailing again, maybe for like another 9 or 8 months, something like the same thing I did before. But like one thing I wish I could see is a military vessel at sea. I think that would be so awesome.
Yeah, just don't get too close.
Y'all ever seen the video of the fishermen guys that go up to the vessel? You ever seen that?
Yeah, and they get yelled at.
Yeah, I've seen that one.
There's 2 videos. One of them they get yelled at. The other one I don't think they get yelled at. But I think that's so cool though.
The one I saw is when they sent the big giant military ship sent a drone over and told them to turn around.
They did it via a drone?
Well, they sent there's one of them. They definitely did send a drone, but they were talking to him on the radio.
Oh, okay, yeah, right.
Is that the same one you think?
Speaker.
The one where they were talking about their bad boys or whatever?
It was like a New Zealand fishing boat, right?
Yeah, I think so.
Yeah. I think I haven't seen it for many years.
I love that video, but it's so like it's crazy how fast the warship comes up on them. Like that shit looks like it'll be here in like 30 minutes, and then they're just there like immediately. Like it's like damn.
Yeah, those things move to be so big. I mean, you think they can send out a group of them off of the east coast of the United States, and it's only like a few days, and they're in Europe. Like going through the Strait of Gibraltar or whatever.
Yeah, I got a uncle. He's in the private military now, but dude, he gets paid around I think about $2 or $3 million a year from the U.S. Navy, and he just does office work, bro, on the airplanes. But he used to work on the aircraft carrier when he first started out. He did airplane maintenance on an aircraft carrier.
Oh yeah, aircraft carriers are amazing to me. I mean, they have the population of a small American town.
Have you ever been on one? You ever been on one? Like one of the older ones?
No,
Dude, you gotta go. You gotta go. You got to go. Like especially the World War II. I mean, really, any of the old World War II butts I think are interesting, but yeah, I mean, bro, like I was in Boy Scouts and one year, excuse me, one year we camped out on the aircraft carrier, which was
Oh,
fun
that'd be awesome.
for like 3 days.
And just out of curiosity, what part of the world is everybody from? I mean, you don't have to tell me like exactly where we live. I'm in the Smoky Mountain, Tennessee.
Yeah, I'm in Myrtle Beach, bro. Myrtle Beach.
No, yeah, that's every redneck from East Tennessee goes to Myrtle Beach.
Mm-hmm.
Yeah, the good old flat beach.
I don't know. Myrtle Beach actually has some pretty steep sand by comparison to Florida beaches.
Well, dude, it's so. I'll tell you this: it didn't used to be that way when I was a kid, but it changes so much. It changes every year. It changes.
Yeah.
They put so much sand back out there you wouldn't imagine. You would not imagine how much sand they dump out there on that beach.
Hey, I'll tell you, I went to Ocean City, Maryland one year, and they have these things. I called them sand bonies. They're like a Zamboni at a hockey rink. They go out there and rake the sand every evening in these things, and like
On the beach?
it's insane. Yeah, it was the weirdest thing I'd ever
What
seen.
the hell?
Really?
Yeah, yeah, they look just like a Zamboni that you'd see at a hockey rink, but they're like the size of a large John Deere tractor that you'd see like in a cornfield, and then they have basically it looks like discs on the front and then like forks, and it like rakes and levels the sand and cleans it up.
Yeah, my dad actually owns some land over there beside where they dredge the waterway out. And basically they dredge out the intercoastal waterway and then they truck all that sand down to the beach.
Oh yeah, yeah, they did that in Florida too. We
But
used to have at the
Do you
inlet,
guys
Ponce Inlet. Go ahead.
do you, do you guys think an airplane could land on an aircraft carrier that was spinning at 1,000 miles an hour?
So I think that's a poor argument for either side because like speed
It's
is
yes or no.
relative, right?
It's yes or no. Do you think it could or not?
On
Yes or
both
no?
examples, yes. Like when you jump off the ground, does the earth spin out from underneath you? Even if it was a spinning ball, would it? No, because it's like if you are sitting in the car and you have a ball in your hand and you're going 60 miles per hour down the road and you toss the ball up, the ball doesn't instantly go to the back window. It falls back down to your hand because it's in motion with the car. So for the globe argument, it would work. And for a non moving flat earth, it would work.
So you think an airplane could land on a spinning object at 1,000 miles per hour?
Again, speed is relative.
So
So in both
yes.
examples, yes. Both examples, yes. I mean, I'm sorry you
How
don't
about a
understand
million
basic
miles per
physics.
hour? How about a million?
If the plane took off from an object that was going a million miles per hour and wanted to
No,
land back on
no,
the
it
thing that was
didn't.
doing
No,
okay,
no,
so
the
the
plane did
plane
not
took
take
off,
off
then
from
the
an
Earth.
object.
So the plane takes off, and then the Earth speeds up to 1,000, and then it has to land. No, it's relative. Do you not understand relativity?
No, I'm saying if the plane did not take off on an object that was moving at 1,000,000 miles per
You're
hour,
doing a
and then it
disservice
had to
for the
land on an
argument.
object that was moving at 1,000,000 miles per hour, do you think that that's possible?
I will say it for the fourth time on both examples. Yes. Awesome.
I just think it's funny. Go ahead, continue. Sorry, I just think that was funny.
So get in your car, go down the interstate, hold a ball in your hand, throw the ball straight up. Does the ball instantly slam into the back window?
No,
Right. Why?
because there's a container.
Okay, you're in a convertible and wind is not a factor, and you're doing 60 miles an hour and you throw the ball up. Does the ball instantly go backwards?
Wait, wind is not a factor. What do you mean?
Because we're talking about relativity. So it's behind the windshield. You toss the ball 6 inches up out of your hand. Does it fall straight back down in your
The
hand, or does
windshield
it
is
go
the
straight?
container. The windshield is the container.
Oh Lord, you really are doing a disservice for the argument. This is the kind of crap that makes globers laugh at flat earthers.
Yeah, like this dude doesn't know basic physics. He
A
might know
million
quantum.
miles per hour spinning aircraft carrier, and they think an airplane could land on that. That's hilarious.
Because it starts going at 1,000,000 miles per hour because everything is spinning at the same
How do you
speed.
know
That's
everything
why
is
he's trying
spinning?
to. No, because you're if we're to assume the globe model, right? You're trying to say like it doesn't make sense how
Sorry.
things
I
go
didn't know
down.
we were assuming the globe model. Sorry.
No,
Go
but
ahead.
you're trying to make a counter argument against it. You're trying to say that the globe can't work because like how can planes land? And that just doesn't make sense at all because plane starts going at the same speed that the Earth is
I'm not
spinning at.
asking you. All I'm asking you is hypothetically, if there was an airplane that was trying to land on an object that was moving at 1,000,000 miles per hour, and that airplane did not take off from an object that was moving at 1,000,000 miles per hour, do you think that that's
Then
physically
no, it
possible?
would not work. So if the
Yeah,
Earth was a
Okay, so
ball and it
no.
wasn't
So
spinning
the
and we
answer is
jumped,
no. Okay, thank you.
no, it's not, dude. You're a dumbass.
No, you said
You don't
you
understand
said yeah.
anything.
The first answer you gave me was yes, and now you're saying no.
Yes,
Okay.
yes, because the Earth, in the example of the globe model, doesn't start spinning after the plane takes off.
Yeah, but that's not the hypothetical question that I asked
Yeah,
you.
Listen, Cake gets it. You're obviously need to go back to like middle
That's
school.
not the
And
hypothetical question I asked you
then the
initially.
question
You
is
said yes.
pointless.
so
The
he
question
missed
is
the word.
pointless then.
He
I
missed
think
the
you just
word.
didn't
You're not
understand the basic
understanding the
physics.
hypothetical.
Well, he missed your implication. Right? Get past
How about 1,000,000,000,000
it.
miles per hour? Do you think it would
Okay.
also work?
Clarify the implication and what your argument is.
Clarify the implication. It's just a hypothetical question. It's just your opinion. I just want to know, do you think that an airplane could land on an object moving at 1,000,000 miles per hour, assuming the airplane did not take off from an object moving at 1,000,000 miles per hour?
so the airplane takes off of a globe that's
Okay.
not spinning. Then the globe starts spinning 1,000,000,000,000 miles per hour.
I
No.
never mentioned the word globe in the hypothetical. You're just
So
adding random
when it comes to
nonsense.
this, if you are on an object that is moving at X, so you don't even need a specific number. You could be a million, a trillion, a billion, X miles per hour. If you are on that object, you are inertial to that object as well. So you are also traveling at X. So when you're taking off or taking an acceleration, you're going at X plus your acceleration, just like the airplane does. So it's the inertia and momentum that you're talking about here.
Thank you.
I don't know why I think it's so funny. No. Then 10 seconds later, he's like, nope.
So if you are in
Initially,
a
he said
car
yes, and
going,
then he said no. That was funny.
if you are in a car going at 100 miles per hour, me saying that you are going at 100 miles per hour also in the car is it's funny to you.
Yeah.
It's ridiculous. So when you're sitting in
No,
a
I just
car and
think
the
his
car is at
initial
100
answer
miles
was
per
funny
hour,
when he said
you're not at
yes.
100 miles per
Because your
hour inside the
initial
car?
question was not specific.
Yeah, it's just a hypothetical question. Yeah. It's
What
not.
happens if like the car immediately stops at 100 miles per hour? Do you fly out of the car at 100 miles per hour? Yes, you do, because you are also going at 100 miles per hour. So if the car stopped like that because it hit something, you are in the inertial frame of 100 miles per hour. You're not the one that hit the thing, so you didn't stop. So you're continuing on 100 miles per hour. Therefore, you go through the windshield.
If the okay, in that, let me give you a different analogy. If the car was spinning at 1,000,000 miles per hour, and let's say
If you are inside the car, you're
let's
spinning with it.
okay, so you would not notice, or I'm sorry, not notice is the wrong word. You wouldn't feel it, right?
Yeah, remember that word relativity?
That doesn't. Okay, so
Given that you're inside the car, you're correct. You wouldn't feel it because you're not
okay,
inside an
okay, no, it's
atmosphere.
fine.
So the
I
car
just
would
wanted.
feel it. You wouldn't.
Okay, got it. I understand.
That is also why the ISS, the people inside the ISS at 17 miles per hour, they don't feel it because they're inside the object. So they're inertial inside of it. And the reason why the object at the external side is not also feeling it is because it's not getting friction from the atmosphere because it's in a near vacuum.
Wait, how do you know there's people inside the ISS?
I would say basic deduction here. All I need for this one is just basic deduction. I don't need to go to the ISS and meet people on the ISS to know that
We'll
they're there.
pursue that basic deduction then.
Okay, just the same way that I deduce that there are people living in France, there are definitely people on the ISS.
Nice try. False equivalence, ding dong.
I have no reason to believe that this footage is edited, faked, or in any way, unless you provide actual evidence that they
Okay,
are.
your appeal to your incredulity is noted. You're
That is not
naive and
incredulity.
gullible.
That is not incredulity. That's a misuse of incredulity, my friend.
Yeah, yes, it's a use of it because you're in denial that such a presentation could be made to you that isn't true.
Like what?
Yeah, I mean, like the movie Gravity makes it look like she's floating in a vacuum, but that
The
doesn't
movie
mean she's
Gravity
actually
is a
floating.
movie. It's a movie.
Deductively work it out.
The movie Gravity is not the science of gravity. Is a movie. It's a fictional story.
It's fictional because it talks about gravity.
And so is the ISS.
Yeah, like they're using a camera and they're shooting video footage.
The ISS is something that I've seen for myself in the sky using
How do you know
telescope.
people are in it, ding dong?
I did actually.
Well, for that thing to be operational and for us to have the footage that is on it, there has to be maintenance on that thing.
I have a
and therefore
quadcopter
that thing
and it
is,
operates.
huh?
I have a quadcopter and it operates.
That thing, anything will decay over time. So it doesn't have maintenance. It's just going to break down and fall down. So the fact that the ISS is still running and active, there's people on there doing maintenance. That's for sure. Just like an
Nobody's
airplane
maintaining my
requires people
quadcopter.
to operate the airplane, the ISS requires people to operate and maintain it.
There's plenty of planes that don't have people on them that operate.
Do they require maintenance?
Yeah, they land them eventually.
Yeah, they land them for maintenance, but the ISS doesn't land, so you still need to do the maintenance on the ISS. So how do you do it without landing the ISS? You send people up there.
Well, I'm not denying that the ISS can be observed in the sky, but if you plot the travel of the ISS on a azimuthal equidistant map, it follows a perfect toroidal field.
What
So
does
is
what
that a
does that have
coincidence?
to do with what I just said about if you want to do maintenance on the ISS, since it's not landing, you have to send people up there?
What that has to do with is the fact that it doesn't need to land because it's floating in a toroidal field infinitely.
You are right that it doesn't need to land, but it needs maintenance. So to have maintenance, you have to send people up there.
So if a magnet hovers above another magnet, does it need to land to get maintenance, or does it just stay above the other magnet floating?
Well, it would just
So you're
require
telling me that
maintenance
all
over
the
a measured flat
components,
Earth.
all the magnets are never going to break down because they're eternal and don't have decay like everything else. They're magical things now. We have magical materials that don't decay on their own.
I mean, metal takes a pretty long time, and especially if it's up in a field where it's not exposed to very many elements that would decay the metal. Sure, it's going to last way longer than our lifetimes.
So the radiation of the sun is not going to affect the metals at all?
Not in the
The
model that
magnetic
I believe
field
it's
of
under.
Earth, if you think that the ISS is just a magnet hovering above a magnet, well, that defies the magnetic field of Earth.
Is it made? What metals is it made of?
I mean, I can look up what the ISS is made of if you'd like. What are the materials you?
Okay, and
What
then I'll
specific
ask you
magnet?
how. And then I'll ask you, how do you know that that's what it's made of?
Of course, you're going to ask me that because you don't trust that the
because
people
you're the
that
one
do
because you're the
technology
one
do
claiming
technology.
it.
Of course.
Of
Yeah,
course,
you're
I'm going to
stating
ask
that it
the guy
needs
who's
maintenance.
claiming it. Who else am I going to ask?
I accept the epistemic
I know
standard
you're
as
brainwashed.
evidence.
Got it. You don't have to say any more. You're brainwashed. Got it.
That's not brainwashing. Epistemic
Oh,
standard is not
yes, it is.
brainwashing. No, it's not. Explain how it's brainwashing.
How do you know people are on it? Deductively. Well, it would have to be, this thing would have to be worked on. How do you know it's even something up there that needs to be worked on? And then you're like, well, the sun's not going to affect the metals. What are the metals? Well, of course you would ask that. I'm not expecting you to realize that you're brainwashed, but I'm telling you that's the way it is.
Okay,
If you
sir,
realized you were brainwashed, you'd pull yourself out of this outer space travel fantasy. But you're not there yet.
So if I weren't brainwashed, I would reject all academic science that has been done.
You'd
for
have the same
1,000
answers
years.
for Santa Claus. How do you know Santa Claus is real? Well, who brought my presents?
Santa Claus actually has
I got a
violations
chimney.
of logic.
He must
Santa
have come
Claus
down it.
actually has
He
violations
ate the
of
cookies.
logic.
He drank the milk.
The cookies are gone.
This is a deductive process.
You
Santa
guys are
Claus
the
is
one
real.
using the appeal to incredulity now. See, that is an argument from incredulity.
You guys have been sold a bill of goods and you're still gobbling it up. Pathetic.
They just can't
you
accept
can
it.
say that, but how do you convince someone about it?
You're going to have to convince yourself, buddy.
So that's very convincing, of course. Yeah, I'm brainwashed, but there's just no.
Yeah, it's
no
on you.
argument.
It's on you to grow up.
Yeah, bro. He ate the cookies.
So,
You didn't see that?
so who brainwashed me? Who brainwashed?
Santa's real.
Who
Same
brainwashed
people
me?
who brainwashed me.
Okay, who are these people?
You tell us. You're the ones that said there's these academic scientists that have studies.
Okay, they're not here actively suppressing my thoughts or anything.
No, they've just filled you with bullshit.
That's not the definition of brainwashing.
All right, I got some
And
land on the moon for
calling
sale.
science
I'll really
bullshit
cheap.
is it's pretty bold. So they taught me bullshit. Okay, let's go. Are you saying that the school brainwashed me?
Absolutely.
Okay, so the school taught me how to add and subtract. Would you call that brainwashing?
No, but they also taught you that
Yeah,
World
okay.
War II was something totally different than it
One
was.
thing at a time. One thing at a time. The school also taught me effectively how to do algebra. Is that brainwashing?
You can learn addition and subtraction without school. You can go outside and say, "I've got
Okay,
4
okay.
sticks, and I take 2 of them away. I've got 2
But I was
left."
not
You don't
done.
need
So instead of trying to interject, can you just answer the questions?
one thing at a time. We're talking about math.
We're talking about addition and subtraction. Now I'm saying, okay, they taught me algebra. Was that brainwashing?
Who's algebra?
You don't know what algebra is?
He's talking about algebra.
Oh my goodness, bro! You're
Okay,
using an all or
algebra.
nothing, bro.
So
Okay, you can have some stuff in school that was true. You can have some stuff that wasn't. Okay,
but let's
this
evaluate.
isn't all or nothing.
That's what I'm going to evaluate here. That's why I'm doing this. So they taught me French and English and how to speak and
Oh
use
my
them.
goodness!
Is that brainwashing?
Not everything was, but some things was. Okay.
Okay, so when you say that, I'm evaluating every subject that I know here in school and that I've learned in
We're not
school.
talking. This isn't all the subjects room, dude. We're talking about the Earth specifically.
Okay, well, about the Earth specifically, that's not something that I learned at school.
Really?
There wasn't a globe in any of your classrooms, and they didn't say like you live
There
in
was
this.
no indoctrination of the kind. No.
What about
They never
gravity,
taught you
though?
the
They taught you about
heliocentric
gravity.
model at school.
No, they didn't teach me a heliocentric model. Although I did learn a barycentric model in more advanced school.
What about gravity? They never taught you about gravity.
Yes, they
Well,
taught
letting
us
you know right
about
now.
gravity. But,
They do teach you about our solar system in kindergarten.
Okay, there you go.
Sure,
There
sure.
it is, right there.
But I mean, I knew about it already, so I didn't need school to know that.
Yeah, that's fair
But they
enough, dude.
did
I'm just
mention
saying
it.
it. You know, it is
But
in the
everything that I
curriculum.
learned at school, if I apply in real life, it works, it's valid, and it's useful. Especially the physical education and everything. All of that is actually working out.
Do you raise your hand to go to the bathroom?
No, I just go to the bathroom.
Alpha. That's alpha.
But raising your hand to go to the bathroom when you're in a class session is usually a common courtesy.
So at school, you're saying everything they taught you in school works in reality. Is that really that's what you're saying? Just so we're clear, is that what you're saying?
No.
Okay. What doesn't work?
Within what?
In reality, didn't you say a second ago that everything that you were taught in school worked in reality? Or am I?
Well, it's applicable. It's applicable and useful. The economics, etc., the politics, the morals, everything that they taught me at school. Everything. Yep.
Yeah, I learned my morals at church.
Pretty much valid.
They never.
I mean, I
taught
don't
you
know
the
about
globe.
your country's curriculum. I know that USA has a serious education problem, but in the country that I live in, we have a different curriculum, which actually is fairly educative. So we tend to have more educated people in Canada than
Great,
the US.
great sentence structure there, buddy.
So they never
Also,
taught you the globe.
also,
Because
if
he learned
schools
English and
were
French in school.
brainwashing, by the way, if schools were brainwashing, number one, you would be forced to go to a specific school. This is not the case. There are private
You were
schools,
forced.
there are public schools, and they all have their own curriculum. And if you disagree
No,
with the
yeah, well,
curriculum,
here,
you can
yeah,
just
dude.
not subscribe your kid to it. It's that simple.
No, in the United
private
States, the
schools,
private schools have to adhere to the same curriculum the public schools do.
and you're forced to go because if you don't,
No
the
idea what
parents
you're
get put
talking
in
about.
jail.
No. You're forced to educate your children. That's sure, but you're not forced to put them in this one specific curriculum. You can choose your
But
schools
all
and
those
different
private
curriculums.
schools and charter schools have to follow a specific curriculum according to the
No, that's
law
not
in the
true.
United States.
Maybe in
That
USA,
is
but not
100%
around the
true.
world. I'm sorry, USA isn't the entire world. Okay, the world is bigger than USA.
You were talking about the USA though, so now we're talking about the
No, I
world.
was
Okay,
talking
so
about I
which
was
one?
talking about that USA has a problem with education, but the rest of the world doesn't. I mean, there's a problem with education in many countries, sure, but I mean, not as bad as USA.
I'm pretty sure
Because
they're
I see
talking
so
about the
many
ball.
scholars coming out of Indonesia.
And yes, in USA there are private schools who have a curriculum that is not forced. Maybe some legal things are forced, like law, like the things that you teach in the law of the USA, the Constitution. Maybe that's going to be forced, of course, because I mean it's the law. If you don't agree with that law, you can change country.
Did they teach
You're
you the
not
globe?
punished for questioning these things. Like you ask questions in school, you're not getting punished for it.
Did they teach you the globe?
What kind of question is that?
The Earth.
I
being
figured
a
out the
globe.
globe on my own, and whatever they taught about Earth, etc., I chose those courses. By the way,
Okay. It was not mandatory that you knew the Earth was a globe.
geology is not a mandatory course. No.
Sweet.
Geology is the study of rocks.
Yeah. Sure.
Yeah.
Yeah, but we live on a big
And I've
rock
got the
that's
education
spinning.
problem. Good Lord.
Things that I learned about Earth fit the category of things like geology, specifics that you can choose in major and minor and stuff like that when you're going to college.
But it's not taught in school, in your school.
No.
Oh, you don't remember the graphics that they would show
It's
you in the
not
books
indoctrinated, taught the way that you're saying. No.
when they had
So
the
you
Earth
never
sliced in half and they show you the core and everything? You don't remember that?
See, these are not things that you have in elementary school, dude.
You never taught about
Got
the
it.
planets, or sorry, the 9 planets, I guess. The 7, whatever. 6, 7, Lamau. You were never taught about the solar system
Oh
or
yes,
anything?
we talked about these subjects, but
You
that's
were
not like
never.
them forced to teach us about these
Well,
subjects.
you were
And
never taught.
don't
You
believe
were
the
never taught
subject,
a
you're gonna
mnemonic.
get killed. No, there's no forcing it on anyone.
You were never taught a
Never been
mnemonic device to remember the planets.
But anyways,
Do you
when
even
it
know what a
comes to
mnemonic device
it,
is, smart guy?
all the educative topics at school, work, and even like the physics classes and etc., all of that converges. But somehow, the one class about the cosmology, space, and globe, and etc., all that's fake. That's a
Yeah,
one
because you can,
class that is completely fake, and the whole curriculum,
bro, you
everything
can
else is
check,
good.
you can
That
verify all the other
that's
subjects.
very embarrassing for you.
How do you
You can
test?
verify
How do
all
you
the other
test it
subjects.
though? That's the question. Because you can test the other subjects, right?
Yeah, you can do your personal tests and etc. And you can not do them. You can do a few of them. You don't need to do all of them. You can settle somewhere. When you have your epistemic standards are met, you can settle somewhere. Okay, well, I have sufficient information to conclude that this is likely the case.
Can you test the globe?
Sure, you could test the globe.
Okay.
Okay, so
Can
what
you give me an
happens when you go
example?
outside and you test it and you get the results that deny what you've been told?
You mean what happens when you do an experiment that is imprecise and actually would normally give imprecise results, and that if you account for all factors, the results align with the globe? Yeah, sure.
You're really grasping at straws here, buddy. Like,
All right, show us one test, Storm, that aligns where all factors have been taken into account.
I mean, you've seen all of them so far, and you've made up an excuse for all of them so far. So what am I supposed to do?
For all of them so far.
Okay, so the only one that I can remember you ever presenting was a plane landing on a runway, and you agreed that that could just be sinking refraction. That's the only one that I can honestly remember that you've ever presented. So if there's something else that you presented that I forgot, I apologize. Can you please present it
I mean,
again?
I've presented the arguments and the documentation on atmospheric ducting and refraction and so on, but again, refraction is just an excuse to making no. It's the correct
No,
answer.
Storm. Right, so we just want to see an actual test that was done where they actually took those things into account, not
Amateur
an
rocket
explanation.
launches. Rocket launches. I've posted that one so many times, yet it's always been ignored because nobody watches
Rocket
it.
launches.
so if we shoot
An amateur one, which
an
is an
object up
untouched
off the
footage, by the way.
ground, that proves that we live on a ball.
Okay. It's not one single piece of evidence that's going to prove that we live on a ball. It's a body of facts. It's multiple observations, not just one. Any
Give us
one-off
5.
thing can be explained by anything. It could work on a dinosaur Earth, sure. Now, how do you know it's not a dinosaur Earth?
Because dinosaurs
Well,
didn't have lasers.
let's see if it works on a dinosaur Earth. Oh wait, it doesn't with this observation and that one. Earth is probably not a dinosaur shape.
Okay,
Wait
so
a
then
minute. If we
I'll
use a
just give you
globe,
one.
though, all these
Just one.
observations work together. Ooh, maybe it's
just
both.
one observation. Explain it on a globe. A laser 6 feet off the ground.
One
at 16
observation
miles,
explains
is
nothing.
Still 6 feet off the ground. Well, I mean, if you shut your mouth for like 10 seconds, you hear it. So if I shoot a laser level 6 feet off the ground and at 16 miles away, it's still 6 feet off the ground. How does that work on a ball?
What do you mean? How does that work on a ball? What do you mean?
The lasers curve with the Earth?
Not with the Earth. It's curving with the medium.
Oh,
That's
okay.
curving with the
Exactly
Earth.
the
Yeah.
same height. Yeah.
See, the laser is bending in the medium, the air
Oh,
refraction.
wow.
Not
Because the
not
medium
not
is following the curve of
curve.
the Earth, right?
I've drawn a specific example of this
Yeah.
before, and the person agreed with me that this is not conforming to the
Hey,
8
Storm.
inch per mile square,
Storm,
but it
Storm.
is still bending towards the ground.
Okay, right. So this is why you got kicked from the English Hub the other day, because I asked you to. This is all you had to do, and you could have said you just don't have it, right? So, just show us an actual physical demonstration of a laser bending down over a long distance laser transit test through the medium of air. If you don't have it, that's fine. You just have to say, I don't have an example of a laser
Of course, I
bending
don't have
downward.
that example. Let me explain
Right. So
why.
you can explain how it could happen, right? But you don't have any evidence of it actually happening.
No,
but
we
what
do
we
have
have,
evidence.
no,
It's just that
listen.
you refuse to
But you
listen
don't
to that
have.
evidence.
No. Evidence. Okay, so you think
Okay.
explanations are evidence, right? But I'm asking for a physical demonstration. So you don't have a physical demonstration. You have an explanation, right? I'll take that as evidence. Okay, I'll just take that as evidence. But it's not conclusive because you don't have a physical demonstration to back it up. But what we have, hold on, let me finish. Just let me finish, please. Right. So we have a guy named Dr. John D, who's a PhD scientist, right, in spectrophotometry. He took a bunch of his laboratory equipment and he did years worth of laser tests using different spectrum lasers and different conditions, different time of the year. And he's accumulated over 350 plus hours of laser tests. And he said over all of the years of him doing laser tests, he's never witnessed a laser bending downward over the medium of water or land, and he's been put out a challenge for anyone to prove him
Just
wrong on
repeating
that.
the same claim 5 times.
No. He's done 350 plus
Yes,
hours of
I
different laser
understood this the
tests.
first time you said it.
He's never seen a laser bending downward. He has seen them bending upward because upward refraction is something that can happen,
Okay.
right, with lasers. And
Earlier
he has
you said
plenty
sinking
of evidence.
refraction. Earlier you talked about sinking refraction. Wouldn't
Yeah,
that be
that's
light
upward.
bending downwards?
No, sinking refraction is actually light bending upward.
No, it's the opposite.
Right, it makes things look like they're displaced downward because the light's
And
bending upward.
if sinking is light bending upwards, then a superior mirage
it
is
is.
light bending downwards.
Right, superior mirage.
So
Yeah.
we have superior mirages. So that's an observation of light bending downwards right there. Okay. And then
Right, but
then
superior mirage.
let me I listen to you. When we mention
No, I
atmospheric
haven't finished. I haven't finished.
Yeah,
I'll let
but
you
you
respond
were just
after I
repeating the
finish.
same claim 5 times. We
No,
understood it. We know what you're
I'm not
talking about.
repeating
We know
the
what you're
same
saying.
claim. This is what I'm stating, right? I said it's specifically a laser. Okay, you don't
Yeah,
have any
okay.
footage of a
Specifically a
laser
laser.
bending downward.
But this is the
Yes.
thing you have to do. You have to do some
Hold on.
tactics like this to avoid the evidence because you're afraid of
No,
the
no. I
evidence.
made a specific claim. No, I didn't
Yeah,
deny
you
that
made a
superior
specific claim.
mirages.
Now here's
Okay,
another. Let's
most
establish
hold
something
on.
about
This
light.
is not going to work out for you, as you already know. If you act like this, I'm trying to be cordial with you. Storm,
too.
please.
So
Right, so just
let's
chill,
establish
chill,
something.
chill. All right, let me talk. I'm specifically talking about a laser. I also agree that in very rare situations, you can have a superior mirage, which is super obvious when that happens. And we wouldn't use a situation where we have a superior mirage as proof of anything other than, look, here's a crazy superior mirage effect. Now, with lasers, right, we have all of these laser tests that hit the target. And we don't have any evidence that lasers bend downward as any kind of normal situation through the atmosphere. And I just simply asked you if you have any evidence that they actually do that without
Let's
just it
establish
being
some
an
facts.
explanation.
Let's establish some
Yes.
facts. Is light an electromagnetic wave?
Yeah, sure.
So are lasers electromagnetic waves?
Yeah, lasers are light.
Okay. Is radio an electromagnetic wave?
Yeah, yes.
Okay, so both of them are electromagnetic waves, correct?
Uh-huh.
If something affects an electromagnetic wave by a certain effect, all electromagnetic waves will be affected by the same effect in the same way. Not the same amount, but the same way.
You don't know
Isn't
that.
that true? Yes, we know that.
No, I think that the different wavelengths.
So you're telling me that
have
electromagnetic
huge,
waves
yeah. So
behave like
depending on the wavelength,
non-electromagnetic waves?
depending on the spectrum and the wavelength and all that sort of thing, right? They're going to behave very, very differently. Now, this is the thing: downward refraction, right? That people say is the normal isn't the normal. It's actually the opposite of that. That's the normal, because the normal lapse
we
rate.
know downward refraction is not the norm. We know that.
No, that's
But
what they claim on
that's
the
why we
globe
talk
side.
about ducting. That's why we talk about ducting here. Ducting is not the standard part of the thing. But you see, you have superior mirages, which you try to avoid, but you never thought about avoiding ducting. So you use ducting
Yeah,
and
so
then deny ducting.
No, I didn't deny ducting with radio waves. I said that if you
But
have
if ducting affects radio
visible
waves,
light,
whoa,
if
whoa,
you
whoa.
have visible, okay, so you're talking
Ducting
about
affects radio waves, which
completely
is
different. We're
conceded.
talking about
It
tiny
affects
little
all
wavelengths.
electromagnetic waves, including
Storm,
light.
Storm. I agree that you can have a situation where you could have a duct. Now, super, super rare. If you have a duct when it comes to visible light, you have crazy amounts of destruction and miraging. You don't have any evidence that you can have a nice clear image with visible light in ducting conditions. You don't have any evidence of that. You just have a statement saying that ducting can happen. I say you agreed with this
I'm trying to
last time
address
we
the claims
spoke
one
about
by
it.
one, but you're stacking them up, so I can't address any of them. Let's address the claim
I
you
didn't
just
stack
made.
anything up. What am I stacking up?
Well, you just made a claim, and then you were about to make another, and then another, and then another, and then
Okay.
another. So
What's the first claim
burying
that I
them
made?
below each other.
What's the first claim that I made?
So you just talked about like the ducting claim you just made,
Yeah,
right?
what was my claim? What was my
Do
claim?
you remember what you said about that?
Of course I do. Do you?
Can you refresh that?
Do you don't remember, do you?
Not really, because I have memory issues. Yes. That's why we need to work one by one instead of stacking up 10,000 claims and me having to select one of them that I might actually forget.
Sorry, I didn't realize you had a goldfish memory.
I'll take that. I'll agree that I do have a goldfish memory.
Right, man.
Yeah.
Look, yeah,
I'll
okay,
take
yeah.
accountability for that one.
All right, man. It's all good.
So
Okay, so this is what I'm saying. There's no footage of lasers bending downward. Lasers
okay,
would
but
have
you
to
don't
bend
need the
downward for
footage
the
of
laser
lasers
tests.
bending downward.
Well, you don't have any evidence that they bend downward.
You admitted that ducting affects radio. Radio being an electromagnetic wave. So
Allegedly, yeah. I've not confirmed it
ducting
myself.
affects all electromagnetic waves, not just radio. If ducting affects
Okay.
one electromagnetic waves, it affects all of them. That's how electromagnetic waves
Okay.
work in the first place. If something affects one, they're all affected by it. This includes light. So if the ducting is bending the radio downwards, it's also bending light downwards.
Right.
It's
So it's
that
like
simple. That is your evidence. All you need is that. That is the only evidence you need to know that light bends under
right.
ducting.
So do you have any? Okay. So when we're talking about the laser test, you're saying that ducting is causing the lasers to hit the targets in all of these different laser tests that we have. So do you
I
have
wouldn't say
any
all.
evidence?
I wouldn't say all. I wouldn't say all. There are some that there is clearly ducting. There are some where I clearly identify the ducting, such as the oil rigs.
Okay.
I've seen that that's ducting.
That's not a
That is
laser test.
clear ducting. But
Okay. What evidence do you have that
the
that's
Salt Lake
ducting?
the Salt Lake one isn't a duct. It's actually the temperature gradient from the salt of the water. There's that. Salt flats do this too.
What?
That's how we know that the Salt Lake is doing exactly the same thing that salt flats are doing, because the observations are the same with salt flats, but they're
So
not the same
you're
when you're not
saying
involved in
the
salt.
lasers
The removal
bouncing
of
up and
salt
down, zigzagging through a duct. It's bouncing up and down, zigzagging through a duct, like in this diagram in the side chat. Is this what you're saying? It's zigzagging up and
that's the
down.
radio. Yes, yes.
Right. So you think the laser is bouncing up and down, zigzagging, and then making its way to the target?
Not necessarily at that intensity, because the laser is much more sensitive than the radio. So the radio is much more stable. That's why the radio is bouncing stably. But yes, the effect of the duct, which is basically to drag the radio all the way to the other side like that, okay, that effect is the same on light. Therefore, the light will just be less stable in that duct, but we'll still have some distorted view of what's there beyond. That is
But
exactly
we can
what we
see the
see in the
laser
oil
beam.
rigs. That is exactly what we see with the oil rigs.
So we can just see the laser going straight. It's not zigzagging up and down.
The laser is going over 20 miles.
Right, but we've got laser tests over distances like
Okay.
6 miles,
And the
10
duct is
miles,
also 20
15 miles.
miles. Okay. So think about that for a
Okay,
second.
but we have side views. We can see the lasers not
You
doing what you're
got a
claiming it's
laser
doing.
that is barely bending within the duct to follow the duct. It's not stable like a radio because it's more sensitive. It's still affected by the duct being dragged like the radio and the light. That is what's happening to it.
You're saying it's bouncing within the duct.
No, it's being dragged within the duct.
Dragged by what?
By the duct.
Dragged
It's
by
a
the
new
duct?
medium. It's a new medium.
No, it's just a medium that has boundaries that stop the light from penetrating through the boundaries of the duct. Like in the image there in the side chat with the radio waves, it's bouncing up and down like a zigzag.
Yeah.
If you're claiming that's happening with the laser beams, that's not happening with the laser beams, because we can see that the laser beams aren't doing that, because we can take side views of the laser transit and see that that's
Same
not
as an
happening.
atmospheric duct or just a tropospheric duct? Is that the same thing?
Well, the troposphere is the lower atmosphere.
Yeah. But I mean, we're talking about atmospheric ducting. There's probably a difference here. So I'm just going to make sure about that because I'm not 100%.
So if the radio's in the troposphere and the duct's within the troposphere, that would be an atmospheric duct inside the troposphere.
Yes, okay, they're essentially the same thing. Okay, good.
Yeah. But the laser, if we have a side view of the laser test, right, where so we can watch the laser.
And also, it's not all the waves that bounce up and down the zigzag thing. Some escape, some also are under, but yes, they all follow the same trajectory, and that was my argument, the trajectory.
Right, but the laser beam has a centroid, right? It's a central beam, and the centroid's being detected at the target side. So you're saying that the laser beam is bouncing up and down through the duct and around the curvature of the Earth, and then making its way to
How thick is that
into
duct?
this.
How thick is the duct?
What duct?
Well, the duct that it's bouncing up and down in, how thick is it?
What, the duct that we have every single time that we do a laser test?
It's not every
any.
single time. It's not every
Well, how
single
come we
time.
don't
It's
see
under specific conditions. For example, the oil rig under a specific time when there's ducting, you have that 10-mile observation, but when you do that again on another day when there's no ducting, you only see the 6 miles.
What would cause the ducting? So you said that you know that there's ducting on that day
The
in an
weather
observation with the
conditions.
oil platform. Okay,
The
so what weather conditions?
ducts
What
aren't
weather
permanent.
conditions?
They're due to the
What
weather
weather
conditions.
conditions? Yeah. So what
Yes.
were the weather conditions? I know
The
the weather
humidity
conditions.
levels, temperature. No. We've been through this so many times. I don't get
Okay, but you
why
don't
I
know
have
the
to
weather
repeat this
conditions.
every time.
You don't know the weather
It's like it never
conditions.
sinks in.
You don't know the weather conditions, though. So how do you know what the weather conditions were if you
And
don't
we
know
know
the
that
weather
when
conditions?
we do an experiment, can we know the weather conditions? So if we don't know the
Yeah,
weather
yeah.
conditions, maybe the people
I know
who
the
did the
weather
experiment,
conditions.
if the people who
I
did the
know the weather
experiment
conditions.
forgot to get the weather conditions,
Yeah,
that's
we
on
did.
them.
We
They
do. I
did.
have the weather conditions. You don't know the
Okay,
weather condition.
and the
So
weather
why are you
conditions would
making
show that there's a
claims?
duct, right? The weather conditions would show mathematically that there's a duct, correct?
How do you know? You haven't seen the weather conditions.
I'm saying if you have them, are they saying that there's a duct?
No, you said that you know there's a duct. How do you know that when you haven't seen the weather
The
conditions?
observation shows that there's clear ducting. Just there.
So you said
The
you know that
observation
because of the
alone
weather
shows
conditions. So what's how do you know there's ducting? What do you see that causes you to know that there's ducting?
the exact effect where you see a refracted horizon beyond the apparent horizon that is beyond the curvature horizon. So we
So
have three
because the
horizons.
curvature's not there, therefore there must be. So can you see how that's like begging the question and circular reasoning?
How is that begging the question in circular reasoning? This is what we see when there's a duct, and we see exactly what we see when there's a duct.
So because the curvature that should be there isn't there, therefore there's a duct.
That's incorrect.
Uh-oh.
You completely misrepresented and strawmanned me there.
Okay,
That's not what I
fix it
said.
up. Fix me up. Correct me, please.
Okay. Because you can see a third refracted horizon beyond the apparent horizon, there is a duct.
Really? All right. So you can point out where the horizons are. I only see one horizon.
Did you
Right, so
say
I'm gonna
three?
I can clearly see where the water is refracted, the refracted horizon where it's all refracted, and then where the water is no longer as refracted, which is your apparent horizon, and then behind that you would have your 3-mile horizon.
Where? What is
You
the?
actually see it in the black swan observation. Yes, I
You said
see it.
three different horizons in one
You see
picture.
3 different horizons?
Well, the third one is invisible. The first one is invisible because it's like the
Wait, how do you see it if it's not even visible?
A mathematical 3-mile without atmosphere one. Okay, that one extends to the 6-mile one, and then you have the 10-mile one, which is the refracted horizon. Which everything between the 6-mile and the 10-mile horizon is completely refracted and squeezed out.
Okay, DJ.
All right, here we go.
Okay, DJ's gonna post a picture. Can you just point out the 3 different horizons first, please? Sorry.
Well, hold on. He just said it. He said it's a mathematical. So he's saying the imaginary horizon is not there. Is invisible. Is that what you're saying?
I'm saying that,
Well, I
like,
mean-
if Earth were no atmosphere, there were no atmosphere at all on Earth, you would see to 3 miles. But given that Earth has an atmosphere with a normal refraction value, you'll see up to 6 miles.
So you're
So your
saying that you never, ever,
your
ever.
apparent horizon is 6 miles. That's
So
it.
you
The one that
never
you
ever
see,
see.
the
So
one
you
that you
never.
see is the one that's 6 miles.
So you
Okay,
never ever see the imaginary one then.
it's not
Wait, so
imaginary. It's just refracted to 6 miles.
I mean, you said it's mathematical, didn't you?
I guess you don't like the words that I use, right?
I mean, you're saying words, and I'm just repeating what you're saying.
Yes,
Words,
it's mathematical. That doesn't make it
right?
imaginary. You're not using
Well,
the
it
words I'm
is.
using. You're creating new words to try and shove them in my
No,
mouth. I
because
never said
it's
imaginary, did I? Did I
well,
say the word imaginary? No, I
it's
didn't. Oh,
mathematics.
okay. So
Is
stop with your
mathematical,
imaginary straw man.
right? So is mathematic abstract?
You're trying to make a red herring here. This has nothing
No,
to do
no,
with what
no.
we're talking
Is
about.
math abstract?
Sure, math is abstract.
Right. So not real, imaginary.
So if
Only exists in ideas.
if Earth were to have no atmosphere, the one
Well,
that you
we've
have with
never
the
had that.
math that you're
So
doing, the one that you're having mathematically that you're doing without an atmosphere, which is 3 miles as a result,
can
it
you
would
just
be it would be visually seen at 3 miles without an atmosphere. You
can you
only don't
define
see it. You only don't see it because Earth has an atmosphere. That
can
doesn't
you
make it
can
imaginary.
you can
That
you
means you see
define
further than it. So mathematically, you should see to 3 miles, but you see beyond that because there's an atmosphere. If you add the
right
atmosphere
because
in
it
the
is
math,
because it is
you
in
will see to
reality.
6 miles. And then when you look at the observation, you see to 6 miles, exactly as the maths predicted, nothing imaginary. And then when you add an atmospheric dot, you see a refracted horizon and everything refracted between the actual 6 mile and
Okay,
refracted
so
horizon.
how
That's the
far does the
argument.
math how far does the math say you can see in the perfect conditions?
What do you mean in the perfect conditions?
Your math. You're
Okay,
so
so the
convinced
most
of how
one.
far you can see due to this math. So what's the maximum you can see with your math?
Okay,
What do you mean the
so
math? I didn't learn this in
I'm
school.
see, instead of like doing that, you could just let me respond to your question, right? You
What's
know
the
that.
maximum?
So let me clarify. So for the maximum, you're talking about the most extreme possible refraction, the most extreme possible duct, the most extreme possible conditions. Is that correct?
Are
Is
you
that what you mean?
typing while you while you repeat it? You didn't know what I was talking about, but now you have a question to
I'm
clarify
asking
it
you
with three other questions.
if you meant by
Yeah, how
perfect
far? What's the
conditions.
maximum? What's the
By perfect,
maximum?
first, let's establish by perfect conditions. Do you
What's the
mean the most?
maximum your math allows you to see?
I will answer that as soon as you clarify
Good.
what you want as a maximum. So,
It's your
do you
math.
mean? Why can't you just let me ask you this?
It's your math, dude.
Okay. Did you mean the most extreme possible conditions when it comes to the refraction and ducting for the maximum? This is important. If you want a number for the
Yeah,
maximum,
for the
you need.
10th time.
Okay, the most extreme. Okay, that would be up to 402 miles if there are no attenuation. So, given attenuation, 350 miles, but remove
Okay, I'd like to see
attenuation,
that.
402 miles.
Let's see that occurring in reality. You have it in the math.
It occurs with radio, even right there.
Okay, let's see the math that supports it going around the ball. Please.
Oh, you want me
Hold
to
on,
explain
before
all
that,
the mathematical
Storm,
terms?
Yeah,
Storm.
all the
Defined and
conditions that
We'll
yes.
get back
I
to
want to
that.
all
I'm
all the
sorry, my
conditions you
keyboard is
plugged
not.
into your math.
My keyboard is not equipped with the symbols required to post, so I'm gonna have to use something that'll a copy paste image of the maths themselves because yeah. So let me get.
He's saying, hold on, just quickly before you get that, Storm. I posted the observation. Are you saying you can see 3 horizons here? Everyone else just sees 1 horizon.
Did it go quiet?
No, I'm here, bro. That's good. Are you for me?
What happened to the dude who was talking just a second ago? There he goes.
Oh yeah, there was a guy who was talking about math. Where's the math guy? Where did he go?
Lost in his maths.
Dead silence. All right, while we're waiting for the math guy to return and resurrect himself from the globe, is there anyone else that is a sphere enjoyer that wants to be a defender of the sphere religion? Moment of silence for the globe.
Yo, bro, do you know what the steelman argument is, or what it means to steelman someone's position?
You're asking me? Yes.
Yeah. So I would
Yes.
ask you politely to steelman the globe Earth position.
The best one that I could think of would be the pictures from NASA. I would say that's the best one they got.
Well, what do you
But
want
the problem is they
like
can't
what do you
test
want
it.
specifically to be stillmanned? Like you want get specific.
The view, the view, like the best possible representation of their view. Could be pictures, for example. That's interesting pictures, But you know that they're like sometimes composite
It's
pictures.
just that the Earth is a sphere that goes around the sun. The sun goes around the Milky Way. Rotation of the Earth causes sunsets. I mean, what do you mean?
Held by gravity.
I guess in argument form, they would say the photographs.
There you go, DJ.
Oh, there he is. Okay, he's back. Welcome back.
Me? I didn't ask you for anything. I asked you to just tell me how many horizons you can see in the observation I posted.
Well, I can see that blue line there, and there's some more refraction beyond the blue line between the
you draw
red
lines.
lines. So then you have the red line horizon, and then you have the green line.
Oh, hilarious. Thank you very much. I'll take a screenshot of this one.
Mucky, without argument.
Yeah, so there's only one horizon. So the horizon's defined as the sky, the line where the sky and the ground appears to meet. There's absolutely no sign of any horizons where you drew the red and blue line. Right? Literally zero.
So there's no difference.
Not to mention, let me finish, right? Not to mention the geometric horizon should be halfway to the first platform, not where you drew the blue line. There would be no horizon where you drew the blue line. There's no evidence of any horizon there. Okay, the 3.47 mile horizon's not there.
Can you stop stacking claims now?
No, I'm debunking
now I have two things
all
to
of your
address.
lines here.
You're gonna add a third thing now?
Okay, so let's do one at a time because okay, so you did admit you had a goldfish memory. So the geometric horizon should be at 3.46 miles based off the 8-foot observer height. That's halfway to the first platform, not where the blue line is.
Sure.
Okay, so what's the blue line for?
You don't see that one. I did say you don't see that line.
Okay, what's the blue one?
The blue one is the 6-mile horizon.
Where do you? There's no horizon. So what's define horizon?
Let me explain why that blue line actually is a horizon. Because
Can
you
you
see
define horizon
the
first?
oil rig behind it. Do you think that you see the entire bottom of that oil rig? Do you think that that's the height of an oil rig?
Yeah, I know. I can show you pictures of the oil rig. It's
An
the exact
actual
height.
oil rig is much taller than that, dude. Much taller.
No, it isn't. It isn't. It's called Platform C. Look it up.
Yeah, it's much taller.
And you can also see the reflections from the lights reflecting off the water. So the law of reflection also debunks your claim. And there's no sign of any horizon line there. And yeah, please define horizon. Just go to Google and type in horizon definition.
Well, like,
tell me what it says. Just type in horizon definition in Google and tell me what it says.
I know the definition. Don't worry about that. Like I said,
Okay, say it.
that's
Say it.
the line where the sky and ground appear to meet. I know. Okay.
Okay, so is that blue line where the sky and the ground appears to meet?
That is the now refracted geometric horizon.
Is it this line in which the sky and the ground appears to meet?
No.
Right, so it doesn't match the definition of a horizon.
That's why we call it the geometric refracted horizon.
Okay, get me a citation for that, a definition of the one that you just said.
Look it up yourself, I guess.
I looked it up. It doesn't exist.
Okay, sure you did.
I did. I just typed it in. It didn't. It says there's no such thing.
Okay, yeah.
You want me to read out?
Of course.
Okay.
So there you go. You do have a result when you type it. So you lied. You just lied again. Anyways,
right.
so that's your geometric
Are you
horizon.
saying a refracted geometric horizon? Is that what you're saying?
Yes.
A theoretical concept.
It's logically possible.
That's what it says. The refracted geometric horizon is a theoretical concept.
What's the context of theoretical in this?
It's a concept of theoreticalness. Yes.
Hey, don't laugh.
Theoretical has context. Like scientific theory is established knowledge, not just.
Okay, what
theory? A scientific
There's a
theory
difference
is
between
different
a
than a
hypothesis
theoretical
and
theory.
something theoretical. Just say it.
You understand you understand the difference, though they use the same beginning of
Anyways,
you understand the differences. You know they
anyways.
use you understand the difference. You're not gonna anyway me. I'm about to beat you doing that.
Of course.
Oh wow. What abuse.
Because they start with theory doesn't mean they're the same word. You understand that?
So your geometric horizon, which is established at 6 miles, and we do see that from the tallness of the lacking tallness of the oil rig, we don't see the whole oil rig.
You do see the whole oil rig.
No,
you do see the whole oil rig.
A lot of it is missing. Same
none
thing
of
with
it's
the
missing.
one, the second oil rig.
None of
And
it's
then at the red
none of
line,
it's
what's between in the red and green line is a ducting refraction, by the way.
Yep.
What?
So that's
my
why
God, that's what it's called,
you have this extra horizon that I'm talking about, the ducting
Wait,
refraction.
did someone
That
disagree with
10-mile
Cont?
horizon that you see, where the sky does actually appear to meet the sky.
That's the singular horizon. There's one horizon.
Many. Because of refraction, man.
Dude, you don't see any horizon at the blue line or the red line. You just made that up.
Oh yeah, this is your imagination. So what did they teach you in school what a horizon was, Mr. Superior Education?
Why going to personal insults? Come on, let's be professionals.
Oh, let's.
This
who's
is
this
professional.
Or
I'm not
okay,
getting
fine.
paid.
Fine, we can say boundary instead of horizon. Do you prefer those terms?
What did they tell you in school?
Geometric boundary,
You're a liar.
mathematical boundary, refracted boundary, and ducted boundary. There are your boundaries.
Yep.
So where's the horizon? Remember, you said, "Well, they're actually where the sky actually
by
does
the
meet
cherry
the
pick
sea."
definition of using horizon
No, what did
solely
they
as
tell you? Listen. You're the one with the superior education. What did they inform
and
you
you're
the
the
horizon
one
was
asking
back
a
in
question
school?
and not listening to the answer of the question.
You're not answering my question. You said, we'll just call them barriers or boundaries.
I'm not
What did
answering
they
your
tell
question
you in
because
school?
when I answered your question, you interrupted me and spoke over me. That's why I'm not answering your question.
Okay,
And I
here's
don't
your
like
turn.
repeating myself.
What
So,
did they tell you in school?
if you would like to get an answer, I guess ask Google this time because I'm not repeating.
You must have had to sit in the hall a lot at school, didn't you?
You went to school. Did you?
Wait, just so we're clear, you're not saying that the red or blue line is the horizon, right?
I'm not saying that it's the point where the sky and land meet. No, that's not what I'm saying. I'm saying that what would be the geometric horizon, and where the horizon would be if there were no atmosphere, or I mean, no
Incorrect.
ducting happening.
Incorrect. The
I
horizon
can
would
believe
be
that.
the horizon would be at 3.46 miles
Yes,
if there
yes,
was
I
no
know.
atmosphere.
3.46 miles, and then with a standard refraction, it raises to 6,
No,
and
that's
then
incorrect. What standard
then with
refraction?
added weather conditions, you get to the second oil rig where there's another
No, no,
line,
no.
the
Hold
red
on a
line, and
second.
then you
Slow
get the
down.
green
Slow
line.
down. Slow down. Okay, so if the Earth was a globe, right, and you had no atmosphere, the geometric horizon would be at 3.46 miles, right? If now you add the atmosphere back, right, and we're gonna let you just guess the refraction for some reason. Okay, so they use 0.13, right, refraction coefficient, which just makes it 15% further away. So what's 3.46 plus 15%? Is that 6? No.
Do you have
So why are you just
ducting
making
involved
up
in there?
numbers?
Do you have ducting involved in that math?
Okay, what's you just said to add standard refraction to it? Why did you
Yeah.
say that? Yeah, what's that standard refraction value? I just told you.
It can be 0.17 or 0.23. It's a variable
No,
refraction.
that's not what they use.
When
That's not
I'm
what
saying
they
standard, okay, standard range of refraction. How's that?
Okay, so
There you go.
how
The
did
standard range.
that get to
See,
6?
why
How did
can't
that
you
get
wrap
to
your
6
heads
miles?
around a more general concept instead of trying to cherry pick the specifics?
Dude, what you're saying, right, is incoherent babble that doesn't make any sense. And
Okay,
if you
that's
had
totally a good
any
argument.
globe
What you're
earther
saying
that
is
if
incoherent
you had
babble that
any
doesn't make
globe
any sense.
earther
Are you
in
now
here that
convinced
knew
that what you're
anything
saying is
about
incoherent
optics,
babble that
they
doesn't
would
make
think
sense?
that you're
There
a
you go.
complete
Bro,
moron.
why y'all talking over each other, bro?
Dude, I'm just talking. He's talking over the top of me. Right? He doesn't know anything about what he's talking about. In fact, you're just making a fool of yourself right now on the live stream, just butchering every
Of
single thing you
course I
say.
am. Yes, of course I don't know what I'm talking about when I know what
Okay,
I'm talking about. That's fine.
what's you don't know what standard refraction even means.
Ad hom.
So you said
You don't.
You said a standard variable. So let's take the high and the low and figure both. That gives us a range.
What's the high
Yes,
and the
it's
low?
the high and the low, and then
You
you
don't know
can
what
add
you're talking about
the
either.
ducting. So I'm just naming the mechanisms here. I'm not going to give you the specific numbers.
Well, then how are
You
we going
don't
to get a
know any
specific
specific
answer?
numbers. Yeah, how'd you get to
Because
6?
we could
How'd you get to
speculate
6?
the specific numbers of this image all we want. We don't have them.
You're just making guesses, ridiculous guesses, dude. And if anyone wants to back this moron up, you're just as dumb as him, right? If this was a flat earther saying such
Ad
moronic
hominem
nonsense,
again.
you'd jump all over them.
See, when you can't argue with
You
the
are
argument,
you
throw ad
are an
hominems and try and
absolute
discredit
freaking
the other
Dunning
guy.
Kruger moron, bro.
Yes, I'm the Dunning Kruger, of
Yeah,
course.
that's just a direct insult. I already addressed your argument, and right, so your argument's stupid, and you're just a complete moron.
You're just avoiding everything about ducting. Like, you haven't addressed ducting.
No, we're asking for specifics. We're not avoiding anything. We're giving you the benefit of the doubt and saying you got a standard range. Let's figure the high and the low, and let's try to come to a reasoning why you have a number called 6. If you've got a specific answer, let us see how you got there.
Yeah, so why would you, if you had ducting, then you wouldn't be adding any kind of standard refraction in, because ducting would mean that you wouldn't have any standard refraction. You would have extreme ducting. So you wouldn't have any type of standard refraction values between k equals 0.13 to k equals 0.17 because you've got ducting, right? So that would cancel that out completely. So there would be no reason for you to even put that blue line in there at all. Like, what the hell, dude? So once you start getting up to like k equals like 0.7, 0.8, that's you're starting to get into ducting territory. You can't have standard refraction and then also have some other thing for ducting at the same time, right? It just shows that you have no idea what you're talking about, dude. You want to act so cocky and say that the American education system's all messed up and that you've had some great education when you're in here just making an absolute fucking fool of yourself right now.
Quebecois up here are very prideful of their schooling. Yeah.
Well, this guy said he didn't learn the globe from school. He said he learned it himself. So
Yeah, horseshit. We went to the same education system.
failed
Don't
himself.
try and bullshit through it. Come on.
You know, I'm nice to people until people are just complete bullshit artists. If you're going to come in here and bullshit everyone, even if you're bullshitting yourself, I'm going to call you out, dude. It's not like the first time you've done this. You've done this 50 times at least. If I was a globe earther listening to your nonsense, I'd be pissed. I'd be like, this guy's making us look like fools.
I mean, if he keeps bullshitting, just don't entertain him.
I don't have the ability to permaban him. And I give him chances. I give him all these chances because he kind of acts like he's in good faith. Right? But then he just starts bullshitting. So yeah, he should be permabanned.
All right. Is there any other sphere enjoyers who want to defend the sphere?
If the Earth is flat, how come the cat have knocked everything off the edge already?
What edge?
The edge of the Earth.
Well, how do you know?
Leaf, we know that Leaf doesn't know anything absolutely, so he wouldn't even know if that's absolutely the case.
Wait, why do we have to assume the Earth has an edge?
Well, where's the what's light outside of the Earth then?
So do the standard
litter box.
refraction 1.3 of the standard refraction, K equals 1.3, and do that with your geometric horizon 3.4 miles, you'll get 6 miles. So standard refraction.
That's incorrect. No. Okay,
well, then
that's
state your
not
correction.
correct.
Then where are your maths? I'm doing mine.
Let's say.
All right,
if we
let's
keep
do that.
walking. If we keep walking forward, we're gonna meet.
Leaf. Now's a bad time to talk.
It
And end
wasn't.
up somewhere else, Leaf.
You end
Alright,
up
so if
somewhere else.
if you have an 8-foot observer height, okay, the horizon should be at 3.46 miles. Okay, so K equals 1.13. So that's capital.
No, 1.3. 1.3. Not 1.13. 1.3.
Dude,
1.3.
that's not the refraction coefficient. That's the K factor. That's big K, capital K.
I think the
Little
moon
K
is flat as well.
0.13.
Small K.
No, small K 1.3 isn't standard 1.13. That's not standard refraction. K equals 0. Little K equals 0.13 is standard refraction. Just Google it right now. Just Google it.
That is standard refraction right there. 1.1, 1.2.
No, it isn't.
Hey DJ, I think you might want to ask him on which model he's using that K value in.
I already did. I already did.
Did you? Okay,
Yeah.
because some models
It
they
said little
range
K.
bound between. Yeah, they range bound between -1 and 1, like in the Walter Bislin one, and in other ones they're greater than 1 sometimes.
Right. It depends if you're talking about the refraction coefficient, which is what surveyors use as standard refraction. So just hit right here, right in Google. Okay, like it says 0.13. Standard atmospheric refraction corresponds to a little K value of 0.13. Not 1.13. 1.13 would mean that you have the craziest refraction ever, to the point where you would have extreme ducting, right? That's not standard refraction. That's like some extreme anomaly. In fact, Walter Bislin's refraction slider doesn't go past 1. Doesn't even go past 1. storm.
Right, while we're waiting for the math man to return, was there any other sphere enjoyers, globe defenders, who would like to step up to testify their evidence of the globe?
If you guys are interested in entertaining it, I'd like to get some feedback on the land beam follow experiment that I'm proposing. I can post a link again in the VC.
Oh yeah. Yeah, I was gonna.
I just posted it 14 minutes past the hour.
Can you give a brief summary again, just so everyone is aware? It's you have a laser and you're shooting at a drone, right? And you're checking the altitude.
Yeah, in general, that's what it is. A laser that is pointed east from its origin, so from where the laser is at. Drone flying away from it, where the drone continues to move
I
away.
was just converting from the radio K to the geodesy K. So basically 1.3 applies with radio, but for light it's like going to be a 0.13 or 0.14. So I just did the conversion, and my refractive value for the normal light is going to be 0.68 up to 0.72.
Yeah, so not standard refraction. That's some extreme refraction.
It's not that extreme. It's high, but it's not the most extreme.
Where did you make that up from? Where did you get this from? Why are you just making up some random number?
How's that made up? Explain how that's made up.
Okay, okay, where did you get it from?
I'm a glober, and I'd be interested in seeing the site of that. Also, not sure where you jumped right in the middle of me discussing something.
Well, if you can understand, D equals a square root of 2 times R times H divided by 1 minus K. You do that, and with the values that you gave me, 3.4 miles to 6 miles, the refractive value has to be 0.68. What's made up about that?
Right. What's 6 miles got to do with anything? It's just a random patch of water. You just drew a blue line there and said it's a horizon. Like there's no sign of any horizon there at all. What are you talking
You're
about?
extending the 3.54 mile horizon to 6 miles through refraction. So you're using that exact refraction formula
Why are you doing that?
Used to get 0.628 as a refractive value. What's wrong with that?
Why are you doing that?
Because you asked me for the specific of the refraction value to cause the fucking horizon to be at 6 miles instead of 3.4 miles. I thought I was the one
with
with
a horizon at 6
memory
miles.
here.
There is no horizon at 6 miles at all. What are you talking about?
We're talking about like the refraction value for a horizon to reach 6 miles from 3.4 miles by refraction.
But there is no. What's that got to do with anything? There is no horizon at 6 miles. There's an oil platform at 6 miles.
The mathematics say that the horizon should be at 6 miles. Well, the observation shows that the first rig there, the blue line, is at 6 miles. And when we take observations without these effects, where there's no ducting and extreme refraction, we get 6 miles. We get the horizon at 6 miles. There are images of the oil rigs with a 6 mile horizon, nothing behind it. So yes, the 6 mile is a valid value. We were talking about this just now.
There is no horizon at 6 miles, though.
Still has no idea what a horizon is.
Yes,
Won't admit
there
that
is.
Define
Now,
horizon.
in the image, the horizon's at 10 miles because there's also ducting
now it's at 10
involved on top of the 0.68 refraction value.
It's at 3, it's at 6, it's at 10. What a school.
This is crazy.
It's easy to mock someone when you're not listening to anything they say.
I don't know, dude. I feel bad for you. All right, Shane. We'll get back into your thing in a second. Can you see a horizon at 6 miles? I mean, the first oil platform's at 6 miles. So do you see a horizon there anywhere?
I can fetch an image of that oil rig where you see it, though. I can definitely get that.
Huh?
Let's just go to Shane's thing.
Yeah.
I'm not real
Stay
interested
on
in
mute for a bit, Storm.
in his conversation. I'm interested in other conversation, but I'll stay out of his conversation. I can't validate or deny.
Can you define horizon, Shane?
Yeah, but I'd
Go
rather
ahead
have.
and do it. Thanks. I'd rather
Cool.
you do. Help this other guy out. Cool. Yeah, just define horizon, dude. Why is it so difficult? I don't get it.
It's just distracting from the conversation I'm trying to
Here's the
have.
horizon at 6
It would
miles.
take you 3
Here's
seconds.
the horizon at 6 miles. There you go.
Hey, when you disagree with someone, you don't necessarily want to inject yourself and be a part of their conversation. I'm not disagreeing with you.
No, I'm just asking you to define a word.
That's not the same
I don't
oil
want to be in his
platform.
conversation. I'm not interested in being in his conversation.
So Storm, that's not the same oil platform. It's not the same vantage point, right? So that platform there is called platform Hillhouse. Okay, the platform in the observation above is called platform C. It's a completely different platform from a completely different place. So keep yourself on mute. All right, we're going to talk to Shane for a bit.
I just posted an image though, which shows the
It's
6
not the
mile
same.
horizon.
Yet that's not the same platform. It's not the same location.
It is the same platforms. These are the same.
No, it's not. Okay, look, if I can prove you wrong now, then you agree that I can just ban you, right? Is that a deal? If I prove you wrong with this, or are you just gonna want to just concede right now? Save me the time.
He's on server mute.
Oh, okay.
Fuck him.
Right. Yeah, it's ridiculous.
The mental
It's not
illness,
the same.
the mental
Not the same
illness is
platforms. Completely different.
next level. Too.
Next level.
All right,
All right,
Shane,
Shane.
go ahead.
What's your drone thing?
Yeah, I'll post it again in the VC chat. We'll see how far we get till he jumps back over top of me again. Yeah, I'm just proposing an experiment. I have not conducted this experiment because I just started writing it up and put together. Basic experiment is that you have a laser at a height and above, high enough so that horizon really isn't a question of the distance you're measuring or if you're able to see it. And then you have a drone that starts at the same point. From the point of origin, you start facing east and you send the drone along the path of the laser. The drone only moves forward when it has contact with the laser's beam. The drone would have a basically like a almost like a sonar. It would have something to continually monitor its elevation. It would fly along that path, and we would collect that data in order to make the 3 different determinations of the conclusion of the experiment. And the link that I posted at
Good luck with
22
that.
minutes past the hour is it has information in there. I'm looking for scrutiny on this before pushing this further into the actual implementation
Well,
of the experiment.
do it first.
No. I'm looking for scrutiny prior to, rather than putting the money
This
into
is
it.
the scrutiny prior to it. Do it.
So the scrutiny to doing it is do it first.
So what? So at this point, all it would be is just a reification of your idea that the Earth is a ball. If you're not even going to do the quote unquote experiment, what would you see if to confirm that the Earth is a ball? Would be the results of your experiment that would confirm the Earth to be a ball?
In my experiment, am I saying what the results of the experiment are?
Well, you refuse to do the experiment.
That's not hey, this week I'm gonna go to Florida. Does that mean I'm never gonna go to Florida? I'm talking about in the future I want to do this experiment. Prior to that, I would like to have some conclusions. Hey, what's a good place to stay? What was the weather there?
Florida's a
Like,
very
I'd like to
violent
have some
place. I
information prior
wouldn't
to
go
going
there.
on this experiment. Does that make sense to you, or is that confusing? Because if that's confusing, then we're talking about totally two different types of worlds that we both live in. Is
Just
there
do the
anyone interested
experiment.
in actually engaging with the conversation?
I am engaging with the experiment. What results would you expect to see if the Earth were a ball? If we don't even know what you're looking for in your experiment, what's the point in doing it?
Have you looked at it?
I'm asking you when you're going to do it.
In the future. Or have you looked at it?
Okay, appeal to the future. Thank you.
Cool, thanks. Does anybody else have any feedback on that has some
Yeah,
value?
why don't you just answer the question other than I'm driving right now? Why don't you explain to me what results that you would get out of your experiment that would confirm the Earth is a ball? What are you looking for?
Is Old Haas still a moderator, or can I mute him so we can continue the conversation?
No, but since you're a snowflake, I won't talk to you anymore, okay? Shane.
Yeah,
Is
Shane,
anyone interested in engaging in the conversation?
Shane, I mean, you don't have to, dude. But I mean, why not just answer his question, bro? Like he said, he's driving, right? You can't
He
actually look
has
at
no
your
answer.
material. I mean, that's one possibility. The other one is he's butthurt for whatever reason.
Yeah, I don't try to figure out the emotions of others.
Well, dude, you're the
I'm not
one that's
asking you
running
to.
from the question.
Yeah, no one's
You're the
asking
one
you to figure
applying
out other
emotion
people's
to it.
emotions, bro.
Yeah, I'm just looking for
Okay, so you
feedback
don't.
on the experiment before I conduct the experiment.
Okay. Well, you've ignored my feedback. Crybaby.
Yeah, dude. How can anybody give you any feedback if like they don't have a full picture of what you're actually trying to do? Right?
Fair enough, but I don't think the answer is to go do it before I do it. That's not. I can't. How can I?
My question is, what is it? What are you
How is that any type
expecting to
of feedback
find?
on the experiment before it's conducted?
You little punk had me muted. What are you expecting to find to confirm the Earth is a ball?
Yeah, Shane. If you have Old Hoss muted there, like that's a
He's a
no-no.
punk.
Oh, I asked if that was a no-no, so that's a no-no. Okay, I can unmute him.
Yeah. No. Just answer the questions, bro.
It's so funny when you guys talk about science in this vague term. You always talk about, well, we have a hypothesis and all this.
Okay, I'm muted.
What's the experiment?
Go ahead, Old Hoss.
Did you hear me? What's the experiment?
Probably has you muted too.
No,
Shane, did you hear him?
I don't have anybody muted.
I just banned this weasel.
Shane, you're being asked what is the experiment by several people. Like, what are you expecting the results to be? Right? That's just a different rewording, right? Of more or less the same thing. Not exactly, but you know.
I mean, there's two different hypotheses. What are you asking me? How the experiment is conducted, or the hypothesis that would be there?
Well, either are possible, right?
Can you hear me?
Yeah, either are possible. So one hypothesis could be that the drone would need to continue to rise, so it would stay in the beam, or that also that or it would continue to stay at its same height. Each one would have different results that would show. So if you do have a moment, anyone who does have a moment to look at the link that I've posted, there's 3 different measurement values. Taking those measurement values and putting them into their categories of beta and alpha, and altitude flat, altitude rises, altitude falls, tilt. Does it tilt increase? Does it change unchanged? Does it decrease? And I'm not proposing that I do this only from one view. I'd like to do this with two views. I'd like to have this as unbiased as possible. So I'm trying to remove as many of those variables as possible that would introduce bias. One of those variables is me. So I would need someone to balance out that variable of my view. Hence why I'm here to ask for questions about, before I conduct this experiment, what are the potential biases that I'm introducing, or what are potential flaws in the experiment that we can address while the experiment is conducted.
Sure. Hey, Shane, what you've obviously seen the laser test that we show, right?
Yes.
What was your issue with that? Maybe that, like, if I can understand that, maybe that I can, get a better understanding of what you're trying to do. I just jumped in the conversation, but
Oh, no problem. I appreciate it. I don't think I necessarily have like an issue with them. My perspective is I'd like to test them in a way that I think removes the opportunity for explanation by either side that gets into conjecture, I guess is the best way to describe it. Because I think that in order to address it, I have to like bring in some extraordinary claims in order for me to address it. So it doesn't make sense for that to be the only experimental method that we employ.
okay, yeah. So yeah, I see so your goal right now, just in general, is to try to get a foolproof experiment going, where it's like, this is the experiment, these are the results, and it's hard to argue, basically, without using nonsense, right?
Yeah, I mean, not necessarily. I wouldn't call it a globe Earth experiment, but I'd say we're just measuring a flat surface, or a measurably level surface.
Okay, and then have you yourself? I think I heard you kind of starting to work on this a couple of days ago, or at least I heard you talking about it yesterday. Have you ran into, like, to you? Is this like, this is good to go? You're just looking for other people to poke holes that maybe you haven't seen?
I keep kind of finding holes in it. I found some more just a couple hours ago, but I've been trying to keep poking holes in it, and I've been trying to
This
get
is
perspective.
something he'll never perform.
Why not?
You'll never. I don't know why you won't. I have no idea.
Why not? I
Oh,
mean,
okay. Like,
everything here is
even if
everything
he
here is
doesn't perform it
attainable.
or not, if he's coming up with something new and interesting, I mean, again, I got here. I don't know if you were talking nonsense. He was talking. I don't know the vibe of the room right now at all. So I'm just in here fresh. Um, but yeah, I mean, if you're coming up with something new and no one's really done, I mean, even if he doesn't do it or not, at least we have that. Maybe someone else can do it, and who knows? Maybe Shane will actually do it. Like, I don't fucking know. But I think it's interesting. Is at least he's trying to, do something a little different, right?
Yeah, he's acting. He's acting in that way. Yeah.
Okay. Again,
What's
I
the
don't know.
purpose of acting? I mean, I guess you don't have to try to infer what my
Well,
reasoning would be, but I don't understand why I would act out.
holes into, but you're poking holes into it as well. So I just think even if you got the results, if you got results that you didn't like, you poke holes in those. That's why I don't think you'll ever get around to doing it.
No, they would be the
I
results.
beg you to do it.
Yeah, I have no problem
Hey
with
Shane,
that.
I can see something happening.
And then you'd have a bass.
Shane, check this out, right?
Yeah.
If I'm not mistaken, one of the bigger problems with all the laser experiments that are put forward, right? That are, one of the reasons why they're all kind of hand waved is because, okay, you have a laser on one end, 6 feet off the ground, 5 feet off the ground, whatever it is. You have a camera on the other side, 5 feet off the ground, 6 feet off the ground, whatever. And we see the laser, and we see the the bright spot of the laser, right?
Mm-hmm.
So that is 5-6 feet off the ground. In your experiment, it seems like you're trying to delineate that, oh, okay, if it's a ball that has a curve, the drone would pick up the laser 100 feet in the air, however far it was, versus if it's actually horizontal, then the drone that's 5 or 6 feet off the ground, or at whatever elevation that the laser is, it's horizontal then. But it's kind of like, if you do get something like that, a result like that, where the drone at the lower elevation actually picks up the laser, can it also be explained? Oh, well, the light is just bending around the curve, so it's inconclusive equally as much as any of the other ones, right? Like, isn't it just like a read the same sort of test that has been
you'd want to try to
Fourth?
correct for. I'm sorry, I interrupted you.
Oh, that's it. It's just like it sounds like a rejiggering of the same sort of tests that have already been done that are dismissed by the sheer nature of the test itself, not necessarily the implementation. So like, aren't you kind of like leading to a potential in conclusion equally as much as any of the other ones?
Yeah, I'm trying to think of like the arguments for the globe side and what I've heard of the flat side. And of course, they're my understandings, right? So they're not perfect on it on either side, but trying to remove as much of those variables as possible, like conducting the experiment on multiple different days, different times of day, and ultimately, I mean, it would be great to be able to conduct it at different seasons, different parts of our different regions. But I think that getting started on one and trying to conduct that experiment in bi-directional, out and back, with swapping would be fantastic. A little bit harder to do to find a place where you can do that easily. And also looking at do we how do we remove the excuse of refraction from both arguments?
Mm-hmm.
You'd have to measure for it. You'd have to measure
Exactly.
for it.
Yeah, I was gonna say, dude, if you really want to do the drone stuff, I mean, instead of hooking on like a sensor, like in the way that it sounds like you were proposing to be done, why not put a pressure and temperature and humidity meter or gauge or whatever on them and scan the line of sight, right? Or scan the path of the line of sight, right? And actually collect data on that, right? And then we would know the conditions more or less at every interval, whatever, every meter, every, what have you, right? So as to better model out the actual conditions. So as to be able to actually better model out what the path of light would actually be taking potentially, right?
So add like pressure, humidity, and maybe some temperature.
Temperature, yeah. Because one proposal at some point was purely kind of hypothetical because of the logistics behind it. Is if you had multiple drones, right, throughout the entire line of sight, every 10 meters, right, all flying, hovering at the same time, and then boom, they could all take a snapshot of these variables in an instant, right? You'd get an instantaneous view of what the conditions were, right? As opposed to if you have a drone flying over it, well, there's a time variable in there, right? So things can change over time, so it may or may not be as accurate, right? So something like that was put forth, but I would probably take several dozen, if not hundreds, of drones, and then trying to operate all those at the same time, like, you know what I mean? But something like that would be maybe worth considering if someone's serious and has the funds to actually ultimately eliminate these variables, or at least account for them, like strictly speaking, right?
Yeah. That might go beyond my budget of
that's the problem.
Building a constellation of drones.
Yeah.
But yeah, that is
exactly.
It's a decent experiment. But, yeah, I definitely like adding the humidity, temperature sensors, and to the and pressure to the drone to measure across. What do you think about using two laser lights pointed at the drone, like one that's green, one that's red? Because of the normal globe thing, we would say that they're because they have two different wavelengths, they would refract differently, and you could take the difference between the two to get an estimate of the refraction of the view. It wouldn't help if it was the refraction.
Why don't you just take two of the same lasers and point them at each other?
Well, because then I'm not measuring the ground. I need to measure the surface that they're
No,
flying over.
you'd be measuring the lack of curvature in between the two lasers.
Also, I don't understand how that would.
Well, draw a little picture of yourself and draw a lake and two people shining lasers across one another.
Okay, so they were talking about when the
if
horizon gets in the way,
reach
or
one another, if they're reaching one another, the Earth isn't curving beneath them. Oh, I forgot your magical refraction chant.
Yeah, old
No.
house. That's that's the reason why different bands would be helpful in this case. You know, Shane, I think
Yeah.
that would be next level also. But the key thing here, right, with your initial proposal, is it's more or less analogous to any of the other ones are done, right? You still haven't eliminated the problem of my refraction's getting in the way, curving it around the ball. So you know we got one result, but it's explained by two different possibilities. You know, so doing this the other type of drone thing would assist in that, but it expands the actual budget and logistics and shit. So
Yeah, the multiple drones gets a little bit harder for me to figure out the logistics of that.
If you
I have
knew the
access to
temperature,
drones, but
pressure, and humidity, you'd be able to do the math to know the amount of refraction over distance. It's a K scale, so like for major refraction would be over 0.4 K. Like in one of the most rare instances ever recorded, it's been at like a 1, but you would have to
yeah,
have insane temperature differences between water and air. But yeah, all that stuff could be taken into account to also, I mean, I'll just put some stuff in the side chat.
much appreciated.
yeah, I was gonna ask, like, is there actually a technique out there, a mathematical kind of technique to actually model out the behavior of light, taking only into account the temperature gradient, the humidity gradient, the pressure gradient, and without assuming that the ground is actually curving? I haven't seen one. All the ones I've looked at, like for example, Walter Bidlins and all that shit, right? They all assume a specific radius of the Earth, right?
Sure, yeah. But I haven't seen
So
one
even
that
if we did,
does that.
yeah. So even if we do collect all that data, how are we going to process it?
Well, we mean how would you display it? You mean, or
How would we
because I'm
process
just
it?
proposing.
Like how would we calculate with the refraction index is X on average, right? Compiling all these variables, right, into what model, right? That would spit out what K value or index of refraction value. You know
Oh
what I
yeah, I
mean?
see what you're saying. Yeah, because you're gonna have to inject a globe figure in order to get that refractive value.
Well, if we were to use any of the models that I'm familiar with, yeah, they all assume a radius.
Is there a way to negate the refractive value?
A way to what?
A way to negate it, to reject the refractive value? Like, is there a condition where we might be able to either rule it out by either measurement or observation?
I mean, I would think that if there are no gradients, then there's no bending of light, right?
Yeah.
So if you measure, like, say for example, if you do multiple tests, right? On one day you go out and throughout the entire line of sight, I don't know, you measure homogeneous temperature, humidity, and pressure throughout the entire line of sight. But other days, they vary, like there are
Yep.
gradients. Leaning towards the one where it's homogeneous would be more reliable. Now you would have to assume that, of course, that there are no minor changes that are beyond the scope or the precision of the instruments,
Yeah.
right? That would be one way of basically just discounting it altogether. But you would have to be able to evidence the fact that there are no gradients, right? And that would only be provided by actually measuring it.
What about reciprocal zenith angles?
Again, these paths of light are still subject to the same stuff. So if you can measure the in between and justify why, oh well, there's no bending of light because there's no gradient. Sure, I mean that's a different application of the same sort of ethos or spirit of testing, right? But just using a different technique. Still using
To
light.
the other guy though, the reciprocal zenith angle, you take a measurement in both directions simultaneously, and so you are looking through the same path of light
Yep.
at the same time, and so you can, when you do a correction, you're correcting both at in the same way. So it, in a way, like it's not like literally a canceling out, but it like does nullify most of the effects of refraction.
Well,
So yeah,
here would be the
but
problem,
flat
right?
earthers
So
don't
that would be
accept
very,
this, by the way, because it does prove a globe. They reject
well,
this vehemently.
nah, dude. This is the problem, right? So your correction mechanism, right? We got to dig into what that is, right? If your model presumes a curving ground anyway, well then, like, see the problem. So we're trying to approach this agnostically, only taking into account the actual variables that mean anything, right? Like the humidity, temperature, and air pressure gradients, right? And we're asking, okay, well, what would be the model that actually, we could use for this that doesn't beg the question?
What about
right?
a reciprocal zenith angle begs the question?
It's not the reciprocal zenith angle itself. It's the correcting mechanism, right? The model
Why
that
do
you
you
use.
why do you need to correct, or why do Globers
Why
claim
do
you need to correct?
you tell me, right? There supposedly there's enough refraction, right? Well, how do you calculate what that refraction is? Right? Look at the models that are used that perform the correction, right? And you'll see that they're begging the question that the ground is actually curving in the first place, right? They use a K value that's basically a composite of all the other variables I'm talking about without actually using the specific variables themselves, right? It's just like, a number that's presumed to be a conglomeration of all the other things. And then on top of that, you assume the ground is curving. So we're saying, okay, let's take away the notion of the ground curving. Let's decompose this K into its constituent parts, right? And look at that instead. And those constituent parts would be sampled by like the drones and shit like we were talking about. I don't know, maybe you missed that part. But that's the whole point. Right? We want to be data driven, not necessarily purely model driven. At least what it sounds like Shane is trying to propose, right? What Shane is trying to propose is trying to be that, I should say.
Yeah, spot on. I'm trying to remove as many uses of known models as possible. It's going to get every instrumentation is going to have some model in it that it's using, but I'm trying to.
So hold on, when
Trying to
you're
remove
shooting this laser to the drone initially, is that what's going on?
when I'm shooting the laser to the drone initially. So they both start at the same point of origin. This may not be addressing
Okay,
your
that's what I'm
question.
asking you, dude. Okay, yeah. So
Yeah.
at what point is you're kind of needing to be the laser line between the drone and the beginning of the laser to be a straight line and a curved line at the same time?
How do I need that?
Well, is the laser pointed at the drone a straight line?
I mean, it's the beam of the laser.
So what, you're saying yes?
Yeah, I don't really follow what you're asking.
Well, I'll think about it and re-ask you in a moment. But
Okay, so I had a question on the table.
Yeah.
What does the flat Earth predict? The plumb lines would converge towards each other, or diverge away from each other, or they would be parallel with the raw data after adjusting for the confounding variables like refraction.
why don't
And
you
what
just
does the
why
globe
don't you
predict?
just
So
get a plumb? Why don't you just get a plumb line out in reality and see what it does for yourself?
yeah, they diverge away from each other, though. That's the thing.
You have
And which
measurement
is
of
what a
that?
globe predicts, which is why it's not
Yes,
begging the
that's what.
question. It's
Okay,
not begging
let's
the
see that
question to
measurement.
apply. Well, you need to apply spherical geometry to get them to become
Okay,
parallel
circular
to each other.
reasoning.
No.
What table are we talking about?
Incorrect.
We were talking about
Okay,
an
let's see
experiment.
diverging plumb lines then.
If you take a measurement, the horizon in one direction, and then another angle, those lines, the vertical lines, would be parallel to each other on a flat plane. And why are they not? Why do you need to apply the actual physical geometry to it to get them to be parallel? Well, because the Earth's a globe.
It's a debate, Daddy. Yes. So the kind of recurring theme is that no one has measured the surface, and that's what I'm trying to address with the experiment is measuring across the surface. I'm not sure where you're coming from.
There's literally there's like a U.S. archive of surveying. Like they
those are
have measured
surveys
it.
across.
They measure it
right?
every day.
So debate, Daddy. I'm a glober as well. I am trying to ask you that's not a physical measurement or any type of measurement. So that's the recurring theme that you'll continue to battle against as we try as globers, if we continue to try to say point to point viewing angles or measurements that are not physically touching the ground or physically interacting with the ground, we'll keep getting pushback on that because it doesn't say anything about an actual physical measurement.
They say they measure it with lasers, right? So it's not the case that we have a ruler we need to have a ruler on the ground, and physically measure it with a physical ruler or something.
Yeah,
they're going to accept
that would be
theodolites,
your and I's
presumably,
view.
right?
So that would be our collected view, right? But that's
No,
not the collected
flat
view of
earthers accept lasers and theodolites. They accept these things. It's just
not as measurements of the curvature of the globe, though, because they're not making that statement.
They
So
they use lasers to show that they've measured it flat.
No, we're testing your claim.
Yeah,
that the Earth is a globe. We already experienced the Earth is flat. You do too, right? But you guys claim it's a globe, so we're just testing that. And when we test it, there's no sign of the globe characteristics that would have to be there.
Yeah, so when they're doing the laser experiments from point to point, or even if you're using two survey instruments or whatever it would be, what they're seeing is they're not seeing the horizon at the set point that we're saying and then we have to continue to inject our other pieces of data like refraction and other things into the conversation, which continue to push further away from what's directly observable by the person standing on the ground or the person standing on the hill. Or what I'm trying to do with my experiment is remove that variable of the conversation as many ways as possible. It's hard to do, but trying to find a way so that these conversations may not come to a resolution, but at least maybe it's something we both agree that an experiment occurred that it handled that variable.
Yeah, just use reciprocal zenith angles. That's how you can for the most part can.
But again, you're asking me
eliminate
to measure
the effective refraction.
Those are point-to-point measurements. They're not measurements across the ground. They'll continue to deny that, rightly so, because they're not observing that.
Yeah, here's the big question, right? Just to give Didi an idea of what we're talking about. Let's walk through it, right? So Didi, what would reciprocal zenith angle tests demonstrate? Walk us through that.
It would demonstrate that the plumb lines diverge away from each other, and you need globe math to align them in parallel.
Okay, how?
You take two measurements towards each other simultaneously, which is through the exact same path of light. And so if one side sees, due to refraction, there's refraction is affecting it to a certain degree, it's going to affect the other one the same degree. So when you add the angles up and divide by 2, they cancel out for the most part.
Perfect. So how do we know how much refraction is actually affecting it?
You don't need to. They cancel that number. You don't need to know that. That's the benefit of that approach.
What does that even mean, dude? Here's the problem, right? If I'm on a flat plane, right, and I got two theodolites, okay, and I set them up and they point to each other, and I look at the angle reading on both of them, they both read 90 degrees. Great, okay. Then I have a curved surface, and I did the same thing. They're both pointing at each other, but it's wrapped around a ball. But due to refraction, the light is bending so much so that both theodolites read 90 degrees, like as if the other theodolite is straight in front of them, right? Both outcomes are the same, except for now we have this magical refraction thing. So how do we actually know how much is actually there? Because we need to know, otherwise we can't tell as if whether or not we're actually on a flat surface or a curved surface, right? In one case, there would be zero refraction. The other case, it would be extreme, right? But unless we know how much there actually is, we couldn't tell the difference. Follow?
You don't need that with reciprocals and angles. You don't need you otherwise would need to calculate this. With reciprocals and angles, you don't need to calculate it. You're ruling it out.
Yeah, okay. How do you maybe explain to me, how do you differentiate between either of the two results? Either we're on a flat plane and both of them are the same angle towards each other and there's zero refraction, versus a curved surface and there's extreme refraction and they're both angled towards each other and they both see each other, right? The same angle. How does anyone tell the difference between the two?
How do we rule out what is geometry versus
No,
refraction?
how do we tell the difference between either of these two scenarios? Right, because the results in the end would be the same, right?
I'm not sorry. I don't understand the question. I tried to clarify, but your clarification didn't help.
Do you mind if I jump in and do a ELI 5 or something on this?
I don't know what that is, but give it a shot.
Explain it like I'm 5, fifth grader, whatever. So, debate daddy, if I was at 2 different points on Earth and I have a plum in my hand and I look down at it and I see, okay, that points to the ground, and then I go to another point and I look at the plumb bob and it still points to the ground, how has that shown me anything? That it's not the full question. That is the question that is, greatly simplified.
So imagine you and your friend are both, like, one of you standing on different parts or like different hills, and you shine a laser pointer at each other. In perfect conditions, the laser would shine perfectly straight, but it's probably going to curve a little bit due to refraction, right? So when you aim a laser at your friend and they aim it at you simultaneously, it looks like your friend's standing a little bit higher than they actually are because the light's bending. Your friend has the same problem, right? When they look at you, the air bends in a way that makes you higher than you actually are to them, because you're both looking through the same light at the same time. So let's say that you think that they're too high by, like, let's say 2 inches, and then they think you're too high by, say, 2 inches. And when you add it up, you add the exact same mistake in opposite directions, and the math cancels out. Does that make sense? So in a sense, you don't need to know what the number is, but you do know that it mathematically is eliminated.
Okay, perfect. So now the question is, how do we decompose the error or the difference, right, between how much the light is actually bending versus the ground actually curving? What do we do to parse that
use
out?
radio as a reference. You can use the radio or any other electromagnetic wave.
Brody, after your last innings in here, right, you stay on mute, bro.
My God. Who the fuck asked that guy, man? Go ahead, Didi. How do you tell the difference? How much of that error is caused by the light bending versus the ground curving?
I would have to look into the answer to that question. I don't have that on the top of my head.
That's good. Your non-response speaks volumes.
Yeah,
it doesn't mean that there isn't. It doesn't mean that there isn't a response. It's that I just don't have it on the top of my head for you.
Yeah.
Okay. Well, why the hell are you talking about it?
I can give you a hint, right? So the way that it has been done all along, at least insofar as I've been aware, right, is that there's already a presumed ground curvature rate, right? Factor that in, and then whatever difference still emerges from the calculation, it's presumed that the light is bending at that amount. So then they just plug in a certain K value that corresponds to that difference. Okay. This is the problem, right? The K is not actually computed using the actual data points, right? Insofar as what the temperature, humidity, and air pressure gradients are, right? It's kind of just the remainder of whatever calculation is performed. Okay, it's assumed equally as much as the ground being curved. So what Shane has been bringing up, right, after some back and forth, we're like, okay, well, let's decompose the actual K. Let's try and actually measure the constituent parts and derive a real world K value from those data points. And that's when you jumped in. You're like, oh, just use the reciprocal zenith angle. So you missed half the conversation, dude.
I'm pretty sure you can use the shape of the ground as an unknown variable and the refraction as another unknown variable and solve for both. I don't think you have to assume.
In this case, what we're actually just trying to dig into is the K, right? And then from that, you would actually be able to infer the other one, right? Not solve for both at the same time. There's no need to. You find K.
I think you would need to know.
Okay, it would be bending this much. It would bend this much over X distance, right? And then you plot it out and you see where the beam would actually end up over a certain distance. And there you go. So if it goes down by so much, oh, well, the ground would have to be curving by so much to compensate for it so that the receiver receives it at a certain elevation. Follow?
Yeah, I'm just. It might be true you don't need to know the exact, well, like X to it and for Y. Like you can just solve for Y, but.
Well, here's the problem, right? We don't have a model that can really do that. At least I don't. If you can find one, maybe it can be considered. But at this point, it's already difficult enough to find something that can actually compute K using the constituent parts alone, right? So, it's difficult enough as is, dude. But the good news is Shane says he's going to do it, right? So you do it. Go for it.
Sorry, I got distracted over here. Was there something new that I was doing, or still
No,
the same thing?
Same thing, but Didi was proposing, hey, why don't you just compute the K and the nature of the ground at the same time? Like, nah, dude, you don't need that.
That makes it
you
too
can
easy
use
to
one
follow
to,
an argument.
well, kind of, yeah. We just need a raw K, dude. Right? So here, he came in thinking you can save the day with reciprocal zenith angles. It's like, nah, gee. I think we've heard it about 100 times already.
Yeah.
It's got something novel, so I appreciate that.
I'm targeting this for like the September, October time period when I would be over water or be near water. That I think I might work for this. So I've got some time to kind of continue. What's that?
Yeah, what time did you say you were going to do it?
Probably late September, early. Sorry, I did say that wrong. Late September, early October. I should be at a place where I would be able to do this physically.
Oh, okay. Cool.
And once I have that location, there's no reason for me to keep it secret or anything like that. I'll try to make sure I share that. And I mean, the hope would be that there's at least two observers. Myself, I have a view, right? And a person with an opposing view, and we can confirm with each other that is the is there any tomfoolery going on, or anything else? We can record it as well, but it's going to be a long experiment. So cutting it and taking things out of context can cause issues. So it'd probably be better just to have two observers who are able to give their own points. At least two.
What up?
Hello, are you a sphere enjoyer?
I do enjoy spheres, yes, actually. I especially enjoy reciprocal penis angles.
That's sus.
I also enjoy all the space news about Uranus.
Why don't I have text perms?
You can't post in the chat.
Who you is?
I'm lone wolf.
Are you new?
No.
So you had text perms before and now you don't?
Yeah.
Maybe someone hushed you in a chat.
Yeah, I was just asking this guy that's a moderator in here if he had an argument for his position, and then I didn't have text perms anymore.
And it's Rich Evans, you lying sack of crap.
What did I lie about? I said I'm not new.
No, you said you're lone wolf.
Yeah.
Why didn't you just say
I don't.
Evans?
I am a lone
Nobody
wolf.
knows
What are you
you.
on about?
Hey, bro, nobody knows you by your secret clan name for Modern Warfare 2, okay?
How can you say I'm lying about being a lone wolf? I don't have any affiliation.
No, I didn't.
Group.
Dude, I'm just kidding you, bro. Come on. Do they have jokes in your culture?
The jokes in my culture are usually funny.
Oh, roasted.
Oh!
Damn, he got you there.
I mean, the only reason I could think that text perms would be denied is if I'm saying things that you don't want people to hear.
Well, no, maybe they're just bored of listening to you talk to them. You ever think of that?
So nothing's compelling them to respond to me.
Okay, exactly.
Exactly. So
Maybe
maybe
they just have
things,
maybe they
and
just
they don't
have
have to
listen,
respond
maybe
to it.
right. So maybe they just have poor self control, and so they can't
Don't
resist
doubt that.
responding to you because you're irresistibly handsome, obviously. And so, in order to stop themselves from engaging, they have to practice Odyssean self control by muting you. There you go.
Well, if that's the reasoning, I can't say they're wrong.
That's right. The reason
that
is
I'm just
obviously
so
you're a handsome guy.
I'm too irresistible to speak to. And when you have
Well,
a room that's trying to be perpetuating this flat Earth, and you have just such a handsome glober, it could sway people.
Correct.
So.
Yeah, don't forget that it's also Pride Month, so they might be insecure.
Why? Like they're straight?
Well, they won't be if they keep talking to you, brother.
What about what I would say would turn them gay? Are you saying I'm just so attractive I turn straight people gay? Are you sure you want to continue this conversation?
That's why you're banned all the time. That's why we have to ban you all the time.
You're talking to me right now, buddy. You're talking to me right now. You know what's going to happen by your own logic.
No, the thing is dude, see the way it works is if you refract it just right, you go all the way through gay and then come all the way right back around to straight.
Yeah.
How does that work?
That's the Glovers. That's what they think.
Well, no, AI Overlord. I don't know if you know him. He's a not Glover, and he's making a claim that you can do so much gay shit that you become straight again. So I'd like that explained to me.
Nobody ever said that. Nobody ever said that either. Dude.
You said you go so far on the spectrum, on the gay spectrum, right? And then you
Right,
loop
right.
around to being straight again.
So have you ever heard of celibate? Have you ever heard of celibacy?
I have.
Right. So would you agree that all forms of, let's just call it sexual orientations, for lack of a better term, could be celibate?
Absolutely.
Right. So as usual, Glover gets wrecked on logic.
But that doesn't make that someone who is all the way on the spectrum towards gay come around to being straight again. Stating that someone can be celibate doesn't
But you said no.
change
But
their
you said that
orientation.
somebody who does all kinds of gay stuff. Do you see the difference?
That's what I thought you meant by moving along the gay spectrum. I thought
Well, I know that's what you
in
thought
order
because
to
you were
land
imagining the stuff
in order
between
to
you and me.
land
That's the problem.
somewhere on the gay spectrum, there has to be some form of attraction or want to do things with a person of the same sex, right? And you're saying that someone can have an attraction or a want to do stuff with the same sex so much so they can go all the way over that they come back around, and that doesn't make sense to me.
Dude, it's kind of like a black hole. The attraction is so intense that once you get to the center, you come out the other side.
I don't know that anything does come out of a black hole.
Well, dude, how could you? Because pretty much everything they talk about black holes is fantasy. So just make it up, dude.
I mean, it's a cute red herring.
Then
Like
how the
you're
hell
saying,
does a
your
watch go backwards in
explanation,
a black hole if it doesn't come out the other side, Richie?
what AI just said was pretty funny because he went to an explanation of a thing he doesn't think actually exists or works in the way as described for the explanation as to why he thinks someone could get so far on the spectrum towards the gay side that they would pop out on the straight side.
Right, right. And well,
Which is quite funny.
you're mistaking the point that you're criticizing me for something that would be unrealistic, and so I'm just giving you an example of something else
Well,
unrealistic.
correct me if I
Because we're
did you
just
not
talking.
say that someone could go so far gay that they would come out straight?
No, I said they have to be refracted.
Yeah, that's the reason.
That's the key part you left out,
It
brother.
seems like there's a category error here.
You'd have to go through a lot of black holes too to get
Refraction
that
is the
straight.
bending
Anyways,
of light through a medium.
Refraction is the bending of light. How do you bend light? Is light like a piece of metal where you heat it up and then you turn it into a circle?
See, I'd post a very good link to an explanation of what refraction is and how it bends light, but
Yeah,
I don't have text chat terms.
Well, listen, I would agree with you that if you had a straight angle piece of metal, you could call it a bend. So, for example, I have a machine that's called a brake that bends metal into all kinds of shapes, and you could have it bent to a straight angle. It doesn't have to be curved.
You're saying that it wouldn't be curved at all?
Well, listen, there'd be a microscopic curve on the crease. Sure, I'd agree with that.
Oh,
because
okay,
the
so you're
the
saying
interior diameter.
You're saying the thing that you have bent at 90 degrees is a little bit curved.
No, just the where the two pieces of metal meet would have to be curved if you bend it because you're creating a radius, and the interior is going to be smaller than the exterior.
Yeah, that agreed. You said no, and then you agreed with what I said.
No, I was disagreeing with something else, but we got there in the end.
All I had said was you have a thing that's bent to 90 degrees, and it's a little bit curved.
Right. So if you get bent,
yeah, great, awesome.
If you get bent, no matter how straight you are, you're still a little bit curved.
Well, your inclusion of the sexual orientation.
Rich. Now that we've established
it doesn't
that
really
you're
work
gay,
because
let's
it's
move
more
on.
so like it's like phraseology. No one actually thinks that a person that's homosexual is not like it's not like if you are perfectly straight standing up that you couldn't be a homosexual, correct?
Now we're getting somewhere. Just because things are straight doesn't mean they're gay.
That is a way that you could ask my question. That is correct. Yeah.
That's right. So just because things are level doesn't mean they're curved.
Well, level is that which conforms to the equal elevation above the curved earth.
No. That would be level in regards to a curved earth if a curved earth exists, but that's not all what level means. Level means many things. It's kind of like on a spectrum. You might say it's a gender spectrum.
Why would we? That doesn't really make sense because gender is something that you identify as. And
Hey,
This
Rich.
is hilarious.
Well, that's how you're
Rich.
identifying it.
Hey,
Well,
Rich.
Your globe Earth identifies as flat, so I mean I don't know what to tell you. Go ahead, friend.
No, the globe identifies as
Not you.
nothing.
I said
it's
go
not an
ahead,
entity.
friend. Listen, I said go ahead, friend. You're not my friend.
Hey,
You're clearly lovers. So let the friend
Richie,
go.
You're not
Richie,
my
I got
friend,
to.
buddy.
Hey, Richie, you're not my pal. Rich.
You're not on good internet.
Okay, I'm driving. Can you hear me now?
Yep.
Okay, if you have two concentric circles,
Okay.
following,
Yep.
are the lines that make up those individual circles level?
Are the lines that make up those are like as level? Is what? That's an interesting question.
It's just that when you lay down a bunch of bullshit, it's not interesting. Just be prepared to be called on it. So go ahead and answer.
I'm not saying. Yeah, no, I'm thinking about it. Can I not have a
Why
moment
is
to
it
think
so
about
interesting?
Because it's something I hadn't thought of before.
Okay. In the meantime, why is it so interesting of a question?
Because trying to level
It should
as a
be
concept
simple for you. It should be simple.
not
You're the one
really.
that just told us that
Level is a
You're the one
concept.
that, dude. You
I'm
just
trying to
said that a ball surface. You just said that a ball surface is level.
Equal elevation above the surface of a spheroid would be level.
Okay, yeah, we have concentric circles.
Yeah, levels and orientation within
Are
3D
the
space,
lines
is it
of
not?
those individual circles level?
Level is an orientation of in 3D, is it not?
Lucky for you.
Your mic is kind of cutting out, but he wants a yes or no answer. Are they level or not?
And I'm saying that in order for us to ascertain level, we're talking about creating a line of equal elevation. Sure, you know what? I will say it.
That's why we have concentric circles.
Yeah,
Yeah,
sure.
yes.
They are
You've
level.
lost your mind.
Yes.
Why?
Because the circle is formed by a curved line.
Yes, and a level line around a globe is a curved
So
line.
so hold on. The lines are only level when that wasn't. So they're only level when considering them as concentric circles. I asked you about an individual, each one of those concentric circles. The line.
Well, no,
the line
level
of
is
the
only
circle,
ever
is it level?
talking. Yeah, level is only ever talking about the orientation of something relative to another thing. Nothing is level simplicator
Okay,
in
so are
terms
those?
of it
So are
being
the
not
lines?
related to
Okay,
another
so are the
object.
lines flat? Are the lines flat?
It would depend on how you're using flat because
they're circles.
Circles are within 2D geometry, right?
Yeah,
and
we have
2D
yeah.
geometry exists on a plane, right? Euclidean plane. So that would necessarily be 2D, and some people
So
would take
anything
2D to
drawn
mean flat.
anything drawn on a piece of paper is a straight line.
That doesn't follow from what I've said.
Yeah, it kind of does.
No, it doesn't. You can elucidate the logic if you want to try.
Okay, so if you draw a circle on a flat piece of paper, is that line flat?
Is that line flat? No.
Love it when you repeat it.
the line itself is not a flat straight line, it's a circle. It's within flat 2D geometry, though. That's why I asked what you meant by flat. Because it can be interpreted as flat, as being within 2D geometry, and it can be seen as not, because it's not a straight line. Do you understand?
Well, I hear you.
I didn't ask if you heard me. I asked if you understood.
Rich, thankfully, I'll never understand you. Thank God.
Why would you be thankful that you don't understand someone?
It's you I'm not understanding. That's why.
Well, if anyone does understand the words coming out of my mouth in this room, if you could kindly ask old Hush why he would be better off not understanding what someone says in a conversation with them than understanding what the person is saying
Well,
to them,
because here's the
that
thing. You
would be
said it
great.
both. You said both things. All I asked was that I eventually had to ask you if a circle is a straight line. If you have a sheet of paper and you draw squiggly marks on the paper, have you drawn a straight line? Can it be interpreted that that's a straight line? Is that
Absolutely.
what I'm supposed to
Absolutely.
understand?
It could be interpreted as a straight line.
Okay.
What?
No, thank you.
That's
Yeah.
No,
silly.
thank
Yeah,
you, Rich. I pass.
that's silly.
Well, Zodiac, you seem more interested in actually having a conversation because you're not just dismissing it. Let's say, right, I have a piece of paper and I have a pen. The pen is extremely reliable at dispensing ink, such as that when I drag it across the piece of paper, it always leaves the exact amount of the exact same amount of ink along my stroke. If I were to do wavy, crazy lines from left to right, right? You're with me, Zodiac?
Yeah.
Okay, so if I'm doing wacky waving lines, right?
So not
And then I
straight
take
lines.
the piece of, and then I take the piece of paper and I hold it so that it's at eye level with me, and all I can see is the ink at an equal height along the page. Would that not look like a straight line?
I see what you did there. But
Would
you
that
can't even
could that
see the
be
full.
interpreted as a
You
straight
can't.
line?
Oh, I see what you mean. Because you're hiding the.
The
If
motion,
you're hiding if you're hiding the lines that are in the back, then yeah.
Okay, so
Right.
you agree with me, and I
Right.
appreciate you because
You're hiding.
it does follow that if the ink is all at the same height as you do the squiggles along the paper, and then you view the paper flat at eye level, you would just see the difference of the ink
No,
and the
dude.
paper,
No.
and that would
No.
appear as a straight,
He's hiding.
consistent
You're
line.
You're not even seeing the full line though. That
No,
doesn't count.
all I'm trying to show is that from a perspective, it would appear as a straight line.
From a perspective that hides part of the line, yeah.
No, depending on how
It could
heavily
be
the
a
ink was
perspective that
applied,
hides whatever, right? It's still a
you
perspective
would
that
have
shows a flat line.
if you're going to be microscopically measuring the inks rays off the paper, you're going to have topography.
You didn't hear the hypothetical. I know Zodiac heard it, right?
Yeah,
Zodiac,
I know.
what did I say
I heard it too.
to
It's silly.
preemptively
It's
combat that critique? What did I say
Well,
to
if
preemptively
you're
combat
looking,
that critique?
okay, if you're looking at the
I
edge
asked
of the
Zodiac a
paper,
question.
no, dude, if you're looking at the edge of the paper, if your eye line is with the edge of the paper and you're claiming to see ink, that would be ink raised above the height of the paper.
Correct.
I don't even. Yeah, you might not even be able to see the line. Actually, you might just see the edge of the paper.
It doesn't matter, dude. It's a hypothetical. It's a given because he told you can see it.
Okay,
Yeah.
is the line all the same weight, or is some of the line more heavily drawn than others? Because
I'll
you're gonna
I'll
when you
ask
if you're
Zodiark
the last
again
time
to
I
state
yeah
what I
yeah
said
every
in the
no dude
what I said in the hypothetical.
This is silly,
Zodiarc, come
bro.
on.
Holy
No,
crap.
I know, but
no
I
hold
need
on
you
let
You're
me
to
hiding
put
the
it
show
into
your
line.
this.
good
You're
faith. No,
literally
but
hiding the line.
Zodiarc, you gotta show me your good faith. What did I say in my hypothetical that
When you
combats this
write
critique? You
write
can do
on
it. Come on.
paper
He's.
when you write on paper you
Go
make
ahead.
a depression in the paper.
I don't want to defend this hypothetical because it's so silly. I'm not defending
Oh,
Yeah,
this.
come
but he
on,
said
man.
that the paper is made of a non-compressible fiber.
Okay, well then you're going to have topography within the ink. If he's saying that the ink is raising above this non-compressible paper and seeing it from the edge, he has raised ink.
Yes.
Yeah,
Right, but he
that's
said that
crazy.
he said the surface of the ink would be uniform. So he's imagining an ideal piece of paper that doesn't depress, doesn't have any depressions in the fiber. So every fiber is equal height. Or maybe the paper is made out of God's toilet paper, which is truly
Yeah,
unidimensional.
okay, well
Yeah, I prefer that.
God's toilet paper is flat. God's toilet paper is flat. The line that he's drawn upon it is not.
From the
That's
perspective of looking
so
at the sheet
The
of
silly.
line
God's toilet paper with the consistent, thick ink that comes from my pen,
it would
it
have
would
to be a straight
appear
line. It
as a
would have to
straight
be a
line.
straight line you're drawing because if the line goes away to and fro your point of view, it's going to be like mountains in the distance.
Oh
That would
yeah,
depend
true.
on
Yeah, but
your distance
he's
from
saying
it.
you're looking at it. Listen, you're looking at it orthographically, so you have idealized resolution.
So now he's going to be
Okay.
So
dealing
it's
with
not straight
perspective
then.
of the inks. Yeah, he's
No, there's no perspective. No, orthographic projections don't have perspective. That's part of the unique fact about orthography.
but
There
he's
are
got
no
ink.
perspective.
But what about the ink
Yeah,
on top of
thanks.
the
Thank
paper?
you for that, AI. I actually didn't know that. That's interesting.
And an orthographic projection, there's only really x and y axis, and so any variation in the y, if they're at an equal elevation, let's just say 1 across the x-axis, it would just be a straight line.
Okay,
It
so
couldn't be
but if
otherwise.
okay, that's fine. But if he's drawn a circle, he's going to see an arc of that circle from his perspective. Because if there's no perspective, he's
Oh,
not
you
going to be able to
can't.
see behind that line.
Okay, Haas.
Yeah, but it
So
wouldn't
he's
be
hiding
arc.
the line,
Let's
then it looks
let's
straight.
let's let's take this to the most
The most he's going to see is
fundamental.
half a circle.
Let's take
Listen,
this to the
listen.
most
No, let me help you out,
fundamental.
Rich.
No, no,
Rich,
no.
Rich.
If I can
Stop.
have one go
Rich.
at it.
No,
Oh,
no,
for fuck's
no,
sake!
no,
Can I
no.
get text
Wait,
perms
listen.
back then?
Listen, in an orthographic projection, okay, the z-axis and the y-axis are compounded. So if you have a z-axis variable, right, that's a variable, but it's only plotted at a y-axis value of 1. The only way you could graph that or demonstrate that is a straight line across the paper. There's no other way. It's going to be a straight line, nothing else. It cannot be
Yeah,
anything else.
but it's not going to be the entirety of the shape, the circle he drew.
That's fair, but he's not using a what it is. He's using what it looks like to you from your viewpoint, and those are two different things. Except if you're a glober, and then if you can't see the bottom of the boat, that means you're looking at the curve of the Earth all of a sudden.
Well, now he's
All right. So, old Haas, I want to take this to the most
so
fundamental
what
place
would
we can take
what?
it, which would be the actual geometry that
So
underlies all
hold
of
on
it.
a second though.
No. I
So
need to take this to the most fundamental that we can, which is the realm of mathematics upon which it is based. Within Euclidean space, I draw a circle, right? We then rotate the Euclidean space 90 degrees, right? To, let's say, to the right. What do you see?
I don't know, the squiggly line or a circle.
So the circle that you put in Euclidean space relative to you is rotating 90 degrees, so that the left side of the circle is directly facing you and the right side of the circle is facing away from you. What do you see?
Well, I would see the same. There would be no difference if we're playing this game in how a straight line or a circle, what I would see.
No,
But now,
if you
but
take
I'm
a
not asking what
circle
I would see.
within,
But now you're left with, you don't even know. Would you be able to tell the difference between a straight line and a circle?
I bet $100 that Matthew Learns will back me up on this. Okay, you have this circle in Euclidean space. You rotate it 90 degrees so that the left side is facing you and the right side is facing away from you, and you will see a line. It will appear to you as a straight line. Matthew, can you back me up on that?
Yeah, just hold a hula hoop up to eye level. It looks like a line.
Thank you.
So basically, if you hide all the curves, then it looks straight. Is basically what you're saying.
Yes.
Oh, yeah, this is a long-winded
you
way.
saying that, Zodiac, what you're conceding is that something can have curve and you not see it.
If you hide all
Right.
of the curve.
Hey, Zodiac. This is a long-winded way. Hold on, brother.
Since it's sufficient for the
Holy
thing
crap,
still to
dude.
be curved, but
Rich.
you don't see it. Exactly.
So silly.
All right, Zodiac. This is a long-winded way of saying appearances can be deceiving. No, duh.
Yeah, true.
All right, let's put Rich back on.
Yeah, so I think we all actually agree on this. When you look at the circle in Euclidean space from the side, you're going to see a straight line, just as Matthew pointed out. If you took a hula hoop and held it up level to your eyes, you would just see a line. You can call that some kind of malicious hiding of the curve, but all it's really pointing out, all it's really pointing out is that there can be curve present.
Hey, Rich,
and based on your perspective, you cannot.
Let me give you a hint. Rich, let me give you a hint. Fighting with the mic with me is not a good way to get your text perms back. All right, so let's agree.
How do I do that again?
Let's agree that if all the information is coming at the same angle, right? So the same drop angle and the same distance, it's going to come and appear like a straight line, right? Let's agree with that.
I don't really understand what you're getting at.
Okay, if you turn something orthographically, right, and you imagine that you're the observer relative to that location, the quote unquote light information would be coming all at the same angle, right? So it'd be at a zero elevate. Well, we called it 1 earlier, so let's keep it at 1. So it's at 1 across the entire field of your view, right?
Well, I mean, not necessarily. You could hold the hula hoop vertical, and you would get the same.
No, I don't care about the hula hoop, dude. We're talking about the orthographic line that we had earlier.
But the same thing is true of something being curved but being vertical, and you see a vertical line as opposed to a horizontal line.
Yes, true, but that's irrelevant, dude. Unless you're going to then rotate.
It's not irrelevant when you bring up the angle. It's not irrelevant when you bring up. It's not irrelevant when you're bringing up the angle.
Let me explain it to you, dude. Unless you're going to rotate the hoop away from the 90-degree orthography, if you rotate it around the center or the origin, you could put it diagonal. It's still going to be a straight line. You could put it in an infinite number of degrees rotating it, but unless you rotate it contrary to the orthography, you're not going to see any curve. Correct?
I'm with you there. But the reason I brought it up was because you were talking about the angle, like of which it deviates horizontal or vertically, right? Like if it's flat in front of you horizontally, then there would not be a change in angle. But if it was flipped vertically, then you would have a difference of angle on that.
Okay, but it'd still be a straight line, dude.
Yes, I agree.
So we're talking about the horizontal example. Take your vertical example, stick it in the trash, then take the trash, dump it in the toilet, and then go to the southern hemisphere and see if it circles counterclockwise, okay? And after you've done that, let's move on with the conversation.
It's probably going to take me a while to get to South America.
Well, if you can put a concept in a trash can, good luck, bro.
I thought it was a conceptual the garbage can as well.
Trash can.
So.
Yeah, it's a conceptual trash can. So you can go to the southern hemisphere in a nanosecond in your mind, and then return. So anyway, the moral of that story is
were
that,
you asking me to conceptually go there or physically go there?
dude, we're done talking about it. Move on. So you have this line, right? All
Yep.
points have the same value across the line.
Yeah.
So now let's go to the horizon. So now we're imagining a horizon where it's coming at you at an angle where it's similar to this orthographic projection.
Below eye level.
Now on a ball, it don't matter where you put it. You could put it above. You could make yourself looking down at
Well,
it.
no,
You make yourself
if
looking up at it.
if it's the horizon, then my face would have to be in the sand to have it be at eye level, right? Or in the water, really.
Oh yeah. You're correct. Yeah. I mean, it's physically going to be below you, right? Because the ground's below you, so that's just a fact.
course.
But the approach angle is going to be the same angle. So all points on the surface, if it truly is a circle that you're intersecting on a ball, all points on the surface would be the same altitude and the same distance and the same drop angle, correct?
Yeah. Yeah.
Okay, so if all points have the identical value,
Yeah.
how could it possibly look curved?
Because they're all equal value from the radius. Or of the radius,
Oh
I
my
mean
God,
to say.
Zodiac, did you catch it, Zodiac?
I did not catch it. Sorry.
Yeah, you got to explain it for everybody.
Unfortunately.
He's setting up this orthographic example, Zodiac, to say something that's curved can look straight when looking at it from the side because of these value relationships.
Yeah.
And then we put it to the actual Earth, and then I ask him, and he parses out that all the points on that line that you're looking out at all have the same value.
Well, it's a
360 degrees around you.
It's a curve.
Right, but they
when you're looking at the horizon, it's a curve.
No.
Yeah.
No.
I could post proof in chat if I had text perms, but here we are.
This is the whole point we're trying to get to, dude, is you're saying that if you have this angular relationship to what you're looking at, it's going to look like a straight line and it's going to hide the curves. Now, technically, you're correct.
For an object,
but what I want to know,
it creates a line when you look at it through the orthographic view. It'll look straight. When you're looking at it from front facing, it's a circle. That's all I'm saying. That
nobody
doesn't
would doubt that,
necessarily equate it to when we're looking at the horizon, because when we're looking at the horizon, we're looking at a curved line.
Wait, what? You're looking at a
on,
curved line
on what axis?
Horizon? Wait, what do you mean?
An object in 3D space, right? So it's curving.
No, you said when you're looking at a horizon, you're seeing a curved line. How so?
Yeah.
Left to right?
It's dipping at both sides. Yes.
Okay.
Are you sure about that?
Yes.
Well, that would be a tiny
That
Earth
sounds
claim.
crazy.
Yeah, that's tiny Earth or shit.
Not gonna lie, that's
well, no. The fact that you're looking at a curved line is a different fact than your eye can detect the curve of the line that you're looking at.
Are you seeing it or not, dude?
What you are looking at is a curved line. Whether or not you're able to detect that curve with your bare eyes is a different question.
If you're claiming to see a curved line from left to right while standing at the beach, you're speaking of a tiny Earth.
Yeah, no, I didn't say that you see the curved line. I said that you are looking at a curved line.
You said what you're looking at. Dude, Rich,
what you are looking
at,
at,
bro.
what you are looking at is a curved line.
Stand at the string, hang it from your garage, dude. You've
what
lost
you're
your
looking
mind.
at,
you literally just
what you are looking at,
what we are looking at right now is your complete fucking loss of reality.
What you're looking at is a curved line, is what I said, and
okay,
whether or not your eyes. Whether or not your eyes can detect your curve, detect that curve, is a
are you
different question.
incapable of perceiving the idea that what you look at and what you see can be different ever? Like, are you under the perception that when you just look at something, you're looking at absolute truth? Or is that your perception?
Are you that monster from Pan's Labyrinth who has to hold your eyes?
Why don't you answer
No,
his
I'm talking
question?
to you. I'm not talking to the guy that's saying that you see, and like I agree with that guy. Like you definitely can see a straight line and it be a
But
curved
when you're
line
looking at it,
in many
okay, you
examples
don't
in life,
see it.
right? Like we can.
You don't see it,
You're familiar
but
with
when you
illusion?
look at it,
There's a difference between what you see and what something is, right? There's an objective
yeah,
reality,
but
and then there's when you look
there's
at it,
no
what you
difference
perceive
between
something
what
to
you
be.
see and what you look at. What you look at and what you see are the same thing. That's how
No,
you see.
this
Is
is
to look at
easily
No,
this is
it's not.
easily highlighted through like even the most basic of thinking, right?
If a complete blind person
if you're
looks at me, what
hold
do they
on, let me
see?
I got this. When someone looks out at a field that is very far from them and they see a cutout of a sheep, they could be reasonable to say, "Hey, I see a sheep over there in that field,"
Oh my God.
because their eyes are not sufficient
Okay,
to
so let me get
tell
this. Let me
that
get
it
this
is a
straight. Hold on.
cutout as
Let
opposed
me.
to it
Yeah,
being an
bad
actual
analogy.
sheep. If you were closer to it, you would be able to tell that it actually was a cutout. But from a
Okay, so
far
let me ask you,
distance,
Rich.
someone can look at a
This guy just
cutout of a sheep
keep
and say
rambling.
that it
Hey,
is a
Rich.
sheep.
So, Rich,
That
what
was
you're saying?
maybe 30
hold on,
seconds.
let me ask. Do you have me
Yeah.
muted?
No, you were just trying to cut him off, and he just didn't let you
Okay,
cut.
I have a
He just
question then.
continued to speak.
I just want to clarify.
You were
I
just
just want
very
to clarify.
disrespectfully.
I
Yeah.
want to clarify. When you look at the horizon, what you're looking at is a curved line, but what you see is a flat line?
It seems mostly flat.
Nailed
from our
it.
eyes, yeah.
Okay. So you're dreaming, saying that what you're seeing and what you're looking at, that's describing the same act.
Well, will you
No,
engage with the thought experiment that I provided in terms of seeing a cutout and being justified in
Okay.
thinking that you see a sheep?
Yeah, but that's a bad analogy, dude. That
Why
has
is that a
nothing to
bad
do with
analogy?
It's entirely analogous to the situation of seeing something and not being able to tell certain aspects of it based on your perspective. That's how it's directly analogous.
And maybe there's a dog behind the sheep cutout, and the dog. I mean, dude,
you're not addressing it.
You sound like a 10-year-old, bro. I don't even, like. What do you like? Are you genuinely of the perspective that when you open your eyes and you observe the world, that what you see is an exactly accurate reality to what it is that you're looking at? Like, is that your actual perception in life? Like, have you never experienced an optical illusion ever?
okay. Let me ask you
Like,
this. Let me
why
ask
don't
you
you just
this.
go
Okay,
Google optical
No.
I'm going.
No. You don't
Okay.
get to ask any more questions. You have to address
Okay,
the
dude.
question.
Yeah, address that.
Hold on.
Yeah, address the question I just asked you, and then I'll answer your question.
Yeah, I'm trying to talk about your sheep cutout.
No. I just asked you a very word for word question. Like, can you answer that question? Like,
I didn't hear your word for word question. Ask it again.
you didn't. Okay, so are you of the perception that when you open your eyes
Now
and
you're
observe
just
the world, that what you're
just
Oh
seeing
using
my
is
words
god!
wrong.
What? Do I get to
He's
speak?
fucking
Or?
asks you to reiterate the question and then just talks over you.
Yeah.
Okay, let me ask you a question.
No. Again, I don't. We're trying to get you to answer a question, right? I get that you want to ask a question, but how about you answer the question, and then you're more than free to
Okay.
ask a question. But like, you've been
I'm
asked this
going
question
to.
repetitively, and you have not answered it. So can you answer the question, and then I'm glad to answer whatever question that you have.
Yeah,
he can't even
Can
answer
you
that.
repeat the question?
He can't even answer that.
Have you forgotten the question already? Like, did you? I mean, you didn't hear me
No,
even say the first time. The second time,
I'm
because you just spoke
no.
over me. You claim to have not heard me
No,
the
I'm
first
being
time.
interrupted. But I'm being interrupted by driving directions at the moment. Okay, so I'm at the edge of this field.
Why are you asking a question?
Bro,
Because
there's
I'm
no
trying.
field.
This is
I'm
your
just asking
example.
you a very simple question. We're not even talking about the
Ask
example.
him
We're asking
again.
a very
Ask
simple
him
question
again.
here. Are you of the perception that when you open your eyes and observe the world, that what you're seeing is the objective reality? That when you see something, that's exactly what it is. That there's no possibility of error of what you see. What you see is in fact objective reality. Is that your understanding of the world and your perception?
Well, yeah, but when I go
So
to the
have you
side of a
never seen an
field and see
optical
a
illusion? So wait.
sheep.
Do me a favor. Go on Google, spend the next 5 minutes. Oh, actually, you're driving. You said you're driving. So when you stop, when you're finished and you're safely parked, look up optical illusions, please, because like
Yeah,
I don't
MC Escher.
understand how you could even have the comprehension that what you
Are
see
you
is reality. You don't see
okay?
reality, bro. You see what you don't even
Just
see in your
silly.
eyes. You have some perception that you like see in your eyes. Like seeing is a brain processing procedure. Like it's not just
No,
you
no,
just
no, no.
see objective
You said
reality,
no.
dude.
You
It's
said look.
nonsense, bro.
No,
It's
you
nonsense.
said looking. You said looking at is a
Yeah,
brain
looking.
process procedure, not seeing.
I said seeing.
What?
Seeing is a brain processing procedure, right? Looking at something like
This
if you're
is so.
looking at it, that's just reality. Reality is an
Okay,
objective
let me
reality,
ask you.
unless
Let
you
me
just
ask
don't
you,
believe in
dude.
objective reality. But that's a different question. Maybe you're a
Yeah,
subjective.
if I'm. Yeah, man, you just don't shut up. If I'm at the
Wow.
side of the field and I see the silhouette of a sheep, correct?
Then you have to see a sheep by your lights.
Yep. The only
No,
thing you
I'm
could
seeing
possibly see is
what
the
I'm
sheep.
seeing is the silhouette of a sheep, and what I'm
No,
looking at is
it's a
the silhouette
painted
of a
it's a
sheep.
painted
I have
cutout.
a
It looks like
question.
a sheep.
Okay, so if I
So
walk
it's
up
not just
upon
a
it,
silhouette.
okay, well, that's what a cutout is when seen at distance. So if I walk up to the sheep and
Well,
find
do
out
you
that it's,
change your perspective?
Everything's a
if I
silhouette
walk
at your
up,
distance. That's
yeah,
how pretty much
okay, I'm
reality works.
asking now. Now that I've walked up to the sheep and see that it's not a sheep, it's a silhouette, it's a cutout. Am I both seeing a cutout of a sheep and looking at the cutout of a sheep?
Possibly. Yeah.
Yeah,
Quite
I think that
So it is
follows,
the
but
I
same
think
thing.
that
most
goes
of the time. Yeah.
you're entirely missing the point that we're making, right? We're saying that
Well,
when
I'm
you
not going to make
see
any.
the
I'm not going to
cutout
be.
of a
I'm not.
sheep
Listen,
that's
dude.
not
I'm,
actually a sheep, you think you are seeing a sheep from when you first see it,
no,
but
dude, now
upon
you're
more
worse.
inspection, you are seeing
I mean, I think the
that it
sheep's a
is a
better.
cutout.
Well, dude,
It's
if
the
I'm
example
seeing
for
something
Gettier
not
cases, so that's
moving,
why I'm
Yeah,
using it.
there's
yeah,
just
I'm not
simpler.
making. If I'm not seeing the thing walking around and hearing it from 200 yards away, I'm not going to make any grand announcement that I'm seeing a sheep.
Yeah, that's just why it's a bad example because they can
You're
just do.
the one demanding that I'm going to be making a decision on what I'm looking at / seeing from 200 yards away.
This conversation's hilarious.
You're looking at a curve.
You're missing the entire point of the hypothetical, right? The point of my hypothetical is to say that you look out from
but
where you're standing
your
and you see
hypothetical doesn't work, dude.
from everything that you can tell from that distance, it looks like a sheep, right? So your brain thinks that is a sheep.
Well,
Then
if it's not
upon
moving,
closer
that's a sheep.
inspection,
yeah, it's a bad analogy.
what would be a better?
Because
What do you think would be a better analogy there, Moses?
I mean, just like any optical illusion, like have you never like? There's so many great optical illusions. Like it's just like the idea that you just think that you see. I must be lagging.
Your mic is cutting out, Haas. Your mic is cutting out.
Oh, that's him. I thought it was me for a second. Okay.
Hey, old Haas, when you're far away and you can see a person that looks like they're only about an inch in the distance, and you bring your fingers up and pretend to squish them, are they squished? It's a hard one.
I think he.
mistakenly identifying. Yeah, my mic's. I'm driving through hills.
You're mistakenly identifying what?
He's exactly right. You're mistakenly identifying the horizon as a straight line when, if you had the full perspective, you would call it a curve. Thank you. We all understand.
That's insane.
That sounds crazy, honestly.
No, that's
you can
exactly
walk up
what
to the
old
sheep.
Haas is saying.
Yeah.
No. You're cutting out badly. You're roboting.
Good beatboxing though.
Yeah, you're roboting, by the way, House. Do we have a lot of Globers here today? Seems like a lot more than yesterday.
Well, I am an oblate spheroid earther. I don't know if anyone else wants to raise their
Yeah, I
hand.
wouldn't call myself a Glober for sure. I wouldn't use that slur, but that's just me.
What would you call it? Oh, sorry. So but you believe the Earth is a globe, right?
I believe the Earth is a continuous object that I could walk from A to B anywhere on its surface and still remain on its surface without falling off an edge, and I can continue to walk in one direction for an infinite amount of time, and I will cover a
Wait, why do you believe it's
finite
walk
space.
or
why do you
swim,
believe it's
right?
infinite?
No, I don't believe it's infinite. I believe I'm just saying, like, I could continue to walk in the same direction and I don't fall off the Earth, and I, like, depending on the speed at which I was traveling, would perform.
Oh, you mean you would end up where you
Are you
started?
Jesus? Can
Yeah,
you walk
well,
on water?
it depends on where I was. It depends on where I started one. But yeah.
So you do believe in the globe?
No, not a globe. Not a globe. No.
Do you have
Not
a
an oblate
claim to
spheroid?
Oh, I definitely a blade spheroid would be much closer of a description for sure. Potentially, I would say I leave it up to
Do you have 100%
I don't know
confidence
certainty.
you know what the
I don't
shape
have
is?
No. That's why I wouldn't say specifically what it is.
Okay.
A
So
blade
you're on the
spheroid is
fence.
something close. No. It's something I'm on the fence. It's like it's a level of accuracy. It's like how I wouldn't say I could say with a level of high enough accuracy
So
to
you're like
define
Matthew, basically.
Well,
Matthew's
but you
the
would
same
say
way.
that it's more likely an oblate spheroid than
Oh, it's definitely not
planar
fucking
and
flat, dude. Yeah, it's
Yeah.
definitely not flat.
Right. Okay.
I have an off-topic question. Sorry, I'm just kind of like illiterate with Discord, but why in the side chat do I have a little diamond next to my name?
You have nitro.
If you click on your name, nitro booster.
Oh, that's why. Okay.
Is it purple diamond or is it like a Minecraft diamond?
No, it's like a Minecraft diamond.
Like
it's like a. It looks like a diamond on a ring.
Who answered that? Was that you, Rich, answering that he was a booster?
Yeah.
Were you looking at the diamond, or did you see the diamond?
I clicked his name and it said Nitro Booster with the diamond next to it.
Yeah, but that's the wrong diamond. This is a blue. I'm talking about inside chat next to my name.
Or
There's
were
a
you
blue
looking
diamond.
at it? I know.
Oh, dude,
I'm
this is
asking.
a great example. No, this is a great example. He was looking at it. He didn't see it. What he actually saw was a mix of fucking red, green, and blue fucking pixels at the perfect ratio to trick his eye into thinking that he fucking saw a diamond. So this is such a great example that you asked it like that. Your fucking computer screen is the best example of the fact that you're being lied to, and you're just like, what?
That's a
Come on,
gem,
dude.
not a diamond. But
are you
no,
looking
seriously,
at your
wait,
screen, or do you see it? Your screen.
You're looking at it. You don't see it. No.
You look at your screen.
You see your screen. You see your screen. You don't see the things on your screen.
Yeah, your brain
and you're looking at your
fabricates
screen.
whatever
I
you're looking
see
at,
the
you know?
light coming from my screen, which in the composition of the light coming from the screen.
But you only see it when you're. But you only see it when you're looking at it.
Oh, it's definitely required. Yeah, looking at it is definitely required. Definitely.
This is so.
Yes, you can't see something you're not looking at.
I listen to
Except
him.
for
You
in the
can't
mind's
see
eye,
something
maybe.
you're not looking at.
Wait,
Do you disagree with that? Do you think you can see something you're not looking at?
Okay, wait. So
no, that sounds like you.
Are we still answering my
I just
question,
said
or
the
are you guys
opposite.
just
You said it in a mocking tone. Then I asked if you had an issue with it, and you said you agree with me.
No,
This is the level of flat Earth debate and how anti-globe these people are. They can't agree with a glober on something so simple as
dude,
looking
now you're
and
disagreeing.
seeing.
You're disagreeing with your original statement that seeing something and looking at something are two different things.
Nothing
now one's a
about my
prerequisite.
hypothetical, including you not
God.
looking at the thing.
He literally never did that, dude. You're just making that up out of nowhere. Like,
I heard the sound and I'm listening and hearing the sound. It's like, dude.
I would have to see that.
Well, for the record, sound
so
and
it's on the live stream,
visual
right? We can
process
just go
totally
back and check. I would have to hear him say that. That's crazy.
Wait, one of you is live streaming this?
All right.
Oh yeah, they live stream all of this. They live stream
That's
this
amazing.
24/7.
This all started because he says when you're at the beach, you see a flat horizon, but what you're looking at is a curved horizon. That's how this started.
Right, because there's a difference between objective reality and what you see, right? That statement is just as much true now as it was then from both of our perspectives. Like, no,
Okay, so how do you know the Earth as a ball exists in objective reality?
Here we go.
Well, that's getting into a lot longer of a topic. To remain on the topic that we are currently talking about, if someone is standing 2 feet from you and there's a building 500 feet away, and based on your perspective, that person looks taller than that building, are they taller than the building? Old Haas,
yes or
that's
no?
a question for you.
Come on, Haas.
Well, it depends on if it's the Jolly Green Giant.
Let's say it's not.
There's a 6 foot
Am I
person.
looking at my friend?
There's
Am I
a
looking at my
6 foot
friend?
person.
Or am I seeing my friend?
Your choice
do
to
both.
interpret. You can do either one. Your choice to interpret it how you wish.
You are both looking at and seeing your friend in front of you, who
so it is
appears
the same
to
thing. Got it.
look taller than the building in the distance that you are both looking at and seeing. Is he actually taller than the
Well,
building?
how tall is the building?
25 stories.
Oh.
Okay. How tall is my friend?
6 feet.
Okay. Well, then you know the answer.
The question is he taller than the building? Because from where you're looking at him, he appears to be.
Yeah, but you're telling me that you're seeing him taller than the building, and what you're looking at is he's taller than the building. So it doesn't help
Yes,
your
correct.
argument.
You are both seeing him taller than the building, and what you're looking at is his head being higher than the building in the distance.
He's seeing
right, yeah, exactly. What you see is his light particles are coming in above in relation to those other light particles. That's what you see. What you're looking at is him being taller than the building, because what you're looking at is your field of view, your reference, right? So it's like, but what you're seeing is the position of the light particle.
You're also seeing
Seeing
that.
is the position of the light particle. It's not. There's no. Yeah.
So you're also seeing it. So hold on. What you're looking
seeing
at
something
is
different.
Okay, I got you now.
Yeah.
So what you're looking at is he's taller than the building.
Yeah, I mean, you're looking at him and he appears to be
Okay,
taller.
so according to your previous,
Let's be specific. Let's be specific in regards to the previous statements, right? What you are looking at is your friend of 6 feet height compared to a building at 25 stories in the distance, and what you see is that your friend of 6 feet height is taller than the building at 25 stories. You are looking at a 6 foot person and a 25-story building. From your perspective, the person appears taller than the building. Is the person actually taller than the building?
No.
Perfect. So something can look to be the case while the actual material facts of what they are
Okay,
different.
now you've completely flip-flopped from your original
No, I have
claim.
not.
Because,
No, I have not.
You said that no, dude, yes, you did. Because you said, although you see a flat horizon, what you're looking at is a curved horizon. Now, all of a sudden, you've got it flip-flopped.
No, just as the person appears taller than the building, the horizon appears flat.
Oh, now we have appears, sees, and looks like.
but the horizon in actuality is curved.
Can you
Yeah,
prove
all
that?
fundamentally all
Yes.
we're talking about is the difference between subjective and objective reality, right? Like that's all it's saying, right? Like,
have you seen the horizontal compression images of the horizon there, Zodiac?
No, show me. Let's see it.
I can't. I don't have text chat.
Oh,
firm.
okay.
I just like how do
I'll paste it.
like
DM
what?
it to
Let's
me.
just all go dig a well right now. Let's agree on a design to put in the bottom for measurements. Let's put in the bottom of the well and let's see what the fucking angles of the light are, and let's just see, is it a flat Earth or not? Because I'm gonna tell you right now, it's not gonna be a fucking flat Earth. It's like not that difficult. Like it takes literally
Well,
like
no,
3 small holes
you
in the
did,
sun, and we can prove it. We can literally
no,
prove
you
it.
did,
Oh, you're right. We'd
you
have to
did.
measure the distance in between, so we'll do that. Let's try. Let's pick some people that aren't too far away, so we can make that easier, right?
No,
Pick some people
dude,
that are somewhat
you
close.
already said we see it flat.
See what flat?
The horizon.
All right, I DM'd it to you, Zodiac.
Right. Yeah, we do see it
Okay,
flat,
let me
right?
post
Like,
it. 1 second.
I mean, even a person in the space station, when looking at the Earth, observes the Earth as flat, right? I mean, it's like, I'm not saying it's that you don't see it that way. I've never made that claim at all, right? Like,
So when the space station has their video footage of their camera attached to the outside of their space lab, are you seeing when?
you're not far enough away to observe curvature, no.
So what are we quote unquote looking at then?
What do you mean?
Well, you've not seen the space station views of Earth.
Oh, how it looks somewhat curvatured? Yeah, it's just fisheye
What do you
lenses.
mean?
Right?
What do you mean? Look somewhat curvature. A great
I
sentence
would just say
structure,
fisheye.
by
I
the
would just
way.
say fisheye lenses. That's what I'd say.
Dude,
I mean, they're not far enough away to
laughing.
observe it. You're
Can
only
we
seeing a
talk
small
about?
part, right?
Okay, so the only curvature that we can, the only
jeez.
curvature that we can,
Well, like the Artemis mission, but you guys don't believe in the Artemis mission, right? So
Yeah,
doesn't count.
we'll
well, the
reject anything
astronauts
that
on
goes
the
against your
Artemis,
position, of course.
yeah,
But
the
if we could
astronauts on the
please talk
Artemis at this
about
point don't believe in their mission.
Zodiac asked me for evidence that the horizon is curving, and I provided him this image. Right, this is the MC Tune curvature
Yeah, we're like,
display.
why?
Right, so the beams, the red beams of metal on the table, are straight. When you uncompress this image and you have the full image, I can find that for you if you'd like me to. There, Zodiac.
Holy crap.
Those both the beams and the horizon look straight, but when you compress them horizontally, the curve is more apparent and the straightness of the beams remains.
Yeah, let's see the full one. I'll
Yeah,
paste
yeah,
it.
I'll shoot that over to you. Give me a sec.
I can't believe he's using this one, dude. Embarrassing.
Well, do you know which? Was this like at the beach?
It was pretty high up in elevation, actually. I would have to look into. Oh, that's not the exact image of it.
Was
That's
it
a
like
different
in
image.
Europe
That's just
or
taken of
America?
the table. I'm not exactly sure of the location. I can look it up for you.
No, it's
This
okay. It's
is
okay.
this is the image there.
Yeah.
That the second one was the actual one
Zodiac,
that was compressed.
this is the famous one where they, at first when they started providing this, cropped out the table after they did the compression because they didn't want people to see that the table was also.
The table being bent does not impact the observation whatsoever. The table being bent.
See what he just said,
and
Zodiac? It doesn't matter that when you compress something it looks bent because it's totally straight.
No, because no one is saying that the table is the flat thing being compared against. We're comparing against
Doesn't
the
matter,
red
dude. It's
beam.
demonstrating that there's curvature being added in optically, dude.
No, because the red beams remain straight.
No, they don't.
And they absolutely do.
Nope. Dude, I've seen this picture. Dude, this picture's been being presented. Listen, let me help you out, dude. This picture's been being presented for like the past 8 years. And when it was first being presented, there was a much higher resolution version, right? And you could clearly see Set the alleged flat standard that there also curves in the image, along with the table, etc. That's why they had to edit it constantly and deceptively.
Post the second one there, please, Zodiac.
Well, yeah.
Because the second one is the actual one that was compressed, right? So the metal beams on the table, right? They are bending the table via their weight. The beams themselves remain straight because they have enough tensile strength in order to remain straight upon their own weight. The table being bent does not influence the it's more so just proving the point, right? Because when you look at that second image, the table looks like pretty straight. But when you compress the image, the red beams remain straight. The table, you can see the curve is more accentuated, and the curve of the horizon is also more accentuated.
And it gets more so accentuated when you shoot your horizon shot above and below the center line of the lens. And that is today's task for you, Rich. Grab yourself a camera, go and shoot somewhere with a horizon or even a flat surface. Shoot one below the center line of the lens of the camera, one above the center line of the lens of the camera. Put it in your computer and compress the snot out of it. And watch what
kind
happens.
of lens are you? What kind of lens are you assuming that I'm using?
I'm assuming you even know how to tie your shoelaces in the first place. I don't care.
Oh, this prick's big. I love it.
Do you
dude.
think that
My
that would
favorite
change
person on the
anything if
channel.
I was using a rectilinear lens?
You don't have a rectilinear lens. They're too expensive.
That's not an answer to my question.
Why are you trying to dodge? Because you know
What?
what the
You're
answer is.
accusing me of dodging? You dishonest prick.
Yes.
I just
Yeah,
asked you
you're
a straight up
literally
question.
dodging the question and then accusing him of dodging by like, come on, bro. Like what?
What the reason he wanted a rectilinear lens, Moses, is because rectilinear lenses allegedly account for these kind of problems. So he instantly has to jump to the dodge. That is what that was about. When you take photos,
I go to
anywhere,
the thing that
shut
accounts
up.
for the distortion
When
that
you
you're trying
take
to allege.
photos and you compress them, it exaggerates any issues you have. Now, when you're shooting above the center line and below the center line, the horizon that is, it will compress concave or convex depending upon where your center line is. Now, also a problem when you're using wide angle lenses, things in the foreground will not distort as much as things in the background.
Well, then why does the table distort?
It is an
yet
optical
the red beams do
because
not?
it's in the foreground. Congratulations,
So
you've just learned something.
The table
It's
and the
close.
red beams
Rich,
are nearly
Rich,
the
listen
same
carefully. Rich, you
distance
can
from
do
the
this.
observer.
Rich,
So when you
beams
claim
close,
that the distance
horizon
from
far.
the observer is depending upon,
He's an idiot.
I'm talking about the table.
Yeah, I don't give a shit about the table.
Don't worry, bro. He's just gonna start
The
muting you
table
soon. You
is
say
at
something
the
he disagrees
same-
with too many times.
No,
he'll just mute
yeah,
you.
no,
Don't
for
worry.
sure. No, hey,
Yeah,
this
we're
is
just
not
gonna
my
get
first
that
rodeo.
one and make a
Yeah.
Oh yeah, just prove
He's
his point.
back. He's back.
If he mutes me, I'll just leave.
Oh, he's gonna cry already. Good boy.
When
We're
you're
not talking
like
about the
when you're
table.
such an utter
Your
bitch that you have to
claim,
mute people for
your
disagreeing with you.
claim,
That's the sad part.
your claim is a simple one. The horizon curves. So,
As
where's
demonstrated
the
in this
curved
image.
horizon? You
I
had to
just provided
compress or doctor the image to get that. And what I'm telling you is if you go and take the photo again and you put the horizon above the center line of the lens and you compress it, it will bend the opposite way and you'll have a whole heap of concave earthers in here stroking their egos.
Depends if you use a rectilinear lens or not.
Well, how about this? Use the same lens that was used in the photograph. That will solve all the
Rectilinear.
problems.
So,
how do you know it was a rectilinear?
Entirely
in those images you
bullshit,
provided, Rich, how do you
entirely
know
bullshit
in those images you provided,
representation.
where is the stamp that says it was a rectilinear lens?
This is an entirely bullshit cope
Where is
argument
your
because
claim it
of
was
the
a
fact
rectilinear lens?
That in the second image, you can plainly see that the beams and the table and the horizon are all located at the center of the frame of the image.
They're not at the center.
How would we know? How would we know it's not cropped, dude? But nice try.
I
Go and
don't
do
know how you
basic
could know
photography,
that
Rich.
it's not cropped. From
How
the
can we know
image
it's
that we
not
are
cropped?
provided,
So we've got to prove a
we could
negative.
only say that it's in the center of the frame of the image that we have. That's all we can do. So then when
So
you
you're
compress
hitting and
that
hoping.
image,
That's all you're doing.
when
This is somebody
when you
throwing shit at a wall,
compress
hope it
that
sticks.
image, if what
Why the
Matrix was
necessity to
saying,
compress it?
what
Rich,
if
let's do this one
Matrix,
step at a time.
if
Rich, one step at a time. I know you like talking shit. Why the necessity to compress it?
because it accentuates it and it makes it easier for our eyes.
Excellent. So, do you understand that if the horizon is above the center line of the camera, it will compress one way? And do you understand that if it's below the center line of the camera, it will compress the opposite direction? Do you know that? Yes or no?
Yes, I understand that, and we
Excellent.
know
Now that you understand that, excellent. Now you've answered my question. You've answered the question.
Let me
No,
finish
you
my
don't have to
statement.
explain any
Let me
further.
finish my statement.
You don't have to explain any further. You've answered the question. And he ran away like a good little boy. Fancy that. Why do they still use this AI? Seriously.
Plan, brother, because they're dumb. All right, so everybody look at that. Everybody look at that image again, and then remember the conversation we had previously with Rich, where he said if something at you sideways, it's going to look like a straight line. Now, I told him, what is the horizon on a globe? Isn't it the same distance, the same elevation, and the same drop angle from the observer? Agreed. That means that no point along the horizon has a different information to the observer. It's the same distance, it's the same drop angle, it's the same elevation. Now I want you to look at the image he just posted, the hump that supposedly is the curve of the Earth. Put your finger anywhere on there and tell me, is it higher or further away than any other point on that alleged curve? Higher or further away? Which one? Can't be further away, right? Because the horizon's equidistant. Can't be higher because they're all at the same altitude. So now we got a problem here.
You know what would be really funny? All right, sorry, I don't want to interrupt. Go ahead. I just thought of something really funny.
Zodiac, that's a famous. I mean, you can go look back through our server and our streams, like even up to, and you could see that they were trying to present that with all kinds of crops of it to try to trick people into thinking that these are straight. That image is like one of the most blurry versions.
Is there a
So
way
so we can actually go back. Listen, we can go back to the ones that posted in our server before, and I think you could even find the original, and you could compare the two to see if they deceptively edited, like used some kind of Photoshop. Because I remember seeing this, and when we zoomed in on the bars, there was a curve in the bars as well.
The red things?
Yes.
Everything in the image, when you compress it, pretty much everything.
Yeah. It'd be really funny if they could compress the Black Swan. I wonder what would happen. That would be really funny if they did that. But I don't know. They don't have to. I just thought it would be really funny if they did that.
What was the funny thing you were going to say? Entertain us.
I was going to say, has anyone ever tried to compress the Black Swan image of the horizon? Oh, I guess you can't really see it because it's blocked, the oil rigs.
That was the funny thing. That was the funny thing you were going to say.
I think it was funny, but I mean, because that would be crazy if they're arguing. Because then it's just so silly to me.
Well, he's using slimy language when he says it accentuates the curve. Well, the table that was green that got cropped out, that's flat. So then that becomes curved when compressed. So has the curve been accentuated or created?
I'm going to tell you guys, that was all kinds of things, but it was absolutely not entertaining.
If I just trace the horizon with the uncompressed one, shouldn't I don't know. Like, based on that compressed image, if I just trace the one that's not compressed, the middle of the trace should be higher than the... I would have to take some...
Zodiac, it's just crazy talk, right? This is what he wants you to imagine. He wants you to imagine that's the curve of the Earth, right? Left to right, drop from a Sagittarius. Right there, at that spot. That's the spot. So if I were to set up to the right of that demonstration, the same exact demonstration, right? Just to, maybe 5 feet, but then I'm going to look off. Then he's going to say, but now that's the high point, right? I'm going to see the same thing if I move 5 feet off to the right and I look out, or even 15 degrees to the right of his demonstration. And he's going to say, no, it's dropping left to right, and there's the Sagittarius in that demonstration. And now his Sagittarius is at the same elevation as mine. And everywhere we go, we're going to go do the same demonstration. And they're all going to be at the same elevation, which is going to conclude that there's no drop, there's no curve. Crazy what he's trying to tell you is happening.
Yeah,
do you not see like 7 holes in what you just said out loud? Even if you believe in flat Earth, there was literally 7 holes in what you just said. Genuinely, what do you mean it's going to be at the same elevation? What do you mean by that?
It is the same.
Let me
explain it to you, brother.
That's just nonsense. It's literal nonsense.
Hey, Moses, go to the image that Rich Evans.
No, I'm not. I don't want to get caught up
draw.
in that image. I'm not going to get.
Okay. So you don't actually want to progress. Okay, so you just want to hear yourself.
You guys bullied that kid. You guys let that one guy bully that guy out of here. If you guys wanted to talk to him, you shouldn't have let that guy bully him out of here. Like that was him talking about that.
What are you talking about, dude?
What do you mean? What am I talking about?
Whatever, Moses.
I think you stepped away. No, I think you stepped away actually. But there was, in the meantime, while you were stepped away, there was another guy. I don't remember if it was Jedi or if it was.
One of those guys. Let's say it happened. Who cares? Who cares? That's in the past.
Yeah. Well, I'm just saying,
no,
if you
dude, guys
want
to the bridge.
Time out of here. I'm not going to talk for what he was talking about.
You've got the wrong timeline. He left after he was muted.
Right, that's called bullying somebody out of here. Yeah.
Oh, is it? It's called shutting someone up when they don't stop yapping.
He was very good, and we literally had an hour and a half conversation with a whole bunch
of people. Excellent. If he was very good, Moses. Moses, you're doing the same thing. You're yapping.
This guy that
I'll just bully you too. Shut up. Which part of it was very good, Moses? That's all I want to know. And he can't even answer that. That's interesting.
And he ran away.
Oh, he's back. You made the claim that part of Rich Evans's presentation... What is he doing?
Who cares? I want an answer to my question. And we have to use his image, because that's where the question is relevant to.
Okay, your question, please.
Oh, everybody look at the image. I'm going to do it too, so give me a second. In politics, so I got to go to the channel. Hold on. All right, how's this mic working?
Good.
Oh, the sexy mic.
I'm going to put it directly in front of me too, rather than to the side, so I don't do the waning.
Which image are we looking at? The cropped one or the uncropped one?
I like the one DJ put. It's so embarrassing, dude. The one Rich posted. Well, he didn't post it, so I'll repost the image I want to talk about, okay?
Well, he did post it he sent it to someone to, yeah.
Yep.
Sent it to Zodiac.
I'll repost it. I'll repost it so we know exactly which one I'm talking about. I'm gonna. You know what, guys? Can we just take a moment to all mourn the loss of the remix feature on Discord, which just allowed you to draw directly on an image that somebody else posted and then quickly repost it for illustrative purposes? Thanks, Discord. Oh, by the way, I'll pay $3 a month if you give it
Well,
back.
just screenshot it and edit.
I know, but it just was so much easier native. You know what I mean?
It kind of sounds like you were responsible for them taking it off.
Well, yeah, because I was using the crap out of it, smacking Globers left and right by immediately editing and posting data on their images that showed how they were smoking crack. So they said, "Oh man, this dude's defeating the globe. We better get rid of this whole feature."
Thank you for your service.
Welcome.
You will continue on.
All right, so look at the image that I just posted. Okay, you can all agree that the blue water and the blue sky have two distinct color fields, right? I don't care about the red or anything. I just care about the blue sky, because you don't need to look at the red thing to realize that you have an arc there. And they're claiming that that arc is representative of the curve of the Earth, being the horizon. The horizon, which we already agreed, is a circle around you with the same distance to every point on it and the same drop angle to every point on it. Now, if you put your finger on the left side, put your finger in the middle, then put your finger on the right side, you know the left side is low, the middle is high, and the right side is low in the image, right? So if you put your finger in the center, is that point higher physically than the left side and the right side? Not visually, but physically. Or is it further away? It must be one of the two. It must be higher or further away in order for it to be rendered as curvature in the image. It must be higher or further away, right?
Yeah, it would have to be one of those two.
Okay, so when our friend here earlier said if I stood right next to this guy 1,000 yards down the beach and took the same image, and I had a hump in my image and you have a hump in your image, how can that be the hump of an apex of an arc? And then the other guy said that's silly. But the question remains, how can it be the hump of the apex of an arc when you're both seeing it in different locations? And it's higher in the center of the image. We are already agreed it's the same distance. So the left side of the image, the right side of the image, and the middle of the image are all the exact same distance from you and at the exact same drop angle from you. So how is this rendering as a curve?
Isn't it an artifact of like making a 2D image? That's what I would assume.
I mean, we've talked about it before, and that's plausible, but you didn't validate that with any modeling or experimentation or anything, right? So I would agree with you. That could be a solution, but you'd have to solve that solution for it to be meaningful.
The way to try it out would be to get a hula hoop and put your cell phone camera right in the middle of the hula hoop and then raise it up a little bit and see if you get the same kind of phenomenon when you take a picture.
It depends. That depends, because keep in mind you have the economy of scale when it comes to the angles of approach. Okay, so putting a hula hoop and dropping it a certain amount below your eye line, then trying to scale that to the size of the Earth, and then create an analogous example, you can't do it because you would have to have a camera the size of a city. Look, in principle, there could be something there, Matthew, but it's not solved.
Yeah,
then we just end up back where we started. We end up back where we started, which is appearances can be deceiving, right? So, for example, I was going to challenge Rich since he said, oh, if you use a rectilinear lens, blah, blah, blah. So I was going to ask him, dude, how do rectilinear lenses manage distortion? Because most people think rectilinear lenses are distortion-free. That's not true. There's no distortion-free lens. They just manage the distortion. They manage the distortion in different ways.
Yeah.
No, pinhole cameras are not distortion free because
Really?
light interferes with itself. So they're the closest you're ever going to get. But when you're talking about taking a photograph, you're in a whole different ballgame.
Yeah, all these are photographs, so yeah.
Now keep in mind, and this is just a little history lesson, but it also has to do with globe Earth versus flat Earth arguments from one side to the other and from them replying. At least two famous globe Earth proponents that interact with our spheres, one being Ruhif, and I can't remember if the other was Rumpus, but I think it also started with an R. They basically said that, well, no, if you're looking out across an infinite flat Earth, you're not going to have infinite resolving power. So your ability to resolve the surface and for your line of sight of angles that you can resolve will intersect the surface at a specific distance. And if you rotate yourself 360 degrees, that distance will trace a circle on the surface. And it'll be the same drop angle and the same distance. So likewise on the globe, it'd be the same drop angle and the same distance. So they concluded if the Earth was flat, it would have a curved horizon. So if that's the case, and I don't see any geometric reason why it wouldn't be, then that means that no matter what the shape of the Earth is, if the Earth is beyond the realm of your ability to resolve the whole thing at once, or at least a significant size where you can't see the whole thing, so your available vision sphere is smaller than the whole size, you're going to get a curved horizon no matter what, according to these guys.
I think you might be right about that. That sounds reasonable to me.
So in other words, this curved horizon is proof the Earth is flat.
No, it's just not proof either way, right?
Perhaps.
Well, what do you think about this screenshot in the side chat, Matthew? I'll read it out, actually, right? So this is Catty, globe earther. Right, the horizon cannot curve on a globe. Well, it can't. Look at the horizon. Now turn to the right. Did it drop? Now turn more to the right. Now did it drop? Now continue turning to the right. After turning 360 degrees, what happens? It meets up right where it started. How could it have curved down? Anybody who thinks the horizon on a globe can curve is nuts.
Right.
That's the problem. When you leave a curve in your field of view, the curve rate should continue to the oblique side of your field of view, and then as you're turning more to the right, it shouldn't be there anymore. Which is to our other friend's point, who was saying if I went 1,000 feet down the beach and took the same image, what are you saying? There's two apex of the arc of the curve? And this is what Caddy's saying. Dude, there's not multiple apexes of the arc of the curve. It's one consistent curve. So what in the world could possibly be causing the curvature in the image? Well, flat earthers know what causes it. It's a very simple answer. It's called optical effects. Duh. You have to have a certain distance from a curve and a certain angle of approach from a curve, just like Rich Evans started. He started this whole gambit with, if you had an orthographic side view of a curved line, right, so that the angles of approach and the angles of reception equalize, where you can't resolve any differentiation, it's going to look like a straight line. If that's true, and in these examples, the horizon is equidistant and all of that, then why wouldn't it look like a straight line? Then you take Caddy's example, coupled with our other friend's example, who said he's taking a picture of the apex of the arc. This becomes very weird very quickly. And so when the globers show a low altitude curved horizon, or even a high altitude curved horizon, because I don't know if a lot of globers realize this, but most alleged high altitude curved horizons are actually relatively low altitude compared to the size of the alleged curve. For example, this is me quoting a glober, and the glober I'm going to quote is an astronomy department director at a university who holds lectures and teaches kids, 100% believes the Earth is a globe, 100% believes in the cosmology. But he taught in his lecture to his students that from the height of the ISS, you wouldn't see the Earth curvature. And he showed it. He had a physical ball that he painted blue and white to show the outline. He showed the math on the screen, and he explained to them that this angular relationship doesn't change significantly enough for you to discern curvature of the Earth at the height of the ISS. It's a Glober guy. Now, you could argue he's wrong, maybe, but what counter evidence are you going to provide? Are you going to show me how there's a differential curvature information at the point of the optic if the horizon is equidistant? Matthew's test with the hula hoop seems to be a solution, but the scales are all wrong.
Yeah, it's more of a thinking about the concept of what you would see if you took a picture slightly above the hula hoop.
Yeah, but when it comes to the economy of scale in relationship to an Earth, right? Are you slightly above the Earth at that point versus the hula hoop? Maybe the hula hoop example, you're like 7 times higher than the ISS would be before you see the curve. That wouldn't go well for the Glober. And they'd have to account for the fact that if you were doing it this way, your eye's aperture would be bigger than any optic we've ever created in the history of mankind, times 10. So basically it's saying, well, if you had aliens come and give you a telescope that was 10 times bigger than the biggest telescope we ever made, then you could see the curve from the height of the ISS. Well, anyway, if you guys look in the chat, Degas just proved lasagna Earth. So he went up to China's ISS footage, and it shows a flat horizon, and then he compressed it, and it clearly shows that the horizon goes one direction, then takes a sharp curve upwards, then keeps going, and then curves down again. So it's like a piece of lasagna. Well, that's weird. Guys, anytime a Glober says that a rectilinear lens has no distortion, don't even have a further conversation till they give a citation that they're distortion free from a reputable optical source, not Wikipedia. And then they need to demonstrate the actual distribution of the distortion on a rectilinear lens. And they need to have a citation for it, or they have to drop the claim, or they can never speak here again. Isn't that fair?
Yeah, absolutely. Yeah, it's also true. They have like varying degrees. Well, they have like varying degrees of how well they preserve straight lines and that kind of thing. Even the best ones aren't distortion free. But when I was looking into it, the fact that the horizon is just a big giant circle around the observer, when you go really high up, the rectilinear lens doesn't, it's not trying to preserve a straight line, right? Like a perfectly straight horizon line, because it's just a big circle around the observer. And what it does, it takes the image and it processes it onto a big rectangular onto the rectangular sensor. And according to a bunch of AIs that I put it into, they said you would absolutely expect to see a convex horizon if you're using a rectilinear lens from high altitude.
Interesting.
Yeah, I'll pull it up. I'll grab the.
How many optics have a curved sensor?
None that I know of.
None that I know of.
Sure.
That I know of. There may well be. I've not crossed any.
Oh, Matthew wins. He gets the prize. He gets 10,000 credits in the Flat Earth merch store. Eyeball.
So then can you get because I've made remember the David Hockney photographs where he connected all these photographs and he created all these different, like the Pear Blossom Highway, and then he did other ones. Him and his friends playing Scrabble, where he's got photographs from every point of view of the table.
But I've done a lot of. Once upon a time, I did a lot of photographs of the beach. You know, the horizon using, I guess, a rectilinear lens, like a 50 or 52 millimeter, I think is what it was. Like what they sold on the camera, like on the Canon A1s and AE1s. So if you're always going to get, what I'm saying is, my photographs of the horizon from the beach are, you can take a ruler to them. So what if you got rid of the lens and you just had a pinhole camera from the beach? In the back of your pinhole camera, where your paper was just a box, like flat. Then there's no lens. So what do we get then? It would be, I don't know, it'd be the same.
You'd have an angular field of view being cast on a flat surface, right? So there'd be something going on there, but it probably
Well, you'd have the horizon. You would have the horizon projected on the flat surface, the photographic paper.
Okay, so the back of the box, which is the basically receiver or sensor, I suppose, for lack of better words.
Yeah, it's the film.
That angle that's on relative to what it's imaging will affect the horizon if they then print the photograph and compress it. So if it's angled downwards, so not vertical, so top pointing forward, we'll put the image high. Low, sorry, it's reversed. And if it's leaning backwards, it'll put the image high.
Yeah, you also have to take into
I'm going to
account
say
that
it's completely vertical.
fair enough, but you also have to take into account that light interferes with itself, especially when it's passing through a small hole. Right, so you're going to have diffraction to deal with.
Yep.
And interference. So, but I would like to see a bunch of people do it. Sure. But I would think that if you're low to the ground, right, the horizon should be mostly rendering as a straight line, or coming in towards the camera as a straight line, as much as possible. You'd have to get higher altitude to even have any variance. But like we already said, like you end up with the same distance, the same drop angle until you get a significant distance away. But we may be in luck and somebody has already done this. Completely unrelated to this topic even.
Yeah, I mean, I've got some in a box somewhere.
We could convince that one kid. Remember that one kid who said, I won't accept any evidence unless it's from somebody who just accidentally got the evidence without even thinking about it?
Yeah, I guess that would qualify.
Alrighty, so I just jumped onto a website. He does pinhole cameras, explains how to make them. Ben Peter Post 16 Photography at Weebly.com. So there's nothing to do with FE, nothing to do with Globe Tardia. This is just all about pinhole cameras. And actually, to do you a favour, copy and paste. So you can all see what I'm talking about if you just want to go there. Tells you how to make them, the whole lot. Get down to the bottom, and there's even photographs of random people. Even says the example of pinhole photography. Below are photos taken with pinhole cameras, some by pros, some by random people.
Yeah, the ones, yeah, the vessels, the can, I made one out of a cool container, like screw on circular cylinder things. Then you're going to get a curve. Well, that's obvious, but you're going to get a curve because the paper's curved in the back of it. But yeah, if you made a box, yeah,
Yep.
they're easy to make. You just have to get some photography developing chemicals. Yeah, they're the easiest way to get photographs.
Right, so if you set up a camera in front of a white wall, you take photos with the camera, and it shows like a beach with a bunch of people on it and a boat. Right now, take the camera and just chuck it in the trash. Then look at the white wall. That white wall is saturated with the quote unquote image that you just took. You see what I mean? Because the light that would have been hitting your camera is now hitting the wall. So it's right there on the wall and then bouncing off the wall. But the wall looks white because it's, got its own color to it. You could actually build a room around that white wall, just like the little pinhole camera. A big old room, 12 by 12, 8-foot ceiling. Put a hole in the side of the room facing the beach. Then that white wall will show you the beach. The original camera obscura was a room, just like I described right there. Except maybe it didn't have a white wall. It might have been a sheet.
If I may, can I take a Perfect Storm off mute? I want to get his take on the debate last night.
Sure, why not? I think he owes us something, but we could put him on clemency for a minute.
You there, Perfect?
Lights are on, no one's on.
What debate was it?
It was a guy Q-op versus some dude who hasn't been around for some years. I can't think of his name right now. It was on MDD. And they switched the format. Is Globe now has a positive claim on MDD. It used to be the Flat Earther has a positive claim. It's always Flat Earthers had to demonstrate their flat Earth. And now they have the Globe, supposedly. This is a new format. You got experts in the Globe are supposed to demonstrate the Globe. And they're like, yep, let's do it. And the guy's supposedly some sort of graduate of like physics. He's going for or he's got an undergraduate in physics. He's going for a graduate degree in astrophysics. And all he did for like 2 hours was just shit talk flat earthers as his only proof of the globe. I was like, this guy's supposed to be some sort of like graduate level out, bring the numbers, bring all the information. And just talked about how embarrassing it is, like in 2026, that there's still flat earthers. As his proof of the globe, mind you. This is the experts that we're looking for. I was looking at and wondering what Perfect Storm. Cause I know he watched it. I was wondering, like, what his take on that? Doesn't he? What's he? What do you think about that? That was the performance level that we're looking at. Nothing.
I think he's mad that I didn't look at his picture.
I don't
Well,
think he's there.
here's
I
a
think he's
cape.
left his mic on and he's not there.
Yeah,
That's
here's a
what's lit
cape.
up.
He can be super mad.
Yeah, the reason he was red flagged is because he was lit up on the stream and not talking.
Oh, okay.
I'm quite certain when he comes back to his computer, he'll have a meltdown that he's muted. So we'll find out soon enough.
Yeah, I told him too that he's got to change his definition of winning. He says he wins every time he's muted. I'm like, and so you like to win? He's like, yes. So you want to be muted so you prove you won? He's like, yes. But you don't want to be muted. And he's like, no. But you want to win? Yes. I'm like, golly. I mean, I'm trying to get you to understand what you're saying. Okay. So you go here to win debates. Yep. And your proof that you win debates is you're muted. Yep. But you don't want to be muted. Yep. But you want to win. Yep. Man. Okay.
You know
It's
what,
like a new
Crit?
yeah.
That sounds like someone who believes that they're standing still and accelerating upwards and accelerating downwards simultaneously.
Yeah, it's all kinds of fucked up.
Holy, how cool is this? There's actually websites that sell pinhole body caps lenses, as in flat glass, for digital cameras. So you don't need to make up the whole box or can kit anymore. You can just chuck a cap on with a hole in the front of it and use your digital camera as a pinhole. That is cool.
What?
Yup. But when you think about it, technically, you've already got the everything except for the pinhole. So if you put a cap on the front of it with a pinhole in it, done. Click the button. Just a matter of adjusting your timing. Excellent. I've got some old cameras. I'm going to give this a crack.
All right. Here's what I got real quick. And now I'm just taking this with a grain of salt because I didn't parse out all the sources, but it says pinhole cameras do not suffer from traditional lens distortion because they do not use lenses. Light simply travels in straight lines from the subject through the tiny aperture. Oh, that proves a flat Earth. Through the tiny aperture to the film or sensor, making them excellent at keeping straight lines perfectly straight. However, while they are free of optical distortion, they do experience, well, no, that's not true. They're free of lens distortion, okay, not optical distortion. They do experience perspective or projection distortion depending on the shape of your camera's image plane. So curved plane cameras, if you wrap your film or sensor around a curved surface, you get an extremely wide angle shot. The resulting photo will look heavily stretched or warped towards the edges. Flat plane cameras, if your camera has a flat back, like most standard boxes or modified digital bodies, the perspective behaves like a true rectilinear lens. Right, listen closely now. Straight lines will remain straight, but extremely wide angles will cause objects at the edges of the frame to appear elongated or stretched. So as you approach the edge of the frame, it stretches. Now, if you distribute the distortion in a rectilinear lens, right, and you put two color fields in the center of a rectilinear lens, the edges as it approaches the frames, the color fields will get increase and appear to separate, which could appear to be a curve. Excuse me.
I just put my
So
headphones back in. I only caught the end of what you just said, AI. But I did find that little section that I was talking about in one of the conversations with AI about the 56 miles high amateur rocket launch. So it says at 56 miles high, you are seeing in all horizontal directions at once, which means your field of view is a full circle around you. The horizon is not a physical edge bending away, it's a circular boundary of perspective where the surface meets your line of sight. When a rectilinear lens projects that 360-degree circle of vision onto a flat rectangular sensor, it must mathematically stretch and map curved angular space into straight image space. That mapping does not preserve the visual curvature of a circle centered below the camera. It converts the circular horizon into an apparent upward bow across the frame, especially near the edges where the stretching is greatest. Seeing equal distance in every direction from altitude naturally produces a circular horizon, and when that circle is translated onto a flat sensor through rectilinear projection, a convex arc across the image is exactly what geometry predicts on a flat plane.
Yep. Don't forget that important sentence too, where it says, as you approach the edges of the image, the stretching is greatest, which means it stretches from the center all the way out to the edge of the image. So that this illusion that Globers say rectilinear lenses are distortion free is just laughable.
Yep.
It's worse right where they need it to be the best.
Right, so the artifact of the lens and the projective geometry equals you think you see a physical curve because you're actually looking at an optical curve, and you were told that the horizon curves because the Earth is a globe, and so you see a curve in an image and you say, dang, the Earth must be curved. And the snake eats its own tail. But now that we know that a flat Earth would have a curved horizon, allegedly, based on new Globers who said so, so that's consensus, so it must be true. Plus, we have AI said so, so it must also be true. That's 3 people. And on the mouth of 2 or 3 witnesses, let a fact be established. Therefore, the Earth is flat. I rest my case.
Well, I think it's actually a bad argument on the FE side when they say that if you send up a camera with a rectilinear lens on a weather balloon we see a perfectly flat horizon. I've never seen anyone provide an example of sending up a rectilinear lens on a weather balloon where we see a flat horizon as it pans around and pans up and pans down and that kind of thing. It is literally not what happens. I mean, I've seen only cherry-picked footage where they're picking a frame where the horizon looks flat because the camera doesn't pan up or pan down. And no source, right? No source for the video showing that, what happens when it is actually panning up and panning down. And in some of the ones people share, you can actually see as it does take a tiny little pan up and pan down, it doesn't look completely flat. So indicating that if it was to pan up or pan down, you would get some crazy, lens distortion from the wide angle lens they're using. And then we have Dwayne Kellum's awesome balloon launches where he actually straps like 3 or 4 rectilinear lenses of different focal lengths, some of them infrared as well, to his weather balloons. And in all of his footage, the horizon looks convex, and he's a flat earther as well. And he says the same thing. That's exactly what you would expect to see with the rectilinear lenses. I think Jay Tolan says the same thing as well.
Yeah, you can't have it both ways. You can't, on one hand, say that wide-angle lenses have a distorting effect, while at the then same time saying that, see, here's flatness from the wide-angle lens. So you can't have both arguments at the same time.
Yeah, I mean, I hear it all the time. They say, I've probably said it a bunch of times myself. Oh, when we send up a weather balloon with a non-fisheye lens, non-wide angle lens, it's just a perfectly flat horizon. And then, I challenge anyone, find me the footage where someone uses a rectilinear lens on a weather balloon and we have a perfectly flat horizon as it moves around up there. It's not the case, and I don't think it's what we would expect to see. Just by the way that the horizon's a big circle around us underneath us, and the way that gets projected on the sensor, the flat rectangular sensor.
And don't forget
maybe
the globe argument, which is if you show a curved horizon, the Earth is a globe. If you show a flat horizon, the Earth is a globe.
Heads I win, tails you lose. But that's exactly correct, DJ. And the thing that I find interesting is is the people who can't. They show these cherry-picked videos, and then you're like, okay, well, you're using this as the original source. Well, what's something other than a TikTok video? Where's the original source? The original source isn't a TikTok video. Where's the original footage that's probably not seconds long, that's probably minutes or hours long? Where's that at? And nobody ever seems to produce those footages.
Right.
So, I mean, we don't even know, if you will, we can't even see if that's actual footage or something somebody's produced, yet alone analyze.
Well, check this out. There's a glober, and if I'm not mistaken, it's who is that guy? Baron Rutledge, who's supposedly a surveyor or whatever the hell. And last time I was on whatever channel he was speaking, he said, "What I do is I take photos, and then I doctor the position or shape of the horizon, and then I present it in communities that don't know me, and pretend I'm a flat earther presenting flat Earth evidence." And almost every flat earther in the room agrees that this is proof the Earth is flat. So that's pretty telling.
Well, it's interesting because he's saying that he goes into the Flat Earth channel, he convincingly lies, and especially to those who are likely new or less educated, and wonders why he as a victory. That's kind of interesting. It's an interesting tell of both sides at the same time. If that's the best that he has, if that's the best evidence that he has that some flat earthers aren't educated enough to know that that's not proof, then
Well, that's not evidence of his position. That's just him presenting evidence that a lot of flat earthers are self-deceived into thinking that they're analyzing what they're looking at when they're really just saying, "Oh, flat earther told me, therefore it's true."
100%. Yeah.
Which, by the way, so many globers fall into that same category, including globers with alleged credentials and careers and positions like physicists, astrophysicists, et cetera, et cetera. They've come in here and have been challenged by us why they believe certain things. They say, well, somebody who I trust told me.
Mm-hmm.
Why do you trust them? Oh, well, because they agree with the consensus that I already agree with.
As you know, the modern definition of science is submission to consensus.
Yeah, we had a guy in here the other day, and we were challenging him on the scientific method in comparison to, let's just say, flat Earth arguments or whatever. He's saying nobody, and I didn't get him on the category error or anything like that. I just wanted to parse something out with him to see if he could apply those steps. And he said, no, I don't even need to do it. Because I know you're flat earthers, so your conclusion is that the earth is flat, so you must be wrong because the consensus is that you're wrong. So I don't even need to do this exercise with you.
I love it. Let's give him A++ for being honest. He's one of the few honest ones. No sense in even trying to waste time with some idiot like that. Back when I used to sell cars, one of the managers used to say, when you'd have people come in and tell you how they know how to beat the dealer and everything, he said, the first thing you do is congratulate them for being stupid. And that's stayed with me ever since. So somebody like that, that's about all you can do. But go ahead, Brother DJ.
Oh, no big deal. I was just it just came to me. I was just typed into Google, what's the longest perfectly straight line stretch of road in the world? And it says that the longest straight stretch of road in the world is a 240 kilometer, 149 mile interrupted segment of highway in Saudi Arabia. And it's void of any curves, turns, or noticeable changes in elevation. I wonder if that's handy in some way to test certain things.
Yeah,
Maybe
so how you do
something
it,
to do with that.
DJ, is you take two trucks, just like they did at the Salt Lake, but times it by 2. Put the lasers on the truck, put the observed camera on the truck, then drive the trucks away from each other. So you're getting a contiguous reciprocal zenith angle crisscross applesauce crossout, like Jesse always claims to have. And then the two trucks witness the laser the entire time, right? And then, according to Jesse, that cancels out refraction, and you have to accept the results.
Yeah. Man, Jesse's got the best luck when it comes to observations. Every single one matches the globe perfectly.
DJ, was there a conclusion about the 240 click highway? I may have missed if you had a conclusion there.
No, I thought maybe it could be useful in some way of testing distances, like the 69-1 rule or whatever. I'm not sure. I hadn't really thought about it.
Well, yeah. You could do all that at the same time. You send the two trucks down, shooting lasers at each other with cameras, tracking the centroid, while another dude on the truck is doing an angle to a star. Right? You could do so many tests simultaneously. Interesting.
Yeah,
course,
I
you have to
wonder
be in
how
Saudi
straight.
Arabia.
Yeah. Yeah, I wonder how straight it actually is. I mean, it says it's straight. I wasn't expecting there to be a straight road that long.
We got
Listen.
a 90-mile one.
Hate to
Really?
tell this to you, brother. It's in the closet.
So since we had Rich Evans around here, does Brenda still come around?
Yeah, came in today or yesterday, yeah.
Problem is that Brenda's imaginary girlfriend from 25 years ago sued for back child support, and now Brenda had to get like a third job to be able to pay it back. Busy now.
That's hilarious.
The inside joke there. Inside joke there, for those that don't know, is that we were in a debate with Brenda once, and Brenda literally said that imaginary girlfriends are physical objects.
I didn't hear that, but I know I could tell Brenda. I can imagine. I can just hear Brenda saying that.
So, DJ, our 90-mile straight in Western Australia, to be classed as straight, it is not allowed to deviate more than 1 degree, start to finish.
Oh, shit. Okay.
So, that's pretty straight. But what's interesting is I can't find any information on elevation profile. Like, I've driven it a couple of times, and yeah, it's straight, it's flat, it's boring. But I'd like to find elevation profile of that area.
Old dude made the comment about the Saudi king loving fast cars. Is Saudi Arabia where the Rolls Royce met its fantastic match? At least mythically, old dude. Do you know? Yeah, like the king went to a Rolls dealer when visiting London, I think it was, and they assumed that he couldn't afford it, not knowing that he's the king, and turned him into trash trucks or something. There's a historic story about that. I don't know if that's actually true or not, but I think that's from Saudi Arabia. So AI, what? Why do you think it is that these supposed scientific minds do buy the bend the earth theory just based upon religious virtue, in a sense?
Hey, are you there?
Question. What's the question? Hello.
It's tough to
Did you
do
catch
this.
that, AI?
What is the question?
The question: why do you think it is that the supposed scientific minds all take the Baltard just as a religious principle, if you will?
You answered your own question.
But why is that belief so important to them?
That it's that old argument that if oh, you're a Christian because you were born in a Christian nation, right? And statistically that bears out, right? So if you're born into a system that already has a sort of adopted set of principles that they all agree when you arrive are true, the chances are you're going to believe it too.
And I agree. Yeah, they get there, they just take it. But it is interesting that, like the meme somebody shared earlier, they spend 18 hours asking flat earthers questions they can just Google themselves.
Oh, DJ's left. Damn. I found the elevation profile. I had to use AI to scour some pages. The 90 miles straight. It's actually basically 9 miles, so 91 miles. They just cap it at 90 mile. Starting at the eastern end, elevation of 489 feet. There's a slight rise in the center of it, and then it descends down to 377 feet. So that's over 90 miles.
Yeah, the rise in the center is because they had to account for the curve of the Earth.
Well, if you chuck the 90 miles into a curve calculator, like the GitHub one, 90 miles, 5 foot eye height, target hidden height, 5,049 feet at the other end.
Hey, supposedly, there's an influx just in the past month that I've noticed people posting very long distance observations in the 200 plus mile range. Just added to the list of alleged long distance observations. I think people are starting to notice them more now. You know, like whereas before they just take images of things and be like, "Oh, this is a great panorama. It's so beautiful." But now they're like, "Hey, this is a great panorama. What's that bump? Oh, it's a mountain that I shouldn't be able to see if the Earth was a globe." And now they're like, oh dang, I better post this.
Hey, DJ, can you hear me? Where's he gone? I think.
Dave's not here, man.
I was just gonna ask him, like, so when they had that compressed image, and if you just turn a little bit to the right, the height of the curve is the same height as if somebody made the same observation just 5 feet to the left or right, and the height of the middle of the curve would all be the same elevation. I was just trying to understand how it just doesn't make sense to me. Because
Which bit doesn't make sense?
like, okay, like when I look at Cat, do you see the screenshot from DJ where he take a picture of what Caddy said in the chat at 25 minutes past the hour?
Hold up, 27. Yes.
Based on that, if it was curved, then it would still appear flat, right?
Correct.
Or am I
What?
mistaken? Am I mistaken?
There's no way.
So,
I thought this was like a satire thing. Is this not satire?
no, it's actually measured as flat, mate. Sorry to
Oh,
break
I hate to break
anything,
it to you,
but
but
yeah.
I hate to break it to you, but it's really not.
Excellent. Can you provide demonstration of measurement of
Uh,
drop over distance so we can assess that, please?
Didn't some flat earthers go out and do that a couple years ago? Pretty sure they did. With like a laser pointer on some boards.
Oh, that's the one
Did
that they
something like
didn't
that.
use the laser on. Go watch the video again, mate. They start off with a laser, and they broke it, and then they finished off with a flashlight.
Alright, the first thing I think I'm going to ask you is why do things fall down?
Say that again, please. Why do I think?
Why do things fall down?
Why do things fall down?
Yeah.
Because they're more dense than the medium that they're in.
Density isn't a force. What's causing objects to accelerate downward?
Oh, whoa. Sorry. I didn't claim density was a force.
Well, then why do things accelerate? Because acceleration is proportional
Things
to force.
accelerate because
If
I
there's
put my foot down on the accelerator, my car goes faster. That's why they accelerate.
no, according to Newton's law, force equals mass times acceleration. Acceleration is proportional to force. So any acceleration is due to a force.
So demonstrate the force then, using a scientific experiment.
Okay, walk in a vacuum chamber, drop a bowling ball and a feather.
And what happens if that vacuum chamber is extended and it's longer and they have a greater time period to fall?
Then they still accelerate. They don't hit terminal velocity because there is no air resistance.
Do they hit the ground at the same time?
I would imagine so, yeah.
This is incorrect.
Well, if they don't, it's because the force of the attraction between the bowling ball is probably greater than the force of the attraction between the feather and the earth. It's minuscule, but there's a difference.
Why do we have to assume everything moves just because you say it has a force? Why do we have to assume a force?
He hasn't demonstrated that yet.
Because of Newton's law. Force equals mass times
So
acceleration.
did Newton test every object of existence physically?
If you deny force equals mass times acceleration, then I'm just not going to talk
I
to you.
asked you a yes or no question. Did Newton
If you deny force
himself,
equals mass times acceleration, I'm just not going to talk to you.
Hey, kid,
yes or
stop. Hey, Zodiac, hold up. Hey, kid, stop chanting. It's not going to make your ideas any more valid by repeating it like a broken record.
Do you know how it was?
Yeah, that's great.
derived?
This is what you've got at the moment. I'm just gonna break down what you've given me at the moment. You've come in here, and flat earthers are whatever you want to call us. It's not flat because things fall down. That's what we've got out of you at the moment. So I'll let my pen go. It goes down. Therefore, the Earth is a globe. I think you can do better. You sound very intelligent.
Okay, anyway, like I said, Newton didn't test random objects and come up with F equals ma. He
That's great.
derived it. He
So
derived
how?
it using
So
math.
with this derivation, how does that prove curvature? Because that's what this channel's about. This is not 24/7 gravity is my best friend. This is 24/7 flat Earth. So how is your things going down because some guy derived a formula proving the shape of the ground?
Well, if things accelerate downward, then there needs to be a force. That's
Okay,
literally the
I'll
point of the
grant you that.
equation.
You've got your force. How does that make the ground round or spherical?
Okay, gravity predicts a spherical Earth.
No, it doesn't.
Gravity does. Yes, it does.
No, it doesn't. Gravity just
It's
goes
the force.
down. Read the formula out.
No.
Read the formula
No,
out,
gravity.
please. No, read the
F
formula out.
equals for gravity. Okay, F equals G m1 m2 over r squared.
And the R
That's
stands
universal
for?
gravitation.
How
That's
did you get the
universal
R?
gravitation.
Yeah, that's great. We
R is
heard you.
distance.
You don't. Hey, kids, slow down. You're getting really excited for no reason. You don't have to. It's 24/7, not 24 seconds. Okay? So, where did you get the R from?
The R is the distance.
The
Distance
R's
from
the
the centers
distance
of the
of
object.
what?
Distance between the centers of the objects. M1 and M2.
So, distance between the center of the object. So, it's got absolutely nothing to do with the shape of the ground then. Excellent. That's what we needed to know.
No, but that predicts that predicts a spherical Earth.
The distance, no, it doesn't predict spherical. It predicts the distance between the objects. Object A, object B. Nothing in that references the shape of the ground. I'm sorry.
Well, if you extrapolate that and you use that equation to determine
Extrapolate it.
you know,
Holy shit. So if I
take a
imagine
leap of
something,
faith.
therefore it's true.
Yeah,
No, but
take a
like
leap of faith.
anyway,
So
gravity.
what we're
gravity,
after, we're not after inferences. We can talk about gravity all day. Gravity makes the ground flat. There we go. I'm happy with that.
No, so anyway, it's because of the
Yep, so now you've
inverse
just
square law.
understood by using the same argument and just applying a different result, it doesn't change anything. Gravity makes the
No, 'cause
ground
the
flat. You're
inverse-
saying gravity makes the ground curved. So now we can take gravity out of the equation and show us how it's curved or where it's curved. We'd be happy with that.
Okay, let me try to make this simple for you. Do you understand what luminosity is?
Luminosity.
Yes.
Lux. Lumens. Yeah, you can take intensity readings
Okay.
using a lux meter.
Yeah.
Probably
Okay.
picked
Anyway,
the wrong person.
do you know that luminosity follows an inverse square law?
Most excellent. Yes, I do.
And does luminosity emanate in a spherical radius around a certain object? The luminosity, there's a I think it's equilumin line. I don't know. I know there's equipotential lines, but there's an equidistant line that's a sphere around an object of a given brightness, right?
Yeah, so
It's the
keep
same
going with
thing
your
as
inverse
gravity.
square law. So distance from object, double the distance, quarter the energy. So now tell me how the sun's 93 million miles away. I'll wait.
Okay, so there's parallel light
Using
wavelengths.
it, make sure you apply the inverse square law because that's what we want in this situation. How about I do you one better? How about I just click on my little chart here because I've got a lux meter. You did pick the wrong person for this one. Where is my light meter readings? Clickety clickety.
Hey, guess what, brother? Guess what?
Guess
I
it.
got
Yep.
I got a shop light that has a round bulb.
Ooh.
Then I got a shop light that has a flat bulb.
LEDs.
It's not even a bulb. It's an LED. So how does the inverse square law tell me which light is which?
Are you serious, dude? There's no way you just asked that. I said
Yeah, I did
that around said object of a given brightness,
Don't care.
there's an equidistant line where
Hey,
you will
young
observe
fella,
the
I want to
same
show you something.
brightness.
Hey, 5 up, check it out. I actually have a lux meter, and one of the things I was doing was taking light intensity readings every half hour for a full day. Over multiple days, I've done this now. Now, one of the readings I got, the highest one was 131,000. Okay?
For what the sun?
This is off of the sun.
Okay.
Right. So at 12 o'clock, if I've hit 131,000, if we double the distance, that's a quarter of the energy. Now, the problem is, if we follow globe law, and Earth is a ball with a radius of 3,959 miles, when I rotate around to 6 o'clock, or from 6 o'clock in the morning to 12 noon, and then back to 6 o'clock, that's only a difference of 39.59 in, and then that back out further away from the sun. So if you then work out the distance to the sun over that, it works out as 0.002 of 1%. That's all our movement is as a ratio from the sun. That breaks the inverse square law. Now, laws don't normally get broken, do they?
No, but I don't see how you
Excellent.
broke the
So
inverse
from
square
the
law.
sun, check it out. So from the sun, allegedly 93 million miles away. So Earth is 39.59 mile radius. So when I'm at the front of the ball at the sun, directly over my head, it's a given luminosity, 131,000. As we rotate away, all of a sudden now the sun is 90 degrees from me, 6 o'clock in the afternoon. I check up my trusty rusty readings, and where's my mouse gone? There it is. Slide up. 1800. I'm looking at a reading of 828. Now, double the distance, 1/4 of the energy.
Okay,
So that means
if I
in order for
understand,
me to go from 130,000, what's a quarter of that? So let's just say it's 100 grand, just for the sake of argument and easy numbers. A quarter of that, 25k. That means I've doubled my distance to get that energy reading. So that means you're telling us that the sun magically moves 93 million miles in a 6-hour period.
it doesn't though. There's probably
It doesn't
some.
do that. Excellent. So that would suggest that either number one, the distance claim to the sun is not true, or what else? What other options could we have?
Faulty equipment, faulty calculations.
Inverse square
Okay,
law is
there's nothing
wrong.
wrong with the equipment. Inverse square law could be wrong.
There's nothing wrong with your equipment at all.
So I've got to go out and buy another lux meter.
I would suggest you do, yeah. Or I would suggest you, I don't
Here's
know.
an idea. You could also purchase a lux meter, take some readings over the day, and see if you get something similar.
All right. So then, please explain to me why rays from the sun are essentially parallel.
Rays are essentially parallel.
Yes.
And
Shadows
you've
are
measured them to
essentially
confirm
parallel.
this?
You don't need to. It's
So
visual.
it's an
You can
assumption.
go outside in your backyard. You can go outside in your backyard right now and tell me,
Rays
do shadows pass through a
diverge.
light bulb?
Rays diverge off a light source. You know that.
The
If you have a
shadows,
look at
the shadows.
if you have a look at the inverse square law, see how it shows the square pattern getting bigger and bigger and bigger as it gets further away from the source. That's how we know they diverge. The inverse square law shows you that, mate.
Hey Matrix,
Yeah,
I got
but
a
when you're
question for you real
93,
quick. Hold
when
on,
you're
hold on,
93
five
million
grips.
miles
Hold on,
away.
5 grips. I got a question for Matrix real quick.
Yeah, what's going on?
Did you just say that that you did this like thing with your Lux thing, whatever?
Yeah.
And he didn't.
It's boring as
He didn't
bat
like.
shit, man.
He didn't like it. So
I
he
don't
said
know whether
he
he
didn't.
liked it or not.
And so he said to get a new one.
Yeah, my lux meter not good enough apparently. Oh.
It's broken.
Dude, I've never heard
Broken.
anybody skedaddle from a point so fast in my life.
I just joined the call and I'm just like, that's the first thing I hear was oh,
I'm
your
sorry.
Lux meter, I don't like it.
Hey,
Get a new one. I'm like,
can I
what?
ask? Lats, can
Bro,
I
he
ask
doesn't
what
even want to
your
address the point.
Lats,
Why
can
don't
I
you
ask
want to
what
talk
year
about
of
what
college you're
Matrix
in?
just said?
Lats, can I ask what year
I'll
of college
answer
you're in?
whatever question you want, dude. Just address what Matrix said first. He went through that
Okay,
entire
okay.
lengthy
Lats, what
discussion for you.
what level, what year of college are you in?
I am a kindergarten dropout.
Yeah, I assume so. I assume so.
All
That's
right, now
Hey,
can you address
five
what
up.
Matrix said?
5 up. Look, people's academia
Okay, so
claims. Oh, what? Hold up, mate. I know you're excited. You've got something to prove to the world. That's great. We love it. We want you to. It's good. People's academia levels mean absolutely nothing in this conversation. We get a lot of people coming in here going, "Oh, you don't believe in science, you must be stupid," and all these silly, silly claims. This is not a question of science. This is a question of geometry. That's all we're
You
after,
do
is people
realize
to
that
show that
geometry
we
is a
live on.
science?
No.
Geometry is now a science. Well, there's the
Yes,
education
and
system
math
for
is
you.
a science. Math
Oh,
is a
so
science,
math is
believe it
now
or
a
not.
science. No,
Yes,
math
it
is not a
is.
science. It's a tool used
Oh my
within
god.
science. No, he's not going to
Oh
help
my
you either.
god. Did you say math
Oh
isn't
my
a science?
god.
Math is not a
Oh, sorry,
science. I'll
sorry. Oh my
repeat it again.
non-existent god.
Obviously,
Oh my
obviously you
non-existent.
didn't hear it. Hey, Five. Obviously, you didn't hear me because you got me to repeat it. Math is not a science.
Oh, really? Really? Do you want to look that up?
Oh my goodness gracious.
Math.
Bro, you're-
Do you use mathematics within science? Yes or no?
That's a good one.
Yes.
Excellent. So it's a tool used within science. Congratulations.
Holy
You are now
crap.
educated.
I guarantee you I'm at a higher level of education than you ever
All right,
thought you were. Okay.
5 up. Hold on, brother. This is called a rate limiting factor here. You have to answer this question correctly. Okay. So there's an acronym. It's called the STEM fields. S.T.E.M. What does the acronym stand for?
Science, technology, engineering, mathematics.
Oh, dang! You know what? Because you're wrong. I'm going to tell you what it
STEM?
stands for. No.
Did you
Hey,
just tell
listen,
me
dude.
that I was wrong with STEM stands for?
Listen, friend. Hey, bro. Okay, I'm going to speak. You're not going to speak. By
Tell me what
force or
STEM stands for.
acquiesce. Okay, I'm going to tell you once you stop talking.
Tell me right now.
Okay, I'm going to tell you once you stop
Hurry up.
talking.
Hurry up.
All right. You chose mute, I guess. Hopefully you're got enough balls to stay for the 15 seconds to be unmuted. Okay. You're wrong because what STEM stands for is science, 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 and science. Got played, fool. All right, I'm going to unmute now.
Wow, you're hilarious. Did you graduate high school?
Well, hey, Five. The reason he said that is because that's what you require for your beliefs to be true.
Okay, anyway, answer my question, please. Did you graduate high school? And if you did, I would like to see your diploma.
Yo, brother,
No, I don't. No one in here will dox themselves.
Oh,
Can you just address
you
my
didn't graduate high school?
Hey,
Hold
kid.
on, dudes. Holy fuck. Dude.
Oh, well, if
Stop.
wants to.
5 up. The next time you ask for somebody's credentials, you're getting heated. Okay, it's a non-point. And the next time somebody answers you when you ask, except to tell you to shut up, they're getting heated. Now, that being said, I actually hold an education degree. That's why I just schooled you.
I seriously doubt that.
Okay. You could doubt it all you want, but if you talk about it, again, I'm yeeting you. Yeah, if you talk about it again, I have to yeet you, bro. Otherwise, I can't. I'm not a man of my word.
All right, bro. Anyway, please
talk about
like
the
I was
topic.
talking.
Thank you, for the love of God.
Yes. Okay. Who was I talking to? All right. Matrix, please tell me why. Say, for example, if I go outside of my backyard and I'm looking at the pylons, right? Why are the shadows parallel? Essentially parallel.
Why your shadows are parallel? I don't know.
Yes.
Why your is this a joke or what's the?
Oh, you got it wrong, Matrix.
No, you
Matrix, you got it wrong. Hold on, 5 up. He's strawmanning you. Okay, he didn't say that, Matrix. What he said was parallel, essentially parallel, not parallel. Two different things.
Ah. So how far away is your light source from you that's causing your shadows?
93 million miles away.
Really?
That's why they're essentially parallel. Yeah.
Didn't you listen to my discussion earlier about the inverse square law that you brought up?
Didn't you know that you completely bluffed something because that's not true?
Excellent. If it's not true, then you can go and purchase, when you get your pocket money, you can go and purchase a lux meter and do it yourself. And tell me I'm wrong then. The rules of the game are simple. Listen carefully. The rules of the game are simple. You purchase a lux meter. You point it at the sun at half-hour intervals. You are not to be any more than 30 seconds off the half-hour interval. You must do it from dawn till dusk. 6 in the morning till 6 at night. Every half an hour, you're going to be outside, looking at the sun, taking bloody readings. It will drive you insane for a full day.
This is going to improve your pizza land?
When you're done, you then bring your data. You'll get a graph full of numbers. That's it. You bring it in, you compare it to mine, and then we can say, oh, look, my lux meter's not broken, or it is broken.
All right, anyway, I want to ask you how you...
So you're just going to sidestep that?
Yeah, I will do that. I will do that. I said I will do that. Anyway.
Bro, we called the skedaddler, bro. What the fuck is this?
How about this? How about I make it easy for you? If you look up your local observatory, a lot of them keep this data for people just like you. So you can go and log onto their websites, collect the data for any particular day, lux readings for the day, and you can download them yourself. You don't have to buy the equipment. Pro tip for young players.
By the way, Lax, I said I would do it, so you're stupid as fuck. And also, Matrix, how do you explain the circumnavigation of Antarctica in the Antarctica Cup yacht race?
How do I explain? I don't have to explain anything. Why do I have to explain
the
things
circumnavigation
to you? Listen, check it out. Circum, to go around. Navigate, to navigate. Navigate around something. That's it. That's all circumnavigate means. Nowhere, check it out. Nowhere in circumnavigate is the necessitate a sphere. You seem to think it does.
The circumnavigation of Antarctica. You think Antarctica is a big giant ice wall?
Check it out. No, I don't. Whoa! Where did you get the ice wall from, son?
Because that's all your guys' model.
No, whoa, and a model. Holy, what are you doing to me? So now I've got to defend a straw man of an ice wall and defend a straw man of a model that haven't put forward yet. Where do you get this information from?
Your flat earth gods like Eric Dubé.
Well, here's a cool idea. If you've got a problem with something that Eric Dubé has said, give him a phone call and say, look, bro, you're wrong. Some people might not like Eric Dubé. Some people might not agree with his things. How about you ask us what we believe in as opposed to strawmanning us? That'd be really cool.
Okay, so let me ask you this then, Matrix. Do you think that Antarctica is a big giant ice wall?
No. Antarctica is a continent, and it's supposed to be a higher elevation than quite a few. Actually, it's a really high elevation, one of the highest on average.
Oh, and is Antarctica? Does it happen to be surrounding your pizza land?
Strawman again. What's this pizza land crap you're talking about? I don't ascribe to some pizza. I don't ascribe to a pizza land. So your question is false. It's broken. You are strawmanning me again.
Well, I don't prescribe to a globe. Sorry, not a globe. I don't prescribe to a ball. It's not a ball. It's an complete sphere.
Hold on, guys. Hold on, friends. Hold on. I'm converting to 5UP's team. I'm on 5UP's team now. I did what he told me to do. I went out and I took some shadows of some poles. So I'm going to post you my results. Sorry to do this to you guys, but I can no longer, no longer be a member with you guys. I have to switch sides to 5UP side. I know it sucks to hear, but here's the proof. There it is, bro. There it is. Read it and weep. Okay, guys, the sun is 138 feet away, and the Earth is a globe.
What are you talking about?
Dude, I posted my proof, dude. Listen, dude, I'm convinced, bro. You got parallel light that diverges and converges to a sun 138 feet away. So, I mean, I don't know, dude. I'm a glober now.
Not what essentially parallel means.
Dude, I did the measurement, dude. You told me to go measure it. I took a photo. I took the angles there. I put them in the program and traced it back to where the sun is. It's 138 feet away, dude.
That has nothing to do with what I said.
You said to go out and measure the shadows.
I didn't say measure the shadows. I said go outside, look at the shadows cast by your light.
Oh, just look. Oh, I got you, bro. Okay, so you're not supposed to measure them. You're just supposed to look at them. I get it now.
Oh, yeah, because guess what? If the sun was only 3,000 miles away or some whatever crap it's supposed to be on your model, they would diverge at a great rate.
Oh, dude, this is on your model. This is on your model. Dude, the sun is 138 feet away on your model.
It would be very noticeable on your model. It would be.
'No,
138 feet away.
it is noticeable. It's so noticeable on your model when you told me to go out and look at the poles. So I looked at them, then I had to measure them, then I traced it back to the sun at 138 feet, dude.
Dude.
Listen, dude, I don't know why
really
you're
did not do
complaining.
that.
I'm literally, listen, dude, I'm literally converting back to your side of the argument over this, dude. Why are you fighting me on this?
Bro. Lats, you can keep laughing. I know you don't have an education. It's pretty funny.
Funny shit, dude. Yeah, I already told you I'm a homeless kindergarten
Lats,
dropout.
Lats, tell me what a face-centered cubic structure is.
No need to,
Hey,
bro. You can't have
tell me what the
ball, dude.
formula. Hey, tell me what the formula for the Rayleigh criterion is. Tell me what the Rayleigh extinction coefficient is in the ambient atmosphere.
Tell me what a
What's the wavelength? What's the wavelength of blue light?
What's the wavelength of UV light?
Which gene controls whether or not you get blue eyes?
What's the highest recorded redshift?
5 up. 5 up. I'm gonna give you a hint here, bro. We're not playing trivia games, so you can pretend like you're flexing some education you think you have that other people don't. Okay, we're not gonna waste our time doing that. Okay, so if you want to man up and actually just talk about the merits of the arguments instead of these little games, dude, you're not gonna last long. All right, let me unmute you, bro. Now, for the love of God, stop it with the nonsense. All right, go ahead.
It's an education that I directly have. You guys are all fucking stupid. Oh my god, Jesus isn't real. God isn't real.
Oh, you need to
Yo,
relax.
So
Matrix,
you're
you fucking broke
we
this dude.
figured it out. He's a butthurt atheist. Oh, we got a butthurt atheist on our hands, friends.
God isn't real. 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 God isn't real.
Yo, look at him.
Jesus.
Oh my gosh. He's obsessed.
Yo, good shit, dude.
If you guys had an education, you'd be atheists like me.
Well, you probably wouldn't be as
Hey,
fucking
guess what?
stupid as you are right now.
Well, let me ask you this question, friend. Let me ask this question. Do you know who Brian Greene is? This isn't a trivia. This is just like, if you know him.
No, I don't. Can you explain split brain structure to me in your Christian worldview?
No. So Brian Greene.
Can you explain the severing? Can you explain the severing of the corpus callosum in your Christian worldview?
Why do we need to explain anything?
What is that even? That doesn't even make sense.
What's
Dude.
the
That's like
corpus
saying,
callosum?
can you explain?
What's the corpus callosum?
Hold on, brother. Hold on, brother. Hey, the only thing you need to be worried about. Listen, bro. The only thing you need to be worried about with 2C's in it is the corpus cavernosa and whose is bigger.
Okay, what is the corpus callosum? What happens when you sever it?
Who cares, dude?
It disproves
I told you to worry about. I told you to worry. No, I told you.
It disproves
I told you to worry. I told you to worry. Really, you sure about that?
Yes, it does.
Hey, let me help you out, bro.
No
let me help you
duelist,
out.
no duelist can explain
Hold
the
on,
severing of the
brother.
corpus callosum.
Hold on, brother. Hold on, brother. Hold on. I'm gonna post something for you. You're gonna love it. Don't leave. I'll promise I'll mute you once I post this, but I need to concentrate because I have to go to 3 different places. Keep in mind while I'm looking for this, you could think about like what you're talking about and actually put it into an argument form so you could actually explain it to other people rather than do it in a quiz style. Because maybe you have a point, but no one's going to know it. If you think they don't know it and you just chant it, how are they going to know what you're talking about? All right, sorry, I'm supposed to be looking. All right, give me 1 second, brother. I promise you'll get unmuted. I'm just going to hum in the meantime. Doobie doobie doo. Do da 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 da. Strangers in the night. Copied it. Coming back. Promise. I'm almost there, dude. I'm asymptotically arriving, okay? I'm having the distance every second to arrive. I'm going to defeat Xenu's paradox. Okay, I'm almost there. Xenu's paradox is about to be defeated. I know you're in suspense, but it's going to be worth it. Okay, there we go. Brian Greene explained why it's impossible for consciousness to be in your brain. You should watch that show, bro. See, the problem with you, bro, is you're so behind in science, you don't even know what's actually going on in the real.
It's funny that I'm behind in science, given that I'm in second year of materials engineering.
Cool story, bro.
All right, and anyway, besides that, I don't care what some grifter has to say because he
He's
objectively
not a
cannot
grifter,
explain.
dude. You don't know.
He
So you
cannot
don't even know
explain. He
Brian
cannot
Greene,
explain the
dude.
severing of the corpus callosum. He cannot explain the severing of the corpus
Yes, I
callosum.
could explain it. I could explain it. Watch, I'll explain it right now. So to sever something, you cut it. There, explained.
Oh, really? So
Hey
the
kid,
effects
before
of
you have
severing
a
the corpus
meltdown,
callosum.
5 up, stop. You're having a breakdown, mate. Have a look at the channel
Hold on.
name again.
Yeah, dude. Listen, dude, I speak jive. Matrix, calm down. I speak jive. All right, 5 up. God's not real. God's not real. Not real. God. God's not real. Real. God's not real. Real. God's not real. Okay, now that you understand what I mean, do you understand?
Well, you're making a lot of sense now because that's the only defensible point you've had.
Okay, so listen, dude. All you're doing is chanting words. You're not
That's the
explaining
only
anything you're
defensible point
talking
you've
about.
had. Wow.
Hey, why don't you watch that
Maybe
video
Hope
I
isn't watching.
posted, dude?
Okay, so
Watch
can I
that
ask you
video I
why? Can I
posted,
ask you why
and then
hundreds of
watch your
thousands of scientists
worldview
are all in
melt
on time?
into pieces. What? Go ahead. Tell me
Why?
Tell me again.
Can you please explain to me why hundreds of thousands of government agencies, government employees, and scientists are lying about the shape of the Earth so that you can feel super great about your super secret truth?
Dude, what are you talking about?
Okay,
Let me ask this
guys,
question.
we're living in the
Let me ask
Matrix.
this question.
Take the red pill.
No, hold on,
Take the red
5 up.
pill.
5 up.
Take the
Hold
red
on,
pill. Oh
brother.
my gosh, guys, take the red pill. We're
Wow,
so
dude.
super secret.
5 up, calm down.
Hold on. Hold on, guys. I know you can't understand him, so let me translate for him. Hold on, guys. Let me translate. I'm going to translate for him now. God's not real. God's not real. I hate Jesus. God's not real. I hate Jesus. God's not real. I hate Jesus. That's what he said, in case you guys didn't hear it. Now, 5 up. In case you didn't know, when you're searching in science, right, they have this idea that they're searching for ever decreasing sizes of objects, like the smallest particle, the smallest unit of space, the smallest unit of time. When they do these experiments over the years, the guys who are involved, and rest assured, these guys are not flat earthers. They're not even necessarily Christian. In fact, some of them are atheists, some of them are secularists, some of them are Big Bang, all this stuff, right? They're evolutionary people. Like they believe just a lot of the things you believe. But what they realize is that in these experiments, there's a necessary precondition for all these experiments to happen. And I'm not going to go the long story. You're going to have to do the research on yourself. Essentially, the conclusion that they come to is that the sentient agent is the precondition for the material world to exist. Okay. And so books such as The Case Against Reality by Donald Hoffman, this lecture by Brian Greene, which I posted for you, if you're going to be interested, maybe you will, maybe you won't, maybe you'll put your fingers as your say, no, it's not possible that scientists, that my worldview is incorrect. But guess what? They did. So it doesn't matter whether you chant God's not real, dude. The eternal sentient agency is the fundamental cause of the material, physical, energetic, and temporal world. Okay? So you can just cope. Go ahead.
Please tell me why I should be genuine when you were, why I should be good faith when you were not.
How was I not good faith?
You're telling me you guys were good faith to me. And respectful and all that shit.
Well, if you were good faith,
I never said I was respectful.
If you want me to be good faith and listen to what you have to say, then you shouldn't be a dick. That's what I'm
Maybe
saying.
if you wanted to be good faith, you'd stop talking through other people and being rude.
Hey, if you wanted to be good faith, you'd stop trying to denigrate us. Listen, you'd stop trying to denigrate us as ignorant, uneducated schmuck cards, okay?
That was
But nice try, dude.
That was after you guys acted like a bunch of dicks. But
what?
Yes.
Who acted like a dick? Wait a minute, are you saying Matrix acted like a dick to you? Is that what you're trying to say?
I'm saying various people.
Listen, dude. Matrix is Australian, so I need you to respect his disability. We don't hinder people for their disabilities here, okay? Listen, Matrix is upside down and all his blood is rushing to his head. He can't even think straight, dude. How do you expect him to talk to you with a civil tone?
Wow, that's hilarious. Because I'm pretty sure you know that's not how gravity works, but okay.
All right, so why do you
So
believe
my
there is
accent affects gravity now. Holy shit.
What are you talking about?
How does gravity work? Can you explain it?
Wait,
Can you explain
before
why
we
an
go
electron
there.
has a negative charge?
Oh my god.
Pro skedaddler.
Five up.
Look at
5 up. Stop doing stupid things like that. That's what AI was talking about. You wanted to know a question, someone asked you something, and then your answering it is to ask some totally non-related
Because
question.
it's an analogy.
So
It's
I'll give you an example.
analogy.
Check it out. An analogy. So gravity works by the knowledge of positive and negative charges.
No. But do we understand why
So
an
it's not an
electron has a
analogy
negative charge?
then. Excellent.
Please
So
tell me
it's
why
not
an
an
electron has a
analogy
negative
then.
charge. Please tell me why an
Okay.
electron has a negative charge. then.
We're not going to there yet. What is gravity by your
It's
definition?
analogous.
Okay. What is gravity by your definition?
The force of attraction between two masses.
Mass attracting mass was superseded about 112 years ago by bendy space-time.
What?
What is a unit of power? Please start listening.
What?
That's what I said. Is a unit of power. A what is a unit of power? We're
Yeah?
not discussing
You
those.
said-
We're supposed to be talking
You just
about
said what is the
gravity.
unit of power?
He's not real quick, this kid, is he?
Hold on, guys. Hold on, I gotta. Hold on, bro. Hold on. I gotta translate again. Okay, Matrix. This kid is completely uncultured and doesn't know the Jeopardy meme. Okay, so please don't use it again. We gotta respect his disability.
5 up. Why do you
Oh,
believe
well.
we're on a sphere? Why don't we just cut to the chase?
What?
Why do you believe that the Earth is a sphere?
Why do you believe it's not a sphere? Why do you reject the scientific consensus?
Oh my.
It's a sphere. It's a sphere because that's what the evidence points to.
Okay.
What
show us
evidence?
the evidence?
That's the
Show
good
us
bit.
the
That's the what we're after.
Oh,
Give one specific piece
All
of
right.
evidence.
Why do you
Go.
see it? Why do you see a sharp horizon?
No. This is where you come along. 5 up.
Okay.
This is where you
Here's my
5
evidence.
up. Stop
Here's my
talking.
evidence.
Stop talking for a second. You've just claimed that there's evidence for this curvature. Please provide it.
Here is my evidence. Here is my evidence.
That's
There
a
is a
question.
sharp horizon. We see a sharp horizon. If we didn't see a sharp horizon
soon.
and the Earth was flat, and what you're saying about visibility and the atmosphere and stuff like that, atmospheric scattering, right?
Okay.
If there's
So
atmospheric scattering that causes. Wait, I'm not done.
find the horizon.
I'm not
If you're
done.
going to use big words,
I'm not done.
I know. Having a meltdown, son, it's not going to help you.
I'm not done. I'm not
Having
done.
a nervous breakdown
I'm
is
not
not
done. You
going
asked
to
me to
help
explain to
you.
you, so that's what I'm going to do.
So you've just
You
yibbered on
asked me
about
to
a
explain to you.
non-crisp horizon.
You asked
This
me
is
to explain to
Mctoon
you.
classic.
You asked me
5
to
up.
explain to you. You
We
asked
want
me to
your
explain.
proof of
Please
this.
let me finish.
Explanation means
Please
nothing
let me
without something
finish.
to back it up.
Please let me finish.
I will, but I need you to understand your
Please
explanation means
let me
nothing.
finish.
Yeah,
Duh.
that's great. You will finish. I have no problem with that. But so you know, your explanation means sweet diddly without something to back it up. Now you may finish.
This. Do you agree that in your model, atmospheric scattering is what
There's no
restricts
flat
our?
Earth model. There's no flat Earth.
Okay.
I don't have
In your
to. I don't
opinion,
have to agree to any of your ideas. You just present your data that proves
I don't want
curvature.
to. I don't want to agree to any of the ideas, so I can't be proven wrong.
We don't have to. You don't understand.
I don't want to agree to any ideas, so I can't be proven wrong.
Hey, debate bro, silence. Just take it easy. You're not in a hurry. There's no problem here. You just have to present your data that backs up your claims. That's all. At the moment, you've given the cool story. We've all heard it. Non-crisp horizon can't be flat. So now back it up with some kind of observation, data that enforces your claim or
Here's my
reinforces your claim.
observation. Here's my observation. We see a sharp horizon. Boom. That's my observation.
So if I go out on a foggy day
Wow.
and the horizon is not that's not a boom. If I go out on a foggy day and the horizon is non-visible, that means what? That the Earth is a ball
That has
tub or the
nothing
Earth
to
is
do with
flat?
it. That has nothing to do with it. That's meteorological
Well,
conditions. If you go out on a clear day and you see a sharp horizon, that disproves the flat Earth.
What do you mean sharp?
So
What does that mean? Sharp.
he's a McToon supporter.
It means there's a
that is a
distinction
classic
between.
McToon claim.
Sharp.
Means there's a distinction There's a visible distinction between the ground and the sky. That's a sharp horizon.
Holy crap, dude.
What?
Painful, dude. Hey, listen, five up. Go draw me a picture of a horizon on a flat Earth.
It's gonna be a gradient because there's atmospheric scattering. We don't see that though.
Whatever.
We don't see that. Explain to me why there would ever be a
This
sharp
kid,
horizon on a flat
this
Earth,
kid has
please.
heard a lot of big words
No,
and he
no,
thinks he can
please.
just throw them
I want you to
randomly.
explain to me. I want you to educate me. Please tell
We
me
don't
why
have to
there would
explain
ever be.
anything.
Please,
Five
no.
up. All we
I'm fine.
require, five up. All we require from you is
I will
measured
concede you.
drop over distance. You don't have to
I will
concede to
concede.
anything. You don't
Why
have
are
to
you?
pull
Why
your
are you
pants
trying to?
down.
Why are you trying to
It is
change
a
the? Why are you
very
trying to change the
simple
topic?
thing. Let's know. I'm not changing the topic. I'm trying to help you, and you're not helping yourself. All you need to do is back up your claims. That's it. You talking about crispy horizons means absolutely nothing because the horizon, the maximum distance where the sky appears to meet the ground. Nowhere in that statement does it mention anything about curvature. So whether it's crispy, whether it's blurry, whether it's super clean, whether it's fuzzy, you can use all these descriptors that you wish to. I'm not going to stop you, but none of those enforce curvature or flatness. Okay? So please try again.
Please explain to me why there would be a sharp horizon on a flat Earth.
I
Sharp
can
like
do
a
it.
knife? Or what do you mean
That's
by
all I
sharp?
want.
Yeah, I can do it for you.
Like
So check
he
this
just
out,
said,
dude.
a distinct.
If you measure the ground to be flat from where you're observing to the point where the horizon is, then this phenomena can obviously occur over a flat surface. Yes?
Wait, say again. What?
If the ground or the water that you're observing over from your point to the horizon is measured flat, then this phenomena of a crisp or clean horizon, as you describe it, is possible over a
No.
flat surface.
No, it's
No?
not.
It's a hypothetical
What?
question. You failed it already.
Oh my
Oh
goodness.
my goodness!
It's
Holy shit!
five up. That was a hypothetical question. He just
Think of
he
it as a
really
trick question.
you can't really. Why not? Okay, tell us why not. Tell us why no. If you
Okay,
measure
so
something to be flat, go ahead.
if you did see a sharp horizon on a flat Earth, you would of the flat Earth.
Well,
That's
yeah,
what
dude.
you
It
would be
was.
seeing because there was no
Dude,
distinction between.
Holy crap, dude. Holy crap, dude. You might be the dumbest person in the room, bro.
All right, bro.
Well, he just got schooled by like a kindergarten dropout homeless guy. Like, bro, are you serious right now?
Yeah,
Hey,
straight
what
to
do you
ad
think?
homs.
What do you think? What do you think if the Earth is flat, that the Earth is the surface is going to render in the sky or something, dude?
No. What?
Right. So the bottom portion of your view is going to have the surface of the Earth in it. The top portion of your view is going to have the sky in it, and they're going to meet at some point in your field of view. Correct?
So if I stare down a really long hallway, the ceiling and the floor will meet at some point?
Yes.
Yeah, they will.
No, they will not. They will not meet.
They will
If you
appear
grab
to
a
meet.
telescope and you zoom in, will the ceiling and the floor meet down a very long hallway?
Oh my god,
They will
dude.
appear
Five
to
up,
meet.
dude.
Eventually, yes.
No, they
Yes,
will
eventually.
not.
Perspective.
What are you
Five up,
talking about?
Five up. It's called
Oh my
perspective.
god. No, we're not even playing this game, dude. Five up. Holy crap, dude. You've offended my sensibilities. I actually have a degree, my friend, and a teaching license. And my teaching license is in art. And now I have to give you an F minus, bro. Because you don't know anything about how perspective works. You actually think that if you took out a telescope down an infinite hallway, that you'd be able to see the hallway never meet. It doesn't even make sense, dude. You know why? I'll tell you why. Because optics actually have a limit. They don't have infinite resolving power. They have an angular resolution limit, which is determined by the Rayleigh criterion, which is one of the trick questions I asked you earlier. So optics have an aperture, and the light has to fit through the aperture, and that limits the amount of spread that you can have in your angular field of view. And since light interferes with itself, and all these things I'm sure you know because you're a physicist scientist, dude.
He actually said that?
Yes.
So the problem is that after you go to the distance that's below your angular resolution limit, any color field in that angle is going to be rendered as one color value in the final image. So that means that if the end of the hallway occupies that angle, it can only be rendered as one color, which means it's going to appear to touch top and bottom, dude. Not to mention that it's going to have a smaller angular size. So of course they're going to converge together. Now, you're going to come back and basically tell me that optics have infinite resolving power out to infinity because you're dumb as a brick. Or you're going to concede that I'm correct. Those are the only two options. Go ahead.
No, what I'm going to tell you is that I didn't say infinite hallway, you fucking idiot.
His issue is that there's no such thing as an infinite hallway.
I didn't say infinite hallway in my analogy, you fucking dumbass.
So why do you believe?
And also, percentage guy,
Hey,
I did not say, oh, I'm a smart
breathe,
physicist guy.
oxygen,
I'm a
Junior.
second-year materials
Hey,
engineer
kid.
student.
Hey kid, just breathe. Holy. You're standing in a hallway, you're looking down it. All of a sudden, you grab your binoculars or your telescope. What do you think is going to happen?
How long is the hallway? If it's a finite distance, like I fucking said, then you're going to see the end
Hey,
of it.
slow down, Junior. I'm
Nope,
asking
wrong,
a very
wrong.
simple
Nope,
question.
no, we're not asking him any questions. He's going back on mute for a second. Okay, we're distracted from the point, which percentage notice he distracted. Now you know why I said infinite hallway. Because what I actually parsed out, that the only thing that matters is the relationship between the angular size of the approach angles, right? Which is why you get an angular size, because you have an angular field of view. And if they fall below your angular resolving, they're going to be rendered as one color value. So it doesn't matter the length of the hallway. It only matters the angular field of view and the angular resolution limit of the optic. So if the ends of the hallway are lower in their angular size than your angular resolving limit, it'll appear as one color value, which means it'll look like the top and bottom are touching each other. Now that could happen at any distance depending on the optic that you have. Okay, 5 up? Hope you're paying attention that time.
He's saying that you conveniently have an optic that lets you see the end of this finite hallway.
Right, which means it hasn't passed the resolving limit of that optic. So as soon as it does pass the resolving limit of that optic and the angular size falls below it, they will merge together. That is a physical fact that cannot be otherwise. Unless he's claiming to have a non-angular field of view. In other words, be like God. Go ahead.
Please tell me what the resolving angle is for the fucking the firmament in quotation marks in the flat plane in quotation marks.
The what?
The firm.
Did you say that did you say the angular resolving limit of the firmament?
I said the resolving limit or whatever you said.
Of what?
Oh, but of what? The optic?
Yes.
Depends
on
the
a
lens.
flat
Oh,
on your
okay.
flat Earth.
No, it's not about
How
flat
far
Earth.
can I see? Is basically my question.
It's got nothing to do with the shape of the ground.
Oh my fucking
It's
god!
got-
I asked him based on what he just said. How
Hey,
far can
5
I
up,
see?
slow down,
Please
slow
answer
down.
me with
Yeah,
some math.
that's great. That's
how
all
far
good.
can I
You
see?
can. It's based on the size of the optic.
Well, it's multi-factor.
And also what you're looking at.
So, for example, looking out horizontally, the base level atmosphere, you have what's known as the Rayleigh atmospheric extinction coefficient, which means at about 300 miles, some people do a little less, some people say up to 350. But when you do the math out, depending on the wavelength of light, the atmosphere is functionally opaque at that distance. So you can't see past 350 miles looking at horizontal. Now, within that range, you're going to have ancillary effects like fog, temperature differentials, particulates, all kinds of things. And then when you finally get down to where the camera is, you now have the limits of the camera. So for example, I don't know too many cameras off the top of my head, so I'll just use the human eye. So the human eye has an angular resolution limit of 0.02 degrees. Now, if you put that in a side profile, like an orthographic projection, and you trace that out to where that angle intersects the surface of the Earth, it would be at about 3.25 miles. So you're going to start losing resolving power at 3.25 miles. That would be actually congruent with the alleged supposed intersection of the curve of the Earth at that range, which is approximately 3.2 something miles around. They're very close together.
Okay. You know, I do kind of want to apologize for some of my language and behavior, actually.
All good, bro.
That's the smartest thing you've said yet.
What the fuck?
Apology accepted.
It's weird.
Yeah, no, I am sorry. I have been acting like a little bit of a child. I apologize. I genuinely do.
Fuck, make me feel bad for laughing at you now.
You said what?
You're gonna make me feel bad for laughing at you now.
No, but like you do raise some good points, and I might actually have to look into that.
Now I'll tell you this, friend. When I didn't know about flat Earth before, but like I said, I got an arts background, and so we do a lot of things with perspective and exercises about perspective, and we learn about how cameras and techniques to make things look camera real, if you know what I mean, like paintings that look really photorealistic. And there's like this history, like when you do the art history series, you find out that paintings used to lack certain techniques, and then at certain times, guys were like, "Hey, what if we just try doing it like it is in reality? You know, the angles obviously converge towards the center." And some guys actually went out with these devices which would allow you to look at the paper at the same time, and so you could actually trace the lines of buildings and make them very 3D perspective correct using perspective techniques. And they also developed that into what's known as linear perspective techniques, and that helps you mimic the three-dimensional world. But the reason why the linear perspective exists is because you have an angular field of view. So your pupil, it's like what 5 centimeters or something like that. Less than that, might be millimeters, right? So you have this little hole in your eye, and obviously the world's bigger than the hole in your eye. So how are you going to see it? Well, the only way to see it is for you to get an angle to everything, and that angle comes into your pupil, right? It flips on the focal axis and then goes out to the sensor, right? And the relationship of that to the world is what causes perspective. It's what causes a lot of these visual arts. And so, yeah, when you look out into the world, it's not a single factor, it's multi-factor. But rest assured, whenever you look out into the world, you're seeing it, right? So you're seeing something that is Euclidean geometry, but when you experience it, it's projective geometry, and there's a translation of those two words. Then you have to couple in atmosphere, you have to couple in the limits of light, you have to couple in near field diffraction, far field diffraction, all of these optical conditions. If I'm not mistaken, there's like 44 different conditions that ultimately lead to what you see that are out there in the world.
Okay, yeah, I'll have to look into that.
What blew my
No pun
mind,
intended.
bro, this blew my mind. The coincidence of this, of when somebody told me that when you're seeing out, there's a reduction in what you can see that converges towards the center point that's based on what's known as the angular resolution limit. And that number for approximate 6 foot tall man, that it would intersect a horizontal line coming out from his feet, is at almost the exact same distance as the alleged globe Earth horizon. And I was like, wow, that is uncannily interesting. And the number for the Rayleigh criterion that you multiply the aperture size by is the same number that you multiply how tall you are times the square root to get the horizon distance. And it coincides where those two meet. It's like within a tenth of a something, whatever it is, a degree or whatever. And I was like, dude, this is so uncanny that these two things match up. And that the number, I forgot to tell you the number. The number is in the Rayleigh criterion, I think it's 0.225 is the multiplier. And in the equation to get the distance to the horizon, it's like 0.2203 or something. It's like they're very, very close together. I found that so interesting that led to a snowball, which ultimately made me realize that all of these claims about the globe of Earth, a lot of them are fantastical. And so I started pulling on the sweater, and over time, I didn't have a sweater left anymore.
Yeah.
I'm going to show you a picture, dude. Let me show you a picture, if you don't mind. It's of my lake. It's going to take me a second to find it because I got to my files. But I'll explain my lake to you. Because this is another interesting thing. Because I've always heard in my life, and I'm sure you have, that the Earth is a globe, obviously because boats disappear from the bottom up, right? They're cut off by the horizon, which is, supposedly the edge of the Earth, right? That's what we've been told our whole lives. And so I actually did some little experiments in my own life, and I found out that that's not true. That you can get things to cut off from the bottom up well before the alleged horizon would even physically be present. And you can see things well beyond the alleged horizon is supposed to be blocking. And that blew my mind too, because I'm like, wait a minute. I have all these optical conditions which are super coincidental. Then I got these claims from the globe side that none of this can happen unless the Earth's a globe, but these geometries don't match up.
That's just caused by extraterrestrial refraction. Yeah.
Well, I mean, I would agree with you that the more I researched it, the more I realized that everything that we see is optics. And I mean, think about it. That makes perfect sense. Like, we're seeing everything optically, duh. And then there's claims about the geometry, which may or may not be true. All right, give me a second here. I almost got it. All right, Small Lake. That's my folder name. And then I need this one and this one, I think. All right, done. All right, they got to upload. I think they're uploaded now. So what I posted is I posted a picture from this guy called Dexter, who's showing a boat appearing to disappear out in the distance. It's a far distance away from the observer. So on a very large lake, or I think it's an inlet actually that will eventually go out to the ocean. And then I have my pictures of my small lake. Now my small lake is only approximately 1,014 feet wide. And so in other words, the horizon for my observer height should be 3 times the distance that this lake is long before the horizon even begins to crest. And so what that means is that anything that's blocking anything on this little lake couldn't possibly be the horizon. Yet I clearly have things disappearing. And I actually have a list of, not a list, but like a series of shots that basically mimic long distance shots. So people will, they'll send me a picture of a boat disappearing, and I have a picture of the boat that I filmed disappearing in the same manner, but on a much smaller lake. So I know I can get the same effects on a small scale. And I know that I can see things past where they claim the horizon is. So for example, there's observations of boats seen at 30 miles away. According to the Earth curve geometry, that boat should be 400 feet below the curve. There's no boat that's 400 feet tall. So according to globe geometry, it's impossible to see a boat at 30 miles. So I have a claim that this can only happen if the Earth is a globe because of the physical horizon. But then I have things disappearing before the physical horizon and things that can be seen after the physical horizon. So what does that tell me? It tells me it's not physical. It's an optical effect.
Yeah.
One thing that really made me snap in my mind is I went to my lake to do these observations. And I was lowering myself down into the water before I even began doing the observations. I was just looking, and I noticed something I had never noticed before in my entire life. I had seen it, obviously, but I had never paid attention to it. And that was that as I lowered myself down, I was looking at things in the distance, expecting them to have essentially a uniform rate of disappearance, or they're moving through my field of view uniformly. But as I started to approach what I've learned later in life is called the critical angle, those things were moving at a uniform rate in my field of view. And before I even got down anywhere close to the water, they snapped out of existence like they just got erased by God himself. And later I learned through watching physics lectures for free from MIT that as you're approaching the critical angle of your angular resolving power, the things that are disappearing accelerate like hyperbolically. So, you have a pretty steady rate, and then all of a sudden a really sharp hockey stick parabola. So at the very close to the critical angle, things just blink out of existence. Can't be seen. Like they just vanished. And I was able to float in the water, and just bend my knees a little so that my head goes up and down. And later I learned I can just do it by tilting my head back and forth, because that changes the height of your eyes ever so slightly. And you can just watch an object. Nothing is in between you and that object, and you can just watch it disappear, reappear, disappear, reappear, disappear, reappear. And I experienced it in my own eyes with my own mind. And from that point forward, no one could ever tell me that things can only disappear if there's an earth curve in the way. And that right there falsified a claim that Globers made boldly and confidently. And that alone right there was enough to put a crack in the glass house.
Yeah. Yeah, when I first came in here, I've seen all those media things kind of talking about, like,
We can't hear you, bro.
Oh, wait, I can't, wait 1 second, I need to fix something, my internet's being weird. Alright, sorry about that. What did you say?
Please don't tell me you're
Oh,
talking
we
to
were
AI.
telling you we can't hear you. We were telling you we can't hear you, so it's your turn to go.
Oh, okay, yeah, there's something wrong with my internet. Yeah, so I said when I first came in here, I've seen a lot of media and stuff, like, kind of dissing the flat Earth view, and that was kind of like fresh in my mind. But yeah, you guys are actually you're a lot smarter than I am. So yeah, it's just makes me kind of feel weird about like what I've seen.
Yeah, I got you, brother. But check this out. Before I came across the topic, I didn't know much about the topic. I've been interested in this topic now for 10 years, and I've had conversations with probably literally 10,000 people on this topic. I've had evidence presented to me by probably half of them. I've reviewed it. I've seen other tests, et cetera, et cetera. So there's no shame in not knowing about a niche topic.
Yeah, no, that's my bad. I acted like a buffoon though. Like I acted overconfident.
Bro, don't
Hey,
be too
dude, we
hard
can
on
hug it
yourself. It's a
out.
slow roll.
Virtual hug.
All right, bro.
But before your internet died, you heard what, like, the spiel that AI went on, right? Talking about how
Yes,
like, made it
yeah,
reappear.
I heard about that. It's when I was trying to start talking it.
Yeah, thanks for sharing, by the way, AI. All you need is one crack. One crack and there's no going back.
I took my son out to that lake and I had him do the same test. So in his mind, he would see, and then he'd be, this is crude, but I call it an inoculation. So never again, if he ever met someone that said, "Hey, did you know things can only disappear if the Earth's a globe?" He'd be like, "No, that's wrong. Saw it with my own eyes, bro. But nice try." And that's not even to convince him whether the Earth is a globe or flat or not. It's just to show him that it's not always the case that people who claim to have this dogmatic grasp on science and where they're the arbiters of truth can't be challenged and can't be defeated by actual experiments and actual tests. And that right there is enough for him to be able to later in life think on his own and know for a fact that he defeated at least one claim of the juggernaut.
That's good parenting, man. That's such a good lesson. Like to take matters in your own hands and that you have agency. Like the overarching, yeah. Good on you.
Yeah, I'll probably have to,
Yeah, there's a lot I have to think about.
But check this out, brother. There's actually a lot of because I don't think what we've really talked about here yet is like actually really measuring or testing the surface. Now, I obviously, to my satisfaction, disproved the claim to me that things can only disappear from the bottom up if the Earth is a globe. But there's a little more to it than that because we do agree that that's in the optical category. But we also agree, like when I went and saw this, I was at the water line, right? And so there's this claim out there that the water on the Earth is wrapped in a circle coming back around on itself, like water is sticking to a ball. Now, that sounds good, but when you really start to think about it, you're like, when I was a kid, that sounded stupid because I just imagined, how could that be? Because everywhere I go, water's flat. And later in life, people tell you these other stories like, well, look, the boat disappears, therefore the Earth's a globe. Or you're too small to be able to tell. But guess what, friend? I may be too small to be able to see it with my own two eyes, but we have technology. So, for example, powerful zoom cameras that can see a boat 30 miles away, which we already described the geometry as a problem there. But we also have lasers. And so in my field, I'm into construction now, and we do use lasers to level things and to measure things. And you can actually take a laser and shoot it across the body of water, right? So essentially creating a measurement, a laser measurement, right? So many of these have been done. I'll just give you one example. So they took a laser to Lake Idsel in the Netherlands, and they shot the laser across the water. They set the laser up on one side, about the height of a man, 5 to 6 feet. They had a target on the other side, about the height of a man, 5 to 6 feet, and a camera. And if the Earth is a globe, obviously, if its horizon is blocking things, it has to be in between you and them. And so there'd be this big arc of curvature. And that arc of curvature would result in like a 300-foot drop on the side that the laser's on. And the laser can't shoot through the Earth, right? So the laser would go over the target by hundreds of feet. Yet in the test, the laser hit the target. Now, of course, there's ambient conditions you have to account for. These guys actually did 17 tests. This was the biggest test that they did, 25 miles. And they have a 120-page document you could read if you're so inclined. They also have a very entertaining documentary about their endeavors, how they built the laser, how they were testing the model, all this kind of stuff. But the moral of the story is that they shot a laser across the water and hit the target, when the claim is that the giant hump of Earth curve is blocking everything in the distance. This is the cause of the horizon, supposedly. The Earth is literally in the way in this. And the problem is that not only did these guys hit the target, there's guys that did laser tests over 35 miles on land. They could see the laser the entire time. They literally put a laser in the back of a truck and drove the truck away. Saw the laser the entire time. That would be over 400 feet. There's a PhD in optics, John D. He is a PhD level physicist specializing in optics, not photogrammetry, but like photo something or other. And so he said, you know what? Somebody told me the Earth was flat. I'm going to go test it. He went out and tested it. He's got a whole channel showing his journey. He used his expertise. He used lasers. He used dual frequency lasers, et cetera, et cetera. In the end, he concluded there's no hump of Earth curve in between point A and point B because I'm measuring it flat every time I go out.
Yeah.
Where would I be able to find this guy?
Oh, we'll post it for you, bro.
Well, dude, so here's the thing, man. I'm on PlayStation, so if you could like
Oh,
give me a
dang.
name.
Oh yeah, so his what's his YouTube channel called? I'll look it up and tell you what it's actually called. Okay.
Oh yeah, for sure.
And I'll
Man,
post it in
I'm
the chat
sorry.
for other people who want to see.
Yeah.
No worries, brother. We're here to answer your questions, dude. Yes, it gets
I
contentious
said
in here
old dude
sometimes.
posted it in the side chat. I don't know if you guys heard me.
All right, there you go. So his YouTube channel is literally called this: Doctor, no dot, just Dr. space John space D dot. So Dr. John D dot.
Dear John, dear.
No. Dr. John D, just the letter D with a dot, like period.
I, Dr. John D.
And his video is called Peer to Peer. And if you know how to spell peer, if you don't, it's PIER. So this is his actual title. It's PIER 2 PIER, and then a space, and then the letter two, not the letter, the number 2. So it's like peer to peer with a 2 instead of a TO. You know what I mean?
Oh, he's a shipping guy.
No. Peer to peer just means he was at a pier and he shot a laser to another pier. So the pier was his sending location and his target location. And he's got, so if you get to his channel, he's got tons of videos on it, all about his journey and to figuring out the Earth was flat, and then his journey afterwards, continuing doing tests. And if I'm not mistaken, he has ways to validate his credentials. You know, some people care about credentials, so they might want to check him out, make sure he's not, just some schmuck that claims to be a physicist.
Are there any other like videos I should watch or something?
I'll tell you what, brother. I got a nice short video, which will go over the theory of optics in regards to the flat Earth, globe Earth, what you can and can't see thing. It's less than 8 minutes. It was made by one of our admins at our home server, 24/7 Flat Earth Discord. And I'll post that for you. And I think you should start there, because that will show you like the angular relationships that I was talking about, and like a theory of why, as you're looking through projective geometry and through an angular field of view, how different things where they're at are lost more than other things. And then I think after that you should watch some of these tests, like the actual physical tests, like the laser tests. So I'll get that video for you. I'll be right back. I usually just say I'll get it, and then I dilly-dally, and then one of my friends posts it, so I don't have to do work. I'm just kidding. All right, give me a second. I'll get that for you.
Man, how you guys weekend been?
I've been feeling kind of flat lately.
Oh, for real, man?
Yeah.
I'm sorry to hear that, man. Me too, dude. I just been getting drunk, you know.
Is it expensive these days? Isn't alcohol expensive these days?
I mean, like $10, you can get a bottle, you know.
10,000 for what?
Huh?
I'm gonna ping you in the chat with this link, so hopefully you'll record it.
I said $10, not 10,000.
Oh, sorry. Well, when you put the surface of the alcohol, when you put a glass and you look at the surface of the alcohol at rest, it's flat, right?
Sure.
Yeah.
Well, that entirely, listen, bro, that entirely depends on how much of it you've already drank, whether or not it's flat to you.
It entirely depends on what? Sorry, let me turn up my volume.
On how much of it you drank.
Oh yeah.
Depends on the type of glass too. Shot
Yeah,
glass
it's like
could
it's in a superposition. It's to the left of me and the right of me at the same time.
I mean, a wise man don't put his glass on a stilt, like on a like
A wise
somewhere
man
it's
doesn't
gonna
drink.
fall down.
What do you think happens to the alcohol when you spin the cup at 1,000 miles per hour and then throw it at 66,000 miles per hour? And then on top of all that, you put it inside a vacuum,
Right.
and then throw it another 1,000,000 miles per hour. Guess what happens to the alcohol?
I don't know, dude.
Well, one thing is for sure. If you don't put a container on it, that shit's gone, bro. It's gone with the wind.
That shit is gone.
Do we have any sphere enjoyers? Is 5-Up still here? Is he still here?
Dude, he's simmering, dude. You gotta let the pot simmer, bro.
Okay. Is there any other globe defenders who want to defend the imaginary sphere?
Hey, listen, you can also update your rhetoric too. Is there anybody who wants to ask flat earthers questions? They don't always have to be in the position of.
Yeah, any flat earth questions? Anyone got a flat earth question?
Why
Because
are
there's no curve.
boobs round?
I actually know the answer to that. I'm gonna post it for you, bro. You can't look at the chat though, but I need to post it so I can refresh my.
Okay, and the Earth is flat.
Yeah.
Okay, check this out. Okay, I'm gonna read this to you. Okay, you ready? So, the butt to breast shift is a famous evolutionary hypothesis popularized by zoologist Desmond Morris. Early humans shifted to upright walking and facial mating signals became dominant. So permanent breasts evolved to mimic the butt so that men would be interested in talking to women face to face.
This Desmond
Isn't
Morris
that
guy is an
hilarious?
absolute retard.
This dude basically said that butt cheeks moved to the hips and then made their way up to the belly and then made their way up to the chest so that men would think they're looking at butts because all men back then were butt guys. You know how there's butt guys and breast guys? But back in our ancestral history, all men were butt guys. So the only way for women to get men to talk to them is to have butts on their chest. Isn't that stupid?
That's the dumbest thing I've heard in a long time.
Yeah, well, that's evolution, bro.
That might be true, man.
We
Because
evolved for the need to cause attraction to one another. That's a high
well,
need.
well, you do see a lot of men with titties nowadays, right? Well,
Fair
I'm
point.
not talking trans titties. I'm talking men
We're out
eating
of
Look at this
these.
theory. Look at this theory, though, dude. Follow this. Listen, everybody follow the logic of this theory. So here it says that as early humans shifted to upright walking, facial mating signals became dominant. So listen. So the whole point is to be face to face. So that means that eventually boobs are going to grow out of women's faces.
Wow.
Oh shit.
Yeah,
That's the
you think
next
about it, dude.
evolution.
No, think about it. Think about it. You know how girls always say my eyes are up here because men are looking at their breasts? Well, the only evolutionary
Oh
success
shit.
that this could be solved by is for them to grow breasts out from under their eyes.
God damn it, dog. You done figured it out, man.
Now I can prove it. I can prove it, dude. Go look up women and their
They're gonna
photos, and
see
you'll
his
notice
name
that.
in the
Check.
history
No,
books
no,
under
bro.
titties.
Bro, you got it, bro. So check this out. You may notice that a lot of women lately are starting to develop bags under their eyes. Rest assured, friends, these are the early preconditions of eye breast.
Is this a real conversation right now?
This is absolutely real, dude. Spawned on by retarded evolutionists who think that the reason women have luscious boobs is because men have to be attracted to their butts. And so
Dude,
evolutionarily, they move to their chests.
Yeah, but what if I'm only a boob guy? I'm not an ass guy. I'm only a boob guy. Not because they're on the
Well,
chest, but just because they're boobs.
Exactly, but the only reason you're a boob guy is 'cause your ancestors were butt guys. Don't you get it?
So
That's how.
I don't get it. I don't get it. A butt doesn't have like two nice little nipples to suck on, you know?
Well, listen, dude. Let me
Way
help you out.
different. It carries
Let me
a
help you out,
whole.
dude. Let me help you out. Please
so
report to the Evolution Re-Education Camp promptly.
Okay, send me the link.
Will it kindly
Need to
erase your
record my
mind
mental
and
frustrations about this.
what
exactly?
about guys? Are
I should
guys
just kill
just gonna
myself, but I
start
don't give a
growing
shit.
muscles on their face? Like what the fuck?
What are women attracted to when like people started
Money.
walking upright? Like what?
I'm
Men's
just kidding.
balls started growing more fucking horizontal or something?
They're attracted to clavicular.
Dude, listen,
We
there's an
started getting
evolutionary.
bigger veins. Our veins on our arms got bigger. Less hair to expose the veins. That's what they're into.
They're into Chad. All they want is Chad.
Anyone who supported this theory should have been absolutely like discredited, canceled, delicensed. Like if this
think
is
he
what
made it
your
up.
credentials are from,
Have you
like
heard
this is
about
you're a
Put 'em in an
zoologist and you're
asylum.
coming up with this, retarded.
Have you heard about having fun?
Yeah.
Have you thought about having fun?
Yeah.
Yes.
It
Is
is
this going
just a
somewhere?
joke.
Does fun prove the Earth is a globe?
No, I'm saying the boob stuff is a joke, dude.
Oh, so you think he was
I
trolling the scientific community to see how many morons would agree?
dude, I'll be right back, man.
It's
He's
possible.
out. He's like, I'm gone. He's done.
Yeah, see, you learn something new from Flat Earth 24/7 every day. So you guys thought boobs evolved from mammary glands, but actually they evolved from butt cheeks. I mean, sorry to tell you.
All right, I'm gonna head out here. I'll definitely probably be back.
Catch you on the flat side.
Wait, sorry, what'd you say?
I said catch you on the flat side.
Oh yeah.
Get it?
Yeah. Hey, I want to thank you, bro. You've been very very informative.
No worries.
I appreciate it, bro. I do. I'll be back. And
Let us know if you
yeah.
see curve. Let us know if you see any curvature. All right.
All right. I'll see you guys.
Hey, bro, have a good one.
You too.
Good.
It just sounded like me, man. Just like totally, utterly defeated when she found out. It's just crazy.
It takes time.
Oh yeah, for sure. I just remember it brought me back to like when I first found out. It just sounded like sad as hell, defeated. I was like, damn, I'm starting to feel bad for the guy. I was like, oh shit.
He didn't sound that sad or defeated. He sounded kind of like exhausted.
Don't worry, guy. Listen, don't worry. Like, probably within the next 72 hours, he'll stumble around a Professor Dave video, feel spry again.
Yeah.
You know, if that's true, then we can go back to laughing at him again after.
That's like psychological warfare, you know? Because it's supposed, or I don't know if this is true, but if somebody, I don't know if everyone experiences demoralization after they're lied to, but I feel like, I don't know. It depends on the way you look at it, you know?
I did.
Yeah.
I think yeah, that's probably a natural reaction, and you have to remind yourself that,
or anger.
You know, you're not like depressed, or it's not you, it's them, or whatever it is. You know.
Yeah, or they react like with anger. Because I mean, that's what happens when someone. I mean, it is kind of, it's betrayal essentially. I mean, that's what lying is essentially, is betrayal.
What broke him, the exact time it broke, was when old dude posted up the life is short thing in the side chat, whilst AI was talking about the exact same thing. And all of a sudden, that article and the audio, or the visual and the audio, clicked together. And that's when he realized that AI wasn't talking shit to him. That's why there was that really sudden change.
Oh, that was like almost instantaneous. That just shocked the hell out of me.
Yep. That's
Yeah,
what
bro.
happened.
This is an example of what's known as the 5 modalities of learning. So, for example, you got auditory, hearing, kinesthetic, touching, etc. You know, visual, etc.
Hey, what up, boys?
So
Ladies and gentlemen, how are you?
What's up, man? Hey, is
Welcome
my
back,
microphone
Gemsy.
crazy?
We might have woken one up, Gemsy, right before you came back. We might
Yeah,
have got a
actually,
guy.
dude. I think AI gets to, well, AI and Matrix gets to put a little notch on their bedpost there. Pretty good.
by the way, the 5 modalities of learning. So you got
Is that you, Maz?
visual, audio, etc., etc. So there, the first
I think
modality we
Maz
used
says something, but I
was
couldn't comprehend what he said.
Gemsy, I think you're muted, someone. We can't. Can you hear us, Gemsy? You have AI muted. If you don't, no, he's talking. Go ahead, AI, sorry.
whatever, dude. The moment has
5 modalities.
passed. 2 minutes are over, so I don't care if you finish.
For some reason, my Xbox buttons, but yeah.
Gemsy, can you hear us?
Yes.
Was talking earlier, but I don't think you could hear him. Can you hear AI talking?
Liar,
Yes.
he's not talking right now.
I mean, he.
Earlier,
Yeah.
I mean. You heard him earlier?
I had him muted for some reason. I unmuted him.
Hey, go ahead.
Well, there was probably not a reason, but maybe the clicking in here was the reason.
Dude, I mute people all the time. I mute people all the time just by scrolling with my thumb.
Yeah.
And then it doesn't actually tell you. It doesn't tell you that you've muted the person. Like there's no icon or anything. So the only way to find out is to talk over them.
And get a signal for someone else.
No, when you mute someone, the icon should appear.
It doesn't. I couldn't see AI talking. I couldn't see him talking.
All right, so
For me, when I mute someone, it's like a gray mic, like their mic's muted, like that they self muted, but instead of the line across, there's a little stop sign type looking thing on top right corner.
All right, so back to the 5 modes of learning.
It depends. I guess it depends on what platform or how you're currently viewing the call.
Yeah, what was your point with the 5 types of learning?
I was trying to remember all of it. Obviously, audio, visual, touch. What's the other 2? Dang.
Probably text.
Taste.
Smell.
Reading.
Imagination.
Let me look at
Reading is crazy.
Audio, visual, tactile, textual.
Oh yeah, touch is taste, I guess.
Visualizing.